Hello everyone and welcome to Simplilearn's YouTube channel. Data is everywhere, but the real value comes from knowing how to collect it, analyze it, visualize it, and use it to make better decisions. Businesses today rely on data to understand customers, measure performance, identify the trends, improve marketing campaigns, and uncover opportunities for growth. This is where SQL, Tableau, and Google Analytics become extremely valuable. SQL helps professionals work directly with databases to retrieve, filter, combine, and analyze structured data. Tableau helps transform that information into interactive charts, reports, and dashboards. Google Analytics helps organizations understand website and digital user behavior, measure conversions, track important events, and evaluate online performance. Together, these tools create a practical analytics workflow. You can use SQL to extract and prepare data, Tableau to visualize and communicate insights, and Google Analytics to understand how users interact with websites and digital platforms. In this complete data analytics with SQL, Tableau, and Google Analytics course, you will begin with SQL fundamentals and understand how databases and queries work before moving into data analysis, subqueries, joins, normalization, SQL Server, views, PostgreSQL, common table expressions, and advanced SQL concepts. You will also work on a practical SQL data analysis project and explore common SQL interview questions that can help you prepare for analytics and database-related roles. So by the end of this course, you will have the practical knowledge to query and analyze business data using SQL, create interactive visualizations and dashboards using Tableau, and understand website performance and user behavior using Google Analytics. Having said that, let's take a look at the agenda for this course. We will start off with Module 1, which is Introduction to SQL, Databases, and SQL Fundamentals. Module 2 is SQL for data analysis, queries, filtering, functions, and data operations. Module 3, we have subqueries, SQL joins, and database normalization. And Module 4 is SQL Server, Advanced SQL, Views, and PostgreSQL. Module 5, Common Table Expressions, SQL Data Analysis Projects, and Interview Questions. Module 6, Introduction to Tableau, Tableau Interface, and Data Visualization Fundamentals. Module 7, Tableau Functions, Parameters, and Data Connections. Module 8 is Level of Detail Expressions, Data Blending, and Advanced Tableau Analysis. Module 9 is Tableau Charts, Visualizations, and Interactive Dashboards. Module 10 is Tableau Projects, Dashboard Development, and Interview Questions. Hope I made myself clear with the agenda. That said, if these are the type of videos you would like to watch, then hit that subscribe button along with the bell icon to get notified whenever we upload a new video. Also, just that you know, if you want to upskill yourself, master data science and data analytics skills, and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various data science and data analytics programs. Simplilearn offers a variety of master certifications and postgraduate programs in collaboration with some of the world's leading universities. Through our courses, you will gain knowledge and work-ready expertise in skills like Python, Tableau, Power BI, generative AI, and over a dozen others. That's not all. You will also get the opportunity to work on multiple projects led by industry experts working in top-tier data and product companies. After completing these courses, thousands of learners have transitioned into a data science or data analytics role as a fresher or moved on to a higher-paying job and profile. If you're passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a data science and data analytics program that fits your expertise and areas of interest. So let's get started with our data analytics with SQL, Tableau, and Google Analytics full course 2026 with a small quiz. Which SQL command is primarily used to retrieve data from a database? Your options are select, update, delete, and draw. Please let us know your answers in the comment section below. Now over to our training experts.
Hello everyone, welcome to this video tutorial on SQL Basics for Beginners by Simplilearn. In this session, we will learn about the database and the need for a database. Then we will transition to SQL and see some basic SQL queries. After knowing what a SQL query is, we will see the features and applications of SQL query. And then we will have a hand on some of the basic SQL queries. So hey everyone, I'm Abhisar Ahuja from Simplilearn and welcome to this video on SQL Basics for Beginners. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update. Let's start with database. A database is a vast collection of data that is stored and retrieved electronically from a system. In today's world, data has become the new oil, which has mandated companies and businesses to rely on an excellent database to store their vast amounts of data. Every millisecond, the tech giants are accumulating vast amounts of data that need to be stored. The database comes with features to update and effortlessly manipulate data, and not only that, these database provider companies ensure the data to be safe and secure. They also provide tools to extract useful information to help the companies make meaningful decisions. After knowing about the database, let's see how SQL communicates with the database to get desired results. SQL stands for Structured Query Language. The structured query language is the standard language used by database operators and developers to carry out different operations, from manipulating, updating, and retrieving data from relational databases. Now let us see how we write a basic query. There's a customer table with columns: customer ID, customer name, age, gender, date of purchase, address, item, and price. And we need to extract the customer ID and customer name from this table. So we will write a query, select customer ID, customer name from customers, semicolon. When we will execute the query in MySQL Workbench, we will get the desired result, that is the output table, with customer ID and customer name. This is how we write a query to extract the information from the database. We'll see some more queries as the session proceeds. Now we'll see what the features of SQL are. SQL lets you access any information stored in a relational database. With SQL queries, data is extracted from the database in a very efficient way. The structured query language is compatible with all database systems from Oracle, IBM to Microsoft, and it doesn't require much coding to manage databases. Now we will see applications of SQL. SQL is used to create a database, define its structure, implement it, and lets you perform many functions. SQL is also used for maintaining an already existing database. SQL is a powerful language for entering data, modifying data, and extracting data in a database. SQL is extensively used as a client-server language to connect the front end with the back end, thus supporting the client-server architecture. SQL, when deployed as Data Control Language (DCL), helps protect your database from unauthorized access. After knowing SQL with its features and applications, let's go through some basic queries in SQL. That is DDL, Data Definition Language, DML, Data Manipulation Language, DCL, Data Control Language, TCL, Transaction Control Language. DDL or Data Definition Language consists of the SQL commands that can be used to define the database schema. Let's see DDL commands. Create command is used to create the database or its objects like table, index, function, views, store procedure, and triggers. Drop is used to delete objects from the database. Truncate is used to remove all records from a table. Alter is used to alter the structure of the database. DML or Data Manipulation Language consists of the SQL commands that deals with the manipulation of data present in the database. Insert into command is used to insert data into a table. Update is used to update existing data within a table. Delete is used to delete records from a database table. Select. This command helps you to select the attribute based on the condition described by the where clause. TCL or Transaction Control Language. These commands deals with the transaction within the database. Commit commands commit a transaction. Rollback command rollbacks a transaction in case of any error occurs. Save point. It sets a save point within a transaction. Set transaction. It specifies characteristics for the transaction. DCL or Data Control Language. It consists of the commands such as grant and revoke, which mainly deals with the rights, permissions, and other controls of the database system. Grant command gives user access privileges to database. Revoke. It withdraws users access privileges given by using the grant command. Now we will have hands on some basic queries in MySQL Workbench.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
Now we will see some basic queries executing in MySQL Workbench. So we'll start, and first query we will run will be use SYS, that is the database. This command is used to select the database in which we want to create or manipulate any data. Now we'll see another command that would create a table. Now we will add attributes to the customer table. That would be the columns. First would be the customer ID, and we will act at it as a primary key. The next attribute we would add would be customer name, customer underscore name, and its data type would be varchar. Next attribute we would add would be age with int data type. Next attribute would be gender with character data type. Next we will add as date of purchase with date data type. Now we'll add another attribute that would be address with data type varchar. Next we would add the attribute item, that would be the item purchased with data type varchar. Next would be the price. Okay, for price we will make it as float. And let's shift this to next line, and now we'll execute this command. Yeah, you can see that the table is created. Now we have to insert values into it. For that, we'll write a command insert into customers values, and I have all the records written in the notepad, so I will copy these and paste it here. These are 20 records, like all the attributes, they are in the order, so we have written all the records in the order only. Like customer ID, that would be 101, customer name, that would be Joseph, age, that would be 22, gender, male, date of purchase, this is the date of purchase, address, Pune, item, that is vegetable purchased, price, that is 80. So now we will run this command, and all these records, they would be inserted into the table. And these are 20 commands, 20 records. You can see insert into customer values. The command has been executed and they have been inserted into the table. Now we'll see the table. For that we'll write the command select star from customers. Here you can see the table in the output grid. Okay, I will make sure you will see the whole table with all the 20 records. Yeah, you can see all the 20 records, they have been inserted. Now see another command, and for that we would just get the output as customer ID and customer name in the output grid. For that we'll write the command select customer ID, comma, customer name from customers semicolon, and we'll run this command and we will get both the columns customer ID and customer name in our output grid. Now we'll see another command that would be drop. The drop command just removes the component from the database. So we'll write drop table and table name, that would be customers, and semicolon, and we will execute this command. Now the table has been removed from the database. To verify whether the table has been removed from the database or not, we will run a command select star from customers semicolon and execute this command. And what we will get is select star from customers, error code, table says customers doesn't exist. The table has been removed from the database, so the drop command worked here. Now we don't have any table, that is the customer table has been dropped from the database, so we have to create that table again. So we'll go at the top, okay, yeah, and we'll create the table again, and we'll insert all the records again into the table. Both the commands have run. Now we'll run this command to see whether the table has been created and the records have been inserted into the table or not. Both commands have worked. Now we'll see another command, that would be truncate. The truncate command just vanishes all the records from the table. Truncate table, table name, semicolon, and just run this command. The command has been executed. Now we'll see. Yeah, you can see that all the records from the table has been vanished. So the truncate command worked here. Now to carry other operations, we have to insert all the records again into the table. We'll do that. We'll again go upwards and run this command, insert into customers values and all the records, and we'll execute this command, and that command has been executed and all the records are again in the table. We'll run this command and check it. Yeah, you can see all the records are inserted into the table. Now we'll see another command, that would be alter. Alter command is used to update any record into the table. We'll see alter table, table name, that is customers, and now what we should do, okay, we'll drop the column age from the table. So we'll write command drop column age semicolon. Now we'll run this command. The command has been executed, and now we'll check whether the age column has been dropped or not. Select star from customers semicolon, and we will execute this command. Yeah, you can see the age column has been dropped off the table, so the alter command has been executed successfully. Okay, so now we'll see another thing, like if you want to comment something during the execution, you can do that. Just write 2 minus signs and the text. This would be the comment, and you can also use slash star and the text inside it, and star and slash. So this is also the comment section. You can write comment with this syntax or with this syntax. They both work. Now we'll see another command that would be update. This is also used to manipulate data in the table, to update any record into the table. So we'll write update table name, that would be customers. And what we should update? Okay, we will update a record. We will change the customer name and address, and we have the primary key as customer ID, so we will use that. So update customers, set customer name equal to James, comma, and address equal to Boston, where customer ID equal to 101. Okay, you can see here in the table 101 customer ID, the customer name is Joseph, and the address is Pune. We have updated command and we will execute it. Let's see. Okay, we have an error here. Yeah, no, it's correct. We will execute this command. Yeah, the command has been executed successfully, and now we'll check the table with the command select star from customers, semicolon. You can see the row has been updated. The customer name is James here and the address is Boston. So the command has been executed successfully. Now we'll see another command that would be delete. So delete command is used to delete any particular record or any particular row. So we'll write the command delete from customers where customer ID equal to 102, semicolon. So the second row, that is with customer ID 102, that would be deleted when we'll execute this command. Now we'll check into the table. Yeah, you can see the record has been deleted. Now we'll see distinct command that is used to return different values. So we will write command select distinct and the column name for which we want different values to be in the output grid. We would select address from customers and we will execute this command. Yeah, these are the address, or these are the cities in the address which are different and which are unique, and we have get that through the distinct command. Now we will see minimum command. Minimum command is used to get the records or get the data that is minimum of all the data. So for that we will write the syntax select minimum, like min, in bracket we will write the attribute name or the column name for which we want the data to be minimum as less price. This would be the attribute name from customers. So we will execute this command, and what we would see is that 60 would be the less price. Like the customer table, they have the column price, and in that we have all the prices, and from that the minimum price is 60 and we have get it at less price. Similarly, we have the maximum command. To get the maximum amount from the column, we will use the maximum command. Select max In bracket we would write the attribute name as max price from customers, and we will execute this command, and what we get is 3400. It's the maximum price from the price column. Now we'll see another command, that would be count. Count command, it returns the number of rows according to the query. So we'll run the query and see like how it works. We'll write select count and the attribute name, that would be customer ID from customers, semicolon, and when we'll run this command we will get 19 as a result. That is, it counted the number of customer IDs, that is 19, in the table. Now we'll see another command, that would be average. So it just gets the average of the numbers, and how we do it, let the query select avg and the attribute name for which we want the average from table name, semicolon, and we'll execute this command and we'll get the average of the price from the customers table. Now if you want to add up all the prices from the customer table, you can use the command sum. So how we will execute that command? Select sum, in bracket we would write the attribute name, that would be price from customers, semicolon, and we'll run this command and we'll get the sum of the prices from the customer table. Now we'll see where command. Where command is used to filter records. Let's see it through syntax. So we will write select star from customers where address we will where address equal to Pune, semicolon, and then we will run this command, and this is the table we will get the records with address as Pune. So this is the functioning of where command. Now we'll see group by command, that is used to just group the number of rows that have the same values. We will see it through the syntax. Like we will write select count, attribute name, that would be customer ID, comma, address from table name, and group by accordingly with address. Here the comma will not come. This is the command, select count customer ID, comma, address from customers, group by address. When we will execute this command, we will get this table. That would be, these are the different addresses and these are the number of times, number of persons who live in this address with the count with respect to customer IDs. Now we'll see having close with the help of an example only. Select count, attribute name, that will be customer ID, comma, address from table name, that will be customers, group by address, having count customer ID greater than 3, we have 4, 4, 3, 2, 3 only. Semicolon, and then we will execute this command, and you can see the output we have got through this command, that is group by command, was this. And when we have added having close, having count, customer ID greater than 3, we just got the customer ID count with 4. Now we'll see another command, that is order by. Select star from table name, that is customers, and we will order this output by address, semicolon. We have got the output with respect to the address. The address has been assigned alphabetically here.
Now, without further delay, let's get started with our demonstration on SQL data analysis for today. So we will be having two different Excel files. So one Excel file will be having the customer's dataset, and another Excel file will be having the dealership Excel file or dealership dataset, right? And along with that, we will get started with the SQL Workbench, MySQL Workbench data tool to run our queries. I hope I made myself clear with that. Now, let's get started. Now, this is our customer dataset. So our customer dataset will be having order ID, state where the customer belongs to, and the region of that particular state, and his customer ID and his name, right? Along with that, we have another dataset known as dealership dataset, right? Remember this order ID, the first column, remember this, right? When we're performing joins, this is the key based on which we are going to perform the joins with two different datasets, right? Now let's check out the second dataset. So this is our second dataset known as the dealership data, right? So we are having the first order ID, and after that we have order date, delivery days, and dealership name, which particular store is that, and the dealership's PIN code, category of vehicle bought, and product name, quantity, fuel type, traffic, leads, orders, revenue, profit, and basically profit as revenue minus cost to company, right? And the order status, is it in transit, is the order cancelled or placed, or is the order delivered, right? So is it not delivered yet? So these are the order statuses. So we have four different of one of them: order in transit, delivered, cancelled, or not delivered, correct? So these are the two datasets that we will be working on today. And let's also take a look on the workbench that we will be executing the queries on. So this is the SQL or MySQL workbench where we will be executing our queries, right? So currently it is using data from a different dataset. So we don't want that. We can create a new prompt and we can get started with our datasets here. So to get started with the new file, you might have to create a new schema first. So let's create a new schema. So you can just write down your name, car dealership, right? So that's the new schema name. Just apply. So you have just created a new schema. Now let's open the schema here, and you have the tables there, and you don't have any data table, right? So for that we might want to add a new table. So double click or right click on that, and here you can see a table import visit. So browse the path, and here we have the dealership data. Open and click on next. And if you go back here, you have an option called drop data table if the table already exists, right? If you already have a dealership data table there, then you can just drop it off, right? And now let's try to make some changes to it because we don't want the confusion. So either what you can do is you can add an underscore, or if you want to keep the space, or you can eliminate that underscore. I'd prefer to eliminate that underscore and click on next. And there you have the data types, right? So if you want to change some data types, you can do that over here. And I think there is some issue with the first one. Here you have order ID with some extra thing which you don't want here, but we can clear that down the line, not a problem. And import the data file, click on next, and there you go. The data file should be shortly imported. It might take a little while, but it's all right. There you go. Click on next, and 1000 records have been successfully included. Finish. And we want another table also to be included. So what you can do is use the import data wizard once again and browse and import the customers data this time. Click on next, and the file name, just make sure that you don't have any spaces, but if you literally want the space, use an underscore but not the spacing, right? It might cause some problem while you're writing queries. That's the reason for which we should either eliminate or use an underscore. So go with next, and here we have the same order ID. No worries, we can change the column name over here, right? It's all right, just import the data, go ahead with it. Click on next and finish. 1000 records have been successfully imported. Now let's run some basic queries like, okay, first we might have to use the dataset, right? So we want to use a car dealership. So car dealership, press enter, or you can use control enter. Okay, there was some spelling mistake. So I think we have created the schema with a wrong spelling, but it's okay. All we have to do is just change the name over here, car. So we have added an extra R there, but not a problem. So we are in the schema now. Now let's try to run. Okay, I'll not erase these names because we'll create a document out of it. So we can select any of the tables. Select, let's look at all the columns. Let's look at, okay, double click, start from, yeah, there you go. We have refreshed it. So if you extend, here you can see customer data, right? So let's type in customer data, semicolon, and there you go. When you run it, you have the data, right? So since we have 1000 rows, we can go with the current 1000 rows, or if you want to extend it, we can go with 50,000, or if you want the whole 1 lakh more than, right? There might be data with more than 50,000 rows. In those scenarios, you can also click on the don't limit option. But since we have 1000 rows, we can continue with what we have, 1000 rows, right? Now let's copy and paste the same command and change the name of customer data to dealership. So I'd like to pass a small suggestion here. So when you're writing the queries, use the keywords in caps, right? So uppercase and data tables or column names in lowercase, so that whenever you pass your queries or your document to your fellow developers, then they can easily identify the difference between the keywords and the column names or the data table names. This will help them to resolve an issue if there is, correct? So we have the table over here. Now we have discussed some issue with the column name, right? Now we will proceed with a quick editing query where we will change the column name of this particular data set, or no, not just the column, correct? Just a moment. So we will take the help of alter keyword. So alter table, and our table name here is customer data. Before that, let's copy this particular keyword here, or we can do one thing, describe table. We can make use of describe keyword, describe table, customer data, enter. Okay, let's find a way to at least copy that column name. I'm not finding how to copy that. Okay, we found a way. Right click or double click, and we have an option of copy field name. Let's copy the field name, and here let's continue with alter keyword, alter table, customer data, and let's not use the semicolon here. Now use the rename keyword, rename column, paste the okay, alrighty. So there's the mistake. So we found a way to copy this column name. Just double click or right click here, copy the field name. so that you get the format or you get the exact data which is written as a column name here. There might be some mistake or there might be some problem during the import, but that's not something to worry about. So we are renaming the column name from the existing name to order ID which we want. So just place it over there, or you can manually write it so that you don't want to take any chances for any more risks. So order ID, there you go. Just run this query. And now let's select the data from customer ID once again. And there you go. You have a proper functional working ID. Now let's rename the order ID column from dealership data as well. So I want to rename customer data to dealership data. Just copy the name of the table and replace it over here. And yeah, let's check the columns first. There you go. You have a similar problem here. So let's change or alter the name of the first column in dealership data as well. Now quickly run the query, and now let's select the data from the dealership data. There you go. So we have a fully functioning or fully corrected data set. So we have order data. Remember, you can see I'm using underscore symbol here whenever or wherever I feel like having the space. You can eliminate the space and keep it as order ID in a continuous form without having a space or without having a underscore. But remember, don't just leave it as a simple space. If you leave it as a space, then you might be having deep trouble while you are writing a query to fetch some data. Okay, so SQL or MySQL Workbench might be confused to have spaces in between the column names or the entity names. Let's not make that happen, right? Now let's continue with some queries. So we are currently in the order or dealership data. So here we have some orders data. So we have a product quantity. Now let's build a kind of a problem statement where we have to extract a couple of data sets or a couple of results from the data set that we have. Now let's make use of where statement and try to find some answers, right? Now let's say the dealer wants to know one of the dealership names where it is Prime Auto, right? So he wanted to know how many number of orders Prime Auto dealership has received. Now it's a simple where statement. Let's try to answer the query, answer the solution to the problem. Just write down, select. What do you want to select? I want to select the dealership name, right? Just write down, or let's use the auto suggest mode. So before that, select, leave a space from table name, which is dealership data. Right now you can proceed with the column names. What happens here is when I wrote select from dealership data, it is automatically giving me some recommendations here, right? So the typing time will be less, right? So I want to get back to dealership name, right? Dealership, press tab, and underscore name. I want this dealership name from dealership data, where dealership name is equals to single quote Prime Auto. And I also want to know total number of orders they received. So you can either use count or sum. I'll go with sum of orders. So far so good. So let's run this particular query. Control enter, and there you go. So we have found that Prime Auto dealership has received 5466 number of orders. So if you want to, if you don't want sum of orders here, you can also alias it by typing as total orders received. Yeah. So your column name has been successfully changed, right? And if you don't use alias as, it will still work. There you go. But in case if you want to make the code clearer to your fellow developers, I would recommend to use as, right? Now let's proceed with some other similar where commands so that you have a good habit of how to use where clause in your real-time queries. Now let's go back to our data and see what else we can build as a problem statement. So here we have days to deliver. Now let's say the client wants to know how many cars, if there is a premium, if it's a premium car, then he wants to know the premium cars which took more than 10 days for delivery. Now let's write a where query for that. Place the same query here, and now the name is where auto. I'll use an and statement here. Delivery date or days to deliver is greater than or equal to 10. Or we just copy this and paste it over here. And we don't want the alias. There you go. Now let's run this query. And why don't we also write the product name here, right? So we understand which is that car which is taking so much of time. So some of the cars are BMW X3 Baleno. So maybe some reason why these cars are taking a long time for delivery, right? So what happens here is he's able to understand there are couple of cars from couple of categories or couple of manufacturers which are taking a lot of time for delivering the car. So what he can do is he can write down a request or an email to those manufacturers to reduce the time they are taking to manufacture the product so that he can give an early delivery to his clients, right? Now let's run our query back again to see some more places where we can use the where clause. Right, now let's see, we want to categorize or we want to find out specific cars from the segment sedan or the category sedan, where the dealership is Elite Automobiles and the fuel type is diesel, right? Let's try to build a where command for that. Let's copy the same where clause here, paste it again here, product, dealership name, and instead of days to deliver, let's type category. Instead of prime auto, we will be using Elite Automobiles. And the category is equals to, since we're using character data type, we will be using single quotes or double quotes. Sedan. Control Enter, and there you go. So Elite Automobiles is selecting or he is selling all the sedan class BMW series, and these are the details, right? So if the dealership wanted to know what are the cars or what are the products this particular dealership is selling in category sedan, he wants to know if he's focusing on any other manufacturer or a specific manufacturer, so that he wants to make sure that these type of cars or these type of makers should be proceeding with giving more deliveries of that particular category. Now this is one way of doing it, and now let's identify, since we have a couple of and a few more other categories, we want to find out the total number of orders received based on the category. Let's say the business owner wants to understand which type of category vehicles are being sold a lot, and he wants to make sure that his inventory has good number of such type of vehicles for future deliveries or future orders from the customers. In such situations, you want to group by the category, and group by is also a keyword in MySQL where you can use that and categorize based on the category provided. Okay, let's build the query so that you can understand it in a better way. So let's copy paste the same query here, and now we will change a few terms here. Instead of product, we will write category, and instead of dealership name, and instead of category here again, okay, we will write down sum of orders from dealership data, group by category, and order by sum of orders descending. Now what does this query mean? It means I want to find out the category. So SUV category, sedan class category, and hatchback category, right? So I want to find out which type of category is getting the highest number of orders, right? In that case, what happens is, if you find out that SUV category is getting a lot of sales, then what you will do, you will buy a lot of SUV based vehicles from the manufacturers and keep them in your inventory, so that whenever you receive an order for that particular vehicle, you can show the options and make a sale, right? And why are we using order by, right? So we want to find out the highest number of sales, right? Order by descending, what it does is it keeps the highest selling category on top and the lowest selling category on the bottom. So if I run this query, you will understand what exactly I meant. So here you can see SUV category is the one which is receiving the highest number of orders, followed by hatchback, sedan, and multi-purpose vehicle, MPV, right? Now these are the vehicles. So what you will do is, the next business decision what you make is, you will try to order a couple of more SUVs for your inventory, and it can be from different manufacturers, and then you will provide multiple options when a candidate or when a client comes for buying SUV type vehicles. Now to deep dive, let's say, since you've already found out SUV is highest selling, and now you want to find out which is that one single car in SUV category which is getting those many high orders, right? So that you want to make sure that you want to understand this particular car is getting highest number of sales from SUV. So I want to keep a little bigger number of that particular car, so that whenever a client comes for that car, I have it ready, right? So if you make slight modifications to this query, you can come up with that category, and I'll also include product and sum of orders, and order by product, group by product, order by sum of orders descending. Now I am expecting a small error here, but it's all right. There you go. So we might have to place category as well. Okay. Let's try to run this query once again. There you go. So now we also might have to use a where command here, where category is equals to SUV. Now run the query. I guess you will find the answer. There you go. So BMW X3 series is that one SUV which is getting a lot of orders, right? Now if you scroll down, yeah, these are the top five SUV products for which we are receiving total number of highest orders. So what we did here is, we are selecting the category column, product column, and total number of orders, right? So we are filtering, basically we are using where command to filter down the data. So wherever the category is equals to SUV, filter those data alone. And now we are grouping by the product, which is here, group by product and category, and order by sum of orders descending. Keep the highest orders on top and the lowest orders on the bottom section where the category is SUV. So in categories SUV, the lowest orders received are 1130 for BMW X5 series. So what you can do is, if you want to cut down, if your inventory is already having a couple of BMW X5 series cars, then what you can do is, you can cut down the imports for that category. And if you have less number of X3 series, you can increase a couple of more cars, maybe 5 to 10 more cars, so that you have your inventory ready with X3 series for your clients, right? So this is how you can use where group by order by in your query. So let's say you wanted to eliminate that particular one product manufacturer which is receiving less number of orders in sedan class. So ASC ascending order, and it is sedan. Now if you run the query, you will find out sedan class BMW X3 is the one which is receiving less number of orders in the category sedan, and you can eliminate that. And if you want to specifically identify a particular dealership name which is having lowest sales, then you can also do that, where category is equals to sedan and dealership name underscore name is equals to Elite Motors, Elite Automobiles. You can also include the dealership name in the column here. and group by category and dealership name. Sum of orders sum of orders ascending, and run this query. And there is some problem here in the query. Dealership name category error, unknown dealership name in the field list. Okay, so Elite Automobiles. Let's copy this from here. So we might have made a spelling mistake in our query, but not a problem. Just place it here, and there you go. Now we must be getting the answer. Okay, dealership name. Okay, we messed out with the dealership name, so we had a spelling mistake in case of dealership name. Yeah, that's the one. And now let's run the query. There you go. So in Elite Automobiles and Sedan class, we have BMW 5 Series in less number of orders received, right? Now, there might be some reason for it. Maybe the location of the dealership, where it is. So there might be chances, right? So where, let's say you are in South India, or let's say you're in North India, or some part of a country where the roads are really wonderful. You don't have a ghat section. You're not living in Western Ghats, and you're having good longer highways. In those segments of roads, you would prefer sedans. But in case if you are in a ghat section, or if you are in a where we have a lot of mountains, a lot of off-roading trekking kind of regions, in those regions you might prefer SUVs, correct? So there is a chance. Now Elite Motors might be in a place where there are some odd roads, not good roads. They might be a hilly region. It might be a region where you don't have good roads, right? Even if you're not in the Western Ghats or a Ghat region, or even if you're not in a region where you don't have any kind of hillies or mountain regions, but the roads are not good, or if you are passionate about it, it might be a trend, right? It might be some cult. If you are coming from a region where there's a good cult for SUVs, right? There might be multiple reasons. So I think that is one of the reasons why there could be a high demand for SUVs or sedans or a specific category of vehicles in a certain region. Now, let's proceed with the next remaining queries or clauses. So far, we have dealt with the with clause, the where clause, and order by, group by clauses. Now, let's proceed with case clause, right? Now, case is something like a switch case where you have, if you're familiar with the switch cases in programming, then case is similar to that in SQL. Now, let's say the dealer wants to identify, or the business owner wants to identify different dealership names based on the profit they make, right? Or the number of the revenue they make. Then he wants to find out the highest profit making category as high profit, the medium profit, and the low profit. So the threshold is like 1 million. If they're making 1 million, then they are under highest category. If they are making in between 50 to 1 million, they're medium. And if they're making lower than that, then they are least profiting. And if they are least profiting, they might have to, the business owner might have to take some decisions, might be like helping them improve their sales, or fixing their contracts, or if they want to collaborate or combine that particular dealership, the high performing one, right? Some business decisions to make sure that everyone is breaking even in their profits. Now let's use the switch statement here. So as I discussed, high profit. So I'm going to take 2 columns here. So selecting the dealership name, sum of profit they are making, and case starts here. When sum of profit, I'm calculating the profit here, revenue minus the cost to company, is greater than 1 million rupees, that is 10 lakh rupees, then it is considered as high profit. And if the profit is between 50,000 or 5 lakhs or 1 million, then it is moderate profit, else low profit. Now, let's run this query, and we're grouping them by dealership. Let's run this query and see the output. There you go. So we have profit categories. Here we have high profit result. Okay, let's minimize this section here. Yeah, there you go. So there are 5 to 6 dealerships we have across the country, and most of them are in high profit, or all of them are in high profit. So if we increase the number to 10 million, so far we had 1 million. So if it is between 5 million to 10 million, now let's run the query and see if we have any. Yeah, so most of them are making good profits here. There you go. So far so good. Now this is how you can use a switch case statement. Now let's say I also want, okay, let's first use the pattern matching case here, kind of like statement we can use here, like clause. Now I want to make sure to identify a specific product. Okay, let's run this query once again where we have the dealership data. Select all from dealership data. So now we have 8 series, X8 series, right? So some of the premium vehicles. Now I'd like to go with X8, BMW X8. So I want to identify the dealership names which are selling X8 series. Now we can write down the query as select dealership name. What you can do is just copy the dealership name so that we don't make any spelling mistakes. I think we wrote dealership. Yeah, we can remove this. Dealership name product from dealership data where product like, or you can use like, I think we don't need to use equals to there, double quotes, mod, percentage or mod, X8 and percentage. Okay, so what am I specifically mentioning here is, I don't care if it is having anything in front of X8 and after X8. So we are damn sure that the series X8 will be released only by BMW. So in few scenarios, the BMW could be in small cases, or there might be no space in between BMW and X8, right? So I don't want to take a chance. So I want the exact details. So I don't care if there is a space or not, if there is anything else. There might be even spelling mistakes, BM or Beamer X8, or the full form of BMW, right? So, and after X8, I don't want to take any chances here as well. It might be series, it might be cars, right? So I want every detail, the dealership name and the product from the dealership data, who is having X8 car in their inventory. There you go. So we have so many dealerships here. So if I have to take the exact names, or if I don't want any repetitions, then I can go with the distinct here. So distinct of dealership names, where we can find out who is dealing with X8 in their inventory. So we have 5 automakers here, 5 dealerships who are having X8 in their inventory. Now let's also have a count, right? So we can make sure that how many number of X8s they have, count of product. So we can understand how many number of, okay, so there is some query mistake here, aggregated without group by. So here we can add another statement, a group by dealership name or distinctive dealership. I'll just go with dealership name here, and order by count of product is sending. Now let's try to run this query by product. Now let's run the query. There you go. So we have City Motors, who has the highest count of BMW X8 series, and they have the biggest inventory, I presume. So in the next upcoming fiscal year, if there is a requirement of importing X8, then you can check out the numbers, right? If you want to import a huge inventory, or if you want to reduce the number. And you can also, if there is a good sale for Asian dealership for BMW X8 series, you can also improvise their numbers as well. So that's how you can use the pattern matching statement. And if you don't want, if you want to exclude X8, then what you can do is just place an I here, I like, or product not like X8. So if you're filtering out X8 and running numbers or codes for every other car but X8, you just want to run that query, and here you can see instead of X8 you can have details repeat, and you can see instead of X8 you have every other detail on every other car. That's how you can go with it. Now let's proceed with the joins in our tutorial for today. Now let's create a use case, right? You wanted to identify all the customers who bought an X8, right? So if you check the data, if we go back to our query here and run the dealership query, and you can see here we have order ID, order date, delivery date, everything, but we don't have customer name. But I want the customer name, but customer name is in the table customer data, right? And here we don't have the product detail what they bought, right? So Vivan, Sai or Vihan are it can be anyone who got an X5 or X8, right? But now I want to know the exact customers who are or who have already placed an order for X8, or you've already delivered that X8, right? Or let's say you wanted to know if they have placed an order for X8. Now in this situation you might want to make use of joins, which join two tables and give you the results. So there are basically a couple of joins that you can use: left join, right join, inner join, outer join, Cartesian join, right? So most of the cases you would just go with the keyword join. So it will basically function like a left join, right? You're choosing the first table and you are choosing the matching data from the right table. Now we want the order ID column, we want the customer name, and also the product name, which is equals to X8, and we want to run a join command based on order ID. So order ID happens to be the primary key based on which you can perform the join. So it could be a little complicated orally, so I will write the query so that you have a better understanding for it. So let's quickly run the query. I'm going to use the select statement here, and we wanted the customer name, right? So we want the customer name, or we have it here, right? Double click, copy the field name so that we don't have any mistakes done, and it is from customer data, right? So customer data dot customer name. Okay, let's also copy the customer data table name as well, right? So that we don't have any mistakes in our query. And want dealership data table name as well, so comma dealership data, and what we want from dealership data is product, and we also want dealership data dot order ID, copy the field name, comma from dealership data join customer data to dealership data on what terms. So order ID is common between customer data and order data, right? So we want order ID equals to order ID, but it will be confusing. So what we can do is join customer data on customer data dot order ID and dealership data dot order ID, right? And we will also use a where clause where product dealership dot product, like again the same statement which is here. There you go. Now we are selecting order ID from dealership data, customer name from customer data, and product name from dealership data from the table dealership data. Join customer data table on customer data dot ID is equals to dealership data dot ID, which is the order ID, where dealership data dot product, right? The product details are in dealership data table, and the product is like anything before X8, anything after X8, because we want the details only for X8, the customers who bought X8. Right, now let's run this query, and there you go. So these are the customers who bought X8s. So we have about 29 results. 29 members are the premium customers who got this premium vehicle X8 series. Now that's how you can use joins in a SQL table, a SQL data query. And so far we have covered joins, we have covered case, we have covered pattern matching, we have covered where clause, group by, order by, and select, and few others. So we have also made a complete documentation out of it. We now know how to create a schema, how to import data, and few protocols to follow when you're importing data, like using an underscore, and we also have covered alter table if you have some mistakes in your column name, how to alter the name of that column, right? So these are the fundamentals that you can know about SQL, and also some advanced concepts like case and joins that you can know about SQL. So far we have covered everything that you must know for a beginner, and also we have covered something if you're an advanced level SQL developer. It's like a brushing up tutorial for you, how to use some clauses like group by, order by, and how to use cases, how to use joins, right?
So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright. So this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause, or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city, and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee from my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select, I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than, I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with two different tables. So suppose you want to display some information that are present in two different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using two tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is, I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table, and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay. Now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay. So first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players, and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write &&. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was $. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top underscore players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top underscore player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top underscore players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now, there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment, stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL underscore IQ database, which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use / I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records, so I'm using this limit keyword and my variable var, which I created here. I'll end my select statement. I'll end my stored procedure with / and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is SP underscore sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is SP underscore sort by salary, the other 2 were top underscore player and top underscore players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is SP underscore sort by salary, and inside this I'll give my parameter, which was actually var, and this var we have used in limit, let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now, instead of a select statement inside a stored procedure, you can also use other statements, let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /, then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in 2 parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says 1 row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore employees, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter. 2// I'll write create procedure followed by the procedure name. It is going to be sp_count employees, and inside this I am going to give my out parameter and the variable name, that is total_EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total_EMPs. From my table, that is EMP_details, where sex is equal to F, which means female, I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp_count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table EMP_details. So I've used my out parameter and I'm creating a new variable called total_EMPs. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total_EMPs. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp_count employees. Now to call it, I'll write call the name of the procedure, that is sp_count employees. Within brackets, I'll pass in the parameter as @f_emp. I'll give a semicolon. Then I'll write select @f_emp as female employees. Okay, so as is an alias name, let's run this one by one. First I'll call my procedure and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now there are mainly 3 types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we will learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I am giving it as 30, finally we have the marks as floating type. So let's create this table, which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter, like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting. If any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. Age is 13. The name is Dave. And let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case, our trigger name is marks_verify_st. I'll just paste this here, and if you run this, it will automatically delete your trigger. I'll give this as a comment. Okay. Now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here, let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is, I'll write create view followed by the view name which is cust_details. Then you write as select. I'm going to select a few column names from my original customer table, which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright. I'll write from my table that is customers. If I run this, my view that is cust details will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name that is cust_details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that, I am going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside Classic Models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there's some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name that is product_description as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, And next, from the product lines table, I want the text description of the products. So I'll write from products table. I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay. So here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay. Now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here, if I just refresh it and I'll expand this, you can see we have the cost details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel, or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be okay. So instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright, now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay. I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over. I want to partition it by department. So I'll write partition by department, which is DEPT, and I'll give an alias as total salary, so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright, now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num. I'll give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name, which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values. I'll give 101. The name is Shane. Give a comma. I'll insert the second student name 102. The name is Bradley. I'll give a comma. This time for 103 we have two records. Let's say the name of the student is Herath. I'll give a comma. I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the fifth student, which is Kevin, we have two records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over, within brackets I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, if you see here, there is just one student in the name Shane. We have one student in the name Bradley. But here if you see, for Herath, the second record it says 2, which means there are 2 records for Herath. And if I scroll down, there is 1 record for Nathan and there are 2 records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when 2 or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable, that is var underscore a, as an alias name, let's say test rank, from my table, that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function assigned the same value, which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function, which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column, that is salary descending. I'll give an alias as highest underscore salary from my table, that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table, Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function, that is first underscore value, followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table, that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial. So let me just scroll through and show you what we did from the beginning. First we learnt about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database, which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. We learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL, which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions. In this tutorial, we will learn how to work with databases and tables using SQL with Python. To do this demo, we will be using our Jupyter notebook and the MySQL workbench. You can see it here. So we will write our SQL queries in the Jupyter notebook with Python-like syntax. If you don't have MySQL or Jupyter notebook installed, so please go ahead and install them first. While installing the MySQL workbench, you will be asked to give the username and password. Let me show you. So I am on my MySQL workbench. So once you connect, it will ask for the username and the password. So I have given my username as root, and password you can give while installing it. We will be using the same user ID or the username and the password to make our connection. So let's get started with our hands-on demonstration part. First and foremost, let me go ahead and import the necessary libraries. I'll give a comment as import libraries. Alright, so first I'll import mysql.connector. Next, from mysql.connector, I'm going to import my error method or the error module. Next, I want to import pandas as PD. So let's run this. Okay, there is some error here. This should be capital E and not small e. Alright, you can see I have imported my important libraries. Now I'm going to create a function that will help us create a server connection. So I'll write my user-defined function by using the def keyword. I'll write create underscore server underscore connection. This is going to be my function name, and it will take in 3 parameters. First is the host name, next is the username, and then we have the user password. Alright, I'll give a colon, and then in the next line I'm going to define a variable which is going to be connection, and I'll assign it to a value called none. Now we'll be using exception handling techniques to connect to our MySQL server. The try block lets you test a block of code for errors, and the except block will handle the errors. So I'll write try and give a colon, and then I'm going to reassign the connection variable to a method which is mysql.connector.connect. Now this mysql.connector.connect method sets up a connection, so it establishes a session with the MySQL server. If no arguments are passed, it uses the already configured or default values. So here we are going to pass in 3 parameters. The first is the host name. I'll write host equal to host name, which is host underscore name. I'll give a comma, then I'll write user equal to user underscore name. Next will be my password, and I'll assign the value user underscore password. Alright, now I'm going to use a print statement and write MySQL database connection successful. After this, I'll give my except block. So I'll use the keyword except. Here I'll write error as err, give a colon, and then I'm going to use the print statement. Here I'm going to use some print formatting techniques using the F letter. I'll write error colon, and I'll use curly braces, give err, and then I'll close the double quotes. After this, I'm going to return my connection. Alright. Let me give a comment here. We are going to assign our password. So we need to put our MySQL terminal password. So this password you assign it while installing MySQL Workbench. I'll write PW and I'll give my password, which is simply@123455, and then I'm going to give my database name. So I'll give database name. Here I'm going to write DB equal to, this is the database I want to create, which is going to be MySQL_Python. Let me just scroll this down. Okay, now I'll say connection equal to, I'll pass in my user defined function name, which is create server connection, and the parameters, which are going to be localhost, that is my host name, my username, which is root, and then I'll give PW, which is my password, that is exactly simply@123455. Let's just run it now. Okay, there is an error here. We need to remove this double quotation. Alright, made another mistake here. This should be root. Okay, you can see here MySQL database connection successful. Alright, next we are now going to create a database, that is MySQL_Python. So I'll give a comment, create MySQL_Python database. Again, to create this database, I'm going to create another user defined function using the def keyword. I'll write the function name as create database, pass in the parameters as connection, query, give a semicolon, and in the next line I'll write cursor equal to, I'm going to make the connection, so I'll write connection dot cursor, and I'll give the parenthesis. So this MySQL's cursor of MySQL connector Python is used to execute statements to communicate with the MySQL database. The MySQL cursor class initiates objects that can execute operations such as the MySQL statements. Okay, next I'm going to again use my try and except block. So I'll write try, give a colon, and here I'm going to use cursor dot execute. Within that I'm going to pass in my query. Next I'll use a print statement, and the message I'm going to display is database created successfully. After this I'm going to write my except block. I'll write except error as err, give a colon, and then I'll use a print statement. I'll write print, I'll use the formatting again, error colon, then I'll write within single quotes, I'll give curly braces err, and then I'll close the double quotes. Next let's use the variable create underscore database underscore query, and here I am going to write my SQL query to create the database. So I'll write create database, and followed by that I'll give my database name, which is going to be mysql underscore python. Okay. After this, I'll call my function, which is create database, and I'll pass in the parameters. The first one is connection, and next the query is create underscore database underscore query. Let me just copy it, and I'm going to paste it here. Alright, so what I'm doing here is I am creating a new function, that is to create a new database with the name mysql underscore python, which you can see it here. Now this function takes in two parameters, connection and query. I'm using the connection.cursor function, which is often used to execute SQL statements using Python language. And then I have created my try and exit blocks. So this try block statements will try to create my new database, which is mysql underscore python. In case it fails to create the new database, the exit block will work. So here I am writing my SQL query to create a new database, which is create database followed by the database name, and I am assigning it to a variable which is create database query, and then I'm calling my function create database and passing in the two parameters, connection and the query. Alright, so let's just run it. Alright, you can see here it has created my database successfully. Now you can verify this by checking the MySQL workbench or the MySQL shell. You can see on the MySQL workbench here on the left panel under schemas, there is a database called mysql underscore python. Let me just expand it. Now we haven't created any table, so it's not showing it now. The next step, we are going to connect to this database. So let's go ahead and connect to our database that we have just created. I'll write the comment as connect to database. Now to connect to our database, I'm again going to create a user defined function using the def keyword. I'll write create underscore db, which is for database underscore connection, and the parameters it will take is the host name followed by the username, then we have the user password, and finally we have the database name. I'll give a colon. In the next line, I'm going to create my variable, which is connection, and then I'll assign it to a value none. After this, I'm going to use my exception handling techniques. So I'll write my try block first. I'm going to reassign my connection variable using the MySQL connector method. So I'll write mysql dot connector dot connect. So this method will take in the parameters. So first it will take the host name. I'll write host equal to host underscore name. I'll give a comma. Next it will take the username, so user equal to user underscore name. Give another comma. Next it will take the user password. I'll use passwd equal to user underscore password. I'll give another comma, and this time it is going to be the database name. So I'll write database equal to db underscore name. Now let's use the print statement, and the message we are going to print is MySQL database connection successful. Alright, finally we'll write my except block. I'll write except error as ERR, give a colon, and then I'll use the print statement. F within double quotes I'll write error colon, within single quotes curly braces I'll write ERR, and will close the double quotes. Finally, this function will return the connection value. Alright, let's run it, and there you go. It has run successfully, so we have connected to our database. Now it's time for us to execute SQL queries. I'll give another comment saying execute SQL queries. Alright, now to execute our SQL queries, I'll use another user-defined function, which is execute underscore query, and I'll pass in the parameters as connection and query. I'll give a colon. I'm going to write cursor equal to connection dot cursor. Now this is used to establish a connection and run SQL statements. Next we'll use the try and except block, so I'll write try cursor dot execute. This will take in one parameter, which is going to be my query, and then I'll write connection dot commit, which is another method. Now let's use the print statement. So I'll write print, let's say the message would be query was successful, and then we'll write our except block, which is except if the try block doesn't work, throw an error using the print statement. Within double quotes, inside the curly braces, I'll write ERR and close the double quotes. Alright, so let's run it. Okay, so we have successfully created our various functions that were needed to create a database, establish a connection, and to execute our queries. Alright, now it's time for us to create our first table inside the MySQL_Python database. So to do that, I'm going to write my create command in SQL. So first we are going to assign our SQL command to a Python variable using triple quotes to create a multi-line string. So let me show you how to do that. I'll write my variable name, which is going to be create orders table. It is always recommended to use relevant variable names to make it more readable. And now I'm going to use triple quotes. So the triple quote will ensure I can create my multi-line string. Inside the triple quote, I am going to write my create command, which is create table. Here I am going to create an orders table first, and inside the orders table I am going to create my column names. The first column would be the order ID. It is going to be of type integer, and I'll assign this order ID as my primary key column. We'll give a comma. Next, the second column would be customer underscore name. The customer name column would be of type varying character, so I'll write varchar and I'll give a size of 30, and this is also going to be not null. Moving ahead, my fourth column would be the product name column, so I'll write product underscore name. Product name will be of type varying character. The size is, let's say, 20, and it is also not null. Next, I'm going to create my fourth column, which is the date on which the item was ordered or the product was ordered. So I'll write date ordered. The data type will be date. Next, I'll create a quantity column to keep track of the number of quantities that were ordered. This is of type integer. My next column would be unit price, which will basically have information about the price of each unit of product. Unit price can be of type float. And finally, I'll have the phone number of the customer. I'll write phone number. Phone number can be kept as of type varying character. I've assigned a size of 20. Now let's give a semicolon and we'll close the triple quotes. Alright, so this is how the syntax would look like. Next, to run this, we are first going to call our createDB function. So let me give a comment as connect to the database. I'll write connection equal to create underscore db underscore connection. My parameters would be my host name, which is localhost, my username, which is root, comma, my password, and then my database name, which is mysql underscore python. So I'll write just db. Alright. Finally, let's execute this query using the execute underscore query function that we had created earlier. This takes in two parameters. The first one is connection, followed by the variable name, which is create orders underscore table. Let us run it. Okay, there is some error here. Let's see what's the error. Okay, so here we have put 4 double quotes. This should be triple quotes. Now let's run it. Okay, there is another here. Let's debug it. It says name cursor not defined. Let me just roll it to the above cell. If you see here in our execute underscore query function, instead of cursor, I have written cursor. So R is missing. Let's rerun this. And now let's run this again. There you go. You can see here MySQL database connection successful. Even our query was also successful. Now if you want to recheck if the table, that is orders, was created or not, you can check it on the MySQL workbench. So let me show you how to do it. So I am on my MySQL workbench, and under MySQL underscore Python database you have something called as tables. Let me just right click and I'll select refresh all. There you go. You can see this arrow. Just click on this arrow and here you can see we have a table called orders. So we have created a table called orders. Now you can check the columns as well. You have the order ID, the customer name, product name, ordered date, quantity, unit price, and phone number. Now it's time for us to insert a few records to this table, which is orders. Now to insert records, I'll give a comment as insert data. I'll start with the variable name. Let's say the variable name is data underscore orders. I'll give triple quotes. Next, I'll write my insert into command. So I'll write insert into. my table name, that is orders, followed by values, and now I'll start entering my records for each of the rows. So first I'll give 101, which is the order ID. Then I'll give the customer's name, let's say Steve, and the product he had ordered is, let's say, laptop. Then I'll give my date in which the item was ordered. Let's say it is 2018. I'll choose 06 as the month and the date is, let's say, 12. I'll give another comma. This time we'll pass in the quantity, which is 2. Let's say the price of each laptop was $800, and we'll give a phone number. This is random, let's say 62937330, let's say 802. Alright, similarly I am going to insert 5 more records of different customers and their items that they have purchased to this table orders. So here on my notepad I have my rest of the 5 records. Let me just copy it and we'll paste it in the cell here. This will save us some time. Okay, let me recheck if everything is fine. I'll give a comma here. Alright, so we have 6 customers in our table which have their customer IDs from 101 to 106. We have Steve, Jaws, Stacy, Nancy, Maria and Danny. You have the different items they have purchased: laptop, books, trousers, t-shirts, headphones and smart TV. This is the date on which they had ordered this item, the number of quantities they had ordered, and then we have the unit price and some random phone numbers. So let's create the connection now. I'll write connection equal to, I'll write create underscore db underscore connection. Then I'll going to give my same parameters. Let me just copy it from the top, which is localhost, the host name, root is my username, then we have password and the database name, and then I'll use the same query as above, which is execute query. I'll copy this, paste it here, and instead of create orders table variable, I'll put as data underscore orders. So this will store my insert into command. You can see the variable I've used here is data underscore orders. Now it's time, let's just run it. Alright, there was some mistake here. Let's debug it. Again, this should be triple quotes and not 4. Now let me rerun it again. There you go. You can see here my SQL database connection successful and my query was also successful. Now we'll create another user-defined function which will help us read query and display the results. So I'll write my function name as def read underscore query. This will take in 2 parameters, connection and query. Then I'll write cursor equal to connection dot cursor. I'll put my result as none, and then I'll use my try and accept block. I'll write try cursor dot execute. This will take in 1 parameter, which is query, and then I'll give another variable which is result equal to cursor dot fetch all. Now this fetch all method will return all the results in the table. I'll write return result. Next we'll use the accept block. So I'll write accept error as err, give a colon, and I'll use my print statement. Scroll this down. I'll use my formatting f error, give a colon followed by a space, within single quotes inside curly braces I'll give err and close my double quotes. Let's run it. Alright, so now we are all set. Now we are going to use our select clause, having, whereby, then we'll see how to use order by clause, some inbuilt functions, we'll update some records, delete some records, and do a lot of other stuff. So let's start with our first query. So our first query is going to be using the select statement. Alright, so suppose I want to display all the records that we have inserted into our orders table. So the way to do is, I'll assign my query to a variable, let's say q1. I'll give triple quotes. Within triple quotes, I'll write select star from orders. I'll give a semicolon followed by the triple quotes. Now we'll establish the connection. So let me just go to the top and I'll copy this line, which is to connect to our database. I'll paste it here. Now we'll create a variable called results that will store the result of this query, and we are going to assign this variable to our function, that is read query, and this read query will have two parameters, the connection and the variable name, which is q1 for the query. Next, to display, I'm going to use a for loop. I'll write for results, for result in results print, I'll say result. Now we are done. Let's just run this query. There you go. You can see here we have successfully printed all the rows in our table, which is orders. You can see we have 6 records in total. Now we are going to explore a few more queries. So let me just copy this and we are going to edit in the same query. I'll paste it here. Next, let's say you want to display individual columns from the table and not all the columns. So let me create the variable q2. Now instead of star, I'm going to display only the customer name and let's say the phone numbers of the customer. So I'll write phone underscore number. Alright, the rest all remains the same. Let me just recheck it, and here instead of q1 we'll put q2, and let's run this cell. Alright, you can see here now we have displayed only 2 columns. The first column is the customer name and then we have their respective phone numbers. Okay, now let me just paste that query again. Now we are going to see how you can use an inbuilt function, that is, in our table we have the order date, and from the order date we are only going to display the different years that are present in the order date. So to do that, I am going to use the year function. I'll edit this query. Instead of q1 I'll make it q3, and here I am going to write select year, which is my function name, from my column which is date ordered, from orders, and here I'll change this to q3. q1, q2, q3 are basically query 1, query 2 and query 3. Let's run it. There you go. So we have successfully extracted the different years present in the order date column. Now if you want to display the distinct or the unique dates present in the column, you can use the distinct keyword in the select statement. So the way to do it is, I'll write select distinct, give a space, the rest of the query remains the same, and here in q3 I'll write q4. I'll make this as q4. Let's run it. You can see 2018 and 2019 are the unique year values that are present in the order date column. Okay, now moving ahead, let's write our fifth query, and this time we are going to explore how you can use the where clause. So I'll change this to q5 before I write my query. So let's say you want to display all the orders that were ordered before 31st of December 2018. So to filter this, we are going to use the where clause. So I'll write select star from orders. Next, I'll write where my date underscore ordered is less than, within quotes, I'll give my date value, which is 2018 December 31st. So all the items or the products that were ordered before 31st of December 2018 will be displayed. So let's run it. Alright, you can see here there are 3 orders in our table which have been ordered before 31st of December. Now moving ahead, we want to display all the orders that were made after 31st of December. So here what you can do is, I'll just copy the above query again. I'll copy this line. So instead of less than 31st of December 2018, I'll make it as greater than. So every order that was placed after 31st of December will be displayed. If you run it, so you can see here there are 3 orders in our table which were ordered after 31st of December 2018. Now moving ahead, let's write a 7th query. Now let's see how the order by clause works in SQL. So you can filter your results based on a particular column or sort it based on a particular column. So this is going to be my query 7. I'll write it from scratch again. Let's say you want to display all the columns from the table. So I'll write select star from orders. Then I'm going to use order by unit price. I'll give a semicolon. Let's run this query and see the output. Now if you see the result here and you mark the unit price column, the result has been ordered in ascending order of unit price. You see here it starts with the lowest price and then goes on with the highest price towards the end. Now if you want to order it in descending order, you can use the keyword DESC. So this will ensure your top or the most expensive products appear at the top and the least expensive products appear at the bottom. Alright. Next, now let's see how you can create a data frame from the given table. So as you know, using Jupyter Notebook and Pandas, you can create data frames and work on it very easily. So with this table also we can create our own data frame. So for that, let me create an empty list first. I'll write from db equal to, I'll assign this as an empty list. So we are going to return a list of lists and then create a Pandas data frame. Next, I'll write my for loop. I'll write for result in results. I'll assign result to list of results. So I'm converting the result into a list and then I'm going to append it to the empty variable or the empty list, which is from underscore db dot append. I'll append the result to my empty list. Next, we need to pass in the columns now that will be part of our data frame. So I'll write columns equal to this column. I'll pass it within a list. So I'll give my first column as order ID. Then we have the customer name. Next, I have my product name. Then I have the date on which it was ordered. Give a comma. Then we'll have the quantity column. Let me write it in the next line. Next, we have the unit price column. And finally, we have the phone number column. So I'll write within double quotes phone number, and this we are going to assign it to a data frame. So I'll be using pd dot data frame, which is my function to convert a list into a data frame. My variable I'm going to pass is from underscore db, and I'll write my next argument is columns equal to my variable name, that is columns. Finally, let's display the data frame, which is df. Alright, so here I'm creating a empty list first, and then I'm creating a for loop, and I'm appending the results to my empty list. Here you can see I have created my column list, and using pd.dataframe I'm converting the list into a data frame. If I run this is append and not appends. Alright, you can see we have our data frame ready. This is the index column, it starts from 0 onwards, and then we have the different column names. Okay, now let's see how to use the update command. Now suppose you want to change the unit price of one of the orders, you can use the update command. So the way to do it, I'll first create my variable, let's say update, and I'll give 3 quotes or triple quotes. Then I'll use my update command, which is update followed by the table name, that is orders. Next I'll write set, let's say unit underscore price. If you see this, let's say I want to set the unit price of trousers from $50 to, let's say, $45. I want to update this particular record, so I'm going to write set unit price column equal to $45, where the order ID equal to 103. So this query will update the third row in our table, which is order ID 103. So it will update from $50 to $45. I'll close the triple quotes, and now I'll use the connection queries again. Let me just paste it here. Alright, I'll delete these 3 lines of code, and instead of that I'll put execute underscore query, and this will take into parameters as always, which is going to be connection followed by the variable name, that is update. Let's run it. You see here it says MySQL database connection successful, query was successful. Now you can recheck that. To do it, let me just go to the top and we'll just copy our first query, which is Q1. I'll copy this and I'll paste it here. Let me just rename this now. This will be Q8, and I'll change this as well. I'll write select star from orders, where my order ID equal to 103. Let's see the unit price of 103 now. You can see here instead of 50, now we have updated it to $45. Alright, now the last command we are going to say is how you can delete a record from the table. I'll write delete command as my comment. Now to delete a query, I'll first give my variable name, which is delete underscore order, and I'll pass in within triple quotes. Next I'll write my delete query, which is delete from my table name, that is orders. Then I'll give my where clause, where let's say I want to delete my order ID 105. Let me just go to the top and explain you again. So if you say this, we want to delete the order ID 105, which was for customer name Maria and she had ordered headphones. We want to completely remove this particular record. So I have my delete query ready. Now let me just create my connection and display the results. So I'll go to the top and I'll copy this connection command, which also has the execute query command, and I'll paste it here. And I'm going to make a change here. Instead of update, we'll write delete_order. Everything looks good. Let's just run it. You can see our query was successful. And now if you want to print it, let me just show you. I'll just copy this. We'll paste it here. I'll make this as Q9. I want to verify if my order ID 105 was deleted or not. Instead of this statement, I'll write select star from orders, and here I'll change this to Q9. If I run this, you can see it here. You can mark order ID 105 was deleted and it no more appears in this table. Alright, so this brings us to the end of the demo session on SQL with Python. Let me just scroll you through what we did. So first we imported the important libraries, MySQL connector, then we imported the error function, then we imported pandas using PD. We learned how to create a server connection to MySQL database. We created a new database, that is MySQL_Python, and now we connected to that database. We created a function to execute our queries. We saw how you can write a create table command. Then we inserted a few records to our orders table. We created a read_query command to read the queries and display the results. Then we started exploring our different SQL commands one by one. We saw how to use select query. Then we selected a few individual columns from our table, followed by using a inbuilt function which was year. Then we saw how to use the distinct keyword. After that, we used our where clause to filter our table based on specific conditions. We saw how to order your results based on a particular column. Then we saw how you could convert the table into a data frame using pd.dataframe function. Finally, we learned how to use the update command and the delete command. PostgreSQL is a very popular and widely used database in the industries. In this tutorial, we will learn PostgreSQL or PostgreSQL in detail with an extensive demo session. So in today's video, we will learn what PostgreSQL is and look at the history of PostgreSQL. We will learn the features of PostgreSQL and jump into performing PostgreSQL commands on the SQL cell and pgadmin. So let's begin by understanding what is PostgreSQL. PostgreSQL is an open source object relational database management system. It stores data in rows with columns as different data attributes. According to the DB Engine's ranking, PostgreSQL is currently ranked 4th in popularity amongst hundreds of databases worldwide. It allows you to store, process and retrieve data safely. It was developed by a worldwide team of volunteers. Now, let's look at the history of PostgreSQL. So in 1977 onwards, the Ingress project was developed at the University of California, Berkeley. In 1986, the Postgres project was led by Professor Michael Stonebraker. In 1987, the first demo version was released, and in 1994, a SQL interpreter was added to Postgres. The first PostgreSQL release was known as version 6.0 or 6.0 on January 29, 1997, and since then, PostgreSQL has continued to be developed by the PostgreSQL Global Development Group, a diverse group of companies and many thousands of individual contributors. Now, let's look at some of the important features of PostgreSQL. So PostgreSQL is the world's most advanced open source database and is free to download. It is compatible as it supports multiple operating systems such as Windows, Linux and Mac OS. It is highly secure, robust and reliable. PostgreSQL supports multiple programming interfaces such as C, C++, Java and Python. PostgreSQL is compatible with various data types. It can work with primitives like integers, numeric, string and boolean. It supports structured data types such as date and time, array and range. It can also work with documents such as JSON and XML. And finally, PostgreSQL supports multi-version concurrency control or MVCC. Now with this theory knowledge, let's look at the PostgreSQL commands that we will be covering in the demo. So we will start with the basic commands such as select, update and delete. We will learn how to filter data using where clause and having clause in SQL. We will also look at how to group data using the group by clause and order the result using the order by clause. You will learn how to deal with null values, get an idea about the like operator, logical operators such as AND and OR. We will also explore some of the popular inbuilt mathematical and string functions. Finally, we'll see some of the advanced concepts in PostgreSQL, that is, to write case statements, subqueries, and user-defined functions. So let's head over to the demo now. Okay, so let's now start with our demo. So first we'll connect to PostgreSQL using PSQL cell. So here under type here to search, I'll search for PSQL. You can see this is the SQL cell. I'll click on open. Let me maximize this. Okay, so for server I'll just click enter. Database I'll click enter. Port number is already taken, which is 5432. I'll hit enter. Username is already given, and now it is going to ask for password. So here I'll give my password so that I can connect to my PostgreSQL database. So it has given us a warning, but we have successfully connected to PostgreSQL. Alright, so now to check if everything is fine, you can just run a simple command to check the version of PostgreSQL that we have loaded. So the command is select version with 2 brackets and a semicolon. I'll hit enter. Okay, you can see the version PostgreSQL 13.2. Okay, now let me show you the command that will help you display all the databases that are already there. So if I hit /L and hit enter, it will give me the list of databases that are already there. So we have PostgreSQL, there's something called template 0, template 1, and we have a test database as well. Okay, now for our demo, I'll create a new database. So first I'll write create space database, and I'll give my database name as SQL_demo. I'll give a semicolon and hit enter. You see we have a message here that says create database. So we have successfully created our SQL demo database. Now if you want to connect to that database, you can use \c space SQL_demo. There you go. It says you are now connected to database SQL_demo. So here we can now create tables, we can perform insert operation, select operation, update, delete, alter, and much more. Now I'll show you how to connect to PostgreSQL using pgadmin. So when you install the PostgreSQL database, you will get the SQL cell, and along with that you also have the pgadmin. So I'll just search for pg. You can see here it has prompted pgadmin. I'll click on open. This will open on a web browser. You can see it has opened on Chrome, and this is how the interface of pgadmin looks like. It is a very basic interface. So on the top you can see the files, we have object, there's tools, and we have the help section as well. And here you have dashboard, properties, SQL, statistics, dependencies, dependence, and here on the left panel you have servers. Let me just expand this so it will connect to one of the databases. Alright, so if I go back, you see when I had run \L to display the databases, it had shown me PostgreSQL and test. Now you can see here we have the PostgreSQL database and the test database. Alright, now we also created one more database, which was SQL demo. So let me show you how to work on this pgadmin and the query tool. Alright, so I'll right click on SQL demo and I'll select query tool. I'll just show you how to run a few commands on the query tool. So let's say you want to see the version of PostgreSQL that you are using, so you can use the same command that we did on PSQL cell, which is select version closed with brackets and a semicolon. I'll select this, and here you can see we have the execute button. So if I hit execute or press F5, it will run that query. You can see we have the output at the bottom and it says PostgreSQL 13.2 compiled by Visual C++. It has a 64-bit system. Okay. Now let me tell you how to perform a few basic operations using PostgreSQL commands. So here, let's say I'll write select 5 into 3. I'll give a semicolon, select this and hit F5. So this will run the query and it returns me the result, that is the product of 5 and 3, which is 15. Similarly, let's edit this. Let's say I'll write 5 plus 3 plus, let's say, 6. I'll select this and hit F5 to run it. It gives me the sum of 5 plus 3 plus 6, which is 14. Now the same task you can do it on this cell as well. Let me show you how to do it here. So let's say I'll write select. Let's say I want to multiply 7 into, let's say, 10. You know the result, it should be 70. If I hit enter, it gives me 70. Now this question mark column question word, we'll deal with this later. Alright, let me go back to my PG admin again. Let me do one more operation. Let's say this time I'll write select 5 multiplied by, and within brackets I'll write 3 plus 4. I'll give a semicolon. So what SQL will do is, first it will evaluate the expression that is there inside the bracket, that is 3 plus 4, which is 7, and then it will multiply 7 with 5. Now let me select this and I'll hit execute. So you can see 7 multiplied by 5 is 35. Alright, now we'll go back to our shell and here I'll show you how to create a table. So we are going to create a table called movies on the cell, that is PSQL cell. So here we will learn how you can create a table and then you can enter a few data into that table. Alright, let me just scroll down a bit. Okay, so my create command goes something like this. So I'll write create table followed by the table name, that is movies. Next, my movies table will have a few columns. Let's say I want the movie ID. After the column name, we need to give the data type. So movie ID, I'll keep it as integer. So integer is one of the data types that is provided by PostgreSQL. Next, my second column in the table would be the name of the movie. So I'll write movie underscore name. So all the variables or the column names should be as per SQL standards. So there shouldn't be any space between the column names. So I have used underscore to make it more readable. So my movie name will be of type varchar or variable character or varying character, and I'll give the size as 40 so that it can hold 40 characters maximum. Next, my third column will have the genre of the movie. So I'll write movie underscore genre. Again, genre is of type varchar. I'll give the size as, let's say, 30. And my final and the last column will have the IMDb ratings. So I'll write IMDb underscore ratings. Now the ratings will be of type real, since it can have floating or decimal point values. If I close the bracket, I'll give a semicolon and I'll hit enter. There you go. So we have successfully created a table called movies. Now let me go back to my PG admin. Alright, so here I have my database, that is SQL demo. I'll just right click on this and click on refresh. Now let me go to schemas. I'll just scroll down a bit. Here under schemas we have something called as tables. Let me expand this. Okay, so you can see we have a table called movies in the SQL demo database now. and here you can check the columns that we have just added. So our movies table has movie ID, movie name, genre and ratings. Alright, now there is another way to create a table. The previous time we created using the SQL cell. Now I'll tell you how to create a table using the pgadmin. So here under tables, I'll right click and I have the option to create a table. So I'll select table. Okay, so it's asking me to give the name of the table. So this time we are going to create a table called students. So I'll write my table name as students. Alright, these will be default as it is. Now I'll go to the columns tab. So here you can create the number of columns that you want. So you can see on the right I have a plus sign. I'll just select this so that I can add a new row. So my first column would be, let's say, the student roll number. I'll write student underscore roll number. Again, the column name should be as per SQL standards. The data type I'm going to select is integer. Alright, now if you want, you can give these constraints such as not null, so that student roll number column will not have any null values. And I'll also check primary key, which means all the values will be unique for roll numbers. Alright, now if you want to add another column, you can just click on that plus sign, and let's say this time I want to give the student name as my second column. So I'll write student underscore name. Student name will be of type, let's say, character varying. If you want to give the length, you can specify the length as well, let's say 40. I'll click on the plus sign again to add my final column. The final column would be gender. So gender, I'll keep this time as type character. Okay, now you can click on save, so that will successfully create your students table. There you go. So here on the left panel you can see earlier we had only one table, that was movies, and now we have two tables. So one would be added, that was students. So if I expand this under columns, you can see we have the three columns here: student roll number, student name and gender. You can also check the constraints. It will tell you if you have any constraints. So you can see it says students roll number, there's one primary key. Alright, now let me run a select statement to show the columns that we have in the movies table. So I'll write select star from movies, give a semicolon, and let me execute this. Okay, so here on at the bottom you can see we have the movie ID, the movie name, movie genre and IMDb ratings. Now the next command we are going to learn is how to delete a table. So there is one way by using the SQL command, that is drop table followed by the table name. Let's say you want to delete students. You can write drop table students and that will delete the table from the database. This is one of the methods, so you just select and run it. Now the other way is to, you just right click on the table name and here you have delete/drop. If I select this, you get a prompt, are you sure you want to drop table students? I'll select yes. So you can see we have successfully deleted our students table. Alright, now let's perform a few operations and learn a few more commands in PostgreSQL. So to do that, I'm going to insert a few records to my movies table. So for that, I'll use my insert command. So I have my insert query written on a notepad. I'll just copy this and I'll paste it on my query editor. Okay, so let me just scroll down. Alright, so here you can see I have used my insert command. So I have written insert into the name of the table, that is movies, and we have the movie ID, the movie name, movie genre and IMDb ratings. And these are the records or the rows. So we have the first record as movie ID 101. The name of the movie is a very popular movie which is Vertigo. Then we have the movie genre, that is mystery. It is also a romance movie. And then we have the IMDb ratings, the current IMDb rating, that is 8.3. Similarly, we have Shawshank Redemption, we have 12 Angry Men, there's The Matrix, 7, Interstellar, and The Lion King. So there are total 8 records that we are going to insert into our movies table. So let me just select this and hit execute. Okay, you can see it has returned successfully 8 records. Now if I run select star from movies, you can see the records that are present in the table. So I'll write select star from movies, I'll select this and I'll execute it. There you go. At the bottom you can see 8 rows affected. If I scroll this down, you have the 8 records of information in the movies table. Alright, now if you want to describe the table, you can go to the SQL cell, and here if you write \D and the name of the table, that is movies, this will describe the table. So here you have the column names, this has the data type, and here you can specify if there are any null values or any constraints like default constant or primary key or foreign key and others. Let me go back to my pgadmin. Okay, now first and foremost, let me tell you how to update records in a table. So suppose you have an existing table and by mistake you have entered some wrong values and you want to update those records later. You can use the update query for that. So I'm going to update my movies table and I'll set the genre of movie ID 103, which is 12 Angry Men, from drama to drama and crime. So in our current table we only have genre as drama for 12 Angry Men. I am going to update this column, which is the movie genre, to drama and crime. Okay, so let me show you how to do it. I'll write update followed by the name of the table, that is movies. Go to the next line. I'll write set, then I'll give the column name, which is movie underscore genre, equal to, I'm going to set it as drama, comma, crime. Earlier it was only drama, and I'll give my condition using the where clause. We'll learn where clause in a bit. So I'll write where movie underscore ID is equal to 103. So here our movie ID is the unique identifier. So it will first look for movie ID 103. It will locate that movie and it'll change the genre to drama and crime. So now you can see the difference. Earlier we had 12 Angry Men as drama as the movie genre. Now if I run this update statement, okay, you can see we have successfully updated one record. Now let me run the select statement again. Okay, so here you can see if I scroll down, there you go. So movie ID 103, movie name 12 Angry Men, we have successfully updated the genre as drama, crime. Okay, now let me tell you how you can delete records from a table. So for that you can use the delete command. So you'll write delete from the table name, that is movies, where, let's say I want to delete the movie ID 108, which is the Lion King. So I'll write where movie underscore ID is equal to 108. This is one of the ways to delete this particular movie, or you can give, let's say, where movie name is equal to the Lion King. Let me select this and I'll hit execute. Now if I run my select query again, you see this time it has returned 7 rows and you cannot find movie with movie ID 108, that was the Lion King. So we have deleted it. Alright, next we are going to learn about where clause in PostgreSQL. So to learn where clause, I'll be using the same movie table again. Let's say we want to filter only those records for which the IMDb ratings of the movies is greater than 8.7. So this is my updated table now. I want to display only those records or those movies whose IMDb ratings is greater than 8.7. So we'll display 12 Angry Men, which is 9. Then we are going to display The Dark Knight, which is again 9. And we are also going to display the Shawshank Redemption, which has 9.3. The rest of the movies have an IMDb rating less than 8.7. So we are not going to display those. Alright, so let me show you how to write a where clause. So I'll write select star from movies where I'll give my column name, that is IMDb underscore ratings is greater than, I'll use the greater than symbol, then I'll pass my value, that is 8.7. I'll give a semicolon and let's run it. I'll hit F5. There you go. So we have returned the Shawshank Redemption, The Dark Knight and 12 Angry Men because only these movies had IMDb ratings greater than 8.7. Okay. Now let's say you want to return only those movies which have IMDb ratings between 8.5 and 9. So for that I'm going to use another operator called between along with the where clause. So let me show you how to use between with where clause. I'll write select star from movies where my IMDb underscore ratings is between, I'll write 8.5, I'll give an AND operator and 9.0. So all the movies that are between 8.5 and 9.0 ratings will be displayed. So let's select this and I'll run it. There you go. So we have returned The Dark Knight, The Matrix, The 7, Interstellar, and we have the 12 Angry Men. So a few of the records that we missed out were, I think, Vertigo, which has 8.3, and there's one more. Alright. Now moving ahead, let's say you want to display the movies whose movie genre is action. You can see in our table we have a few movies whose genre is action movie. So you can do that as well. I'll write select star from movies where the movie genre, I'm writing this time in one line. You can break it into 2 lines as well. I'll write movie underscore genre, which is my column name, equal to, I'll give within single quotes action. Now why single quote? Because action is a string, hence we need to put it in single quotes. If I run this, there you go. So we had one movie in our table whose movie genre was action, that is The Dark Knight. Okay. Now you can also select particular columns from the table by specifying the column names. Now here in all the examples that we saw just now, we are using star. Now star represents, it will select all the columns in the table. If you want to select specific columns in the table, you can use the column names. So you can specify the column names in the select statement. Let me show you. Let's say you want to display the movie name and the movie genre from the table. So you can write select movie underscore name, comma, I'll give the next column as movie underscore genre from my table name, that is movies where, let's say, the IMDb underscore ratings is less than 9.0. So this time in our result it will only show 2 columns, that is movie name and movie genre. Let me run it. There you go. So these are the movie names and the movie genres you can see that have an IMDb ratings less than 9.0. Alright, like how you saw the between operator, there is one more operator that you can use with the where clause, that is the in operator. So the in operator works like a or clause or an or operator. So let's say I want to select all the columns from my movies table where the IMDb ratings is in 8.7 or 9.0. If I run this, it will display only those records whose IMDb ratings is 8.7 or 9.0. Alright, so up to now we have looked at how you can work on basic operations in SQL like your mathematical operations. You saw how a select statement works. We created a few tables, then we inserted a few records to our tables. We saw how you can delete a table from your database, and we have performed a few operations like update, delete, and we saw how a where clause works. Now it's time to load a employee CSV file or a CSV dataset to PostgreSQL. So I'll tell you how you can do that. But first of all, before loading or inserting the records, we need to create an employee table. So let me first go ahead and create a new table called employees in our SQL_demo database. So I'll write create table. My name of the table would be employees. Next, I'm going to give my column names. So my first column would be employee ID. So the employee ID will be of type integer. It is not going to contain any null values. So I'll write not null, and I'll give my constraint as primary key. So the employee ID, as you know, is unique for all the employees in a company. So once I write primary key, it will ensure that there are no repetition in the employee IDs. Okay. Next, I'll have my employee name. So my employee name is going to be of type varchar, and I'll give my size as 40. Okay. Next, we'll have the email address of the employee. Again, email address would be of type varchar and the size is 40 again. I'll give another comma. This time we'll have the gender of the employee. Gender is again varchar of size, let's say 10. Okay. Now let's include a few more columns. We'll have the department column. So I'll write department varchar. Let's say the size is 40. Then let's say we'll have another column that is called address. So the address column will have the country names of the employees. Address is also varchar. And finally we have the salary of the employee. Salary, I'm going to keep it as type real. So real will ensure it will have decimal or floating point values. Okay, so now let me select this create table statement and execute it. Alright, so we have successfully created our table. If you want, you can check by using select star from employees. Let me select this and I'll hit execute. Alright, you can see we have our employee ID as primary key. There's employee name, email, gender, there's department, address and salary. But we don't have any records for each of these columns. Now it's time for us to insert a few records to our employees table. Now to do that, I'm going to use a CSV file. So let me show you how the CSV file looks like. Okay, so now I am on my Microsoft Excel sheet, and on the top you can see this is my employee data.csv file. Here we have the employee ID, the employee name, email, gender, there's department, address and salary. Now this data was generated using a simulator, so this is not validated, and you can see it has a few missing values. So under email column we have a few employees who don't have an email ID. Then you can see under department also there are some missing values here as well. Alright, so we'll be importing this table or the records present in this CSV file onto PostgreSQL. Alright, so here in the left panel under tables, let me right click and first refresh this. There you go. So initially we had only movies table and now we also have the employees table. Now what we need to do is I'll right click again, and here you see we have the option to import or export. Let me click on this, and I don't want to export, I need to import, so I'll switch on import. Alright, now it is asking me to give the file location. So let me show you how to get the file location. So this is my file location actually. So my Excel file, which was this, is present in my E drive under the data analytics folder. I have another folder called PostgreSQL, and within the PostgreSQL folder I have my CSV file, that is employee data.csv. So I'll just select this. You can either do it like this or you can browse and do. Okay, now my format is CSV. Next, I'm going to select my headers as yes, and then let me go to columns and check if everything is fine. Alright, so I have all my columns here. Let's click on OK. You can see I have a message here which says import _ export. Alright, so here you can see successfully completed. We can verify this by using select star from employees again. If I run this, alright, let me close this. There you go, it says 150 rows affected, which means we have inserted 150 rows of information to our employees table. You can see we have the employee ID, these are all unique. We have the employee name, the email, we have the address and the salary. Let me scroll down so that, okay, you can see we have 150 rows of information. That means we have 150 employees in our table. Okay, now we are going to use this employees table and explore some advanced SQL commands. Now there is an operator called distinct. So say if I write select address from employees, this is going to give me 150 address of all the employees. There's some problem here, I did a spelling mistake. There should be another D. If I run this again, our query will return 150 rows. You can see we have the different country names under address, that is Russia, we have France, there's United States, we have Germany, okay, and I think we have Israel as well. Yeah. Now suppose you want to display only the unique address or the country names, you can use the distinct keyword before the column name. So if I write select distinct address from employee, it will only display the unique country names present in the address column. If I run this, see, it has returned us 6 rows of information. So we have Israel, Russia, Australia, United States, France and Germany. Alright, now as I said, there are a few null values which don't have any information. So you can use the isNull operator in SQL to display all the null values that are there. Suppose I want to display all the employee names where the email ID has a null value. So I'll write select star from employees where email is null. So this is another way to use your where clause. If I select and run this, there you go. So you see here for all these employee names there was no email ID present in the table. So it has returned us 16 rows of information. So around 10% of employees do not have an email ID, and if you see, a few of them do not have an email ID and also they don't have a department. So if you want to know for those employees which do not have a department, you can just replace where department is null instead of where email is null. Now if I select this, Okay, it has returned us 9 rows of information, which means around 5% of employees do not have a department. Moving ahead, now let me show you how the order by clause works in SQL. Now the order by is used to order your result in a particular format, let's say in ascending or descending order. So the way to use is, let's say I want to select all the employees from my table, so I'll write select star from employees, order by. I want to order the employees based on their salary, so I'll write order by salary. Let me select and run it. Okay, there is some problem. I made a spelling mistake. This should be employees. Let me run it again. Okay, now if you mark the output, our result has been ordered in ascending order. So all the employees which have salary greater than $45,000 appear at the top, and the employees with the highest salaries appear at the bottom. So this has been ordered in ascending order, which means your SQL or PostgreSQL orders it in ascending order by default. Now let's say you want to display the salaries in descending order so that all the top ranking employees in terms of salary appear at the top. So you can use the DESC keyword, which means descending. If I run this, you can see the difference now. So all the employees with the highest salary appear at the top, while those with the lowest salaries appear at the bottom. So this is how you can use an order by clause. Okay, so now I want to make a change in my existing table. So here if you see, under the address column we only have the country names, so it would be better if we change the name of the address column to country. So I want to rename a column. You can do this using the alter command in PostgreSQL. So let me show you how to rename this column, that is address. So I'll write alter table followed by the table name, which is employees. Then I'm going to use rename column address. I'll write to, I want to change it to country. If I give a semicolon and hit execute, it will change my column name to country. Now you can verify this. If I run the select statement again, there you go. Earlier it was address column and now we have successfully changed it to country column. Okay, let me come down. Now it's time for us to explore a few more commands. So this time I'm going to tell you how an AND and an OR operator works in SQL. So you can use the AND and OR operator along with the where clause. So let's say I want to select the employees who are from France and their salary is less than $80,000. So let me show you how to do it. I'll write select star from employees where I'm going to give two conditions. So I'll use the AND clause or the AND operator here. I'll write where country is equal to France. Now mark here I'm not using address because we just updated our table and changed the column name from address to country. So I'll write country equal to France, and my next condition would be my salary needs to be less than $80,000. I'll give a semicolon. Let me run this. Alright, so it has returned 19 rows of information. You can see all my country names are France and the salary is less than $80,000. So this is how you can use or give multiple conditions in a where clause using the AND operator. Now let's say you want to use the OR operator, and let's say you want to know the employees who are from country Germany or the department should be sales. So I'll write select star from employees where country is equal to Germany, and instead of and I'm going to use or. The department should be sales. Okay, now let's see the output. I'll hit F5 this time to run it. Alright, so we have 23 rows of information now. Let me scroll to the right. You can see either the country is Germany or the department is sales. You see one of them in the table. So here for the first record the country was Germany, the second record the department was sales, again for the fourth record the country is Germany. So this is how the OR condition works. So if one of the conditions are true, it will return the result. It need not be that both the conditions should satisfy. Now in PostgreSQL there is another feature that is called limit. So PostgreSQL limit is an optional clause on the select statement. Now this is used as a constraint which will restrict the number of rows returned by the query. Suppose you want to display the top 5 rows in a table, you can use the limit operator. Suppose you want to skip the first 5 rows of information and then you want to display the next 5, you can do that using limit and offset. So let's explore how limit and offset works. I'll write select star from employees. Let's say I'll use my order by clause. I'll write order by salary, let's say in descending, and limit it to 5. This is going to display the top 5 employees which have the highest salary. If I run this, there you go. You see it has given us 5 rows of information and these are the top 5 employees that have the highest salary. Okay, so this is one method of or one way of using the limit clause. Now in case you want to skip a number of rows before returning the result, you can use offset clause placed before the limit clause. So I'll write select star from employees, let's say order by salary, descending. This time I'm going to use limit 5 and offset 3. So what this query will do is it will skip the first 3 rows and then it will print the next 5 rows. If I run this, there you go. So this is how the result looks like. Okay. Now there is another clause which is called fetch. Let me show you how that works. I'll copy my previous SQL query. I'll paste it here. And here after descending, I'm going to write fetch first 3 row only. So my fetch is going to give me the first 3 rows from the top. There you go. It has given us the first 3 rows and you can see the top 3 employees that have the highest salary since we ordered it in descending order of salary. Alright. You can also use the offset along with the fetch clause. I'll copy this again and let me paste it here. Now after descending, I am going to write offset, let's say 3 rows, and fetch first 5 rows only. So what this SQL query is going to do is it will skip the first 3 rows of information and then it is going to display the next 5 rows. It is going to work exactly the same as we saw for this query. Let me run it. There you go. So these are the first 5 rows of information after excluding the top 3 rows. Alright. We have another operator that is called as like in PostgreSQL. So like is used to do pattern matching. So suppose you have a table that has the employee names. You forgot the full name of an employee, but you remember the few initials. So you can use the like operator to get an idea as to which employee name it is. Now let's explore some examples to learn how the like operator works in PostgreSQL. So suppose you want to know the employees whose name starts with A. So for that you can use the like operator. Let me show you how to do it. So I want to display the employee name, and let's say I want to know their email IDs from the table name, that is employee, where since I want to know the employees whose name starts with A, so I'll write employee name like. Now to use the pattern is within single quotes I'll write A and then followed by percentage. Now this means the employee name should have an A in the beginning, and percentage suggests it can have any other letter following A, but in the beginning or the starting should be A. If I run this, so there is an error here. The name of the table is employees and not employee. Let's run this again. There you go. You can see there are 16 employees in our table whose name starts with A. You can see this column employee name, all of them have a letter A in the beginning. Okay, now let me just copy this command or the query. I'll paste it here. Let's say this time you want to know the employees whose name starts with S. So instead of A, I'll write S. So this means the starting letter should be S and followed by it can have any other letter. If I run this, so there are 10 employees in the table whose name starts with S. Okay, let's copy the query again, and this time I want to know the employees whose name ends with D. Now the way to do it is instead of a percentage, I'll write this time percentage D, which means at the beginning it can have any letter, but the last letter in the string or in the name should be ending with D. Now let me copy and run this. So there are 13 employees in the table whose name ends with a D. You can see it here. Alright, now let's say you want to find the employees whose name contains ISH or have ISH in their names. So the way to do is something like this. So I'll copy this. Now here instead of a percentage, I'll replace this with percentage ISH percentage. Now this means that in the beginning it can have any letter and towards the end also it can have any letter, but this ISH should appear within the name. Let me run and show it to you. Okay, so there is one employee whose name contains ISH. You can see here there is an ISH in the last name of the employee. Alright, now suppose you want to find the employee name which has U as the second letter. It can have any letter in the beginning, but the second letter of the employee name should have U. Now the way to do is I'll copy this, and instead of a%, I'll write underscore U followed by percent. Now this underscore, you can think of a blank that can take any one letter. So the beginning can start with A, B, C, D or any of the 26 alphabets we have. Then it should contain U as the second letter followed by any other letter or letters. Let me run this. Okay, so there are 10 employees in the table whose name has a U as the second letter. You can see these. Okay, now moving ahead, let me show you how you can use basic SQL functions or inbuilt functions. So we'll explore a few mathematical functions now. So let's say you want to find the total sum of salary for all the employees. So for that you can use the sum function that is available in SQL. So I'll write sum and inside the sum function I'll give my column name, that is salary, from my table name, that is employees. Let's see the result. This will return one unique value. There you go. Now this is the total salary. Since the value is very large, it has given in terms of E. Now one thing to note here is, if you see the output, the column says sum real. So this output column is not really readable. So SQL has a method which can fix this, that is called an alias. So since we are doing an operation of summing the salary column, we can give an alias to this operation by using the as keyword. So if I write sum of salary as, let's say, total salary, then this becomes my output column. You can see the difference if I run this. Okay, you can see now in the output we have the total salary. Now this is much more readable than the previous one. So this is a feature in Excel where you can use or give alias names to your columns or your results. Now similarly, let's say you want to find the average of salary for all the employees. Now SQL has a function called AVG which calculates the mean or the average salary. If I write AVG, and I can edit my alias name as well. Let's see, I'll write mean salary. Let's run it. You can see the average salary for all the employees. It's around $81,000. Okay, now there are two more important functions that SQL provides us, which is max and minimum. So if I write select maximum, or max, which is the function name of salary, as, let's say, instead of total I'll write maximum. So this will return me the maximum salary of the employee. Let's run it and see what is the maximum salary that is present in the salary column. Alright, so we have $1,19,616 as highest salary of one of the employees. Similarly, you can use the min function as well. I'll just write minimum, and this will return me the minimum salary of one of the employees in the table. I'll replace the alias name as minimum. Okay, now run it. This will give me the minimum salary that is present in our table. So it is $45,685. Okay, now let's say you want to find the count of department in the employees table. You can use the count function. So if I write select count, let's say I want to know the distinct department names, I can write inside the count function distinct department as total departments from employees. Let's run this. This will return me the total number of departments that are there. So it gives me there are 12 departments. Okay, now let me show you one more thing here. If I write select department from employees, let's run this. Okay, so it has returned me 150 rows of information, but what I'm going to do is I'll place my distinct keyword here just before the column name so that I can verify how many departments are there in total. There you go. So there are 13 departments and one of them is null. So moving ahead, we'll replace this null with a department name by updating our table. Okay, so now let's update our department column. So what we are going to do is, wherever the department has a null value, we are going to assign a new department called analytics. So earlier we have also learned how to use the update command. So I'm going to show it again. So we'll write update followed by the table name, that is employees. I'm going to set my column, that is department, equal to, within single quotes, my name of the department would be analytics, where department is, I'll say null. So wherever the department has a null value, we'll replace those information with department, that is analytics. Let's run this. You can see query returned successfully. Now let's say I'll run this command again, and this time you can see the difference. There you go. So we have 13 rows of information and there is no null department now. We have added a new department, that is analytics. Okay, now we are going to explore two more crucial commands or clauses in SQL, that is group by and having. So let's learn how group by clause works in PostgreSQL. So the group by statement groups rows that have the same values into summary rows. For example, you can find the average salary of employees in each country or city or department. So the group by clause is used in collaboration with the select statement to arrange identical data into groups. So suppose you want to find the average salary of the employees based on countries, you can use the group by clause. So let me show you how to do it. I'll write select. I want the countries and the average salary for each country. So I'll use the average function, that is avg, and inside the function I'll pass my column, that is salary. I'll give an alias name as, let's say, average underscore salary from my table name, that is employees. Next I'm going to use my group by clause. So I'll write group by, since I want to find the average salary for each country, so I'll write group by country name. Let's give a semicolon and let me run it. I'll use F5. There you go. So here on the left you can see the country names. We have Israel, Russia, Australia, United States, France and Germany, and on the right, the second column, you can see the average salary for each of these countries. Now you can also order the result in whichever way you want. Suppose you want to arrange the results based on the average salary, so you can use the order by clause after the group by clause. So I'll write order by. Here you can use the alias name, that is average salary. This is actually average underscore salary, and let's say I want to arrange it in descending order, so I'll write DESC. Now let's run this. You can mark the difference in the average salary column. There you go. So as per our result, in United States the average salary is the highest, and if I scroll down, the average salary is the lowest in Germany. Now let's see one more example using group by. Suppose this time you want to find the maximum salary of male and female employees. You can do that too. So let me show you how to do it. So I'll write select. This time we want to find the maximum salary based on gender. So I'll select my gender column, comma, and this time I'll use my max function. Since I want to find the maximum salary for male and female employees, I'll give an alias name as maximum underscore salary from my table, that is employees, group by, I'll write gender. Okay, so let's run this. There you go. You can see, so one of the female employees had a highest salary of $1,19,616, while of that of a male was $1,17,654. Alright, now suppose you want to find the count of employees based on each country. You can use the count function along with the group by clause. So I'll write the select statement, select. since I want to count the employees based on each country, so I'll first select my country column and then I'm going to use the count function. I'll write count emp_id from my table name, that is employees. I'm going to group it by country. So this query will give me the total number of employees from each country. You can see here Israel there are 4 employees, in Australia there are 4 employees, in Russia we have 80 employees, in France there were 31, in United States we have 27, so on and so forth. Now let me scroll down. Okay, now it's time to explore one more clause, a very important clause that is used in PostgreSQL, that is having. So the having clause works like the where clause. The difference is that where clause cannot be used with aggregate functions. The having clause is used with the group by clause to return those rows that meet a condition. So suppose you want to find the countries in which the average salary is greater than $80,000. So you can use the group by clause and the having clause to get the result. So I'll write my select statement as select country, comma, I want the average salary, so I'll write avg of salary. I can give an alias name as average salary from employees. Now I'm going to group it by each country, so group by country column. Since I want to find the countries in which the average salary is greater than 80,000, so I'll use having clause after the group by clause. I'll write having average of salary is greater than 80,000. Now this condition cannot be specified in the where clause, so we need a having clause. You cannot use aggregate functions along with where clause. Let me just run it now. There you go. So we have Russia and United States where the average salary is greater than $80,000. Alright. Now let's say you want to find the count of employees in each country where there are less than 30 employees. So for this I am going to use the count function. First let me select the country column. Then I'm going to use the count function, and in the count function I'm going to pass my employee ID so that we can count the number of employees from my table, that is employees. Now if you want you can use an alias name for this as well, but I am just skipping it for the time being. I'll write group by country. Next I'll write having count of employee ID less than 30. So this will return me the countries in which there are less than 30 employees. Let's run it. You can see here Israel, Australia, United States and Germany are the countries in which there are less than 30 employees. Okay, now if you want you can use the order by clause as well. So suppose I'll write here order by count of employee ID. So what this will do is it will arrange my result in ascending order of employee ID count. There you can see we have successfully arranged our result in ascending order of employee IDs. Okay, next we are going to explore one more feature of PostgreSQL, that is of using a case statement. Now in PostgreSQL the case expression is same as if-else statement in any other programming language. It allows you to add if-else logic to the query to form a powerful query. Now let me just scroll down and I'll show you how to use a case statement. This is very similar to your if-else statement that you use on Excel, in C++, in Python and or any other programming language. So what I'm going to do is I'm going to write a SQL query that will create a new column, and the name of the column would be, let's say salary range. So I'm going to divide my salary. Suppose if the salary is greater than $45,000 and if it's less than $55,000, in the new column, that is salary range, we are going to assign a value low salary. Now if the salary is greater than $55,000 and if it is less than $80,000, we are going to assign a value that is medium salary. If the salary is greater than $80,000, we'll assign a value high salary. So all this we are going to do using our case expression in PostgreSQL. So I'll start with my select statement, but before that let me show you how to write a comment in PostgreSQL. So you can write a comment by giving a double dash. Comments are very helpful because they make your codes or the scripts readable. I'll write case expression in PostgreSQL. Similarly, if you want, you can go to the top and let's say here you can write with double dash having clause. Okay, let's come down. So I'll write my select statement as select. I want the department, the country and the salary column. I'll give a comma and I'll start with my case statement. I'll write case when my salary is greater than 45,000 and my salary is less than 55,000, then the result would be, within single quotes, I'll write low salary. So this is exactly like an if-else condition. Next, I'll write another case when salary is greater than 55,000 and salary is less than, let's say, 80,000, then the result would be medium salary. And finally, I'll give my last condition, that is when salary is greater than 80,000, then the result will be high salary. Let me write this in a single line, then high salary. Now one thing to remember, in PostgreSQL the codes are insensitive, so you can write your select statement in capital, in lowercase or in sentence case. Similarly, I can write case as small c or you can write as capital C. Alright, now moving ahead, after this I am going to write end. I'll give an alias name as salary range. Now this is going to be my new column in the output. Let me just come down. After this we need to give our table name from employees. I'll order it by salary descending. Okay, so what I'm going to do here is I'll first select department, country and salary column from my employees table, and then I'm creating a new column that is salary range, and I'm specifying the range. So I have three conditions here, for low salary, for medium salary and high salary. So let's run this and see the output. There you go. Here you can see we have added a new column known as salary range, and we have order our salary in descending order, so all the highest salaries appear at the top. If I just scroll down, you can see we have medium salaries here, and if I scroll down further you can see these low salaries. So case statements are really useful when you want to create a new column based on some conditions in the existing table. Alright, now moving ahead, we are now going to see how to write subqueries in PostgreSQL. So subqueries, we write a query inside another query, which is also known as nested query. So suppose we want to find the employee name, department, country and salary of those employees whose salary is greater than the average salary. So in such cases you can use subqueries. Now let me show you how to write a query inside another query. First I'll write the select statement. I am going to select the employee name, comma, I want the department, comma, I also want to display the country name and the salary from the employees table, where my salary should be greater than the average salary. So after this where salary greater than, I am going to use brackets and write my subquery, that is select average salary from employees. Now let me break it down for you. So first we are going to select the average salary from the employees. So this particular SQL statement will find the average salary from the table. We will compare this average salary with salaries of all the employees. So whichever employee has the salary greater than the average salary will display their names, the department, country and their original salary. So if you want, you can run this statement as well. Let me select this statement and run it for you. You can see we have written the average salary of all the employees, which is nearly $81,466. So we want the salaries of the employees to be greater than this average value. So let me run this and see how many employees have a salary greater than the average salary. There you go. So we have around 75 employees whose average salary or whose salary is greater than the average salary. Alright. Now moving ahead, this time I'm going to tell you how to use some inbuilt functions. We'll learn some inbuilt mathematical functions and string functions that are available in PostgreSQL. So I'll just give a comment. There's another way to write a comment. Instead of a double dash, you can use the forward slash, an asterisk, and inside the asterisk you can write, let's say, SQL functions, and you need to close this. So I'll give another asterisk and a forward slash. So this is also a comment in PostgreSQL. Alright. So first of all, we'll explore a few math functions. So there is a function called ABS which is used to find the absolute of a value. So if I write select ABS of, let's say, minus 100, it is going to return me positive 100 or just 100, because as you know, the absolute of any value will remove the negative sign involved in that value. There you go. So our original input was minus 100, the absolute of minus 100 is plus 100. Next, let's see another function that is called greatest. So the greatest function in PostgreSQL will return the greatest number in a range of numbers. So suppose I write select greatest. Inside the greatest function, I'll pass in a few numbers, let's say 2. I'm just randomly passing a few numbers. Let's say 490, let's say 56.5, and let's say 70. I'll give a semicolon. Let me run this. You will see the greatest function will return the greatest integer value or greatest number that is present in the range of numbers that we have provided. So in this case, 90 was the largest number or the greatest number, so we got the result as 90. Again, you can use an alias for each of these statements. Now, like greatest, we also have a function called least, which is going to return the least number present in a range of numbers. If I run this, so the result is 2, because 2 is the least number that is present in this selection. Alright. Now there's a function called mod which is going to return the remainder of a division. So suppose I write select mod, and this takes two parameters, let's say 54 divided by 10. As you can guess, the remainder is 4, and so is our result. You can see it has returned the remainder. 54 divided by 10, the remainder is 4. Alright, if I scroll down, now let's see how to use the power function. So I'll write select power. Let's say I want to know power 2 comma 3, which is 2 cube, that is 8. Let me just run this. There you go. So the result is 8. You can also check, let's say power of 5 comma 3, it should be 125. Alright. Next, you can use the sqrt function that is available in PostgreSQL to find the square root of a number. I'll write sqrt, and let's say I want to find the square root of 100. You can guess the result. The output should be 10. If I run this, you can see the output here 10. Let's say I want to find the square root of, let's say 144. You can again guess the result. It should be 12. Let's verify it. Okay, there is some error. Let me verify it again. There you go. It is 12. Now, there are a few trigonometric functions as well. You can use the sine function, the cos function, and the tan function. Let's say I want to know the sine of 0. If you have studied high school mathematics, you would know the sine of 0 is 0. You can see the result, it is 0. Let's say you want to know sine 90. If I run it, you can see the output here 0.89. Alright. Now there are other functions like ceiling and floor that you can use. So let me show you what the ceiling and floor function does. I'll write ceiling. Let's say I'll pass my floating value as 6.45 and let me run it. You can see the ceiling function returns the next highest integer, that is 7 in this case, since the next highest integer after 6.45 is 7. Let's see what the floor function does, and let me run it. As you can see, the floor function returns the next lowest integer, that is 6 in this case, or the nearest lowest integer to any provided decimal value. Okay. Now that we saw how to use mathematical functions, there are a few string functions available in PostgreSQL. So let's explore them as well. I'll write string functions. Okay. We'll scroll down. Cool. There's a function called character length that gives you the length of a text string. Suppose I write select, give the function as character length, and inside this function I am going to pass in a text. Let's say India is a democracy. This is my text. Let me run this. Okay, you can see the result here, which is 20, since there are 20 characters in my string that I have provided. Alright. Now there's another function called concat in PostgreSQL. So concat is basically used to merge or combine multiple strings. So I'll write select concat, within brackets I'll give the text string now. Let's say I want to combine Postgres SQL. I'll give a space, comma, I want to merge Postgres SQL is, I'll give another comma and write my final word, that is interesting. Now what we have done is, inside the concat function we have passed in separate strings, and now using the concat function we want to merge the three strings. Let's see what the result is. I'll run it. Alright, let me just expand this. You can see here we have concatenated the three strings successfully, so the output is PostgreSQL is interesting. Okay. Now there are functions like left, right and mid in PostgreSQL. So what the left function does is it will extract the number of characters that you specify from the left of a string. Let's say I'll write select left and I'll pass in my text string as India is a democracy. I'll copy this and I'll paste it here. Let's say I want to extract the first 5 characters from my string, so I'll give 5. So what it will do is it will count 5 characters from left, so 1 2 3 4 and 5. If I run this, it should ideally print India for me. There you go, it has printed India for us. Alright, similarly you can use the right function to extract few characters from the right of a string. Let's say you want to extract, let's say I'll give 12 characters from right, so from here onwards it will count 12 characters. I'll change left to right now. Let me select this and run it. So you can see here this is the output. From the right it has counted 12 characters and returned a democracy. Okay. Now there is a function called repeat. So the repeat function is going to repeat a particular string the number of times you specify. Let's say I want to select and use my repeat function, and inside the repeat function I'm going to pass in, let's say, India, and I want India to be displayed 5 times. I'll give a semicolon and run it. In the output you can see India has been printed 5 times. Okay, let's scroll down. There is another function, a string function in PostgreSQL called as reverse. So what reverse function is going to do is it is going to print any string passed as an input in reverse order. So if I write select reverse, and inside the reverse function I'll pass in my string, that is India is a democracy. I'm going to use the same string. I'll copy this and I'll paste it here. I'll close the quotes and the brackets. Let's print this. You can see it here. India is a democracy has been printed in reverse order. There you go. Alright, now this time we explored a few inbuilt functions that are already present in PostgreSQL. Now PostgreSQL also has the feature where you can write your own user-defined functions. So now we will learn how to write a function of our own in PostgreSQL. So let's create a function to count the total number of email IDs that are present in our employees table. So for this we'll write a function, a user-defined function. So let me give my comment as user-defined function. Okay, so let me start by first writing create. So this is the syntax to write a function in PostgreSQL. So I'll write create or replace function, then I'll give my function name as count emails, and as you know functions have brackets. Then I'll write returns, the return type, as integer, then an alias with dollar symbol. I'll write total emails, since I'm going to display the total number of email IDs that are present in my table. I'll close the dollar symbol. Then I'm going to declare a variable. The variable name is going to be total underscore emails. This is of type integer. I'll write begin, and inside begin I'll write my select statement. So I'll write select I want to count the email IDs that are present, so I'll pass my column name, that is email, into total emails from my table name, that is employees. I'll give a semicolon and then we'll write return total emails. As you know, user defined functions often return a value, so hence we have mentioned the return statement as well. And now I'm going to end my function. Then the next syntax would be, let me just scroll down. Okay, so here I'll give my dollar symbol again, followed by total underscore emails. Next I'll write my language PostgreSQL. So the way to mention is PL P G SQL. Let's give a semicolon and end it. So this is my user defined function that I have written. So I created a function with the function name count underscore emails, and this would return integer as an alias which is total underscore emails. We declared that variable as an integer. Then we started with our begin statement that has my select statement where I am selecting the count of email IDs that are present in the employees table, and I am putting the value into total underscore email. So I have used the into keyword, and this returns the result as total underscore emails, and I have ended. Let's run this. Okay, there is some problem. There is an typo, so this should be integer. Okay, let me run it once again. There you go. So you've successfully created a user defined function. Now the final step is to call that function. Now to call this function, I'm going to use my select statement and the function name, that is count underscore emails. I'll give a semicolon. Let's execute this. There you go. So here you can see there are 134 email IDs present in our employees table. Now one thing to mark is there are total 150 employees in the table, but out of them 134 employees have email IDs, the rest of them don't have, so they would ideally have null values. Alright, so that brings us to the end of this demo session on PostgreSQL tutorial. Let me go to the top. We have explored a lot. So we started with checking the version of PostgreSQL. Then we saw how to perform basic mathematical operation, that is to add, subtract, multiply. Then we saw how to create a table that was movies. We inserted a few records to our movies table. Then we used our select clause. We updated a few values. Then we deleted one row of information. Then we learned how to use the where clause. We learned how to use the between operator. We also learned how to use the in operator. Let me scroll down. We created a table called employees, and then we learned how the distinct keyword works. We also learned how to use isNull with where clause. We learned about the order by clause. We saw how to alter or rename a column. Then we explored a few more examples on where clause, where we learned about and or operator. Then we learned how to use limit and offset, as well as the fetch operator or the fetch keyword in PostgreSQL. Moving further, we learned about the like operator in SQL, which was used to perform pattern recognition or pattern matching, you can say. Here we saw how to use basic inbuilt PostgreSQL functions like sum, average, minimum, count, maximum. Next, we saw how to update a value in a column using PostgreSQL update command. We learned how to use group by. Then we learned how to use having clause. Then we learned how to use case expressions in PostgreSQL. So we saw how case expression is similar to our if-else in any other programming language. We explored a few mathematical and string functions, and finally we wrote our own user-defined function. So that brings us to the end of this tutorial on PostgreSQL.
In this session, we will learn about how to join 3 or more tables in SQL. That's right. So far we have a fundamental understanding of how to join 2 tables. But in a few situations, you might have to extract the data by joining 3 or more tables, right? So that's exactly what we are going to discuss today. Now, without further delay, let's get started. Now, we will jump into the MySQL workbench where we have our query ready. So here we will be using 3 tables: employee details, employee register, and employee joining register. So we want employee name, contact number, and joining date. Joining date is available in joining register, contact number is available in employee register, and employee name is available in employee details, right? So here we are utilizing all 3 tables and joining them to extract these 3 columns. So here I'm providing the table name and the column name to make sure that the SQL workbench will not get confused which employee name column should I access, which table should I use. So to clear that confusion, I'm providing the table name. So MySQL will use employee details table, and from there it will extract the employee name column. And contact number, to be sure it is present in only one table, so it will go to employee register. And joining date, it is also present in only one table, so no need to specify the table name. But to be on safer side, if you want to add, you can add, that's well and good, and it will create an impact to your interviewer considering that you know about the syntaxes. So I'll just follow the normal syntax the way I'm going now. And now I'm trying to join. It's the same operation what you use to join 2 different tables. So you'll just use the join clause and give the second table name and on what basis. So I'm joining these 2 tables on the primary key employee ID. So both tables have the same common employee ID. So based on that, I'm joining these 2 tables, and then you will use the join clause once again and give the third table name here, and based on which primary key or which common key. So this is the one which is common in both the tables and is unique, which is the employee ID. So I'm using the same one to join the 2 tables with the third one. You can follow the same syntax and join another table to it as well. So with this, let's execute this particular query to find our answer. So there you go, you got the query executed and you have the table over here with employee name, contact, and joining date. Let's quickly get back to MySQL workbench. So here, let's say you wanted to create a table and load the data. So if the data is minimalistic, maybe the data about 10 rows or 15 rows, you can manually create a table and insert the elements into your table using such insert commands. But this is like mine, which is in the Excel spreadsheet and has about 10,000 rows. Would you like to, write 10,000 insert commands? No, right? It would be really time consuming. So for situations like this, MySQL Workbench has enabled developers to load the data from spreadsheets within a few steps. But before we get started, let's check our column headers. So here you can see it is not compatible with the MySQL Workbench or SQL commands, right? So it has a space and it has a word row and it is a keyword in MySQL, right? So we don't want that confusion. So for that reason, we will try to modify this maybe using an underscore, right? Similarly, for the row ID, you can eliminate space and use an underscore. And when it comes to order ID, the same. So just let us quickly change all the column headers so that they are SQL compatible. There you go. So we have replaced all the row headers with underscores and made them SQL compatible. So let us save it. And when you're saving it, just make sure that your Excel file data is also having the SQL compatible name. So here we have load CSV to MySQL. So here we have the name with space, right? So let's try to change that to lowercase Excel data, and right now it is SQL compatible. Now quickly let's go back to MySQL Workbench. Here we have it. Now you can just create a new table. Just right click here or you can also do it from here. Create a new database, and the new schema will be the name of your data set. So let's type it as Excel data or just Excel, and apply. Now this is the schema. Apply. Now you have Excel right here. Just drop down, and here you can see the tables. Right click the tables, and here you have the option of import data wizard, right? Just click on that. Now browse your folders and have it. So yeah, another notification for you guys. So you need to save your Excel spreadsheet in the form of comma separated file, right? Let's quickly go back and do that. Open your spreadsheet, go to file, save as, comma separated file, save. There you go. Now let's get back to Workbench, and now I think you will be able to find it. Just open, next, drop table if exists. Make sure you do that to be on the safer side, and check all the names here. So we have a problem with row ID, but that is something which you can fix down the line. And before you go to the next step, check all the other names as well. Every other name on the column header is fine. Just the first one we can just alter the table, not a big deal. And next, it should start importing. There you go. The data file got imported. Of course, it took a little while because it's 10,000 rows. That's normal. Now let's quickly go to the next step, and here you can see 9,987 records imported successfully. Just click on finish, and I think it should be shortly done. Let's close the schema, go to the query table, and yeah. So you can quickly refresh so that you will have the Excel data over here. Now let's use the database, that is Excel. On it. Now we are in Excel database. Now the table we are looking for is select star from the data name. The data table name is Excel data without a space, semicolon. Just quickly run it, and I think we should be shortly able to see all the data sets right over here. Yeah, about the first column ID, we can simply use the alter table function or query to change the name. Let's quickly do that with the table name, alter table, rename. Okay, what was this? Can you copy that? Copy field name, rename row ID to. So a small syntax error there. So I think they should be sorted. Yeah. And now let's quickly run this, and I guess it should be done. Now let's quickly run the select command again. There you go. So we have the row ID, order date, shipment mode, customer ID, customer name, etc. And everything is as per the expectations. And that's how you can load Excel data to MySQL Workbench. We will learn about the top 5 interview questions in SQL that you must know to crack your business analytics interviews. Now, without further ado, let's get started. So speaking about the top 5 interview questions, let's quickly jump to the workbench of SQL. So I'm using MySQL Workbench, and here we have a database called use Simplilearn. So SLP is the database name. So we'll be using the use command to get access to that particular database. So we are in access to it. And now let's quickly check our tables. Show tables. There you go. We have a few tables here: book collection, book order, employee details, joining register, and employee register. So let's go with the employee details. So I'll just simply shoot a command, select star from EMP details. So now we have our employee table. So we will be using this particular data set to run few queries from our interview questions. So getting back to the interview questions. So most commonly you will be asked the following interview questions. So the first question is, you will be asked to find out the names of the employees that start with the vowels. So A, E, I, O, U. So they will ask a question, give me the list of names that start with these 5 letters. It can be either A or E or I, O, U, right? So what's the question? So here you will be using like operators and not like operators. Let's say they want the names with vowels, so you can just use the like operator and use this particular command. Select employee name, that's the name of the column, from employee register or employee details, and then where employee name is like A modulus, which means it should start with A and it can have any number of alphabets after that, right? So let's quickly also check what do we have in employee register. So I think it's a similar table to employee details that we used before. We have the same details here, so no problem. Now let's try to extract the names of the employees whose names start with vowels, right? So we will be using the where clause and like operators. Run the command and there you go. So we have 3 names. So if you're able to answer this question, they might ask a similar question with a little modification. So this time they might ask you, give me the list of names that will not start with vowels. So you'll just replace the like operator with not like. So either they'll ask the questions which might start with vowels, or they might ask a question which does not start with vowels. This is one of the common questions. Now going to the second question. So here also they will give it a simple start. They will ask to give the details of the employee who has the highest salary, or they will ask you to give the highest salary. You can simply use the max aggregation and you can get the maximum salary. So we have $87,000. And sometimes if you are able to answer this question, they will make it a little tricky to you and they will ask, give the second highest salary. Here you can use offset, or there are multiple possibilities, but let me give you the simplest one where you can have the same query. Only difference is where salary is less than max of salary. First, the subquery will be executed which will extract the maximum salary, and the next one is less than. So it will give you only one row which has a little salary which is less than the maximum one, right? So simply let's execute the query. So we will have the answer. So the next highest salary is $78,000. Now moving on to the third question. So sometimes they will ask you to use the update commands as well. So here we have some salary details of our employees in the employee register employee. What I'm going to do here is, let's say this is the appraisal period and they're giving you 15% hike to all the employees. So you need to update the salary column. So what you do is simply update table name salary plus salary into the percentage of hike, which is 15%. So here we are adding that particular percentage in the form of decimal numbers, which is 0.15, and simply run the command and you have it. Now you can just simply query the same detail, which is select star from employee details. So you will have the updated salary list here. There you go. Now let's proceed with the next question that we have in our list, which is about select the employee name and salary from a given range, right? If they ask you, give me only the range of employees whose salary lies between 50,000 to 70,000. So you can use the between operator here and range of numbers, that is 50,000 and 70,000. Just run this particular code and there you go. You have the details. So there are 2 employees whose salary lies between 50,000 and 70,000. Now the last question is, they might ask you to extract the details from a certain department. So basically, this might also turn up to find a difference between having and group by clause. Sorry, having and where clause. Yeah. So this is one of the common interview questions where they will ask the difference between having and where clause. So when you are implementing group by in your query and you're also implementing some aggregate functions like count, sum, etc., minimum, maximum, in those situations when a group by clause is involved, then you can use having. When there is no group by function, then you can simply go with the where clause. So here I'm trying to extract the number of people present in finance department. So I'm not grouping by department, so I can just use where clause and run this. And now in situations where I have to group by, when I have to implement group by, in those scenarios, you can include having clause in place of where. So that is the fundamental difference between having and group by. And also you got the understanding of group by command here. Today we will learn join types in SQL. So joins basically help in many ways you can imagine to keep your database intact and improve your query performance. To understand this better, let's go through a small story or a use case imagining you run a database for a company securing the customer's data. So here goes the context. Imagine you are a SQL developer and you faced a critical issue during a project. Customer orders were mismatched with their delivery dates. The data was scattered across two different tables, orders and deliveries. Despite several attempts to resolve it, the mismatched entries created inconsistencies in the report. You realized you needed to understand how the tables were related, and you turned to SQL joins for a solution. By using an inner join, you quickly matched orders with corresponding deliverables. Then, using a left join, you identified missing delivery information for certain orders. After analyzing the results, you pinpointed the incorrect entries and updated the data accordingly. The reports were corrected, and your team was impressed with your clean insights. You learned the power of SQL joins in managing relational data effectively. The project was a success, and you felt more confident in your SQL skills. So that's it. If these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Just for a quick info, if you want to upskill yourself, master data science and data analytics skills, and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various data science and data analytics programs. Simplilearn offers various certifications and postgraduate programs in collaboration with some of the world-leading universities like Caltech, Purdue, IIT Kanpur, and many more. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Excel, Python, machine learning, data visualization, generative AI, and over a dozen others. That's not all. You also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data and product companies, and also academicians from top universities. After completing these courses, thousands of learners have transitioned into a data science or data analytics role as a fresher or moved on to a higher-paying job profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a data science or data analytics program that fits your experience and areas of interest. Now, without further delay, let's get started with our one-point agenda for today's session, which happens to be the types of joins in SQL. So before that, let's understand what exactly is a join in SQL. In SQL, joins are used to combine rows from two or more tables based on a related column, or you can also call it as a primary key. They allow querying data across tables by specifying conditions that define the relationship. Joins are essential for accessing normalized data effectively in relational databases. Now proceeding ahead, we will understand the different types of joins available in SQL. So there are multiple joins available in SQL, but the primary ones that you need to focus on are these 5. So they are inner join, left join, right join, full join, cross join, right? And each of these joins will have a specific purpose in combining the data. Now, let's have an in-detail understanding of each of these joins, starting with the inner join. So an inner join retrieves rows that have matching values in both the tables on specified condition. It only includes records where the join condition is true, excluding unmatched rows. So here you can understand this first circle to be as table A and the second circle to be as table B. Now where it finds a match, that means the common data entries in both the tables are the only ones to be extracted. So that's how an inner join works. Now the next one is the left join. A left join retrieves all rows from the left side table and the matching rows from the right side table. If no match is found, the results include null from columns from the right table. So you have so far understood the inner join, right? So it only presents the data entries which are common in table A as well as table B, right? Now the left join is a little escalated or a little enhanced than the inner join. So it gives all the entries of table A, but along with that, it also tries to pull the matching entries from table B. Let's say you have got 10 entries in table B, which are in match with table A. So those entries are also pulled. That part of the table is also pulled in the left join. Now let's proceed with the third type of join, which happens to be the right join, which is completely similar to the left join, but the only difference is this time you're pulling the data from table B and the common values or common entries from table A, right? So a right join retrieves all rows from the right table and the matching rows from the left table. If no match is found, the result includes nulls for columns from the left table. Now, let's proceed with the full join or full outer join. Now, this acts like a bit differently, right? Whenever you wanted to club two different tables with all the entries, let's say the master data table has 10 columns, right? But for some reasons, you choose to split those 10 columns amongst two different tables. The first 5 to 6 columns will be in table A, and the next 4 to 5 columns are in table B, based on your requirements, right? Now, there comes a situation where you need all the 10 columns in one particular situation. So this is where you come across the full outer join or full join. So this particular full outer or full join does one thing. It combines all the columns from the A column or A table and all the columns from the B table and also the ones which are in common between both, right? So this is how a full outer join works. Now, the last type of join is the cross join. Cross join produces a Cartesian product of two tables, pairing every single entry of the first table with every single entry of the second table. So this particular image here will explain you how a cross join works. So the first entry in table A is matched with all the entries in table B. Similarly, the second entry of table A is combined with all the entries in table B. So this is how a cross join works. So far, we have covered the theoretical explanation of all the 5 joins present in SQL, starting from the inner join, left join, right join, full join, and lastly, the cross join. Now it's time for us to go a little practical. Now we will start the SQL workbench and try to execute some of the queries. Now we're on the SQL workbench, so our data is saved in this particular database, which is named as car dealership, and let's run the query. There you go. And let's also check our tables. So here you can have access to the tables, and these are the columns: order ID, state, region, customer ID, customer name. And if you close this, here you have your second table and expand the columns, and you have your columns here: order ID, delivery date, delivery days, and days to be delivered, right? So you have two different dates: the order date and delivery date, and days to deliver. If I only, oh yeah, you have another section here where you can read, and category, product, fuel type, etc. These are the columns you have in both your data tables, right? So you have a clean visual of your data table. Now let's start with our use cases. So we have mentioned our use cases here. So one for each type of join. So the first join is inner join as mentioned here. And now the inner join is identify customers and the products they purchased. We want to find the names of the customers and the products they purchased, ensuring the data exists in both customer data and dealership data. Now let's write a query for that. So the query will start with the select statement, and we wanted 3 columns here: the customer name, product name, and dealership name, right? So let's push them out, right? Customer name is the first column that we are trying to pull, and followed by that we have the product name that they purchased and dealership name. From the table, which happens to be the customer data. And remember, I'm using smaller case letters for the variables or the table names or the column names, and capital letters for the keywords, so that the reader can automatically understand what is what, correct? Now we want to perform an inner join with the dealership data. So you can just copy this and paste it here so that you can eliminate this and just write it down as dealership data. I want to join on 2 primary keys, which is order ID. So to make sure that there is difference between the order ID from customer data and order ID from dealership data, I'm using this particular approach. So now customer data dot order ID and dealership data dot order ID. The query is done. Now let's quickly run this. Select this particular query and run. There you go. Now we have the data that we were looking for. There you go. So we were looking for the customer name, product they purchased, and the dealership, and here we have. Now let's proceed with the second use case. So now we will be performing the left join, and you are similar with the left join. Here we will be pulling out the data from table A, which is the first table, and also the matching entries from B table, right? Now list out all the customers, including those who have not purchased anything. We want to display all customers and any purchases they made. If no purchases exist, it should show as null for product and dealership information. Now let's write the query for this particular request. Start with select, and next we want to specifically mention the column is from customers table. So customer name as customer, comma. The second one is dealership data dot product as product purchased. Third column is dealership data, dealership name. Make sure you remember the names of the columns. If there is a small error in your column name, the query might fail. So make sure you keep the column names simple and rememberable. The table customer data, C, and I want to join now with dealership data. So use the join or left join, since we are performing specifically the left join. And the left join is upon dealership data. So what you can do is mention the dealership data name here. It's D. On what condition? This is a different database, don't worry. On the condition order ID, customer.order ID is equals to the dealership.order ID. So we can simply place order C.order ID equals to D.order ID. There you go, semicolon, and the query is ready for execution. So select the entire query and run that one single query, and there you go. So we have the customer name, product purchased, and the dealership name as well. So the third use case is identify all dealership orders, including ones without an associated customer. We want to see all the orders processed by dealerships, even if there is no customer information associated with them. Now, for this, we will write the query as follows. Begin with select, as usual. Don't even if the MySQL Workbench gives you recommendations, don't choose that. Go with the use case thing so that you identify which is a keyword and which is not, right? Now, D.dealership name as dealership, comma, D.product as product purchased, comma, C.customer name as customer, from which table? So it will be from the table customer and customer data, and mention it as C, so that it is easier for us while writing the join query. Customer data C, and now we will be performing the join. So since we are specifically focusing on right join, use right join, and we are joining it with another table, which is dealership data, and mention it as D, and the condition is on which columns? C.order ID equals to D.order ID, and semicolon. Now let's quickly select the entire code and execute this. Now I have selected the entire code, execute, and here we have. So we have all the dealership orders, including the ones without an associated customer, and we have all the orders processed by those dealerships, even if there are no customer information associated with them. Now moving ahead, we have our last but one, the fourth use case for today's session, which happens to be the full join. Okay, I didn't mention it here, so let me add it here as well. full join or full outer join. Let's mention it as full outer join. And here goes the use case. So the use case is generate a comprehensive report of all customer orders and dealership orders. We need to complete data set of all customers and dealership orders even if they don't match. Now let's proceed with the code. So in this particular aspect, we might want to proceed with an union. But anyways, let's start writing the code. Select, tab, and what we can do is we can borrow the data from this code as well. So we want customer name as customer, and we want order ID as customer order ID. I think we missed a comma here. That's the error. Okay, not a problem. Now the next one is we want d.order ID, dealership order ID, comma, d.product as product purchased, comma, the last one, d.dealership name as dealership, from which table? I want it from the table customer data, and I will short term it as C. Customer data C. Enter. I want to join this, so I'll proceed with left join with dealership data E on the terms, on the condition C.order ID equals to D.order ID. Now we will unite them by using the union command, and we will copy paste the same keywords or column names here. Copy and paste. Make sure everything is fine. We have customer name, order ID from customer data, order ID from dealership data, product and dealership date. Now, from customer ID, customer data is the table as C, and I will be performing the right join. So both including left and right will complete as a full auto join. Right join on dealership data. Copy and paste it right here. And the condition is the same as before. Order ID should be equal in both tables and semicolon. There you go. Now let's quickly select the entire code and run it. And we should be having our data here. So we have the customer name, customer order ID, dealership order ID, product purchase, and dealership. Now moving on to the last part of today's session, which is the cross join. And here's the use case. So the use case is create all possible combinations of customers and dealership products. We want to understand potential matches between customers and all available products in dealerships. Now let's proceed with the query for this particular request. So we will begin as usual with select statement. We are wanting to select customer name, product, and dealership name. So why don't we just take it from here, customer name, and we wanted the product name as well. So we will take product name and dealership name as well. And we want this from customer data C. Automate as C for join. So we will be doing a cross join here for all the permutations and combinations, right? So basically the use of cross join is matching each and every entry of table A, the first table, with the second table, and the second table is dealership data D. Just paste it here, and that's our query ending. Now let's quickly run this query. Select the entire query and run. So there you go. We have the required data. So we have created all possible combinations of all the customers and dealership products, and we have understood the potential matches between customers and all available products in dealerships.
So let's start with what is normalization. Normalization in DBMS is a method used to organize data within database to reduce repetition. By breaking down large data sets into smaller, more manageable tables and ensuring these tables are properly related, normalization helps prevent issues like data redundancy. Data redundancy means the unnecessary repetition or duplication of data within a database. For example, when a same piece of data is stored in multiple places, it can lead to inconsistencies and take up more storage space than needed. For example, data redundancy before normalization. You can see the table mentioned above where we have order ID, customer name, customer address, product and quantity. You might see some of the data which is being repeated again and again. In the above table, the customer address for John Doe is repeated 3 times. Let's suppose if John Doe moves to a new address, every occurrence of his address in the table must be updated. If any instance is missed during the update, it leads to inconsistencies and errors can occur in the database. The solution is reducing the redundancy through normalization. Let's check it out how. So you can see this is the normalized table we have created. First is the normalized customer table and then we have the order table. So what are the benefits of normalization? The address for John Doe is stored only once in the customer table. If John Doe's address changes, it needs to be updated in one place, ensuring consistency through the database. This reduces the risk of errors and maintains data integrity. The process involves multiple steps that transform data into a tabular format, removing duplicates and establishing clear connections between different tables, making the database more efficient and reducing problems like errors during data insertion, updates, or deletion. Let's now discuss the types of DBMS normal forms. Normalization rules are categorized into different normal forms. The first one is 1NF. For a table to be in first normal form, it must satisfy the 4 rules. Single valued atomic attributes. Each column should contain only one value per row. This means that there should be no repeating groups or arrays within a single column. Same domain values. All values stored in a specific column should be of the same data type or domain. For example, if a column is meant to store dates, all values in that column should be dates. Then we have unique column names. Each column in the table should have a unique name. This ensures clarity and avoids confusion when referring to a specific column. Then we have order of data, which doesn't matter. The order in which rows are stored in the table should not affect the data or its integrity. Let's check the example of the first normal form. Consider the following unnormalized table: customer ID, customer name, and the phone numbers. As you can see, the phone numbers are repeated twice. The problems with the original table is the non-atomic values. The phone numbers column contains multiple phone numbers separated by commas, which violates the atomicity rule of 1NF. Converting to first normal form, to bring this table into 1NF, we must ensure that each column contains only atomic value. This involves splitting the rows where there are multiple phone numbers. As you can see, we have splitted the data. Each row now has a single phone number, ensuring that the phone number column contains atomic value. Same domain names, all the values in the phone number column are consistent in format and type. All are phone numbers. Then we can see that the unique column names, the columns customer ID, customer name, phone number, which has unique name satisfying the requirement. Order of data. The order in which the rows appear does not matter, as the data's meaning and integrity are preserved. By applying these rules, the table now conforms to the first normal form, eliminating any redundancy related to the phone numbers and ensuring data is stored in a more organized and efficient manner. Let's go through each of these database normal forms step by step with simple examples to help you grasp the concepts more easily. Let's talk about the second normal form. For a table to be in second normal form, it must satisfy the following condition. Number 1, it must be in 1NF. Number 2, no partial dependency. Every non-key attribute should be fully dependent on the entire primary key, not just part of it. This rule applies primarily to tables with composite primary keys. Example of second normal form is, consider the following table that is in 1NF. The order ID, product name, quantity, and the supplier name. The problems with this table is that the partial dependency, the product name and the supplier name depend only on product ID, not the entire primary key, which is order ID and product ID. This violates 2NF. Converting to second normal form, to bring the table into 2NF, we separate the data into two tables to remove partial dependencies, order table and the product table. No partial dependency in the order table quantity is fully dependent on both order ID and product ID. In the product table, product name and supplier name are dependent only on the product ID. This ensures that each non-key attribute is fully dependent on the primary key, bringing the tables into 2NF. Let's now talk about the third normal form, 3NF. For a table to be in third normal form, it must satisfy the following condition. Number 1, it must be in 2NF. Number 2, there should be no transitive dependency where non-key attributes depend on other non-key attributes rather than the primary key. Let's check out the example of a third normal form. Consider the following table that is in 2NF. The problems with the 2NF table is that the transitive dependency, the instructor name is dependent on the course name, which is not directly on student ID or course ID, and this violates 3NF. So how do we convert this into 3NF? To achieve 3NF, we split the table to remove the transitive dependency, student course table and course table. No transitive dependency. Now, the student course table, there are no non-key attributes depending on other non-key attributes. The course table stores the course and instructor information separately. This structure eliminates transitive dependency, ensuring the tables conform to 3NF. Let's now talk about the Boyce Codd normal form, which is BCNF. BCNF is an extension of the third normal form, 3NF. A table is in BCNF if it is in 3NF, and for every functional dependency, A implies to B, A should be a super key. Let's check out the example of a Boyce Codd normal form BCNF. So you can see this table here consisting of employee ID, department, and the manager. The problem with this table is that the BCNF violation. In this table, department determines manager, but department is not a super key, since employee ID is the primary key. This violates BCNF. So how do we convert this to BCNF? To achieve BCNF, we split the table to ensure that every determinant is a super key. As you can see, the employee table and the department table. The super key requirement in the employee table, employee ID is the primary key, and in the department table, department is now the primary key. The decomposition ensures that every functional dependency is satisfied by a super key, meeting the requirements of BCNF. Let's now talk about the fourth normal form, which is 4NF. A table is said to be in 4NF if it is in BCNF and has no multi-value dependencies. So let's consider an example of a fourth normal form. Consider a table where an employee can have multiple skills and work on multiple projects. As you can see, the employee ID, skill, and the project. The problem with this table is that it is multi-value dependency. An employee skill is independent of the project, but both are stored in the same table. This leads to multi-value dependency, violating 4NF. So, in order to achieve 4NF, we separate the skills and the projects into different tables, the employee skill table and the employee projects table. And now you can see that no multi-value dependency. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the table conform to 4NF. Let's now talk about the fifth normal form, the employee skill table and the employee projects table. So as you can see that no multi-value dependency is there. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the tables conform to 4NF. Now let's talk about the fifth normal form, which is 5NF. A table is said to be in fifth normal form if it is in 4NF and cannot be decomposed into any smaller tables, losing information, also known as joint dependency. Let's consider an example of a fifth normal form. This is a table here that records the relationship between suppliers, parts, and the project. The problem with this table is that the joint dependency. The table has a complex relationship between suppliers, parts, and projects that can be decomposed further. So how do we convert this into fifth normal form? In order to achieve 5NF, we break the table into smaller related tables, the suppliers part table and the suppliers project table. Also parts project table. Eliminating joint dependency by decomposing the table into 3 smaller tables, we remove the complex relationship and eliminate the joint dependency, ensuring the tables conform to 5NF.
So, SQL Server is a powerful relational database management system developed by the Microsoft, which is widely used for managing and storing the data. Its benefits include high scalability, robust security features, and seamless integration with other Microsoft tools and technologies. SQL Server provides efficient data management through advanced features like indexing, full text search, and in memory processing. It also offers excellent support for large datasets, making it ideal for enterprise applications. The built-in business intelligence tools help organizations gain valuable insights from their data. SQL Server's high availability and disaster recovery features ensure continuous operations with minimal downtime. With strong data integrity and transactional support, it ensures reliable and consistent data management across all applications. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Just for a quick info, if you want to upskill yourself, master data science and data analytics skills, and land your dream job, or grow in your career, then you must explore Simplilearn's suite of various data science and data analytics programs. Simplilearn offers various certifications and postgraduate programs in collaboration with some of the world's leading universities like Caltech, Purdue, IIT Kanpur, and many more. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Excel, Python, machine learning, data visualization, generative AI, and over a dozen others. That's not all, you also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data and product companies, and also the academics from top universities. After completing these courses, thousands of learners have transitioned into a data science or analytics role as a fresher or moved on to a higher paying job profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a data science and data analytics program that fits your experience and areas of interest. Now, without further delay, let's get started. So in this session for today, which is SQL Server tutorial, we will cover the SQL basics, that is how to create a table, how to insert data, how to retrieve the data from the tables, etc. And apart from that, we will also go through some of the other fundamentals of SQL basics, which include sorting in SQL Server, and followed by that, we will also go through the group by and order by sequences in SQL Server. Next ahead, we will also learn another important part, which is conditional statements, which includes case statements in SQL. Proceeding ahead, we will get into another segment of today's session, which is about joins in SQL, where we will be combining 2 or more tables in SQL Server. Followed by that, we have the next part of today's session, which is all about the having clause in SQL Server. Next, we will proceed with learning the next part, which is about the between operator in SQL Server. And followed by that, we will get ahead with pattern matching in SQL Server. Next, we will cover the time and date functions available in SQL Server. And after that, we will proceed with temp, which is temporary tables in SQL Server. And proceeding ahead, we have the most important part, which is about the common table expressions in SQL Server. And followed by that, we have the last part in SQL Server tutorial, which is about creating views and executing a query to extract the data present in a view in SQL. So far, so good. So these are the foundational skills in SQL Server that you need to get before becoming a pro in SQL Server. So this particular tutorial will discuss the major foundation skills, the fundamental skills, the basics of SQL Server and its operations. Now, without further delay, let's get started with one of the compilers which can help us execute the SQL Server queries. So we are on one of the SQL Server compilers available online. In case if you are facing any difficulties setting up the SQL Server Management Studio in your PC, then you can come up with this one. And we have also set a particular tutorial where you can learn how to download and install SQL Server Management Studio and how to configure your SQL Server Management Studio. And the link to that particular tutorial will be dropped in the description box below. Make sure to refer that in case if you wanted to execute these same codes in SQL Server Management Studio. Right? So first, we will be dealing with 2 different data tables. We will be dealing with customer data and dealership data. So the first table will be about the customer data, where we will be having about the order ID, order date, delivery date, dealership pin code, product category, and car fuel type, etc. Followed by that, we will insert some rows into that particular customer table, about 15 to 20 tables. And after that, we have a dealership database where we will be having order date, state, region, customer ID, customer name, primary key, foreign key, etc. And we will be inserting about 20 entries into that particular table. Don't worry if you have more than 20 entries. In case if you have more than 20 entries, let's say about 2000 entries or 20,000 entries, it's not at all a big deal if you're working on SQL Server Studio, right? There you can use the wizard to just ingest the data from your source into the SQL Server, right? You can use SSIS tool to import all that data and you're good to go. You don't have to manually create the data and you don't have to manually insert the data. Just for the sake of learning the basic process of how to create a data table and how to insert the data table, you're going through this particular procedure. So far so good. So we have also inserted the data in the next data table, which is our dealership data. And now let's query the data from our tables. And now let's select the execute data. There you go. We have the data table right over here. And let's copy this query and paste it to query the data from the customer table as well. So instead of dealership, we will be writing down customer. So if you observe closely, I'm using uppercase for keywords like select and from, and sentence case or lowercase for the variables, the table names, etc. So that there's a difference between the keyword as well as the regular variables. There you go. We have executed the customer data and here we have it. The order ID, order date, delivery date, days to deliver, category, and etc. Now, let's mention the use cases, correct? So let's use double quotes, or maybe we can also use hashtag along with the pipe symbol here or the slash symbol here and write the use cases and then proceed with executing the codes or queries. So the first use case is let's try to filter customers from specific regions. And now let's close this particular comment, proceed with writing the query. So we will be using select keyword and we want customers from a specific region, right? So let's write down the customer name. So I think the customer name is not mentioned in the customer data, but instead of customer name we have a order ID. So let's extract the order ID, not a problem. Select order ID and dealership name, permanent state, and the important part, which is about the region and what product did they and what's the revenue that the dealership has extracted out of that particular customer from the table customer. Next line is about join dealership. So we will be using join table dealership, the keyword. So we have one common keyword in between both the tables, which is about the order ID, which is equals to order ID. So this is not done here. Since we are clubbing both the tables, we need to specify the tables here. So dealership dot order ID and customer dot order ID, so that the SQL Server will identify we are trying to map two different tables and we are trying to combine and extract the data. Now we are trying to filter out customers from a specific region, correct? Now we will be using where clause to specify that particular region. So let's go with West region, correct? Since we are using the text format here, so it's better we choose double quotes, correct? Now let's run this query. Let's give it a next try. Ambiguous order ID. So let's do one thing. We will pull customer table name here so that it's no more ambiguous. There you go. So the thing is, we have order ID in both the tables, customer table and dealership table. So SQL Server got confused here, which particular table you want me to extract order ID from. So if you mention customer table or dealership table, it will choose a specific table and extract that particular column. Now we have the order ID, dealership, and all the members that we selected are from the West region if you check here. Now let's proceed with the second use case of today's session. Okay, let's continue with the same here so that it is clearly visible for us. Now let's sort, we're using the sort command here, products based on the revenue. So it's like maybe highest revenue should be in the top or lowest revenue should be in the top. Let's go with the highest revenue. Okay. Sort products based on or based by revenue. We will write the command here itself. We will go with some columns. I would like to have product here, so I'll eliminate everything else, and the product will be here. And I want the revenue as well. Now I don't want the revenue, I want the total revenue. So if you're looking for total, then you will be going with the function or aggregate function, which is sum, right? I want the sum of all the revenues that particular product has earned throughout the years or that particular financial year. From which table? So I have both product and revenue in the customer table itself. So I'll go with customer table itself. I don't want to join anything here. I'll eliminate the join command. And instead of region or instead of where command, I would use the group by command here. Group by product. And it is not done so far. We want to order it. So we want to keep it in descending order so that the highest grossing product is on the top and the lowest grossing product is on the bottom, right? So that we can also make sure that our inventory is filled with those products which are giving us high revenue. So we will be using order by total revenue, right? So we can give it an alias as total revenue. Right now we can use this particular term here, order by total revenue, descending. DESC is good enough. Now this is how you will sort the products. Now let's execute this particular query. There you go. So the car model T, okay, yeah. So the car model J is giving us the highest revenue. Next is followed by T, M, and S and G. So we are not mentioning specific, if you go back to the table, here we are not mentioning the actual car brands and actual car names so that we don't want any copyrights to be faced. So we are just mentioning some random names, not to be too specific there. Now, let's proceed with our next query for this session, where we want to group by state and calculate total revenue. Let's edit the same comment here. Don't worry, if you want this demo document, we will also link that demo document with all edit and view rights so that all the viewers can have a quick glance and try to execute these queries in their own local systems. Okay. Now let me type down group by state and calculate total revenue. There you go. Now let's try to edit the same query. Now we want state-wise revenue and we want from customer table, right? We want to join a dealership for this particular one because dealership is the one which has some details for it. So the state data, right here you can see we have inserted state data California, Texas. So we want the state data, so it is present in dealership table. So we also want to perform a join there. No worries, let's edit the same query here. So we want, instead of product, we want state. And instead of sum of revenue, we want revenue. So we will keep it as it is, total revenue as total revenue, sum of revenue as total revenue from customer table. And we want to perform a join operation. So let's create some space. Join dealership. Okay, let's copy the name so that we don't make any confusions here. Dealership, sorry, here. Don't worry, we'll make some edits down the line. Dealership on order ID. So let's go with the order ID, which is available here. Order ID equals to order ID. Remember the first step we did. eliminate the confusions by mentioning the table names, dot column name, and customer name, the customer table name, dot column name on, we did it, on dealership dot order ID equals to customer dot order ID. Now we will be performing the group by operation. We don't want the order by here. Group by state. Of course, in case if you wanted to, order by the highest grossing state, you could have used order by there. But so far, according to the use case, we don't want that. So let's continue with the same execution here. Click execute and you will be having the answer here. So based on the states, you have their respective revenues. There you go. Now let's proceed with the next use case for today's discussion, which is about using a conditional statement like case. Using case, query, or clause for custom calculations. We'll perform some customized calculations. Now let's say we wanted to find out a product which is giving revenue greater than 10,000 as high revenue. Let's say we have revenues in terms of thousands of dollars, and let's have a benchmark like $10,000. And $10,000 is the minimum revenue you wanted to extract out of that product. And if it is not yielding at least 10,000 for your dealership, then that product is not selling much. So that you can at least make some space in your dealership so that you can import some products which are giving you highest revenue, right? So we want to find out those products which are giving us revenue between 5,000 to 10,000 as medium revenue, and less than 5,000 as low revenue, and greater than 10,000 as high revenue. You understood the game, right? So we have three segments: high revenue, medium, okay type of revenue, and least revenue products, so that you can eliminate the least revenue products out of your inventory. Now we want order ID. So copy the order ID from here and paste it here. So we are looking for order ID, and we are also looking for product. So we don't want sum of revenue here. Let's eliminate this one, and instead of that, let's add product. From we'll extract this from, before from, this from statement will be at the last. Here we will begin with a use case, right? Let's type case. Now when a specific product or revenue, revenue is greater than $10,000, then let's not use sentence case, let's use keywords in caps. Then mention it as high or high revenue. Let's copy paste the same code here. When revenue is between 5,000, and we will be using an AND operator here, then term it as, we don't want alter, average revenue or medium revenue, and copy paste the same here. Remove the alter. And revenue is less than, I think we don't want to use this. Instead of this, we can just place else, right? So we will place else. It should be termed as low revenue or least revenue. Let's go with low revenue. There you go. And now from which table you want to extract that? I want to extract all this data from customer table. So everything will go off apart from that. Now let's execute this particular code. Let's see if we get any errors. Incorrect syntax for case. I think we made some mistake here. We forgot the comma here. Should have mentioned the comma. And so the thing is, we by mistake chose the alter from suggestions, alter keyword from suggestions. So far we missed a comma and alter from suggestions. I think it's everything good to go. Let's try to execute, and if it faces some issues, no problem, we'll try to resolve it in a different way. So incorrect, we missed to write the end. We did not end the case. Okay, fine, not a problem. End as, okay, let's term it as the entire table as revenue category. Since we are splitting into 3 categories, revenue categories. There you go. So this is the way to learn. Make some mistakes so that you can learn in a better way. For the next time, you'll never make a mistake. So far, so good. So we have all the car models have, categorized into the revenue categories: high revenue, low revenue. So far, we have all the cars in high revenue. Not a bad deal. I think all the cars are performing really well. Maybe if we change the numbers a little bit, maybe if we take up 1 lakh in place of 10,000, then maybe we can get a couple of cars. But so far, so good. This is how the query works. Now, let's switch to our next query, next use case, where we will be combining data from multiple tables using a join. We already did that, but still, for the sake of learning experience, we will also perform that particular operation. So we will be naming this particular use case as combine data from multiple tables using a join. So far you have already have a good experience on how joins work, but still we will try to do that. Now we will use customer table here, customer table dot order ID, and we want customer table dot product and customer dot revenue. And, let's also say take some data from dealership. So we already know that some data of states is in dealership, so we'll also take the dealership data. So dealership dot state. We'll also take the region, dealership dot region from customer table. Let's eliminate the case statement from customer, and we want to join. Let's push this to the first line so that we don't have confusion how and where the query is going on. So here I want to join. So the second line is all about join dealership. So let's copy this. We are combining dealership with customer on order ID. In the same way, we will take order ID equals to order ID. Now, which order ID is equals to which order ID? The first table, customer.order ID, is equals to the second table, dealership order ID, so that SQL Server understands which columns from which tables are being joined here for what reason. Right, so far so good. We have given the columns that we want to have in our output, which are these columns, and we are joining two tables based on certain criteria. But now, maybe we can specifically mention some more data. Let's say we already mentioned some query where we wanted the data for a specific region. Let's try to continue that, where region is equals to West. There you go. Let's close the single quote or double quote. Now what happens is it is trying to give us the details of customer order ID, product, revenue, state, region from customer table, and we are going to also execute or extract the details of state and region from the dealership table, and we are trying to join to extract those data with dealership data, and we are specifically extracting the data where the region is West. Let's execute the data. Don't worry if we find any errors in this particular code. There you go, we have the result. So we have all the details from the West region. There you go. Let me expand this so that we have a better view. Anyways, it's okay. Now let's go with the sixth query for today's session, where we will be executing a query based on having clause in SQL Server, and we will try to filter out some states. Only show the states where total revenue is greater than 50,000, just like we discussed before. We initially used a case statement with $10,000 at least revenue, but now let's increase the number to 50,000, and we want those states which are giving us minimum 50,000 revenue. So let's rename the use case here. We will try to name it as filter data or groups with having clause. Okay, so we want state. We have state here. And let's also count as total orders. So order ID. So customer.order ID will be now count of total orders. So the count will be the aggregation function here, count total order IDs, and we can name it as total orders. And do we have revenue? Yes, we have revenue. And let's also remove the product. I don't think we might need a product here. And the aggregation will be sum aggregation here, sum of revenue. And I don't think we need to specifically mention it here. But anyways, we'll keep state first. Copy state and drop it here. We want state count of orders as orders and sum revenue as total revenue. What this does is it will give a clarity, right? So instead of if I don't alias it, what it shows is sum of revenue. And for a generic person, it might not be as helpful as a data engineer can, right? For a data engineer or data analyst, he can totally understand by just reading the aggregation function. So we are counting the orders here, we are getting the sum of revenue here. But for a mere person who just wants to see the report, the business guy who just wants to see the report, for him, total orders or total revenue is a simplest language that he can understand, correct? Now we are extracting this data from customer, and we will join dealership again, okay, because we also want to extract the state, right? So we did not mention the state here. We can mention the state anyway. Okay, we did mention the state. So since we have the state column, for extracting state details, we'll anyway go for the dealership. So we are already joined dealership data with customer data. And let's do a group by function here. Group by region, group by state actually. And now the condition, having sum of revenue at least or greater than 50,000. So we will go with the having clause here, and the sum of revenue, or you can also use the alias name, total revenue greater than $50,000. So let's execute this query and see if the alias works or not. Okay, I think alias will not work here. In case of alias, let's go with the actual term and place it over here. And now let's try to execute this if it works or not. Okay, we mentioned two things here, region and the state. So we just wanted state there, not region. I think this should solve the issue. 20 rows affected, ambiguous column order ID. Now we will, let's say, take customer name and place it here. Or I think the dealership would be the best because we have the details of orders here. No. Customer table has the order details. So let's keep it that way. There you go. So we have so many number of states which have revenue greater than 50,000. So these are the outputs. There you go. Now let's proceed with the next query where we will be using the range function, which is also known as the between function in SQL Server. So let's name the comment as using the range function. Let's not capitalize it. Using the range function named between. So between is the keyword, right? Now let's build a use case. Let's identify couple of states. We will use the same query, will not make some major differences here. So we want to identify a couple of states whose revenue is greater than 50,000 but less than 1 lakh, right? This makes a good use case for that implementation of between function. We will keep all the columns as they are, and maybe we can also include a couple of columns, maybe product as well, and we will join two tables. Now I think we don't need a group by here, but in place of group by and in place of having, we will specify where sum. So to use where clause, so I mean to use between clause, having is not the right keyword, where is the right keyword. So sum of revenue should be in place of the symbol between, you take the suggestions, and 1 lakh. Yeah, this is 1, 2, 3, 4, 5 zeros. So this is the right way. Now let's try to execute if it works or not. If there is some error, yeah, there is some error. An aggregate may not appear where clause unless it is subsidiary. Okay, contain having clauses select. I think this is the place where we can go with the alias name. Let's try that. Or if alias does not work, then we will go with revenue. Okay, let's simplify this. Let's not go with the join statement here. Let's eliminate the join. We shall just simplify. We don't want state. We want, okay, let's not count this. There was no need for counting. I think that was one error. We will go with order ID as total order. We don't want this. And anyways, we want to take a look at the product and dealership name as well. And we also want revenue from customer table, where revenue is between these numbers. Let's try to simplify and run this query. I think it should work. Yeah, it worked. So these are the dealerships and products which yield in revenue between 50,000 to 1 lakh, right? So this is the best way to use it. So we had some extra aggregate functions which complicated the query. No problem. Now let's go with some pattern matching. Sometimes, let's say we are looking for sales from California or something like that, or we are looking for some car model, correct? And we don't know the full name, or we might have a spelling mistake, right? We have California here, but let's say we don't know the spelling of California, but we know the first 3 or 4 letters of California, right? So in those instances, what you can do is try to match the pattern that we have in our hand with the pattern which is available in the data table, and wherever it finds a match, it extracts those rows. So this is how the pattern matching works. Now let's execute a query for a better understanding. Let's keep the same query. Let's change the use case here using the pattern matching in SQL Server. So we will have order ID as it is, dealership name as it is, and product as it is from customer table, where product, so let's copy this and paste it here, like, or I like is the opposite, so let's go with like. Car model, let's check with the car models first. So all car models are the same. So maybe if we go with the fuel type, I think fuel type will help, because all the car models have the keyword car model, and the only thing is an alphabet M, etc. So it doesn't make sense for us to execute the like operator here. So instead of product, let's keep fuel type like hybrid, correct? Let's go with the hybrid one. So we will take only the first 4 letters. Let's imagine we don't know the full spelling of hybrid. So if the pattern is like, and since it's a text, we will use single quotes or double quotes. If the pattern HYBR matches with the elements or the column present in the customer data, it will pull all those columns or rows. Now let's execute this. So there you go. Okay, we missed one important thing. We missed to include the percentage. This percentage symbol will make SQL Server understand that the text should have HYBR, and after that anything is accepted. So anything which has a beginning with HYBR should be pulled out, right? Now let's execute once again and see the data. There you go. You have it. Correct? So remember the symbol percentage, right? And in case if you didn't knew the hybrid, let's say, it has some YBR in its format, right? It has some YBR in the format. Anything before YBR is okay, anything after YBR is okay. Again, it will yield in the same result, hybrid. There you go. But in case if you wanted to change, let's write the name of petrol. I don't know the spelling of petrol, so let's say P-E-E-T. So let's imagine I don't know the name of petrol, so instead of petrol, I'm eliminating P and I'm writing P-E-T-R and anything after that. Now let's run this query and see the output. There you go. So we have all the vehicles which are of fuel type petrol. So this is how you can use pattern matching in SQL Server. Now let's perform some calculations with dates, right? So we'll perform some date and time calculations. Let's rename the comment as date and time functions. Date and time and some math calcs. Now let's say you are the owner of dealership, and let's say for a specific car you are losing customers. Initially it used to perform very good, like many customers used to come for that specific car, and right now that specific car is receiving less orders, and you wanted to find out what is the reason behind it. And after a general survey you come to know that the number of days you took to deliver that car is growing. Let's say earlier you used to deliver that car in 2 days, but right now you're taking like 2 months to deliver that car, right? So that might be the reason, but you wanted to make sure that you have a solid proof that you have the number of days that you're looking at to show your sales team why is so many number of days is being taken to deliver a car. Now for that, let's go with select order ID, order date. You want order date for it. Now you can simply copy the order date here and paste it there, and you also want the delivery date and copy that and paste it there. Remember, these date and order date and delivery date are of date data type, and now you want to calculate the difference. So for that you use a function called dateDiff or datedDiff. So there's two ways of calling it. So if you prefer calling it as date, right, diff, or a few call it as dated diff. Okay, so there's two ways of calling that function. So I prefer to call date diff because date difference. So date diff, comma, open bracket. So I want to provide some details here. So I want to provide a day. I want to count the days, right? So I want the count of days. I'm mentioning day and order date. Difference between the order date and the delivery date. You can specify that using a comma. So I want the difference between these two. In case if you want to alias it, you can also do that. Days to deliver from customer, and we don't want this. Simply place a semicolon there, and now just copy this and execute. There you go. Now you have the number of days that you or your sales team is taking to deliver the vehicles. So, and on an average, you're taking about 10 days to deliver. Now you can prove this to your sales team and let them know this is not good. You want to have at least a minimum 4 to 5 days or 2 to 3 days to deliver a vehicle. If this goes on, the sales might drop and it might be a little problematic, right? Now let's proceed with the next use case of today's session about the temporary tables. Now, why temporary tables? So there comes a situation where you have to just run some numbers, run something very not too critical, but you just wanted to do that. So in such scenarios, what you can do is you don't want to harm the original table. So what you can do is you can create a temporary table or a copy of that table, which is somewhere in the intermediate memory storage. And as soon as you close the studio, it fades away and nothing happens to your original data table. So that is where the temporary tables come into picture. Now let's create a simple use case for that particular temporary tables, right? So we will be selecting order ID, and let's also take product, and let's also take revenue into temp order. Yeah, it's enough. Temp order tables. I don't want that. Temp order, and I don't want to alias it. And from which table are you taking that? I'm taking that from customers. You can either choose to keep it in a new line, or you can keep it in the same line, but I want to keep it in a new line. from customers, and where revenue is, I said you right, you wanted to just explore a few things which is not too mandatory, but you just want to take a look at it. That's why you take the option of creating temporary tables, and I want to find out which are those products which are giving us revenue greater than 1, 2, 3, 4, 5, $1 lakh, right? Now let's run this. It's done, but we don't know where it is. So what you can do is you just write up simple select query, select star from your temporary table. Close the query and run it. There you go. So far there are no such products which are giving us greater than 1 lakh sales about that single product. Invalid object name, temp order. Okay, there might be some error about this particular query. Let's try to reduce the number. Did we miss anything? Where revenue is greater than, okay, this is a number, we don't want semicolon there. Okay, we missed a semicolon here. Let's run this, execute. Let's keep it as 10,000. Okay, so there was no certain product which was above 1 lakh. That was a problem. Okay, so these are the products which are giving us 10,000 sales at least. Not a problem. Now let's proceed with the next important part of today's session, which is about the common table expressions. So remember, common table expressions are also known as CTEs, play a very major role in real-time data analytics. Right, so let's have a sample of that. Let's create a common table expression, which is rather simple, and just learn how technically it works. Right, so the only difference is the CTEs start with a keyword named as with, and after that you can term your common table as some data, so or some name. I'll give it as sales data as, and open a bracket, and inside this bracket is where you write your actual query. Now let's organize a few things. I don't want the temp order table here. I don't want temp order here. Okay, I want to extract a few columns. I want maybe state, and I maybe want I don't want order ID. I want revenue. Maybe revenue is good. So let's sum the revenue and term it as total revenue from customer. And now let's proceed with a join command where we will be joining dealership data. Let's copy the dealership data table name. We will be joining based on the order ID that is common. So maybe order ID. Copy the order ID is equals to order ID. And which order ID are you talking about? I'm talking about customer's order ID and dealership data order ID. So we need to mention that on dealership.order ID and customer.order ID. Group by state. So since we took state as well, we can use a group by function here. And this is not the end of everything, so semicolon may have to wait. So this is the first part. Now using this particular CTE, this entire term is CTE. So the output of this particular query will be stored in sales data. Now we will make use of this CTE or sales data term to extract a few more queries. So we will be writing another select statement. Select state from, okay, let's also take the total revenue which we created here. Let's take that same term here so that we don't make a mistake, from the CTE which we created very recently, which happens to be the sales data. where total revenue is crossing something about $50,000. And now is the semicolon. Let's try to execute this. There you go. So a few regions or a few states and total revenue which are exceeding $50,000 are.
Now, what is SQL Server? In any application development today, in any computer application which we develop, database, SQL Server plays a very important and pivotal role. SQL servers are used for persistence of information in your database, which can be retrieved, mined, data mined, or you can query it at a later point of time. The benefit of having any SQL server is that data is persisted in a structured, efficient manner so that it can be retrieved later quickly and meaningfully. So SQL Server is a relational database management system in which you can create tables, two-dimensional tables, and connect them using referential integrity like primary key, foreign key, and other kind of integrity constraints you can maintain in this relational database. SQL Server is developed and marketed by Microsoft. So this is a Microsoft product, but it is compatible with all the technologies which you might be using or you might want to use, like Node.js, Java, etc., where you want to connect your middleware application server with Microsoft SQL Server. Now, what is the usage of SQL Server? Apart from the definition which I just shared with you for maintaining and building databases, persistent databases, there are other usages also which I'll explain you. Now the first one is SQL Server Analysis Service, which is used to analyze data. Now the SQL Server Analysis Service, or SSAS, is a multi-dimensional analysis tool that features online analytical processing, provide powerful data mining capabilities, and deeper dimensions to business information within a relational database. Multi-dimensional analysis is an online analytical processing technique, OLAP technique, that produces the ability to analyze large quantities of data by storing data in axes and cells instead of traditional relational two-dimensional view in rows and columns. SSAS places predictive analytic capabilities in the hands of information workers by creating an instant connection to backend data using familiar applications such as Microsoft Excel, SharePoint, etc. for analysis, visual representation, and collaboration. The next is SQL Server Reporting Services, which is used to generate reports. Now, SSRS is a framework of reporting mechanisms such as the report builder, report designer, report manager, and report server that work together through a web interface to enable the development of concise, interactive reporting solutions in print or web format. Report Builder and Report Designer are two SSRS components for generating reports. Report Builder is a simple solution for the information worker or business user to create quick reports without the need to understand the core structure of the data. The Report Designer is a tool for developers because it adds complexity to custom reports development and you create data models in it. Using this tool requires an understanding of the Business Intelligence Development Studio shell in Visual Studio and the underlying structure of the data. So you have to be aware of it thoroughly. According to Microsoft, the report server is the core process engine in SSRS that manages the processing and delivery of reports using processors. The report manager is an administrative tool that controls reporting services through a web interface. Now let's talk about another important component, which is SQL Server Integration Services, SSIS, which is being used to perform ETL operations, extract, transform, load. Now SSIS is the data warehousing arm of the SQL Server, equipped with superior extract, transform, and load capabilities, ETL. It provides the vehicle for moving data from different data sources to another and changing the data if necessary. The three components in the SSIS platform for starting the data integration process are the import and export wizard, SSIS designer, and SSIS API programming. The import and export wizard simply transfers data from source to destination but does not include data transformation capabilities. It's the SSIS designer is an integrated component of the business intelligence development studio used for the development and maintenance of integration service packages. SSIS API programming module allows you to code SSIS packages using any number of programming languages. So there are a lot of features which are available to you in order to manage your data, create your data pipeline, structure it, build visualization reports, perform ETL operations, etc. So it's an entire solution, enterprise solution. Now let's see what are the different kind of SQL Server editions. Microsoft provides 5 editions with various tools and services and pricing options as per the needs. So the 2 editions of SQL Server which are free of charge are SQL Server Developer and SQL Server Express. Now the Developer SQL Server edition works and functions exactly like an enterprise SQL edition. The only difference is the license is used for testing and development purpose only. This edition is generally used by developers to build and test applications on top of the SQL Server, but they can't take it to production. SQL Server Express edition now is the free entry-level database version and is ideal for learning and building desktop and small server data-driven applications, but not meant for any serious computation, while also having incredibly limited features. Now the other editions are used for commercial purposes. SQL Server Web Edition. It is a low total cost of ownership option for web hosts and web value add providers to provide scalability, affordability, and manageability capabilities for small to large scale web properties. The SQL Server Enterprise Edition delivers comprehensive high-end data center capabilities with blazing fast performance, unlimited virtualization, and end-to-end business intelligence enabling high service levels for mission-critical workloads and end-user access to data insights. This version has all the features required for big data. Now, SQL Server Standard Edition, this delivers basic data management and business intelligence database for departments and small organizations to run their applications and support common development tools for on-premise and cloud enabling effective data management with minimal IT resources. Now let's look at some advantages of SQL Server instances. Its installation is of different versions on one machine. You can maintain different installations. The maintenance of production, development, and test environments can be done separately. You can maintain a standby server. So installation is streamlined. It can be installed via setup wizard and the prerequisites updates are detected and downloaded by the installer automatically. The complexity of the installing the software is minimized significantly because of automatic installation of updates. Other components such as analytical and database services can be installed separately afterward. Automatic updation also reduces maintenance costs quite significantly. SQL Server 2008 uses policy management to detect security policies that are not compliant. So this feature allows only authorized personnel access to the database. Security audits and events can be written automatically to log files. MS SQL Server has built-in transparent data compression feature also along with encryption. Users don't need to modify programs in order to encrypt the data. The MS SQL Server has access controlled coupled with efficient permission management tools. Further, it offers an enhanced performance when it comes to data collection. Okay, and coming to the cost reduction, so it has lower cost of ownership. SQL Server includes effective data management and data mining tools along with disk partitioning. Your server's optimum maintenance can be ensured by following effective data management practices. These practices also help you ensure the availability and recoverability of data.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's move on to creating a database in SQL Server. So I have installed the default SQL Express on my machine, and now I'm gonna create a database called SQL Tutorial. So let's create a database called SQL underscore tutorial. Okay. Now I will write certain queries on top of it. First, I'll create a table customers. Let's create a table customers which has columns customer ID, which is its primary key, the name, which has varchar, customer ID is int, age, which is an integer, gender, male, female, will notify it with one character, address, which is generally a large string value, so we'll keeping it varchar 20, item, which is varchar 15, and price. Okay, so let's create this table. Okay, so now if you see, this table has been created, dbo.customers. Now all the relevant columns which I created here has been present. Now I have prepared a script to insert some sample values so that we can query this. So I have inserted around about 20 values. So let's just check whether my data is present. I'll do a select star from my customer tables, and you can see now the 20 rows with the customer ID, customer name, age, gender, address, the item which the customer has purchased, and the price at which he has purchased. Now let me show some variations of the queries which we can perform. Now select star means you have selected all the columns. I only want to select some selective columns like customer name and gender. So I can also do that. You just need to give the name of the customer and the gender column. Next query. I want to check what is the distinct values of the gender in my customer tables. So I will only get two values, which is male and female. So there is no other value apart from M and F in my customer table. Next, I have a query where I want to find which all are the customers who have purchased an item. Who all are the customers who have purchased an item which is having price greater than 250 rupees. Okay, great. So out of 20, only 12 are the customers who have purchased a price item which is greater than 250. And you can see all the items which are listed over here are greater than 250. Next, okay, I want the customers who are living in New York. Okay, fine. I just have to change the where clause where instead of the price, I am now looking at the address which is in New York. Now it is also possible that you can apply another filter. Okay, people living in New York but age is greater than 28. Perfect. I only have two customers who are living in New York but having age greater than 28, or I want the female customers who are purchasing items greater than 380 rupees. Okay, only 1 out of 20. Okay, Elena. Now we saw examples of AND condition. There is also possibility that, okay, you want female customers or customers who are greater than age 30. So you will get both the records, age greater than 30 or female customers. Both the records will come. Or customers who are in Chicago or purchasing items greater than 420. So these are the examples of or conditions. Now let's take another example of not. Now I want that the customers who are not purchasing price less than 650, the reverse, right? Greater than 650. So I'll get this answer. Or I want the customers who are not living in New York, apart from New York, any other address. So all these customers are there. Okay. So now these are the examples which I showed you are the examples where you can play around, you can filter data applying the where clause. Now let's take another example of aggregated functions in SQL. Now amongst the list of customers, the data set of customers which I have, I want to know what is the minimum age of my customer. Minimum age is 18 years. So the minimum age amongst all the customers is 18 and the maximum is, I can just change it to max, is 61. So the age range of my customers who are purchasing are from 18 to 61. Okay, now another example, hypothetical example. I want the average age of my customers where customer ID is greater than 105. Okay, so if you see, select star where customer ID is greater than 105. I have 15 customers, and amongst these my average age of my customers is 35. Similarly, instead of average, I can take the sum total of the age above 105, which is 539, sum total. Okay. Now I'll show you an example of like. I want the customers list where addresses which consist of letter E in their address, anywhere in the string, beginning, in the middle, because I have like is a keyword, like percentage, percentage means E can come in any part of the string. Okay. And if I just change this example, I remove the percentage from here, it means that I want the customers whose addresses end with E. So only Pune will come into the picture. Okay. So this is the difference. Now coming, select star from customers where age which between 20 and 30. So I want all the customers which have belong to age between age 20 and 30 inclusive. So 20 and 30 both are inclusive. So it means the customers with age 20 and all 30 will also come in this result set. Next example, I want the count of total customers in my data set, which is 20. I inserted 20. So I know now I have 20. I want the count of male customers. Oh, out of 20, 19 are male. Okay, great. And if I group by, now let's see an example of group by. So I want the count of customers grouped by address. So how many are living in Boston, how many in Chicago, Detroit, Miami, New York and Pune. So I have a customer wise total, count total basis the address, group by. Okay. So it's a very important concept. You can group by any column and then you can do a measure count, a sum, an average. You can do any aggregated calculation basis the other columns which are not in the group by. So like another example, I want an average age per address. So in Boston, the average age of my customer is 34 who are purchasing items, Chicago 35, Pune 43. So like that, you can do some analysis. This is all data analytics. Now let's see another example. I want to filter data now after doing a group by. It's not, so please note this is different from where clause. In where clause means filtering data before grouping. Having clause is used once you want to filter data after grouping. So you are doing a group by address, count of customers, and then only those cities should come where count is greater than 2. Okay, so the customers, only those addresses are listed where customers count is greater than 2. Okay, now this is an example of inner queries. You want group by customer name and age only those customers having age greater than the average age of overall. Okay, so my average age, if I say my average age from customers is 36, so overall all the customers which are more than 36 should come over here, listed over here, and that's what has happened. Okay, now let's talk about order by. It's like sorting. You want to order by address, so it has ordered by default B, C, D, M, N, P, which is ascending, and if you apply keyword descending, so it will do the reverse way. Similarly, I can order by age, which is descending, highest age first, lowest below, or you can do order by multiple columns, where order by address descending, and then same address, within the same address the customers should be ascending. So addresses are descending, but within the address the customer names are sorted in ascending fashion, A first, B, C, D, like that. Now there's an inbuilt function in SQL Server, reverse. If you see, this has reversed the name of the customers. It's in reverse fashion. Okay, the characters are reversed. Another example is where you are, now this is not on the table, this is just a sample query where you are replacing vegetable with fruit. So orange is a fruit, so you have replaced vegetable with a fruit. It is just a, you don't need a table. You can just also write such queries where you don't need a table. Okay, then there is a function called ltrim, which will remove all the blanks from the left hand side, rtrim, which will remove the blanks from the right hand side. Okay, let me read an rtrim. It will remove the blanks from the right hand side, and then there is trim function which will remove from both the sides, left and right. Now let's take an example of update command. I want to update the name of my customer whose customer ID is 103. First, let's check what's the name. So customer name right now is Whipple. I want to change it to Smith, and if I requery, it is changed to Smith. Okay, so this is an example of update. Now if I want to delete, let me check who is at 101. I want to delete customer 101. Joseph, I will delete it. And now if I want to check, okay, there is no customer at 101. Okay, now let's take another example. This is like another example of inbuilt function ASCII. It will give you the ASCII code of the character, ASCII A, ASCII 4, etc, etc, right? So there is n number of possibilities. There's an n number of queries which you can write.
If you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who elects to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's Data Engineering Postgraduate Program from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered.
So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright, so this is my MySQL Workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause, or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee from my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select. I want the employee name, comma, the gender of the employee. I also want the department and salary from my table name, that is employees. I'll write where salary is greater than. I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with two different tables. So suppose you want to display some information that are present in two different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database that is classic models from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using two tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is, I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table, and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay, now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay. So first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players, and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write &&. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was $. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top_players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top_player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top_players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment, stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL_IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records, so I'm using this limit keyword and my variable var which I created here. I'll end my select statement. I'll end my stored procedure with /, and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is SP_sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is SP_sort by salary, the other two were top_player and top_players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is SP_sort by salary, and inside this I'll give my parameter, which was actually var, and this var we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /. Then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name, I'll write in and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in 2 parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says 1 row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore EMPs, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter to / I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore EMPs. From my table, that is EMP underscore details, where sex is equal to F, which means female. I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I am creating a new stored procedure, that is sp underscore count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table emp underscore details. So I've used my out parameter and I'm creating a new variable called total underscore emps. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I'm storing it in total underscore emps. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp underscore count employees. Now to call it, I'll write call the name of the procedure, that is count underscore sp underscore count employees. Within brackets, I'll pass in the parameter as @f underscore emp. I'll give a semicolon. Then I'll write select @f underscore emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now, there are mainly 3 types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we'll learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I'm giving it as 30, finally we have the marks as floating type. So let's create this table which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting, if any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case, we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. Age is 13. The name is Dave. And let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. I'll give this as a comment. Okay, now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is, I'll write create view followed by the view name, which is cust_details. Then you write as select. I'm going to select a few column names from my original customer table, which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright, I'll write from my table, that is customers. If I run this, my view, that is cust details, will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name, that is cust_details. Let's run it. There you go. So we have the customer name, the phone number, and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that, I'm going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside Classic Models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there's some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name, that is product_description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table. I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay, so here we have used an inner join to fetch specific columns from both the tables, and our view name is product_description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product_description view. I'll write select star from product_description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay, now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cost details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be okay. So instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright, now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay, I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over, I want to partition it by department. So I'll write partition by department, which is DEPT, and I'll give an alias as total salary, so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright, now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num, give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name, which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values. I'll give 101. The name is Shane. Give a comma. I'll insert the second student name 102. The name is Bradley. I'll give a comma. This time for 103 we have two records. Let's say the name of the student is Herath. I'll give a comma. I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the fifth student, which is Kevin, we have two records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over within brackets. I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num, from my table that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, now if you see here, there is just one student in the name Shane. We have one student in the name Bradley. But here if you see, for Herath, the second record it says 2, which means there are 2 records for Herath. And if I scroll down, there is 1 record for Nathan and there are 2 records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when 2 or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable that is var underscore a as an alias name, let's say test rank, from my table that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function assigned the same value which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column that is salary descending. I'll give an alias as highest underscore salary from my table that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function that is first underscore value followed by the name of the employee inside my first value parameter. I'll write over. Here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial. So let me just scroll through and show you what we did from the beginning. First we learnt about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. We learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions.
If you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who elects to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's Data Engineering Postgraduate Program from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered.
Injection. So let's begin with what is SQL injection. As the name suggests, SQL injection vulnerability allows an attacker to inject malicious input into a SQL statement. So SQL stands for Structured Query Language, which is a language used by an application to interact with a database. Now, normally this attack is targeted towards a database to extract the data that is stored within. However, the vulnerability does not lie in the database itself. The vulnerability will always lie in the application. It is the developer's prerogative of how to develop the application, how to configure it to prevent SQL injection queries from happening. A database is created to answer questions, and if a question is asked, it is supposed to answer it. Database needs to be configured for some amount of security, but the vulnerability, the flaw here for SQL injection will always lie in the application itself. It is how the application interacts with the database that needs to be modified, that needs to be maintained by the developer rather than just configuring the database itself. So the attacker at this point in time, when they send a query to the application, will form a malformed query by injecting a particular command or an operator that is recognized by the SQL language. And if that operator is passed through the application to the database, then the database basically gets cracked or does a data dump because of that unwanted character coming in. So this character needs to be filtered at the application level itself. Now let's look at a quick demo. So what we have done here is I have this virtual machine called OWASP Broken Web Applications Virtual Machine version 1.2. I'm going to power this on. Till this powers on, I'm going to show you where we can download this utility from. So you can just look for OWASP Broken Web Application Project download. You'll find it on sourceforge.net. Click on the link. You can download the Broken Web Application Project from here. This is a 1.9 GB download, and you can have a zip machine directly for VMware or Oracle VirtualBox. Now, this is an application that has been developed by OWASP, which stands for Open Web Application Security Project, which is a not-for-profit organization and periodically releases the most top 10 risks that an application will face for that particular year. So they have given a web application with inbuilt vulnerabilities for professionals like us to practice upon, to develop our skills upon, because doing this in the real world is illegal. I cannot go onto a website to demonstrate how a SQL injection attack works. Neither should you try your hands on it till you become very well rehearsed with it. So to upgrade your skills, to upskill yourself, please download this machine, host it in a VMware workstation or an Oracle VirtualBox, and you can then try your skills on it, right? So just going back to the browser here, if I open up a new tab, you'll see that this machine has booted up and has an IP address called 71.132. So if I just go onto that IP address and I type in 192.168.71.132, and you'll see the OWASP Broken Web Application Project, and there are a lot of training applications, realistic intentionally vulnerable applications, old versions of real applications, and so on and so forth. So there is a lot of applications inbuilt over here that you can try your skills upon. We are going to try to use the OWASP utility over here. This gives you the OWASP top 10 risks for 2010, 2013. 2017 is the latest one so far, but the difference between 2013 and 2017 is that some of these have changed, but not all of them. The order has changed a little bit, but you can see that SQL injection is on the top A1 amongst the injection attacks, right? And you can see there are multiple types that have been given here: the SQL injection for extracting data, or SQL injection for bypass authentication, or insert your injection attacks, blind SQL injection. And then there is a tool called SQL Map, which is available freely on your Linux machines, Kali Linux or Parrot Linux, whichever you want to use for your practice targets, and so on and so forth. So if I just take you here for bypass authentication, and this is a regular login page that an application may have, right? You look at a username, you look at password, you type that in, and you log in. So let's say I don't know a password here. I'm just going to type in the username test. Password is PASSWORD. I try to log in, and it shows me that the account does not exist. So the authentication mechanism does work. I did try type in a username and password. It wasn't recognized, so the account does not exist. Now let's try to type in a SQL query. Here I'm going to just give it a single quote, which is an operator that is recognized by the SQL language, which when the database tries to execute will cause the database to dump some data or to bypass authentication in this case. And I'm going to give it a condition, single quote, or 1 equals 1 space hyphen space, and I'm going to click on login. Now right now I'm not logged in at all, and we tried our username and password and we weren't able to log in. So now if I log in, you will see that it gives me a status update saying the user has been authenticated, and I'm logged in as admin, got root. So that is what these SQL queries can achieve. I'm going to log out right now, and we're going to look at the basics of SQL injection. So looking at that small demo, now let's look at what types of SQL injections are available. So the first is in-band SQL injection. There are two subtypes within in-band: error-based injection attack and a union-based injection attack. The second type is blind SQL injection attack, where there's a Boolean-based and a time-based attack. And the third one is out-of-bound SQL injection attack. Now, what is in-band SQL injection attack? In-band is where we are either attempting the error-based or the union-based. What is error-based? We send a query to the database, we craft a query to the database, and it generates an error message, and it dumps the error message right in front of us on the screen. That makes us realize that there is a flaw, and there is some information that is dumped on the screen, which we can then further utilize to craft our further queries as we go ahead. Whereas union-based is it is where we combine multiple statements at the same time. So if you look at the URL, earlier in the URL, you would see a large structure in that URL. We can try to add two or more statements within the URL itself to combine them and then confuse the database into executing both the statements together and giving a data dump at the same time, right? So what would an error-based SQL injection look like? If I go back to the same database, which is here, right? And if you remember the username, we gave it a single quote or 1 = 1 space hyphen space. We gave it the condition, right? So basically what it did was a single quote is an operator that goes to the database, selects the default table in the user tables in this database column, and then compares it to the condition that is given. So the condition that we gave was 1 = 1, which is always true. So what it did was it selected the default user table that was available in the database, and instead of comparing it to a password, it compared it to the condition. So if I give it 1 = 2, where the condition is false, and if I log in, you will see that the account doesn't exist, comes back again, because the condition was false, and instead of comparing the user account to the password, it basically compared the user account to the condition. So if I give it a single quote or 1 = 1 hyphen space and log in, you can see that this is a correct condition, and thus we are able to log in. Now, before we even go to that extent, if I just forget the condition over here and I just give it a single quote, the operator, and I send this operator to the database and I click on login, you will see that it generates an error, which is right on top, and it tells us the line, the file where the error happened, and you can see it happened in the mysqlhandler.php file, right? And then it gives us the message, you have an error in your SQL syntax, check the manual that corresponds to your MySQL server version for the right syntax to use. Now, why would a hacker want to do this in the first place? Because there are different types of databases. So there is a MySQL, MS SQL or Microsoft SQL, Oracle SQL, IBM DB2. All of these are variations of the SQL database. They use the SQL language. However, every database has its own command, right? They have their own syntax, they have their own specific commands that are utilized for the database. So in this scenario, the hacker wants to identify what database is being currently utilized so they can craft those particular queries. So now with this injection, with just me sending the quote and the error getting generated, I now come to know that we are using a MySQL server, and the version of that server is 5.1.73, and the rest of the information about where the handlers are located and so on and so forth, right? This gives the information to the hacker of how they want to proceed next, what kind of queries they want to create, what kind of syntax they want to utilize. So error-based attack is where you generate these kind of errors and you get this information. The union-based is where you craft your queries within the URL. You can try to combine multiple statements within the input fields and try to generate a response from that. Then we come to Boolean-based SQL injection. Sends a SQL query to the database, which forces the application to return a different result depending on whether the query returns a true or a false result. So basically, if the input is false, both the inputs are false, the output would be false. There's one input that is false, the other input that is true, input B, the output would be true, and so on and so forth. Right? So depending on the result from the inputs, the attacker will come to know which input is true. With this, he can then access the database of the website. So you're trying to figure out by sending out multiple inputs and then analyzing the output to see what exactly, which command exactly worked, what was the resultant output of that command. Thus, from this kind of an information, the hacker can infer their next step forward. Then you have time-based SQL injections. Now, there are times when a database administrator or an application administrator has done some security configuration and thus have disabled verbose error messages. Now, what is a verbose error message? The error message that we saw right here is a verbose error message. That means that the message gives out details. The message gives out details about what the database is, the version and whatnot. So if they have sanitized these errors and you no longer can generate these errors and thus you cannot figure out what database is, then what do you do, right? For example, if I just take you to Simplilearn, and take you to a URL that is supposedly not accessible, you can see that it gives a generic error. Oops, like it looks like you have crash landed on Mars. It doesn't give you a verbose error that we saw here. So this gives us a detailed error of what went wrong, where it gives us the database, the version of the database, and where the query went wrong, and etc, etc, etc. Whereas on this site, where there's a lot of security that goes in here, so you can see that it doesn't generate a error. It just get a generic page in front of you. So in that case, what does a hacker do? So the hacker then injects a time-based query in the URL, which allows us to verify whether the command is being executed or not. So we put in a time wait, let's say 10 seconds of time wait. So if the moment we inject the query, if the query times for 10 seconds and then gets executed, that means that the SQL injection is possible. However, if we inject the query and it just gets executed without the delay, that means that the time injection attack would not be possible on that particular site. Out of bound is not a very common attack. It depends on the features being enabled on the database management system that is being used by the web application. So this can be a somewhat of a misconfiguration error by the database administrator, where you have enabled functions and not sanitized them. So you have not done in access controls properly. You have not given account control. So queries should never be executed at an administrative level. They should always be executed at a user level with minimum privileges that are required for that query to be executed. Now, if you're allowing these kind of functions to be enabled at the DBMS and there is an administrative account that can have access to them, at that point in time an out-of-bound injection attack is possible. So let's look at how a website works, right? How SQL works on a website. Now, the website is constructed of HTML, hypertext markup language, which would include JavaScripting for functionality, cascading style sheets for the mapping of the website, right? And then React, JS and whatnot for further functionality. Now, when we send a query to the website, it is normally using the HTTP protocol or HTTPS protocol. When the query reaches the application would then go ahead and generate the SQL query. At the client side, you'll have all these scripting languages coming in on the front end that we can utilize to craft queries and then send them across. At the server side, you'll have databases like Oracle, MySQL, MS SQL, and so on and so forth that will then execute those queries, right? So just to give you an example, if I use a tool called Postman, what we generally do when we craft a query is we send out a GET request to the website, and then we receive a response from the site with the HTML code and everything. So this is a tool that is utilized by software testers to test the responses that you're going to get from various websites. So on the left hand side, you can see I've used it on quite a bit. Here we have an example for gmail.com. So let's continue with that. So this is a GET request being sent to Gmail. The moment I send it, it's going to create an HTTP request and send it across. The response that I get is this. This is the HTML code for gmail.com, right? These are the cookies. These are the headers that include information. So you can see this is a text HTML. Character set utilized is UTF-8, and the configuration that has been done with the application, right? So this is where everything comes in. This is the cookie that has been sent with that particular request that I had sent out. Now if we analyze this query, right? So when we went on to this application and I typed in that single quote and we generated this error, right? You can see that the application converted this into a SQL query. So the query was select username from accounts where the username in quotes, single quotes, and we use the quote, right? The single quote right there. So that's where we use that operator, and that's where the exception error occurred. So these are the kind of queries that are structured by the application and then taken on to the database for execution. When we type in, it is a HTTP GET request with the username and password within that query that is sent to the application. The application converts it into a SQL query, sends it to the database, and the database responds with the appropriate response. So how do we prevent SQL injection in the first place? Use prepared statements and parameterized queries. These statements make sure that the parameters passed into SQL statements are treated in a safe manner. So for example, we saw that the single quote was an operator. This shouldn't be allowed to be utilized in the first place, right? So here, what we are doing here is a secure way of running a SQL query in the JDBC using a parameterized statement. Define which user we want to find. So there's a string, the email comes in. Connection to the database, we are going to figure out how the connection is going to be passed, how it is going to be created. Construct the SQL statement we want to run specifying the parameter, right? So we define how is it going to be created, what is going to be created, what can be passed to the database and what should not be passed to the database. So that is one way of utilizing prepared statements and parameterized queries. Then we have object relational mapping. Most development teams prefer to use object relational mapping frameworks to make the translation of SQL results set into code objects more seamless. So this is an example of object relational mapping where we map certain objects and allow that to be executed. And then escaping inputs. It is a simple way to protect against most SQL injection attacks. Many languages have standard functions to achieve this, right? So you need to be very careful while using escape characters in your code base when a SQL statement is constructed. Not all injection attacks rely on abuse of code characters. So you need to know what characters are being utilized in the configuration that you have created, in the structure that you have created, in the code that you have created. Which characters are being recognized as operators. You need to sanitize those operators, and you need to basically ensure that these operators cannot be accepted as user input. If they are, they're weeded out by the application and they never reach the database. Other methods of preventing SQL injection are password hashing, so that passwords cannot be bypassed, the passwords cannot be recovered, passwords cannot be cracked. Third-party authentication, you use OAuth or some other service for a single sign-on mechanism. Thus, you rely on a third party to maintain the security of authentication and what kind of parameters are passed. For example, using LinkedIn logins or Facebook logins, right? For the layman, you normally go onto Facebook and you allow, if you're using a game, right? If you start playing a game, you're allowed to log into the game using your Facebook credentials or your Google credentials. Now that is not just for ease of use, but the game user, the developer, has outsourced the authentication mechanisms to third parties such as Facebook or Google, because they understand that that authentication mechanism is as safe as can be. Facebook and Google are wealthy organizations, hire a lot of security experts, and the development for their authentication mechanisms is top notch. small organization cannot spend that kind of money on security itself, right? So you use a third-party authentication mechanism to ensure that these kind of attacks may not happen. Then web application firewalls. Having a web application firewall and configuring it properly for SQL injection attacks is one of the sure shot method of mitigating or minimizing the threat in the first place. So at this point in time, you have realized that the application has some vulnerabilities for SQL injection, and instead of recoding or restructuring the application, you want to take the easier way out or the cheaper way out. So what you do is you install a web application firewall and you configure the web application firewall to identify malicious queries and stop them at the firewall level itself, so they never reach the application, and thus the vulnerabilities on the application don't get executed. Buy better software and keep on updating the software. So it's not necessary that once you have a software, you install it, it's going to be safe for life. New vulnerabilities are discovered every day, every hour, and it may so happen what is secure today may be completely insecure tomorrow or the day after, right? So you need to keep on upgrading the software. If there are no upgrades available and the vulnerability still exists, you might want to migrate to a better software and thus ensure that you don't get hacked, right? Always update and use patches. Organizations keep on sending out updates and patches as and when they are released. You need to install them to enhance your security postures. And then continuously monitor SQL statements and databases. Use protocol monitors, use different softwares, use the firewalls to keep on monitoring what kind of queries you're getting. And based on those queries, you want to ensure the inputs and the queries that are creating are not detrimental to the health of the software that you have. So the key takeaways that we have seen here in a nutshell are: what is a SQL injection attack? We have seen the types of SQL injection attack, how it works, and how to prevent SQL injection attack. Now we have done a couple of demos.
Firstly, let us understand what is SQL. SQL, as it stands, is defined as Structured Query Language, is basically a standardized programming language that is used to manage databases, and it performs various operations on data in them. Initially created in 1970s, SQL is widely used by many companies and technologies nowadays. SQL is used for modifying database tables and index structures. It is also used in adding, updating, and deleting rows of data. It is also used to retrieve subsets of information from within the database management system. Now, SQL is used to perform various actions such as to insert data, to update data, modify, and delete the data in the database as well. Now, when we talk about SQL, it is important that we talk about relational database systems as well. A relational database system, or RDBMS, is a database system that stores and fetches data in the form of table, that is in the form of rows and columns. Tables are used to store data in relational databases about related objects. Each column contains attributes of data, whereas each row holds a record of unique data known as a key, which helps in making a relationship between different data points that is present in different table, which makes us easy to understand. Now, these relational databases, or RDBMS, are managed using SQL language to perform various operations. Therefore, SQL codes are used to retrieve information from these relational databases by doing various interactive operations like using join, create, truncate, delete, alter, and etc. Let us now look at some popular SQL databases. Some popular SQL databases that are available are MySQL, Oracle Database, Microsoft SQL, Server SQLite, and PostgreSQL. Now that we have understood what is SQL, let us now understand what is NoSQL. NoSQL database is a non-relational database management system that does not require a fixed schema. That is, the data is not stored in the form of tables in NoSQL databases. Basically, it avoids any joining or creating or scaling the databases in SQL. The major purpose of using a NoSQL database is for distributed data storage, which is having high volumes of data storage needs. NoSQL is used for big data and real-time web applications. Like, for example, companies like Amazon, Facebook, Google collect terabytes of users' data every single day. So basically, NoSQL database stands for not only SQL or not SQL, and it is introduced in the year 1998 by Carl Stross. Now, traditional RDBMS uses SQL syntax to store and retrieve data for further insights. Now, instead, our NoSQL database system encompasses a wide range of database technologies that can store structured, semi-structured, as well as unstructured data. Let us now understand why we use NoSQL. We use hierarchical storage structure instead of a table-like structure. That means before relational databases, companies used a hierarchical database system with a tree-like structure for database tables. Now, these early database management systems enabled users to organize large quantities of data. However, they were complex, often required a particular application and in a limited way, which they could uncover the data that is stored. Now, these limitations eventually led to the development of relational database, that is, the data that is stored in tables. So, SQL provided an interface to interact with relational data and allowing the analyst to connect tables by merging on common fields. But as time passed, the demands for faster and more desperate usage of larger datasets became increasingly more important for emerging technologies, for e-commerce and other big giants. For that, NoSQL has become the alternative for everyone. Now, another reason is now we have constant addition of new features and functions in the NoSQL database, right? So that means we know that technology is being rapidly evolved and huge enormous amounts of data has been released on a daily basis, and it's important that we store this data and access in a quick way. Now, NoSQL is the best database to use for large amounts of data or for ever-changing data sets. It is also best used when you have to have a flexible data model or need that don't fit into a relational model. And finally, if you want that there is no relationship between any stored data and you feel it is not important, then you can use NoSQL as well. Let us now look at some popular NoSQL databases. Some popular NoSQL databases are MongoDB, Apache HBase, Cassandra, Redis, Neo4j, and etc. Let us now look at some types of NoSQL databases that are present. Firstly, we have document-oriented. The document database typically stores self-describing JSON, XML, and BSON documents. They are similar to key value stores, but in this case, a value is a single document that stores all the data related to a specific key. Popular fields in the document can be indexed to provide faster retrieval without knowing the key as well. Each document can have same or different data structure. MongoDB, CouchDB, CloudEnd are some examples of document-based NoSQL database. Next, we have key value pair database. The data in this is stored like a key value pairs. Key value pair data stored in database in the form of a hash table. Each key is unique in this case. The value stored may be an integer, a string, a binary object, a JSON object, etc. The key value store based database is simplest database among all the databases in NoSQL database. Redis, Coherence are examples of some key value stored databases. Next, we have column-based or column-stored database in NoSQL, which is, in this, the data stored in grouped columns instead of rows. Every column values are stored separately. It delivers high performance on aggregate functions like count, sum, max, minimum. Group of columns data stored in key spaces like schema in RDBMS. Key spaces contains group of rows or columns, and HBase, Bigtable, Aculomo are some examples of column store databases. And finally, we have graph-oriented or graph-store databases. Data in this is represented in the form of a directed graph. It consists of nodes and edges. Nodes represent an entity and any edge represents the relation between the two nodes. Node edge to be unique. Social networks, logistics, spatial data used graphical storage database. Neo4j, Infinite Graph, OrientDB, FlogDB are examples of some graph storage database. Next, let us understand how exactly NoSQL database works. For that, I'm going to take the example of MongoDB database. Now, MongoDB is based on the NoSQL document store model in which data objects are stored as separate documents inside a collection instead of a traditional column and row of a relational database. Now, MongoDB groups data through collections, and basically a collection is simply a grouping of documents that have a same or similar purpose. A collection acts similarly to a table in a traditional SQL database. However, it has a major difference. A collection is not enforced by a strict schema, that is, it does not have any fixed schema at all. Instead, documents in a collection can have slightly different structure from another as needed. This reduces the need to break items in a document into several different tables as it is often done in an SQL implementation. Now coming to document, a document is a representation of a single entity of a data in MongoDB database. A collection consists of one or more related objects. Major difference that exists between MongoDB and SQL in that documents are different from rows. Row data is flat with one column for each value in the row. However, in MongoDB, documents can contain embedded sub-documents providing a much closer inherent data model for your applications. Now if I just have to map what are exactly and how it is different from RDBMS, a collection in a MongoDB is equivalent to the tables in RDBMS, and a document in MongoDB is equivalent to the rows in RDBMS, and fields in MongoDB is equivalent to the columns in RDBMS. So this is how a document looks in a MongoDB. As you can see, this is similar to a row in RDBMS, but we just have a field and a value that is taken separately instead of a tabular value. And another important thing to note here is that MongoDB supports dynamic schema, which means one document of a collection can have a number of fields while the other document can have less or same number of fields. That is, if a collection can have 4 fields while other document can have only just 2 fields, which is basically not possible in a relational database, which does not exist. It does not support because it needs a particular and a fixed schema in that. Let us now understand some differences between the SQL and NoSQL. Firstly, SQL is a relational database and NoSQL is a non-relational database. That means SQL databases are in the form of tables that can contain rows and columns, and they have fixed logical schema design. All the data in SQL is arranged in tabular format and it is well suited for complex queries. And on the other hand, NoSQL databases is a non-relational database. That means it does not store data in the form of tables and contains collections, and inside every collection there is a document that contains the data of a single entry. This data is stored in the form of a key value pair, unlike SQL where we store data under the fixed schema. So as we discussed, SQL has a fixed schema design and structure, and NoSQL has a dynamic schema design and structure. SQL can handle complex queries, whereas NoSQL can handle large volumes of data. Now SQL is vertically scalable. Now SQL databases support vertical scaling, which means it improves the single server by increasing RAM, SSD or CPU. In vertical scaling, we are restricted to a single system and we can improve it as much as we want till the practical limit. Whereas in NoSQL database, we can do horizontal scaling because they support distributed computing or distributed systems. In horizontal scaling, we can add another node or computer for better performance, and we can add n number of such servers or nodes as per a requirement. So as discussed, we can add as many as nodes as we want, and this is why we prefer NoSQL for high scalability, because there is no limit for scaling. And finally, it follows ACID properties, that is atomicity, that means transactions should be performed at once or it shouldn't happen at all. Consistency, that means the state of a database should remain consistent before and after the transaction. Isolation, one transaction shouldn't affect another transaction and should be independent. And lastly, durability. Now, successful transactions should be reflected even if there is any system failure. Whereas the NoSQL follows CAP property, that is consistency, availability and partial tolerance. Let us now discuss some advantages and disadvantages of using NoSQL. Firstly, let us discuss about the advantages. NoSQL provides high performance and scalability, and it also has a lot of availability and flexibility. It is open source and it is schema-less as well. That is, you can directly download the NoSQL databases from the internet, unlike some commercial databases that are available in the internet. While on the other hand, there are some disadvantages as well. That is, it lacks the standardization. That means it does not have a fixed query in order to retrieve data from the databases, which result in consistency issues. And since it has all these consistency issues and does not retrieve data properly, it has a limited query capabilities. So that brings us to the end of today's session on SQL versus NoSQL, guys. So you might have a doubt that when you need to use SQL and when we need to use NoSQL. Now SQL is easiest to work with relational databases. That is, it is useful when you want to perform complex queries using various operations like join and etc. And if you want to perform quick data storage and retrieval operations, you can use SQL. Whereas you can use NoSQL if you are designing a distributed systems and if you want a hierarchical storage structure instead of a tabular like structure. Also, NoSQL gives you the flexibility to create dynamic structures and can add features as you want. Also, there is no ACID properties during the creation of any applications while creating NoSQL databases as well.
Imagine walking into a giant library. This isn't just any library, it's huge. There are rows and rows of shelves, each packed with thousands of books. But wait, you don't need to read every book here. You're just looking for specific ones like books about space or stories about superheroes. But finding what you need is such a huge library. That's going to be tricky. This massive library is like a database. A database is a huge collection of information stored neatly, ready to be used. It holds everything: name, address, grades, prices, whatever data you can think of. But sometimes all that information can be overwhelming. You don't want to shift through everything every time. You need something specific, right? That's where views comes in. In this video, we will explore views in SQL, explaining what they are and how they simplify working with databases. We'll also cover how to create views, manage them by updating, deleting, and listing them, and also introduce different types of views like simple, complex, read-only, and those with check option. We'll also dive into materialized views with stored data for faster queries. And by the end, you will understand how views can manage data easier and more efficient. We will also look into a quiz question to clarify your understanding. So, what exactly is a view? Let's go back to our library example. Imagine if you had a magic window, a special one that only shows you the books about space or superheroes that you are interested in. You don't have to wander through the entire library anymore. You just look through your magic window and it gives you exactly what you need. That magic window is what a view is in the world of databases. A view is a special virtual window into a data that shows you only what you need to see. And the best part is, it's not actually storing any new data. It's giving you a filtered look into a huge database. Think of view as a shortcut, making your life a whole lot easier. So let us get into the demo part about how to creating a view and the types of views in SQL.
So let's start with the demo part, that is how do we create a table in MySQL. So here, as you can see, I've just logged into an online compiler, and now we will just learn how do we create a table, and then we'll move on to creating views and the types of views. So first, to create a table, just enter this command, just write over here, create table, and this, just enter the table name. It could be something like student details, and here you can give the student ID name. We want a student ID name in the first row, so we'll just keep SID, and the type of the variable is integer, so we'll just mention int over here. And since it's a primary key, we'll just mention it over here, primary key. Next variable can be something like name, and for this the type is varchar. You can just enter any number here. Suppose I've entered 255. Comma. Next, mention the address. Again, it's varchar address. So as you can see, we have created this table with student ID name. So we have to give your underscore, student ID name with primary key integer type, and the name and the address over here. So after we have created this table, we want to insert data into the table. This is our next step. So to insert data, what could be the basic command which you can write? Can be something like insert into student, the table name, student details over here, and just mention what all columns which we have, attributes we have created, which is S underscore ID. Next is name, and then we have address over here, and then we mention the values. So now that we have created table, and then we can enter our details over here. So these are the values which I've inserted, which is Harsh, Ashish, Pratik, Dhanraj, Ram. Okay. So like this, you can enter the values over here. And now if I want my records to be displayed here, the command which I'm using is select star from student details. So all these, the table will be shown here. So we'll just click on this run button over here. Okay, so now you can see this is the SID name, number, and the names which we have mentioned over here. So as you can see, this is the output generated. This is the SID, the name, and here is the address. So as you can see, the table is created now, and the output is also shown. Now we will move on to the main step, which is creating a view. So what exactly is a view? A view is like a window that lets you see specific data, as I've already told you in the intro part. So now let's say we only care about students with SID less than 5. Okay. And instead of running the same query every time, we want to create a view. So here's how you can do it. You can just simply enter a command. So here's how you can create a view. So just mention this command, which is create view detail view as select name, comma, address from student details. So student details is the table here which we have already created before, and I want the student ID less than 5. Okay, so I want this to be shown here. So we'll just simply click on run over here. So as you can see, this is the error it's showing. Why is it showing? Because line number 20, create view, must be the first statement in a query batch. So to resolve this, we have to ensure that the SQL batch is properly separated by go command and the view creation is syntactically correct. Alright, so we haven't used the go command here. To do that, we just simply, after we have inserted our records in the table, here you just type go, okay, and so this is the end of the first batch. And now since we have created a view in a new batch, we'll just mention this whatever command we have already given, and at the end of the second batch we'll again write go. Okay, and now next I want my query to be shown here, so I'll just write this command for generating my output, which is select star from and the table name. Okay, not that student details table name. I want the view table name to be shown, which is detail view, right? This is the table name. So yeah, just copy it from here. Just paste it. Give this semicolon. So now you can see our view is created. So why have we used go? Because go ensures that to create view command is executed in a new batch, and this will help the SQL server properly separate commands and avoid conflict. Alright, and we have also used the select star from details view, which will fetch the data from the view and includes only student with student ID less than 5, which is Dhanraj, Pratik, Ashish, and Harsh. Okay, name and the address is displayed over here. So this is our output generated. Now let's talk about managing views and updating the view. Let's say later on you want to update the view to also include the student's age. Instead of deleting or recreating the view, you can use create or replace view to update it. So let's add the age column to the table now. So we have to just insert the data for the students here. So to add a new column age to the students detail table, we need to use this command, which is alter table, and then provide the name of the table, which is student details, add age, and the type is integer, and give the semicolon over here. Alright, and now we have to insert the age data for the student. So to do this, we will use the update command, and here we will just write this update, okay, name of the table, which is student, and here we use set age is equal to 19, where SID is equal to 2. No, sorry, with SID is equal to 1. So in a similar way, you have to just update all the table over here. So after updating it, you can just simply search run here. So like this, you will just update the student details and set the age accordingly. And now the next step is, after updating it, we have, as you can see, we have just entered all the age number which we want to be displayed here. And we have used the insert to command to insert records into the table with the age values. And now in order to select it, we will give the command which is select star from and the name of the table which is student details. And now if we want to end this batch, we have to use this go command, enter. So now as you can see, we have updated and inserted all the age data for the students. And we have selected all the data from student details to display the final result by giving this command which is select star from student details, and this is the name shown over here, and here is the address, and this is the age. So we have inserted all the age data, and we have also corrected the update statement. Set age is equals to 19 where SID is equals to 1, and do not forget to add this go. Okay. Now, the next thing which we will be talking about is deleting a view. In order to delete a view, you just simply have to give this command which is drop view if exists, and then give the name and the table name which is detail view, right? And just simply you can go to this, just run, and you can see that our table has been dropped. Okay, so now we have deleted our table just by giving this command now. So, and do not forget that this command will delete the view, but don't worry, the data in the original student details table will not be affected. Only the view table which we have created is deleted. And now next we will be talking about listing all the views. Okay, so now in order to list all the views, just you have to simply write this command which is show full tables where table type is equals to VIEW, view. So by doing this thing, this output will give you all the views which we have created in this table, the name, student ID, okay, and the addresses, and also the age. Okay. So it will give you all the view table which we have created. Now let's move on to the main part, which is the types of views in SQL. Now let us first understand what is a simple view. So a simple view is created from a single table. It's straightforward and it doesn't involve complex logics like joins or subqueries. For example, to create a simple table, you just simply have to write this command which is create view student names as, and then select name from student details. Okay, so if you query this view and then write select star from student names. Okay, so after doing this thing, you just simply click on run. So after we have written this view, simple view, which is create view student name as, select name from student details, and do not forget again to mention this go, and then select query the simple view to display student names and select star from student names. Alright, and at last again add this go, and here this is the output generated, the names. Alright, so by using simple query you can do this thing. Now let's move on to the second part, which is creating a complex view. A complex view involves multiple tables or complex logic. Let's say we have another table known as student marks that stores student marks. So let's say we have created this table student marks, and we have given the details here, and again we have inserted the data values, student ID, marks 193. These are the values which we have inserted. This is the student ID and these are the marks which we have given. Alright, so now let's create a view that pulls data from both student details and student marks. So now as you can see, we have created a complex view by providing all these details, and this is the student ID and the marks shown over here. Alright, so now let's move on to the third part, which is read-only view. So a read-only view ensures that no one can modify the data through the view. This is useful when you want users to able to see the data but not change it. To make the view read-only, you can use permissions in your SQL databases, and this feature depends on your database engine. To create a read-only view in SQL Server, we cannot directly enforce read-only behavior with the create view statement. However, you can control access to the view using permissions. So here's how you can do it. So first you can create the view normally. You can use revoke, insert, update, and also delete permissions from users for that particular view, ensuring that they can only read the data. So now this was all for the read-only view. Let's move on to the fourth type of the view which we are discussing today, which is the check option. So with the check option is SQL, which is with the check option. I'll just type here with check option. Okay, this is the fourth type of view which we are talking about with check option in SQL. It ensures that any insert or update operation performed through a view complies with the conditions specified in the where clause of the view. This means that you cannot insert or update records through the view that violate the condition of the view itself. So let's go through the creation of a view with the with check option and provide an example with an explanation and expected output. So now as you can see, we have the expected output for the valid insertion using this command, which is with check option. And with view creation with check option, we created a view named sample view, as you can see here, that selects student ID and name from the student details table, but only where the name is not null. Alright, so as you can see, we have clearly mentioned here not null, and the with check option ensures that any insert or update through the view must comply with the condition where name is not null. And the first insert into sample view inserts a student where student ID 6 name, which also has a valid name, and here is the output generated here. Alright, this is the student ID, the name over here, and that's it. So now we have learned about this with check option as well. Now I'll be talking about a materialized view. So what exactly is a materialized view? Well, a materialized view is different from a regular view because it stores the actual data in a database, meaning the data is pre-computed and doesn't need to be fetched from tables every time you query it. This makes accessing data from a materialized view much faster, especially for complex queries. Alright, so as you can see, we have created the table and we create three tables: the order details table and the product details and also the customer details table over here. And then we have provide the necessary data also. The second step was the sample data is inserted into all the three tables. The materialized view fast order summary is created to summarize orders, joining data from the three tables and computing the total cost. And the next step is the materialized view is queried, and because the data is pre-computed, it returns results very quickly. With new data, when added to the order details table, the materialized view is refreshed using refreshed materialized view to include the new data. Alright, I hope you get it. Why are we using the refreshed option? And the next step is the materialized view is deleted using the drop materialized table over here. We have used this drop materialized view, fast order summary, and in this way you can, create a materialized view. So now you might be wondering that what is the difference between the materialized view and the complex view and the simple view. I'll be saying you that later. So First, let us now discuss why are views so useful. Okay, so why are views so useful? By now, you might be wondering what's the big deal with the views, and here's why it's so useful. They make our life easy. You don't have to keep writing complex queries over and over. You create a view once and it saves you tons of time. They also help you in simplifying data. Instead of pulling everything from your database, views can help you narrow down exactly what you need. They also help in improving security. Want to show only certain parts of the data to certain people? Use views to control what others can see without letting them touch the raw data. You can also rename columns for clarity. You can rename confusing columns in the view without changing the original table, making it easier for users to understand the data. So, before we move on, if you are interested in making a career in data analytics, check out Simplilearn's postgraduate program in data analytics in collaboration with Purdue University. This comprehensive course is designed to transform you into a data analytical expert. The program covers essential skills such as data visualization, statistical analysis, and machine learning using industry-leading tools and technologies like Excel, R, Python, and Tableau. With expert instructors, real-world projects, and hands-on practice, you gain the knowledge and confidence needed to excel in today's data-driven market. So join now to advance your career and become a data analytical professional today. You can find the course link mentioned in the description box and in the pinned comment. So let us now discuss the differences between the simple, complex, and the materialized view. So here's a quick summary of the differences. So simple view pulls data from a single table, no complex logic or joins involved, and it doesn't store data. It also, the performance is it executes every query every time, whereas the complex view, it combines data from multiple tables using joins, aggregates, or other complex logic, and it doesn't store data, executes query every time. And talking about the materialized view, it stores the result of a query, making it faster to retrieve data without running the query again. It also stores data and it is much faster as it uses pre-computed data. So now it's time for the quiz. Here's a quiz question for you. What is the key difference between a regular view and a materialized view in SQL? The first option is regular views store data, but materialized views don't. Second option is materialized view stores data, but regular views don't. C, both regular and materialized view stores data. And number D is neither of them store data. So if you want to answer them, you can just write them in the comment section below. And that's it. Views are an incredible tool in SQL that can simplify your queries, improve security, and make your life easier.
What is PostgreSQL? PostgreSQL is an open source object relational database management system. It stores data in rows with columns as different data attributes. According to the DB Engine's ranking, PostgreSQL is currently ranked 4th in popularity amongst hundreds of databases worldwide. It allows you to store, process, and retrieve data safely. It was developed by a worldwide team of volunteers. Now, let's look at the history of PostgreSQL. So in 1977 onwards, the Ingress project was developed at the University of California, Berkeley. In 1986, the Postgres project was led by Professor Michael Stonebraker. In 1987, the first demo version was released, and in 1994, a SQL interpreter was added to Postgres. The first PostgreSQL release was known as version 6.0 or 6.0 on January 29, 1997, and since then, PostgreSQL has continued to be developed by the PostgreSQL Global Development Group, a diverse group of companies and many thousands of individual contributors. Now, let's look at some of the important features of PostgreSQL. So PostgreSQL is the world's most advanced open source database and is free to download. It is compatible as it supports multiple operating systems such as Windows, Linux, and Mac OS. It is highly secure, robust, and reliable. PostgreSQL supports multiple programming interfaces such as C, C++, Java, and Python. PostgreSQL is compatible with various data types. It can work with primitives like integers, numeric, string, and boolean. It supports structured data types such as date and time, array, and range. It can also work with documents such as JSON and XML. And finally, PostgreSQL supports multi-version concurrency control or MVCC. Now with this theory knowledge, let's look at the PostgreSQL commands that we will be covering in the demo. So we will start with the basic commands such as select, update, and delete. we will learn how to filter data using where clause and having clause in SQL. We will also look at how to group data using the group by clause and order the result using the order by clause. You will learn how to deal with null values, get an idea about the like operator, logical operators such as AND and OR. We will also explore some of the popular inbuilt mathematical and string functions. Finally, we'll see some of the advanced concepts in PostgreSQL, that is, to write case statements, subqueries, and user-defined functions. Okay, so let's now start with our demo. So first, we'll connect to PostgreSQL using PSQL cell. So here, under type here to search, I'll search for PSQL. You can see this is the SQL cell. I'll click on open. Let me maximize this. Okay, so for server, I'll just click enter. Database, I'll click enter. Port number is already taken, which is 5432. I'll hit enter. Username is already given, and now it is going to ask for password. So here I'll give my password so that I can connect to my PostgreSQL database. So it has given us a warning, but we have successfully connected to PostgreSQL. Alright, so now to check if everything is fine, you can just run a simple command to check the version of PostgreSQL that we have loaded. So the command is select version with 2 brackets and a semicolon. I'll hit enter. Okay, you can see the version PostgreSQL 13.2. Okay, now let me show you the command that will help you display all the databases that are already there. So if I hit /L and hit enter, it will give me the list of databases that are already there. So we have PostgreSQL, there's something called template 0, template 1, and we have a test database as well. Okay, now for our demo, I'll create a new database. So first I'll write create space database, and I'll give my database name as SQL_demo. I'll give a semicolon and hit enter. You see we have a message here that says create database. So we have successfully created our SQL demo database. Now if you want to connect to that database, you can use \c space SQL_demo. There you go. It says you are now connected to database SQL_demo. So here we can now create tables, we can perform insert operation, select operation, update, delete, alter, and much more. Now I'll show you how to connect to PostgreSQL using pgadmin. So when you install the PostgreSQL database, you will get the SQL cell, and along with that you also have the pgadmin. So I'll just search for pg. You can see here it has prompted pgadmin. I'll click on open. This will open on a web browser. You can see it has opened on Chrome, and this is how the interface of pgadmin looks like. It is a very basic interface. So on the top you can see the files, we have object, there's tools, and we have the help section as well. And here you have dashboard, properties, SQL, statistics, dependencies, dependence, and here on the left panel you have servers. Let me just expand this so it will connect to one of the databases. Alright, so if I go back, you see when I had run \L to display the databases, it had shown me PostgreSQL and test. Now you can see here we have the PostgreSQL database and the test database. Alright, now we also created one more database, which was SQL demo. So let me show you how to work on this pgadmin and the query tool. Alright, so I'll right click on SQL demo and I'll select query tool. I'll just show you how to run a few commands on the query tool. So let's say you want to see the version of PostgreSQL that you are using, so you can use the same command that we did on PSQL cell, which is select version closed with brackets and a semicolon. I'll select this, and here you can see we have the execute button. So if I hit execute or press F5, it will run that query. You can see we have the output at the bottom, and it says PostgreSQL 13.2 compiled by Visual C++. It has a 64-bit system. Okay. Now let me tell you how to perform a few basic operations using PostgreSQL commands. So here, let's say I'll write select 5 into 3. I'll give a semicolon, select this and hit F5. So this will run the query and it returns me the result, that is the product of 5 and 3, which is 15. Similarly, let's edit this. Let's say I'll write 5 plus 3 plus, let's say, 6. I'll select this and hit F5 to run it. It gives me the sum of 5 plus 3 plus 6, which is 14. Now the same task you can do it on this cell as well. Let me show you how to do it here. So let's say I'll write select. Let's say I want to multiply 7 into, let's say, 10. You know the result, it should be 70. If I hit enter, it gives me 70. Now this question mark column question wall, will deal with this later. Alright, let me go back to my PG admin again. Let me do one more operation. Let's say this time I'll write select 5 multiplied by, and within brackets I'll write 3 plus 4. I'll give a semicolon. So what SQL will do is, first it will evaluate the expression that is there inside the bracket, that is 3 plus 4, which is 7, and then it will multiply 7 with 5. Now let me select this and I'll hit execute. So you can see 7 multiplied by 5 is 35. Alright, now we'll go back to our shell, and here I'll show you how to create a table. So we are going to create a table called movies on the cell, that is PSQL cell. So here we will learn how you can create a table and then you can enter a few data into that table. Alright, let me just scroll down a bit. Okay, so my create command goes something like this. So I'll write create table followed by the table name, that is movies. Next, my movies table will have a few columns. Let's say I want the movie ID. After the column name, we need to give the data type. So movie ID, I'll keep it as integer. So integer is one of the data types that is provided by PostgreSQL. Next, my second column in the table would be the name of the movie. So I'll write movie underscore name. So all the variables or the column names should be as per SQL standards, so there shouldn't be any space between the column names. So I have used underscore to make it more readable. So my movie name will be of type varchar or variable character or varying character, and I'll give the size as 40 so that it can hold 40 characters maximum. Next, my third column will have the genre of the movie. So I'll write movie underscore genre. Again, genre is of type varchar. I'll give the size as, let's say, 30. And my final and the last column will have the IMDb ratings. So I'll write IMDb underscore ratings. Now the ratings will be of type real, since it can have floating or decimal point values. If I close the bracket, I'll give a semicolon and I'll hit enter. There you go. So we have successfully created a table called movies. Now let me go back to my PG admin. Alright, so here I have my database, that is SQL demo. I'll just right click on this and click on refresh. Now let me go to schemas. I'll just scroll down a bit. Here under schemas we have something called as tables. Let me expand this. Okay, so you can see we have a table called movies in the SQL demo database now, and here you can check the columns that we have just added. So our movies table has movie ID, movie name, genre and ratings. Alright, now there is another way to create a table. The previous time we created using the SQL cell. Now I'll tell you how to create a table using the pgadmin. So here under tables, I'll right click and I have the option to create a table. So I'll select table. Okay, so it's asking me to give the name of the table. So this time we are going to create a table called students. So I'll write my table name as students. Alright, these will be default as it is. Now I'll go to the columns tab. So here you can create the number of columns that you want. So you can see on the right I have a plus sign. I'll just select this so that I can add a new row. So my first column would be, let's say, the student roll number. I'll write student underscore roll number. Again, the column name should be as per SQL standards. The data type I'm going to select is integer. Alright, now if you want, you can give these constraints such as not null, so that student roll number column will not have any null values. And I'll also check primary key, which means all the values will be unique for roll numbers. Alright, now if you want to add another column, you can just click on that plus sign, and let's say this time I want to give the student name as my second column. So I'll write student underscore name. Student name will be of type, let's say, character varying. If you want to give the length, you can specify the length as well, let's say 40. I'll click on the plus sign again to add my final column. The final column would be gender. So gender, I'll keep this time as type character. Okay, now you can click on save, so that will successfully create your students table. There you go. So here on the left panel you can see earlier we had only one table, that was movies, and now we have two tables. So one would be added, that was students. So if I expand this under columns, you can see we have the three columns here: student roll number, student name and gender. You can also check the constraints. It will tell you if you have any constraints. So you can see it says students roll number, there's one primary key. Alright, now let me run a select statement to show the columns that we have in the movies table. So I'll write select star from movies, give a semicolon, and let me execute this. Okay, so here at the bottom you can see we have the movie ID, the movie name, movie genre and IMDb ratings. Now the next command we are going to learn is how to delete a table. So there is one way by using the SQL command, that is drop table followed by the table name. Let's say you want to delete students. You can write drop table students and that will delete the table from the database. This is one of the methods, so you just select and run it. Now the other way is to you just right click on the table name and here you have delete / drop. If I select this, you get a prompt, are you sure you want to drop table students? I'll select yes. So you can see we have successfully deleted our students table. Alright, now let's perform a few operations and learn a few more commands in PostgreSQL. So to do that, I'm going to insert a few records to my movies table. So for that, I'll use my insert command. So I have my insert query written on a notepad. I'll just copy this and I'll paste it on my query editor. Okay, so let me just scroll down. Alright, so here you can see I have used my insert command. So I have written insert into the name of the table, that is movies, and we have the movie ID, the movie name, movie genre and IMDb ratings, and these are the records or the rows. So we have the first record as movie ID 101. The name of the movie is a very popular movie which is Vertigo. Then we have the movie genre, that is mystery. It is also a romance movie. And then we have the IMDb ratings, the current IMDb rating, that is 8.3. Similarly, we have Shawshank Redemption, we have 12 Angry Men, there's The Matrix, 7, Interstellar, and The Lion King. So there are total 8 records that we are going to insert into our movies table. So let me just select this and hit execute. Okay, you can see it has returned successfully 8 records. Now if I run select star from movies, you can see the records that are present in the table. So I'll write select star from movies, I'll select this and I'll execute it. There you go. At the bottom you can see 8 rows affected. If I scroll this down, you have the 8 records of information in the movies table. Alright, now if you want to describe the table, you can go to the SQL cell, and here if you write \d and the name of the table, that is movies, this will describe the table. So here you have the column names, this has the data type, and here you can specify if there are any null values or any constraints like default constraint or primary key or foreign key and others. Let me go back to my pgadmin. Okay, now first and foremost, let me tell you how to update records in a table. So suppose you have an existing table and by mistake you have entered some wrong values and you want to update those records later. You can use the update query for that. So I'm going to update my movies table and I'll set the genre of movie ID 103, which is 12 Angry Men, from drama to drama and crime. So in our current table we only have genre as drama for 12 Angry Men. I am going to update this column, which is the movie genre, to drama and crime. Okay, so let me show you how to do it. I'll write update followed by the name of the table, that is movies. I'll go to the next line. I'll write set, then I'll give the column name, which is movie underscore genre, equal to, I'm going to set it as drama, comma, crime. Earlier it was only drama, and I'll give my condition using the where clause. We'll learn where clause in a bit. So I'll write where movie underscore ID is equal to 103. So here our movie ID is the unique identifier. So it will first look for movie ID 103. It will locate that movie and it'll change the genre to drama and crime. So now you can see the difference. Earlier we had 12 Angry Men as drama as the movie genre. Now if I run this update statement, okay, you can see we have successfully updated one record. Now let me run the select statement again. Okay, so here you can see if I scroll down, there you go. So movie ID 103, movie name 12 Angry Men, we have successfully updated the genre as drama, comma, crime. Okay, now let me tell you how you can delete records from a table. So for that you can use the delete command. So you'll write delete from the table name, that is movies, where, let's say I want to delete the movie ID 108, which is the Lion King. So I'll write where movie underscore ID is equal to 108. This is one of the ways to delete this particular movie, or you can give, let's say, where movie name is equal to the Lion King. Let me select this and I'll hit execute. Now if I run my select query again, you see this time it has returned 7 rows and you cannot find movie with movie ID 108, that was the Lion King. So we have deleted it. Alright, next we are going to learn about where clause in PostgreSQL. So to learn where clause, I'll be using the same movie table again. Let's say we want to filter only those records for which the IMDb ratings of the movies is greater than 8.7. So this is my updated table now. I want to display only those records or those movies whose IMDb ratings is greater than 8.7. So we'll display 12 Angry Men, which is 9. Then we are going to display The Dark Knight, which is again 9. And we are also going to display the Shawshank Redemption, which has 9.3. The rest of the movies have an IMDb rating less than 8.7. So we are not going to display those. Alright, so let me show you how to write a where clause. So I'll write select star from movies where I'll give my column name, that is IMDb underscore ratings is greater than, I'll use the greater than symbol, then I'll pass my value, that is 8.7. I'll give a semicolon and let's run it. I'll hit F5. There you go. So we have returned the Shawshank Redemption, The Dark Knight and 12 Angry Men because only these movies had IMDb ratings greater than 8.7. Okay. Now let's say you want to return only those movies which have IMDb ratings between 8.5 and 9. So for that I am going to use another operator called between along with the where clause. So let me show you how to use between with where clause. I'll write select star from movies where my IMDb underscore ratings is between, I'll write 8.5, I'll give an AND operator and 9.0. So all the movies that are between 8.5 and 9.0 ratings will be displayed. So let's select this and I'll run it. There you go. So we have returned The Dark Knight, The Matrix, The 7, Interstellar, and we have the 12 Angry Men. So a few of the records that we missed out were, I think, Vertigo, which has 8.3, and there's one more. Alright. Now moving ahead, let's say you want to display the movies whose movie genre is action. You can see in our table we have a few movies whose genre is action movie. So you can do that as well. I'll write select star from movies where the movie genre, I'm writing this time in one line. You can break it into 2 lines as well. I'll write movie underscore genre, which is my column name, equal to, I'll give within single quotes action. Now why single quote? Because action is a string, hence we need to put it in single quotes. If I run this, there you go. So we had one movie in our table whose movie genre was action, that is The Dark Knight. Okay. Now you can also select particular columns from the table by specifying the column names. Now here in all the examples that we saw just now, we are using star. Now star represents, it will select all the columns in the table. If you want to select specific columns in the table, you can use the column names. So you can specify the column names in the select statement. Let me show you. Let's say you want to display the movie name and the movie genre from the table. So you can write select movie underscore name, comma, I'll give the next column as movie underscore genre from my table name, that is movies where, let's say, the IMDb underscore ratings is less than 9.0. So this time in our result it will only show 2 columns, that is movie name and movie genre. Let me run it. There you go. So these are the movie names and the movie genres. You can see that have an IMDb ratings less than 9.0. Alright, like how you saw the between operator, there is one more operator that you can use with the where clause, that is the in operator. So the in operator works like a or clause or an or operator. So let's say I want to select all the columns from my movies table where the IMDb ratings is in 8.7 or 9.0. If I run this, it will display only those records whose IMDb ratings is 8.7 or 9.0. Alright, so up to now we have looked at how you can work on basic operations in SQL like your mathematical operations. You saw how a select statement works. We created a few tables, then we inserted a few records to our tables. We saw how you can delete a table from your database, and we have performed a few operations like update, delete, and we saw how a where clause works. Now it's time to load a employee CSV file or a CSV dataset to PostgreSQL. So I'll tell you how you can do that. But first of all, before loading or inserting the records, we need to create an employee table. So let me first go ahead and create a new table called employees in our SQL_demo database. So I'll write create table. My name of the table would be employees. Next, I'm going to give my column names. So my first column would be employee ID. So the employee ID will be of type integer. It is not going to contain any null values, so I'll write not null, and I'll give my constraint as primary key. So the employee ID, as you know, is unique for all the employees in a company. So once I write primary key, it will ensure that there are no repetition in the employee IDs. Okay. Next, I'll have my employee name. So my employee name is going to be of type varchar, and I'll give my size as 40. Okay. Next, we'll have the email address of the employee. Again, email address would be of type varchar and the size is 40 again. I'll give another comma. This time we'll have the gender of the employee. Gender is again varchar of size, let's say 10. Okay. Now let's include a few more columns. We'll have the department column. So I'll write department varchar. Let's say the size is 40. Then let's say we'll have another column that is called address. So the address column will have the country names of the employees. Address is also varchar. And finally we have the salary of the employee. Salary, I'm going to keep it as type real. So real will ensure it will have decimal or floating point values. Okay, so now let me select this create table statement and execute it. Alright, so we have successfully created our table. If you want, you can check by using select star from employees. Let me select this and I'll hit execute. Alright, you can see we have our employee ID as primary key. There's employee name, email, gender, there's department, address and salary. But we don't have any records for each of these columns. Now it's time for us to insert a few records to our employees table. Now to do that, I'm going to use a CSV file. So let me show you how the CSV file looks like. Okay, so now I am on my Microsoft Excel sheet, and on the top you can see this is my employee data.csv file. Here we have the employee ID, the employee name, email, gender, there's department, address and salary. Now this data was generated using a simulator, so this is not validated, and you can see it has a few missing values. So under email column we have a few employees who don't have an email ID. Then you can see under department also there are some missing values here as well. Alright, so we'll be importing this table or the records present in this CSV file onto PostgreSQL. Alright, so here in the left panel under tables, let me right click and first refresh this. There you go. So initially we had only movies table and now we also have the employees table. Now what we need to do is I'll right click again, and here you see we have the option to import or export. Let me click on this, and I don't want to export, I need to import, so I'll switch on import. Alright, now it is asking me to give the file location. So let me show you how to get the file location. So this is my file location actually. So my Excel file, which was this, is present in my E drive under the data analytics folder. I have another folder called PostgreSQL, and within the PostgreSQL folder I have my CSV file, that is employee data.csv. So I'll just select this. You can either do it like this or you can browse and do. Okay, now my format is CSV. Next, I'm going to select my headers as yes, and then let me go to columns and check if everything is fine. Alright, so I have all my columns here. Let's click on OK. You can see I have a message here which says import _ export. Alright, so here you can see successfully completed. We can verify this by using select star from employees again. If I run this, alright, let me close this. There you go, it says 150 rows affected, which means we have inserted 150 rows of information to our employees table. You can see we have the employee ID, these are all unique. We have the employee name, the email, we have the address and the salary. Let me scroll down so that, okay, you can see we have 150 rows of information. That means we have 150 employees in our table. Okay, now we are going to use this employees table and explore some advanced SQL commands. Now there is an operator called distinct. So say if I write select address from employees, this is going to give me 150 address of all the employees. There's some problem here, I did a spelling mistake. There should be another D. If I run this again, our query will return 150 rows. You can see we have the different country names under address, that is Russia, we have France, there's United States, we have Germany, okay, and I think we have Israel as well. Yeah. Now suppose you want to display only the unique address or the country names, you can use the distinct keyword before the column name. So if I write select distinct address from employee, it will only display the unique country names present in the address column. If I run this, see, it has returned us 6 rows of information. So we have Israel, Russia, Australia, United States, France and Germany. Alright, now as I said, there are a few null values which don't have any information. So you can use the isNull operator in SQL to display all the null values that are there. Suppose I want to display all the employee names where the email ID has a null value. So I'll write select star from employees where email is null. So this is another way to use your where clause. If I select and run this, there you go. So you see here for all these employee names there was no email ID present in the table. So it has returned us 16 rows of information. So around 10% of employees do not have an email ID, and if you see, a few of them do not have an email ID and also they don't have a department. So if you want to know for those employees which do not have a department, you can just replace where department is null instead of where email is null. Now if I select this, Okay, it has returned us 9 rows of information, which means around 5% of employees do not have a department. Moving ahead, now let me show you how the order by clause works in SQL. Now the order by is used to order your result in a particular format, let's say in ascending or descending order. So the way to use is, let's say I want to select all the employees from my table, so I'll write select star from employees, order by. I want to order the employees based on their salary, so I'll write order by salary. Let me select and run it. Okay, there is some problem. I made a spelling mistake. This should be employees. Let me run it again. Okay, now if you mark the output, our result has been ordered in ascending order. So all the employees which have salary greater than $45,000 appear at the top, and the employees with the highest salaries appear at the bottom. So this has been ordered in ascending order, which means your SQL or PostgreSQL orders it in ascending order by default. Now let's say you want to display the salaries in descending order so that all the top ranking employees in terms of salary appear at the top. So you can use the DESC keyword, which means descending. If I run this, you can see the difference now. So all the employees with the highest salary appear at the top, while those with the lowest salaries appear at the bottom. So this is how you can use an order by clause. Okay, so now I want to make a change in my existing table. So here if you see, under the address column we only have the country names, so it would be better if we change the name of the address column to country. So I want to rename a column. You can do this using the alter command in PostgreSQL. So let me show you how to rename this column, that is address. So I'll write alter table followed by the table name, which is employees. Then I'm going to use rename column address. I'll write to, I want to change it to country. If I give a semicolon and hit execute, it will change my column name to country. Now you can verify this. If I run the select statement again, there you go. Earlier it was address column and now we have successfully changed it to country column. Okay, let me come down. Now it's time for us to explore a few more commands. So this time I'm going to tell you how an AND and an OR operator works in SQL. So you can use the AND and OR operator along with the where clause. So let's say I want to select the employees who are from France and their salary is less than $80,000. So let me show you how to do it. I'll write select star from employees where I'm going to give two conditions. So I'll use the AND clause or the AND operator here. I'll write where country is equal to France. Now mark here I'm not using address because we just updated our table and changed the column name from address to country. So I'll write country equal to France, and my next condition would be my salary needs to be less than $80,000. I'll give a semicolon. Let me run this. Alright, so it has returned 19 rows of information. You can see all my country names are France and the salary is less than $80,000. So this is how you can use or give multiple conditions in a where clause using the AND operator. Now let's say you want to use the OR operator, and let's say you want to know the employees who are from country Germany or the department should be sales. So I'll write select star from employees where country is equal to Germany, and instead of and I'm going to use or. The department should be sales. Okay, now let's see the output. I'll hit F5 this time to run it. Alright, so we have 23 rows of information now. Let me scroll to the right. You can see either the country is Germany or the department is sales. You see one of them in the table. So here for the first record the country was Germany, the second record the department was sales, again for the fourth record the country is Germany. So this is how the OR condition works. So if one of the conditions are true, it will return the result. It need not be that both the conditions should satisfy. Now in PostgreSQL there is another feature that is called limit. So PostgreSQL limit is an optional clause on the select statement. Now this is used as a constraint which will restrict the number of rows returned by the query. Suppose you want to display the top 5 rows in a table, you can use the limit operator. Suppose you want to skip the first 5 rows of information and then you want to display the next 5, you can do that using limit and offset. So let's explore how limit and offset works. I'll write select star from employees. Let's say I'll use my order by clause. I'll write order by salary, let's say in descending, and limit it to 5. This is going to display the top 5 employees which have the highest salary. If I run this, there you go. You see it has given us 5 rows of information and these are the top 5 employees that have the highest salary. Okay, so this is one method of or one way of using the limit clause. Now in case you want to skip a number of rows before returning the result, you can use offset clause placed before the limit clause. So I'll write select star from employees, let's say order by salary, descending. This time I'm going to use limit 5 and offset 3. So what this query will do is it will skip the first 3 rows and then it will print the next 5 rows. If I run this, there you go. So this is how the result looks like. Okay. Now there is another clause which is called fetch. Let me show you how that works. I'll copy my previous SQL query. I'll paste it here. And here, after descending, I'm going to write fetch first 3 row only. So my fetch is going to give me the first 3 rows from the top. There you go. It has given us the first 3 rows and you can see the top 3 employees that have the highest salary since we ordered it in descending order of salary. Alright. You can also use the offset along with the fetch clause. I'll copy this again and let me paste it here. Now after descending I am going to write offset, let's say 3 rows, and fetch first 5 rows only. So what this SQL query is going to do is it will skip the first 3 rows of information and then it is going to display the next 5 rows. It is going to work exactly the same as we saw for this query. Let me run it. There you go. So these are the first 5 rows of information after excluding the top 3 rows. Alright, we have another operator that is called as like in PostgreSQL. So like is used to do pattern matching. So suppose you have a table that has the employee names. You forgot the full name of an employee, but you remember the few initials, so you can use the like operator to get an idea as to which employee name it is. Now let's explore some examples to learn how the like operator works in PostgreSQL. So suppose you want to know the employees whose name starts with A. So for that you can use the like operator. Let me show you how to do it. So I want to display the employee name, and let's say I want to know their email IDs from the table name, that is employee, where since I want to know the employees whose name starts with A, so I'll write employee name like. Now to use the pattern is within single quotes I'll write A and then followed by percentage. Now this means the employee name should have an A in the beginning, and percentage suggests it can have any other letter following A, but in the beginning or the starting should be A. If I run this, so there is an error here. The name of the table is employees and not employee. Let's run this again. There you go. You can see there are 16 employees in our table whose name starts with A. You can see this column employee name, all of them have a letter A in the beginning. Okay, now let me just copy this command or the query. I'll paste it here. Let's say this time you want to know the employees whose name starts with S. So instead of A, I'll write S. So this means the starting letter should be S and followed by it can have any other letter. If I run this, so there are 10 employees in the table whose name starts with S. Okay, let's copy the query again, and this time I want to know the employees whose name ends with D. Now the way to do it is instead of a percentage, I'll write this time percentage D, which means at the beginning it can have any letter, but the last letter in the string or in the name should be ending with D. Now let me copy and run this. So there are 13 employees in the table whose name ends with a D. You can see it here. Alright, now let's say you want to find the employees whose name contains ISH or have ISH in their names. So the way to do is something like this. So I'll copy this. Now here instead of a percentage, I'll replace this with percentage ISH percentage. Now this means that in the beginning it can have any letter and towards the end also it can have any letter, but this ISH should appear within the name. Let me run and show it to you. Okay, so there is one employee whose name contains ISH. You can see here there is an ISH in the last name of the employee. Alright, now suppose you want to find the employee name which has U as the second letter. It can have any letter in the beginning, but the second letter of the employee name should have U. Now the way to do is I'll copy this, and instead of a%, I'll write underscore U followed by %. Now this underscore, you can think of a blank that can take any one letter. So the beginning can start with A, B, C, D or any of the 26 alphabets we have. Then it should contain U as the second letter followed by any other letter or letters. Let me run this. Okay, so there are 10 employees in the table whose name has a U as the second letter. You can see these. Okay, now moving ahead, let me show you how you can use basic SQL functions or inbuilt functions. So we'll explore a few mathematical functions now. So let's say you want to find the total sum of salary for all the employees. So for that you can use the sum function that is available in SQL. So I'll write sum and inside the sum function I'll give my column name, that is salary, from my table name, that is employees. Let's see the result. This will return one unique value. There you go. Now this is the total salary. Since the value is very large, it has given in terms of E. Now one thing to note here is, if you see the output, the column says sum real. So this output column is not really readable. So SQL has a method which can fix this, that is called an alias. So since we are doing an operation of summing the salary column, we can give an alias to this operation by using the as keyword. So if I write sum of salary as, let's say, total salary, then this becomes my output column. You can see the difference if I run this. Okay, you can see now in the output we have the total salary. Now this is much more readable than the previous one. So this is a feature in Excel where you can use or give alias names to your columns or your results. Now similarly, let's say you want to find the average of salary for all the employees. Now SQL has a function called AVG which calculates the mean or the average salary. If I write AVG, and I can edit my alias name as well. Let's see, I'll write mean salary. Let's run it. You can see the average salary for all the employees. It's around $81,000. Okay, now there are two more important functions that SQL provides us, which is max and minimum. So if I write select maximum, or max, which is the function name of salary, as, let's say, instead of total I'll write maximum. So this will return me the maximum salary of the employee. Let's run it and see what is the maximum salary that is present in the salary column. Alright, so we have $1,19,616 as highest salary of one of the employees. Similarly, you can use the min function as well. I'll just write minimum, and this will return me the minimum salary of one of the employees in the table. I'll replace the alias name as minimum. Okay, now run it. This will give me the minimum salary that is present in our table. So it is $45,685. Okay, now let's say you want to find the count of department in the employees table. You can use the count function. So if I write select count, let's say I want to know the distinct department names, I can write inside the count function distinct department as total departments from employees. Let's run this. This will return me the total number of departments that are there. So it gives me there are 12 departments. Okay, now let me show you one more thing here. If I write select department from employees, let's run this. Okay, so it has returned me 150 rows of information, but what I'm going to do is I'll place my distinct keyword here just before the column name so that I can verify how many departments are there in total. There you go. So there are 13 departments and one of them is null. So moving ahead, we'll replace this null with a department name by updating our table. Okay, so now let's update our department column. So what we are going to do is, wherever the department has a null value, we are going to assign a new department called analytics. So earlier we have also learned how to use the update command. So I'm going to show it again. So we'll write update followed by the table name, that is employees. I'm going to set my column, that is department, equal to, within single quotes, my name of the department would be analytics, where department is, I'll say null. So wherever the department has a null value, we'll replace those information with department, that is analytics. Let's run this. You can see query returned successfully. Now let's say I'll run this command again, and this time you can see the difference. There you go. So we have 13 rows of information and there is no null department now. We have added a new department, that is analytics. Okay, now we are going to explore two more crucial commands or clauses in SQL, that is group by and having. So let's learn how group by clause works in PostgreSQL. So the group by statement groups rows that have the same values into summary rows. For example, you can find the average salary of employees in each country or city or department. So the group by clause is used in collaboration with the select statement to arrange identical data into groups. So suppose you want to find the average salary of the employees based on countries, you can use the group by clause. So let me show you how to do it. I'll write select. I want the countries and the average salary for each country. So I'll use the average function, that is avg, and inside the function I'll pass my column, that is salary. I'll give an alias name as, let's say, average underscore salary, from my table name, that is employees. Next I'm going to use my group by clause. So I'll write group by. Since I want to find the average salary for each country, so I'll write group by country name. Let's give a semicolon and let me run it. I'll use F5. There you go. So here on the left you can see the country names. We have Israel, Russia, Australia, United States, France and Germany, and on the right, the second column, you can see the average salary for each of these countries. Now you can also order the result in whichever way you want. Suppose you want to arrange the results based on the average salary, so you can use the order by clause after the group by clause. So I'll write order by. Here you can use the alias name, that is average salary. This is actually average underscore salary, and let's say I want to arrange it in descending order, so I'll write DESC. Now let's run this. You can mark the difference in the average salary column. There you go. So as per our result, in United States the average salary is the highest, and if I scroll down, the average salary is the lowest in Germany. Now let's see one more example using group by. Suppose this time you want to find the maximum salary of male and female employees. You can do that too. So let me show you how to do it. So I'll write select. This time we want to find the maximum salary based on gender. So I'll select my gender column, comma, and this time I'll use my max function. Since I want to find the maximum salary for male and female employees, I'll give an alias name as maximum underscore salary from my table, that is employees, group by, I'll write gender. Okay, so let's run this. There you go. You can see, so one of the female employees had a highest salary of $1,19,616, while of that of a male was $1,17,654. Alright, now suppose you want to find the count of employees based on each country. You can use the count function along with the group by clause. So I'll write the select statement, select. since I want to count the employees based on each country, so I'll first select my country column and then I'm going to use the count function. I'll write count emp_id from my table name, that is employees. I'm going to group it by country. So this query will give me the total number of employees from each country. You can see here Israel there are 4 employees, in Australia there are 4 employees, in Russia we have 80 employees, in France there were 31, in United States we have 27, so on and so forth. Now let me scroll down. Okay, now it's time to explore one more clause, a very important clause that is used in PostgreSQL, that is having. So the having clause works like the where clause. The difference is that where clause cannot be used with aggregate functions. The having clause is used with the group by clause to return those rows that meet a condition. So suppose you want to find the countries in which the average salary is greater than $80,000. So you can use the group by clause and the having clause to get the result. So I'll write my select statement as select country, comma, I want the average salary, so I'll write avg of salary. I can give an alias name as average salary from employees. Now I'm going to group it by each country, so group by country column. Since I want to find the countries in which the average salary is greater than 80,000, so I'll use having clause after the group by clause. I'll write having average of salary is greater than 80,000. Now this condition cannot be specified in the where clause, so we need a having clause. You cannot use aggregate functions along with where clause. Let me just run it now. There you go. So we have Russia and United States where the average salary is greater than $80,000. Alright. Now let's say you want to find the count of employees in each country where there are less than 30 employees. So for this I am going to use the count function. First let me select the country column. Then I'm going to use the count function, and in the count function I'm going to pass my employee ID so that we can count the number of employees from my table, that is employees. Now if you want you can use an alias name for this as well, but I am just skipping it for the time being. I'll write group by country. Next I'll write having count of employee ID less than 30. So this will return me the countries in which there are less than 30 employees. Let's run it. You can see here Israel, Australia, United States and Germany are the countries in which there are less than 30 employees. Okay, now if you want you can use the order by clause as well. So suppose I'll write here order by count of employee ID. So what this will do is it will arrange my result in ascending order of employee ID count. There you can see we have successfully arranged our result in ascending order of employee IDs. Okay, next we are going to explore one more feature of PostgreSQL, that is of using a case statement. Now in PostgreSQL the case expression is same as if-else statement in any other programming language. It allows you to add if-else logic to the query to form a powerful query. Now let me just scroll down and I'll show you how to use a case statement. This is very similar to your if-else statement that you use on Excel, in C++, in Python or any other programming language. So what I'm going to do is I'm going to write a SQL query that will create a new column, and the name of the column would be let's say salary range. So I'm going to divide my salary. Suppose if the salary is greater than $45,000 and if it's less than $55,000, in the new column, that is salary range, we are going to assign a value low salary. Now if the salary is greater than $55,000 and if it is less than $80,000, we are going to assign a value that is medium salary. If the salary is greater than $80,000, we'll assign a value high salary. So all this we are going to do using our case expression in PostgreSQL. So I'll start with my select statement, but before that let me show you how to write a comment in PostgreSQL. So you can write a comment by giving a double dash. Comments are very helpful because they make your codes or the scripts readable. I'll write case expression in PostgreSQL. Similarly, if you want, you can go to the top and let's say here you can write with double dash having clause. Okay, let's come down. So I'll write my select statement as select. I want the department, the country and the salary column. I'll give a comma and I'll start with my case statement. I'll write case when my salary is greater than 45,000 and my salary is less than 55,000, then the result would be, within single quotes, I'll write low salary. So this is exactly like an if-else condition. Next, I'll write another case when salary is greater than 55,000 and salary is less than, let's say, 80,000, then the result would be medium salary. And finally, I'll give my last condition, that is when salary is greater than 80,000, then the result will be high salary. Let me write this in a single line, then high salary. Now one thing to remember, in PostgreSQL the codes are insensitive, so you can write your select statement in capital, in lowercase or in sentence case. Similarly, I can write case as small c or you can write as capital C. Alright, now moving ahead, after this I am going to write end. I'll give an alias name as salary range. Now this is going to be my new column in the output. Let me just come down. After this we need to give our table name from employees. I'll order it by salary descending. Okay, so what I'm going to do here is I'll first select department, country and salary column from my employees table, and then I'm creating a new column that is salary range, and I'm specifying the range. So I have three conditions here, for low salary, for medium salary and high salary. So let's run this and see the output. There you go. Here you can see we have added a new column known as salary range, and we have ordered our salary in descending order, so all the highest salaries appear at the top. If I just scroll down, you can see we have medium salaries here, and if I scroll down further you can see these low salaries. So case statements are really useful when you want to create a new column based on some conditions in the existing table. Alright, now moving ahead, we are now going to see how to write subqueries in PostgreSQL. So subqueries, we write a query inside another query, which is also known as nested query. So suppose we want to find the employee name, department, country and salary of those employees whose salary is greater than the average salary. So in such cases you can use subqueries. Now let me show you how to write a query inside another query. First I'll write the select statement. I am going to select the employee name, comma, I want the department, comma, I also want to display the country name and the salary from the employees table, where my salary should be greater than the average salary. So after this where salary greater than, I am going to use brackets and write my subquery, that is select average salary from employees. Now let me break it down for you. So first we are going to select the average salary from the employees. So this particular SQL statement will find the average salary from the table. We will compare this average salary with salaries of all the employees. So whichever employee has the salary greater than the average salary will display their names, the department, country and their original salary. So if you want, you can run this statement as well. Let me select this statement and run it for you. You can see we have written the average salary of all the employees, which is nearly $81,466. So we want the salaries of the employees to be greater than this average value. So let me run this and see how many employees have a salary greater than the average salary. There you go. So we have around 75 employees whose average salary or whose salary is greater than the average salary. Alright. Now moving ahead, this time I'm going to tell you how to use some inbuilt functions. We'll learn some inbuilt mathematical functions and string functions that are available in PostgreSQL. So I'll just give a comment. There's another way to write a comment. Instead of a double dash, you can use the forward slash, an asterisk, and inside the asterisk you can write, let's say, SQL functions, and you need to close this. So I'll give another asterisk and a forward slash. So this is also a comment in PostgreSQL. Alright. So first of all, we'll explore a few math functions. So there is a function called ABS which is used to find the absolute of a value. So if I write select ABS of, let's say, minus 100, it is going to return me positive 100 or just 100, because as you know, the absolute of any value will remove the negative sign involved in that value. There you go. So our original input was minus 100, the absolute of minus 100 is plus 100. Next, let's see another function that is called greatest. So the greatest function in PostgreSQL will return the greatest number in a range of numbers. So suppose I write select greatest. Inside the greatest function, I'll pass in a few numbers, let's say 2. I'm just randomly passing a few numbers, let's say 490, let's say 56.5, and let's say 70. I'll give a semicolon. Let me run this. You will see the greatest function will return the greatest integer value or greatest number that is present in the range of numbers that we have provided. So in this case, 90 was the largest number or the greatest number, so we got the result as 90. Again, you can use an alias for each of these statements. Now, like greatest, we also have a function called least, which is going to return the least number present in a range of numbers. If I run this, so the result is 2, because 2 is the least number that is present in this selection. Alright. Now there's a function called mod which is going to return the remainder of a division. So suppose I write select mod, and this takes two parameters, let's say 54 divided by 10. As you can guess, the remainder is 4, and so is our result. You can see it has returned the remainder. 54 divided by 10, the remainder is 4. Alright, if I scroll down, now let's see how to use the power function. So I'll write select power. Let's say I want to know power 2, 3, which is 2 cube, that is 8. Let me just run this. There you go. So the result is 8. You can also check, let's say, power of 5, 3. It should be 125. Alright. Next, you can use the sqrt function that is available in PostgreSQL to find the square root of a number. I'll write sqrt, and let's say I want to find the square root of 100. You can guess the result. The output should be 10. If I run this, you can see the output here 10. Let's say I want to find the square root of, let's say, 144. You can again guess the result. It should be 12. Let's verify it. Okay, there is some error. Let me verify it again. There you go. It is 12. Now, there are a few trigonometric functions as well. You can use the sine function, the cos function, and the tan function. Let's say I want to know the sine of 0. If you have studied high school mathematics, you would know the sine of 0 is 0. You can see the result, it is 0. Let's say you want to know sine 90. If I run it, you can see the output here, 0.89. Alright. Now, there are other functions like ceiling and floor that you can use. So let me show you what the ceiling and floor function does. I'll write ceiling. Let's say I'll pass my floating value as 6.45 and let me run it. You can see the ceiling function returns the next highest integer, that is 7 in this case, since the next highest integer after 6.45 is 7. Let's see what the floor function does, and let me run it. As you can see, the floor function returns the next lowest integer, that is 6 in this case, or the nearest lowest integer to any provided decimal value. Okay. Now that we saw how to use mathematical functions, there are a few string functions available in PostgreSQL. So let's explore them as well. I'll write string functions. Okay. We'll scroll down. Cool. There's a function called character length that gives you the length of a text string. Suppose I write select, give the function as character length, and inside this function I am going to pass in a text. Let's say India is a democracy. This is my text. Let me run this. Okay, you can see the result here, which is 20, since there are 20 characters in my string that I have provided. Alright. Now there's another function called concat in PostgreSQL. So concat is basically used to merge or combine multiple strings. So I'll write select concat, within brackets I'll give the text string now. Let's say I want to combine Postgres SQL. I'll give a space, comma, I want to merge Postgres SQL is, I'll give another comma and write my final word, that is interesting. Now what we have done is, inside the concat function we have passed in separate strings, and now using the concat function we want to merge the three strings. Let's see what the result is. I'll run it. Alright, let me just expand this. You can see here we have concatenated the three strings successfully, so the output is PostgreSQL is interesting. Okay. Now there are functions like left, right and mid in PostgreSQL. So what the left function does is it will extract the number of characters that you specify from the left of a string. Let's say I'll write select left and I'll pass in my text string as India is a democracy. I'll copy this and I'll paste it here. Let's say I want to extract the first 5 characters from my string, so I'll give 5. So what it will do is it will count 5 characters from left, so 1 2 3 4 and 5. If I run this, it should ideally print India for me. There you go, it has printed India for us. Alright, similarly you can use the right function to extract few characters from the right of a string. Let's say you want to extract, let's say I'll give 12 characters from right, so from here onwards it will count 12 characters. I'll change left to right now. Let me select this and run it. So you can see here, this is the output. From the right it has counted 12 characters and returned a democracy. Okay, now there is a function called repeat. So the repeat function is going to repeat a particular string the number of times you specify. Let's say I want to select and use my repeat function, and inside the repeat function I'm going to pass in, let's say, India, and I want India to be displayed 5 times. I'll give a semicolon and run it. In the output you can see India has been printed 5 times. Okay, let's scroll down. There is another function, a string function in PostgreSQL called as reverse. So what reverse function is going to do is it is going to print any string passed as an input in reverse order. So if I write select reverse, and inside the reverse function I'll pass in my string, that is India is a democracy. I'm going to use the same string. I'll copy this and I'll paste it here. I'll close the quotes and the brackets. Let's print this. You can see it here, India is a democracy has been printed in reverse order. There you go. Alright, now this time we explored a few inbuilt functions that are already present in PostgreSQL. Now PostgreSQL also has the feature where you can write your own user-defined functions. So now we will learn how to write a function of our own in PostgreSQL. So let's create a function to count the total number of email IDs that are present in our employees table. So for this we'll write a function, a user-defined function. So let me give my comment as user-defined function. Okay, so let me start by first writing create. So this is the syntax to write a function in PostgreSQL. So I'll write create or replace function, then I'll give my function name as count emails, and as you know functions have brackets. Then I'll write returns, the return type, as integer, then an alias with dollar symbol. I'll write total emails, since I'm going to display the total number of email IDs that are present in my table. I'll close the dollar symbol. Then I'm going to declare a variable. The variable name is going to be total underscore emails. This is of type integer. I'll write begin, and inside begin I'll write my select statement. So I'll write select I want to count the email IDs that are present, so I'll pass my column name, that is email, into total emails from my table name, that is employees. I'll give a semicolon and then we'll write return total emails. As you know, user defined functions often return a value, so hence we have mentioned the return statement as well. And now I'm going to end my function. Then the next syntax would be, let me just scroll down. Okay, so here I'll give my dollar symbol again, followed by total underscore emails. Next I'll write my language as PostgreSQL. So the way to mention is PL PG SQL. Let's give a semicolon and end it. So this is my user defined function that I have written. So I created a function with the function name count underscore emails, and this would return integer as an alias, which is total underscore emails. We declared that variable as an integer. Then we started with a begin statement that has my select statement, where I am selecting the count of email IDs that are present in the employees table, and I am putting the value into total underscore email. So I have used the into keyword, and this returns the result as total underscore emails, and I have ended. Let's run this. Okay, there is some problem. There is an typo, so this should be integer. Okay, let me run it once again. There you go. So you've successfully created a user defined function. Now the final step is to call that function. Now to call this function, I'm going to use my select statement and the function name, that is count underscore emails. I'll give a semicolon. Let's execute this. There you go. So here you can see there are 134 email IDs present in our employees table. Now one thing to mark is there are total 150 employees in the table, but out of them 134 employees have email IDs, the rest of them don't have, so they would ideally have null values. Alright, so that brings us to the end of this demo session on PostgreSQL tutorial. Let me go to the top. We have explored a lot. So we started with checking the version of PostgreSQL. Then we saw how to perform basic mathematical operation, that is to add, subtract, multiply. Then we saw how to create a table that was movies. We inserted a few records to our movies table. Then we used our select clause. We updated a few values. Then we deleted one row of information. Then we learned how to use the where clause. We learned how to use the between operator. We also learned how to use the in operator. Let me scroll down. We created a table called employees, and then we learned how the distinct keyword works. We also learned how to use isNull with where clause. We learned about the order by clause. We saw how to alter or rename a column. Then we explored a few more examples on where clause, where we learned about and OR operator. Then we learned how to use limit and offset, as well as the fetch operator or the fetch keyword in PostgreSQL. Moving further, we learned about the like operator in SQL, which was used to perform pattern recognition or pattern matching, you can say. Here we saw how to use basic inbuilt PostgreSQL functions like sum, average, minimum, count, maximum. Next, we saw how to update a value in a column using PostgreSQL update command. We learned how to use group by. Then we learned how to use having clause. Then we learned how to use case expressions in PostgreSQL. So we saw how case expression is similar to our if-else in any other programming language. We explored a few mathematical and string functions, and finally we wrote our own user-defined function. So that brings us to the end of this tutorial on PostgreSQL. Now if you want to get this SQL file that we have used in the demo, you can give your email IDs in the comment section and our team will share this SQL file with you over email.
So, what exactly is a CT, you ask? Now, if you are a beginner in SQL, let's say you wanted to club two different tables or more different tables, maybe 3 or 4, right? So you will be using one keyword, which is join, right? And let's say you may have to create a query in such a way that you have to club different tables and you have to extract the results from one table into another and finally create a output table, right? So this might be sounding a little too complex. So basically what CTE does is it acts as a temporary table, right? Now you can write a query and save it as a CTE, right? And that particular resultant table from CTE will not be created, but will be in the memory as a temporary data or an intermediate resultant data, right? Now, whenever you want to use a join or whenever you want to use the same query inside a bracket or inside something in your query, you can just simply use the name of the CTE and then the data you require, the columns you require, and done. You will get the data. Now, this might be a little too complicated to understand in just mere words. Now, let's just go through the formal definition of what exactly is a CTE and what it does, and then let's quickly. So, it's a little too complicated to understand it just with mere words. So, let's get started with the practical examples. But before that, let's understand a formal definition of what exactly is a CTE in SQL. So, CTE, also known as or also called as the common table expression, or some people also are used to call it as a with expression. So the keyword is with. So a common table expression in SQL is a temporary result set that you can define within a query. As I said, it helps to break down the complex queries, make the code more readable, and allows you to reuse the result set multiple times within the same query. Just you need to use the name of the CTE in the places where you want in your query, and it reduces the code length as well as the execution time. Now, CTEs are defined using the with keyword as we discussed before, followed by the CTE name, right? So for every column name or anything in your dataset, you give a name, right? Similarly, when you are using CTEs in SQL, you also need to give a name to the CTE, and that particular name will be used in your subquery positions that will reduce the query length and execution time. So you should be giving a name and the query that generates the result set. The CTE is available only during the execution of that particular query or specific query, right? So as I said, the CTE table, the resultant table which is created while you are using the CTE, will not be created as a permanent table in the database, right? It will be a temporary or intermediate result which will be active as long as your current query, which is using the CTE, is active. Now, let's go to the demonstration mode where we will try to create some simple queries, right? And we will understand how exactly a CTE can be beneficial in those situations. Now, let's go to the MySQL workbench. This is my MySQL workbench. So I have a lot of tables here. We have the credit card dataset. We have the Sakila dataset, SLP dataset, SIS, Superstore, World, etc. Right? So we will be using the Superstore dataset. The database. So firstly, we need to write in the query, which means that I am going to use the Superstore database, right? Sorry, Superstore. So I prefer using smaller case or lowercase for database names and column names, and uppercase for the keywords. For example, here use is uppercase and superstar is the name of the keyword, right? So that is for identifying or easy readability, which is a keyword and which is a name, right? So let's execute this query and have access to the superstore dataset. And in superstore dataset, I have one table called as Excel data. Now let's quickly check what we have in Excel data. Select star from Excel data. Here we have row ID, order date, ship mode, customer care, everything, right? So we have region, we have sales, quantity, discount, profit rate. So we have a number of possibilities, a number of reports that we can generate. But let's try to keep it simple. Let's try to find out unique regions, right? Select unique of regions, right? Or just regions, Excel data. Group by regions. So let's quickly execute this statement and see the output, or maybe we can make some modifications to it, right? Instead of that, you might want to use distinct function so that you don't get all 10,000 plus rows. So basically this particular dataset has about 10,000 or more rows in it, and it's not real, it's completely made up report using artificial intelligence. So we use ChatGPT to create 10,000 rows of data for 30 years, maybe from 2000 or 2001 to up to 2030 or 31, right? So we don't want all those 10,000 plus columns, rows. So let's use a distinct here and try to execute this statement so that we get 5 of the regions what we have. So there you go, we have 5 regions as expected: northeast, southwest, and central. Now you can also select a kind of maybe average of sales, maximum of sales, and total sales. So this is bringing us somewhere we can try to find out region-wise sales, right? So region-wise sales grouped by years, like 30 years. What was the sale happened in the year 2001, right? We begin from 2000 or 2001 to all the way up to 2030 or 2031, right? So we can see if there is an increase in the year-on-year sales or decrease in the year-on-year sales. We can identify the best performing year, the worst performing year, right? So this sounds like a good use case. Now let's go to the code where I've written it as a CTE and understand the workflow. So here I have named my CTE as sales CTE. So I'm starting it with the keyword with, right? So with sales CTE as. Now this is our query, right? What am I doing? I'm extracting. So according to the dataset, we have the date, right? So the date is year, month, and date of that particular day, right? But we want just the year. So we're using the year function to extract the year from the date as sales year, region, sum of sales, right? We wanted to find out the total sales happened in that particular year as total sales from the dataset Excel data, and group by year, right? We wanted it in increasing order. So 2000 to all the way up to 230 or 2031, correct? So that's how it is. And I'm saving all this as a CTE named as sales CTE. Now I want to select some parts of that particular CTE. So I want to select sales year, region, total sales from sales CTE, which is right over here, and order it in form of sales and region, right? Now let's try to copy this code and run this in our workbench. Right? Now let me close this quickly so that we have a complete view of the code. right? So let's now select all the code. So now we have selected this particular code. Let's try to run this and see the output. There you go. We have the output, but there is something wrong. We did not get the years, right? So all the 30 years of data, here it is grouped by region, which is fine. Okay, we don't want region. We want to group it by year. That's okay. And the thing is, we need to fix this particular year. So maybe there is something wrong with the order date, right? So I think the database has saved this particular. Oh, okay. Since this is generated by ChatGPT, maybe the data type of the date is other than data, right? Other than data type. It may be string. Now, we might have to do some typecasting to change the data type of the order date, and let's quickly do that. So now we have updated the year. So what we have done is just cast here, right? So we have changed the string type of date to the normal date, which follows by year, month, and date. So this is a simple typecasting that you can do, and rest everything. And we've also added a where condition. So where date is not added or date is equals to null, then you can just ignore that. And now let's try to execute this query, and we have also removed that region thing, right? Group by region or order by region. So we want that to be ordered according to the year, which should start with 2001 or the first ever year to the last ever year according to the dataset. Now let's select the entire CTE query and run that and check our outputs. So there you go. So you have the year-on-year sales from 2001 to all the way up to the year 2030 and 2031, right? So that's how the CTE or common table expressions in SQL or the with query in SQL can be used.
So welcome to the demo part of the SQL project. So in this we will do digital music store analysis. Okay, so this SQL project is for the beginners. So what you will learn from this project, main thing is like, so what's the objective of this project, this particular project? So this project is for beginners and will teach you how to analyze the music playlist database, and you can examine the dataset with SQL and help the store understand its business growth by answering simple questions. So as you can see, I will show you. So I have three set of questions. First one is easy, okay, and the second one is moderate, and the third one is advanced level. So we have three set of questions: easy, set, moderate, and the advanced. Okay, so every set is of three questions, I guess. Yes, in every set there is three questions. So okay, in easy one there are five. So we have 5 plus 3 8, 8 plus 3 11. We have 11 questions to solve. Okay, from this you will understand how you can analyze data with SQL, how you can extract something from database, how you can store something like this. Okay, so, and one more thing, I will show you the schema of the particular data set which we will soon we will restore. So we have the tables in this: artist, album, track, media type, genre, invoice line, invoice, customer, employee ID, playlist track, and all. Okay, so this is the music playlist database schema. So without any further ado, let me create one database. So here, just right click, create database. Okay, here I will write music. Okay, and save. So now our database is created. Okay, so if you will go to schema and if you go to tables, there is no tables in it. Means there is database, but nothing is there. The database is empty. So now what I will do, just go to your database, just right click. Here you can see the restore option. Okay, restore. So format as it is, then here file name, go to this music store database. I will put this database link in the description box below, don't worry. Open, then restore. Process started, process complete. Some people will face this that the process is failed or something. Okay, so for that what you have to do, just go to file, then preferences. Here you have to set the path, just binary path. Okay, see I am using the 15th version. Okay, so I have set the path here also and this also, but you have to set this path is important. Okay, if you will not set this edv advanced server path, it's fine, but this path is most important. Okay, but for the future reference I have added on the both. So what you have to do, you have to just see where you will find this path. Just go to this PC, then OS, then program files. Here you will find this PostgreSQL. Then I'm using C15, 15, then bin. So you have to copy this path, right? You have to just copy it and paste it here, and then select this one. After that, just save. You won't find any failed thing. Okay, the process will complete. Right, so now let's move forward and see the tables. Okay, it's still empty. Why? Just refresh it. See, now you can see all the columns in my tables. Okay, so what I will do for the checking, I will run one query here. Okay, let me close it. Okay, I will write here select star from album. Okay, let me run it. So now as you can see here, my table is working fine, everything seems good. Okay, so now what we will do, we will solve question one by one. Okay, so the first question, let's see the first question, easy one. Who is the senior most employee based on job title? Okay, who is the senior most? Okay, so I will write here like the first question is, who is the senior most employee based on job title? Okay, so this is our question. So we know we have the table name called employee, so we will select that table first. So I will write here select star from employee. So you should know which table should to select. Okay, so here as you can see in this question, there is word employee. Who is the senior most employee based on the job title? Most employee means employee is an employee table, right? So I will run it. Okay, so what I will do, I will just select this and run it. Okay, so now you can see there in employee, there is employee ID, last name, first name, title, report levels, birth date, hire date, and all the details of the particular. Okay, so we will do, so there is one more thing, you can see the levels. Okay, level 1, level 2. So we have to write who is the senior most employee based on the job title. So what I will do, I will write here order by levels in decreasing order. Okay, so first I will do, so now you can see the levels are in the descending order from senior to this. Okay, L7 to L1. So what we want only one employee name. So what I will write here, limit is 1. Okay, I will copy this and I will done it. Okay, so now you can see the last name is Mohan Madan. This is last name, this is first name. So Mohan Madan is the senior most employee based on the job title. So question first is done. So the second question is, which countries have the most invoices? Okay, first I will write down the question, which country has the most invoices. Okay, so for this what we have to do, see, just first we have to check from which table we will get the solution. So here you can see the word invoices. Okay, so we have one table, invoice and invoice line. We have to select it from this. Okay, so I will write here, select star from invoice. Okay, so we have customer ID, invoice date, billing address, billing city, billing state, and everything. So here you can see we have the billing country as well. Okay, because we need the country name, so we will take this column, right? So I will write here, so I will write select, change it, select count star from name, select star billing country from invoice, group by billing country. So why I am doing this group by? Because as you can see, we have USA multiple times, USA, then Canada also, then the other countries as well. So from this I will get only the one. Okay, I will group them and I will get the one. Fine. So from this we will get the count. So after this I will write order by, so here I will write C descending. Okay, let me run it. So now you can see the billing, this is the billing order. Okay, so or you can say the invoices, USA got the 131 and Canada 76, Brazil 61. If I will write here again that limit 1, what I will get, see, USA, we got the USA. So USA is the country which have the most invoices. Okay, if you will remove this limit, so you will get the other country as well. Second in Canada, third is Brazil, and like this. Okay, and the third question is, what are the top 3 values of total invoices? Okay, again we need the same table. Okay, first I will write the question. Third question is, what are the top 3 values of total invoices? Top 3 value of total invoices. Okay, I know I can just solve this question by the second one, but I want to do it from the starting. Okay, so first I will select stuff from invoice. Let me run it. So first we will sort the data. Here I will write order by total, because the last, this is a table name. Okay, total in the descending order. So first I will select. So we need just the top 3. So first I will do, everyone know, limit 3. Okay. Okay. So here I have wrote this star. That is why it's giving me all the values. If I want this, only this value, so I can write select total from invoice order by this. Okay, I will write and run it. So I have this total like 23.75999 and 19.8 and 19.8. So these are the top 3 values of total invoices. Okay. So here the fourth question is, which city has the best customer? We would like to throw a promotion music festival in the city. We made the most money. Write a query that returns one city that has the highest sum of invoice total. Return both the city name and sum of the all invoice total. So let me write the question first. Okay, I am writing question for your better understanding. Okay, question fourth. Which city has the best customers? We would like to throw a party or promotional music festival in the city. We made the most money. We made the most money. Write a query that returns one city that has the highest sum of invoices total. Return both the city name and sum of all invoices. Okay. So we have this question. Okay. So which city has the best customer? We would like to throw a promotional music festival in the city. We made the most money. Write a query that returns one city that has the highest sum of invoice total. Return both the city name and the sum of all the invoices. Okay. So first, what we will do, we will select stuff from invoice. Okay, sorry. We'll select this. Okay, so first we will select the billing city. We have to focus on this and the total. In this two table, we have to just focus on. Okay, so here I will write sum of total as invoice total comma billing city from invoice. So this time we will do group by billing city because we need the city names. Then I will add order by invoice total in the descending order. Seems good. Select sum total as invoice total billing city from invoice billings. Okay, so let me select this. So as you can see, the highest billing city is Prague, and the best customer is from the Prague city. Okay, so which city has the best customer? Obviously Prague, or sorry for the mispronunciation. Okay, so this is how we have solved our fourth question as well. Okay, because written both the city name and the sum of all the invoices. This is the city names and the invoice total. Okay, moving forward to our fifth question, which is again the long one. Who is the best customer? The customer who has spent the most money will be declared the best customer. Write a query that returns the person who has spent the most money. Okay, so I will write here who is the best customer. The customer who has spent the most money will be declared the best customer. So write a query that returns the person who has spent the most money. Okay, yeah, so who is the best customer? The customer who has spent the most money will be declared as the best customer. Write a query that returns the person who has spent the most money. Okay, so for this we have to take this customer table data. Okay, so I will write as select stuff from customer. Okay, I will select this and I will run it. Okay, so this is our table data of customer. Okay, so we have the country, fax, emails, state, city, address, last name, first name. Okay, so as you can see, there is nothing like no detail of invoice or the money, okay, which have spent by the customer. So what we will do, we will look at our schema. So now what we can do, if we can't solve a particular question from with one table, we have to join the table to the other table. So here we have to join customer table to invoice table. So in this you can see there is customer ID and here also customer ID. So on the basis of customer ID, we can join both the table, and with the help of this total we will sort out the that guy, okay, that customer, right? So for this I will write here select customer ID comma customer dot first name comma customer dot last name, because we need the full name of that guy, comma sum invoice dot total as total. Okay, let me, can be pause. Okay, I don't need the search pad, right? Then I will write from customer. Okay, my bad. Then join invoice on customer ID equals to invoice dot customer ID. Then I need group by. Okay, group by customer dot customer ID. After this, let me order it by the descending order, so the most spend customer will come up. So I will write here order by total, the descending order, then limit equals to 1. Fine, let me run it. Let's see what output should be. Okay, some error is coming. Limit. Okay, sorry. Okay, so as you can see, the customer ID is 5. The first name is R, the last name is Madhav. R Madhav spent the highest value 144.54, 0000 and 2. So who is the best customer? Madhav, R Madhav, sorry, my bad. R Madhav, right? R Madhav has spent the most money. Okay, so this is how we are done with our easy set of questions. Now let's jump into the moderate one. Okay, so let me write the question first for the moderate. So I will write here moderate questions. So these analytics skill help you in the data analytics to become a data analyst or to become a data scientist. Okay, so the question first is write query to return. Okay, write query to return the email. Query to return the email, comma first name, comma last name, and genre of all rock music listener. Okay, then return your list ordered alphabetically by email starting with A. Okay, let me get the yeah. So for this, okay, let me open this first. Yeah. Okay, fine. So first, what I will do. So now in this question, as you can see, we have to return the email, first name and the last name and the genre of all rock music listener. So if you will see, select stuff from customer. Okay, let me run this. And if I will see, there is no column name genre. Okay, if I will show you the schema of this, see the genre is here, and the customers is here. Okay, we need the first name, last name, and the email ID and the genre. Okay, and the genre should be rock. Okay, so what I can do, I can connect this genre with track. Then because here is also track ID and here is also track IDs. Then track ID to invoice line, then invoice line to invoice, then invoice to customer with the customer ID. Okay, this pattern I have to follow, right? So for this I will write select, just copy this. Okay, just follow these steps. Select distinct email comma first name comma last name from customer, join invoice on customer dot customer ID equals to invoice dot customer underscore ID, then join invoice underscore line on invoice dot invoice ID. Okay, then invoice underscore ID, then where track ID should be in. Here I will do select track ID, okay, from track, then join genre, yeah, on track dot genre dot ID equals to genre dot genre ID, where this is important, genre name like rock, because we need, as you can see, write a query to return this is this and genre of all rock music listeners. Okay, rock, right? Then order by email. Okay, before that let me show you this track. Okay, select star from track. Okay, let me show you this table. You can see the name, the track ID, album ID, media type, genre ID. Okay, then the composer, this bytes and the unit price, right? Okay, so you know this, we have then this customer, okay, invoice ID we took, right? Fine. So now what I will do, I will just select this and okay, invoice ID. Okay, invoice ID is ambiguous. Here I have to write invoice line dot invoice ID. Okay, let me now run. Let me run it. Okay, one more. Join genre on track dot genre ID. There is entry for table genre, but it cannot be referenced from this part of the query. Okay. Okay. As you can see here, the table name is genre underscore id. That was the mistake. Okay, one more, genre dot name. Spelling mistake. Sorry, my bad, guys. No issues, it happens. Okay, now you can see we have all the people who love rock music, and we have the email, then first name, then the last name. See, Aaron Mitchell, Alexandra Roca, Astrid Gruber, like this, Camille, Dan, Edward, like this. Okay, so there are total 59 people who loves rock music from this particular database. Okay, now question 2. Question 2 is, first let me show you. Let's invite the artists who have written the most rock music in our dataset. Write a query that returns the artist name and the total track count on the top 10 rock bands. Okay, so let's invite the artist who have written the most rock music in our dataset. So write a query that returns the artist name and the total track count of top 10 rock bands. So now what we need here? Okay, let me do this. So what we need here? So let's invite the artists who have written the most rock music. First we need the artist. Okay, and the second is rock music. Then we need track. Okay, and the total track count means we will get from the track. So here we have track column, track table, and we have the artist. So now let's see the schema part. So we need genre. Okay, for the rock music. Then we have to combine this with the track id because genre id is there. From track id to album because we need the artist name. See, artist id and artist id. So this is how we have to connect the table. Now, so for this I will write here, just follow the steps. Select artist dot artist id comma artist dot name comma count artist dot artist id as number of songs because we need the total number. Okay, who have written the most rock music, number of songs. Fine, from track. Now we have to join album on album dot album id equals to track dot album ID. Okay, then we have to join the artist with artist ID. So join artist column on the basis of artist ID equals to then album to album dot artist ID. Okay, so here I have joined the artist to the album column table. Okay, then I have to join genre to the track table with the track table. Okay, so here I will write join genre on genre dot genre ID equals to genre ID. Okay, sorry, track ID. Track dot genre ID. Okay, so here I will write where genre dot name like rock. Okay, rock. Fine. Then I will group by group by artist dot artist ID. I need the ID as well. Then order by number of songs in the descending. Then limit, I need only 10 rock bands. Limit will be 10. Let me run it. Okay, let me run it. Okay, album. Okay, now let me run it. Okay, now you can see this guy, Led Zeppelin, artist ID is 22 and wrote the most songs 144. Then U2 122, Deep Purple 92, then this, then this. Okay, so this is how we solved our second question, right? So now the third question. Okay, return all the track names that have a song length longer than the average song length. Return the name and the millisecond of the each track ordered by the song length. Okay, so first I will write this question. Q3. So return all the track names that have a song length longer than the average song length. Okay, first we return all the track names that have the song length longer than the average song length. Okay, then return the name and milliseconds for each track. Fine. After that, order by the songs with the longest song listed first. Okay, fine. So we have to return all the track names that have a song length and the okay. First, we will find the total length of this songs. Then we will do the where. Then we will put the where clause to find out the particular longest song. Okay. So this will do in the two step. First, we will find the average stack length. Okay. So I will write here select name, comma, milliseconds. Okay. From track where milliseconds here I will write select average from the millisecond. Okay, then I will write here as average track length okay, then here I will write from track. After this I will write here order by milliseconds. I need in the descending order. Okay, so let me run it. So now you can see first I will read it again. So return all the track names that have a song length longer than the average song length. Return the name and the millisecond for each track. Order by the song with the longest song listed first. Okay, so this is the longest song. Okay, so we have all the songs which are the longer than the average song length, right? So now moving forward, we have jump into the advanced set of questions. Okay, so now we will do the advanced questions. Okay, so let's see first. Find how much amount spent by each customer on artist. Write a query to return customer name, artist name, and total spends. Okay, so first we will write down the questions. Okay, then question one. Okay, find how much amount spent by each customer on artist. Write a query to return customer name, comma, artist name, comma, total spent and total spent. Okay, so how to solve it? So first find which artist has earned the most according to the invoice lines. Okay, first let me show you the schema. Okay, we need the artist name, we need the customer name, and we need the total spent. Okay, with the invoice line, because the quantity should be there. Okay, so first we'll see how to join these three tables: artist table, customer, invoice, and invoice line, like this. Okay, this is how we will join the table. Fine. So now I will tell you the steps. So first find which artist has earned the most according to the invoice line. Okay, the second, now use the artist to find which customer has spent the most on the artist. So for this query you will we need to use the invoice line, track, customer, album, and the artist table. So just remember, this one is tricky because the total spent in the invoice table, right? Let me show you. So total spent on the invoice table might not be a single product. So that is why I was saying we need the quantity. So we need the invoice line table to find out how many each product was purchased. Then we have to multiply this by the price of each artist. Okay, fine. So now, so this is a lengthy one. I will just, write it for you and get back to you. Yeah. So this is how you can see, okay, group by 5. I have wrote this. You can just, write it, okay, like this. Okay, we took artist name, then sum of invoice line, unit price into invoice line, the quantity that I showed you. Okay, we have multiplied this total with the quantity. Okay, then we joined the table track with invoice, album with track, artist with album. Okay, so now let's run it. Yeah, so now you can see this Hugh O'Reilly Queen, amount spent 27, the customer ID is this. Okay, then Nicholas Schroeder, then 18. Okay, we have the everything. Okay, customer name, artist name, and the total spent. This is the customer name, the artist name, and the total amount they spent. Fine. So now let's move forward to the next one, which is, okay, yeah. So the second one is this. We want to find out the most popular music genre for each country. We determine the most popular genre as the genre with the highest amount of purchase. So write a query that returns each country along with the top genre. For countries with the maximum number of purchases, shared return all the genres. Okay. So what I will do first, I will write the question. Okay. So okay. Question 2. So find how the most popular music genre for each country. Okay, determine the most popular genre as the genre with the highest amount of purchase. Okay, then write a query that returns each country along with the top genre for countries where the maximum number of purchase. Okay, so so there are two parts in this question. First, the most popular music genre, and the second is the need of data at the country level. Okay, so we can do it from the two methods. Okay, using CT and using the recursive method. So I will use the using CT. I will do this CT. So for that you have to write with popular genre as select count invoice line dot quantity, okay, as purchases, comma, customer dot country, comma, genre dot name, comma, genre dot genre ID. Okay, then here I will write row underscore number, then I will write over partition by customer.country, order by count, invoice line dot quantity, okay, into descending order, as row number. Okay, so from invoice line, okay, yeah. So here I will join the tables, join invoice on invoice dot invoice ID equals to invoice line dot invoice ID. Okay, then again join customer on customer dot customer ID dot ID underscore ID equals to invoice dot customer ID. Fine. Then again we have to join track on track dot track ID equals to invoice underscore line dot track underscore ID. Then join genre on genre dot genre ID. Okay, then track dot genre ID. Okay, then I will do group by 2, 3, 4. Then I will do order by 2, then ascending order, and then 1 to descending order. Okay. Then now I will write select star from popular genre where row number is less than greater than 1. Okay, now let me run it. So now you can see we have, okay, let me read it. So we have to find the most popular music genre for each country. Okay, so now we have the country name Argentina, the most popular is alternative and punk, genre ID is this, row number is this. Okay, purchase is this. Then the Australia, this rock. Okay, certain rock, USA rock, and everything is there. Right? So this is how you can find the most popular music genre for each country. Okay, the last question is there here. Now the last question is, write a query that determines the customer that has spent the most on the music for each country. Write a query that returns the country along with the top customer and how much they spent. Okay, for the countries where the top amount of spent is shared, right? And they provide all the customer who spent this amount. Okay, so for this is like a similar to this question. Okay, so there are two parts in this question. Find the most spent on music for each country, and the second is to filter the data for the respective customer. It's very easy. Okay, so okay, I will write the solution. Okay, you can check the question from there. Okay, I will write customer with country as I will here select customer dot customer ID comma first name comma last name comma billing country comma sum should be total as total spending, right? Then I will write row number same over. We have also written here, no? Right? The same we have to write here over. Then partition by billing country, order by sum, total, descending order as row number. Okay, so after this I will write here from invoice you have to fetch. Then again the same thing, you have to join the table, join customer on customer dot customer ID equals to invoice dot customer ID. Okay, then here I will write group by 1, 2, 3, 4, okay, that's it. Okay, then I will write here order by 4 ASC ascending order comma 5 to descending order. Fine. So now I will write here select star from customer with country where ROW number is 1. Fine. So let me run it. See, we have first name, last name, billing country, total spending, row number, and the customer ID. Let me show you the question. Here, write a query that determines. Okay, let me make it this one. Okay. Yeah. So write a query that determines the customer that has spent the most on the music. So customer, we have the customer name. For each country, write a query that returns the country along with this. So we have the country name with the top customer and how much they spend. We have the total spending. For the countries where the top amount is shared, provide all the customer who spent this amount. Okay, so we have everything here, right? We have this Lewis from Brazil, this is okay with the customer ID. So this is how you can solve these questions. So till now, I can say you have a good data analytics skills. So for this, I can say this will help you in the interview of data analyst, in data science, or any SQL.
Picture this, you are in an interview and the interviewer asks, can you write a query to find the top 5 sales records? You freeze for a moment, thinking, am I ready for this or not? Don't worry, SQL might sound complicated, but it's actually a super useful tool that lets you interact with databases. Have you ever wondered how all those apps and websites stores and organize their data? Well, that's where SQL comes in. SQL, which stands for Structured Query Language, is a universal language for talking to databases. It's super powerful and lets you do things like pull out specific information, add new data, update existing stuff, or even delete things you don't need. It's basically your magic key to manage huge amounts of information with ease. Exactly. And if you're aiming for a career in tech, whether it's a database administrator, data analyst, or software developer, SQL is a must-have skill. Databases are at the heart of almost every application. So knowing SQL can unlock some really exciting opportunities. Now, here's the exciting part. This video is your secret weapon to master SQL interviews. We have packed it with 45 carefully chosen SQL interview questions that cover everything you need to ace those tough questions. So we'll be starting with the basics like how databases work and then diving into advanced query challenges. And by the end, you'll be fully prepared to tackle any SQL question thrown at your way. So let's dive in and get you closer to your dream job. Before we comment, if you are interested to advance your career in data analytics, here's an opportunity for you. The postgraduate program in Data Analytics by Purdue University in collaboration with IBM is designed to equip you with the skills needed to succeed in the data analytics field. This 8-month program features live interactive sessions, real-life projects, and case studies that provide hands-on experience. So you can find the course link in the description box and in the pinned comment. So let's get started. So now let's start with a SQL interview question. We'll cover every question starting from basic level to advanced level. So now let's look at our first question, which is very basic. What is SQL? So we all know that SQL stands for Structured Query Language, and it is the language which is used to talk to databases. Think of it like giving instructions to a computer system that stores and organizes data. For example, if you want to find out all the customers who ordered a specific product, then SQL can help you do that with a simple command. You can also use SQL to add new data, like entering a new customer details into a database. If you want to update someone's phone number, SQL has got you covered. Or maybe you want to delete old records that are no longer needed, SQL can handle that too. Here's a quick example. If you want to find all the customers in New York, you could write something like select star from customers where city is equals to New York. So we are using this command to find all the customers in New York. Remember, if you want to find out all the specific data from the table, you have to use the star command. And if you want to add new customer, you can just simply write insert into customers, name, city, and then you can also insert value name, which is John, and you can just enter the specific location. So SQL works the same way across many popular databases like MySQL, PostgreSQL, or SQL Server, which is why it's such an important skill for anyone working with data. So now let's look at our second question, which is what are the different types of SQL commands? So SQL commands are like instructions you give it to a database to tell it what to do. There are different types of commands and each one has a specific purpose. So let me explain these in simple terms. Remember, if an interviewer asks you such questions, simply explain using the proper keywords and use proper definitions and easy language. That's it. So the DDL command we have, which stands for Data Definition Language.
It basically defines the structure of the database. For example, if you want to create a table, or if you want to alter a table, or if you want to drop a table. Then we have DML, which stands for Data Manipulation Language. It deals with the actual data in the database. For example, insert, update, delete, all of these things. Then we have DCL, which is Data Control Language. It will manage permissions and access control. So if you want to manage permission or access control, then you have to use this particular type of SQL command, which is DCL, which is grant and revoke. Grant will provide access rights, and revoke is used to remove the access rights. We also have TCL, which stands for Transaction Control Language. It will manage transactions in the databases. For example, commit is used to save changes, rollback is used to undo changes, and save point is used to create intermediate points in a transaction. So for instance, in a schema with customers table and an order table, data definition language commands are used to define the table, whereas data manipulation commands, which is select, insert, and delete, it is used to update customer or order data. DCL is used to control access, and TCL, which is transaction control language, is used to manage transactions. That's it. It was very simple. Now let's look at your third question, which is what is a primary key in SQL? A primary key in SQL is like a unique ID for each record in a table. Think of it as a way to ensure that no two rows in a table have the same value. Remember that no two rows must have the same value. It is also a rule that the primary key column can't have empty or null value. So these are the basic criteria for a key to be a primary key. For example, in a table of customers, you have a column called customer ID as the primary key. Then each customer have a unique customer ID like 1, 2, 3 and so on. This makes it easy to identify and retrieve specific customers from database. Here's a simple example. Suppose we have created this table, create table customers, and we have given the customer ID as primary key. We have given name as varchar, the city name as well. So the primary key will ensure that each customer ID is unique, no duplicates are there, no customer ID is left blank, that is there should be no null values, and primary keys are also important when linking tables together. For example, if you have orders table, you can use the customer ID as a reference to connect each order to a specific customer. This helps maintain data integrity across the databases. Now the fourth question is, what is a foreign key? A foreign key in SQL is like a connection or link between two tables. It's just like a field in one table that refers to the primary key in another table. This creates a relationship between the tables and ensures that the data stays consistent. For example, let's suppose you have two tables, a customer table with a primary key called customer ID and a sales table with a field called customer ID, which is a foreign key linking back to the customer ID in the customers table. So here's how it will look like. We have created this table and you can see in this example that suppose we have customers and sales table. So we have used this customer ID in our customer table as well. So here customer ID is the foreign key, and in the customer table, the customer ID which we had used is the primary key. So now let's move on to our fifth question, which is delete and truncate command. What is the difference between delete and truncate commands? So delete and truncate commands in SQL both remove the data from a table, but then they work in different ways. Let me break it down for you. The delete command. So what delete command will do is basically, this is used when you want to remove specific rows from a table based on a condition. For example, if you want to delete all the customers from a specific city, then you have to use this delete command. It will allow you to be selective, but it's slower because it logs each row deletion, which also makes it possible to roll back the changes if needed, if you're using transactions. Moving on to truncate command, truncate will remove all the rows from a table at once without allowing any condition. For example, if you just want to remove all the rows just in a one go, you have to use this truncate command. Just simply write this query as truncate table. Suppose the table name is customers. Is much faster because it doesn't log individual row deletions and it simply clears the entire table in one go. However, you can't roll back a truncate operation in most databases once it's done. So the key differences is delete is for specific rows, truncate is for clearing the entire table. Truncate is much more faster because it uses fewer system resources. Delete can be rolled back if used within a transaction. Truncate usually cannot. Delete logs each row deletion and truncate doesn't. So this was all for this truncate and delete command. So anytime if the interviewer asks you such questions, just simply explain this. Now let's move on to the sixth question, which is, what is a join in SQL and what are its types? So this is one of the most important questions you'll be getting to know in the interviews. You'll be asked such questions in the interviews. So basically, a join in SQL is used to combine a data from two or more tables based on related column, like a column key that links them together. It's just like connecting pieces of puzzles. Join help you see the bigger picture by merging related data. For example, if you have a customer table and a sales table, you can use the join to see which customer placed which order by linking them through a common column, such as the customer ID. So, you all know what a join in SQL, and let's discuss its type. So join types are basically, there are 4 types of join, which is inner join, left join, right join, and full outer join as well. So what inner join will do is, it will combine rows from both tables where there is a match in the common column. Think of it as the overlapping section in the Venn diagram. Only rows that exist in both the tables are included. The left join, or we can call, or the left outer join, it will retrieve all the rows from the left table and the matching rows from the right table. Remember, the left join will retrieve all the rows from the left table and only the matching rows from the right table. If there is no match, the result includes null values for the right table's column. Think of it as including the entire left circle in the Venn diagram along with any matches in the right circle. Right join, or the right outer join, is similar to the left join, but it will retrieve all the rows from the right table and matching rows from the left table. If there is no match, null values are included for the left table column. Think of it as including the entire right circle in the Venn diagram along with any matches on the left circle. Then we have the full join. Full join will combine rows when there's a match in the either table. If no match is found, it includes null or the missing values from the either table. Think of it as combining both circles in the Venn diagram. Everything from both tables are included. Now let's move on to the seventh question, which is, what do you mean by a null value in SQL? It's very easy. Null value in SQL means that a column has no data. It's missing or unknown. It's not the same as an empty string or the number 0. Those represent actual value, while null represent no value at all. For example, if you have a table of customers and one of the row doesn't have a phone number, then the phone number column for that row would be null. See, we have listed this in the table here, you can see. If you do not have any data, just simply write null. So the next question is, define a unique key in SQL. So a unique key in SQL ensures that all values in a column or a combination of columns are unique. That is, no duplicates are allowed. It's like having a rule to make sure that no two rows in a table must have the same value in that column. For example, in a user table, the email column can have a unique key to ensure that no two users can register with the same email address. Remember the key points. Unlike a primary key, a table can have more than one unique key. Unique keys allow null values while primary keys do not. So these are very important to remember. So if you're asked a difference between a primary key and a unique key, just simply say that unlike primary key, a table can have more than one unique key, and unique key allows null values while primary key doesn't. So here is a table we have listed below, that is create table users, and we have given user ID as integer primary key, and then we have email varchar as a unique key. So here the email column is a unique key, so that each email must be different. It should not be the same. Now let's look at our next question, which is, what is a database? A database is an organized way to store and manage data. Think of it like a digital filing cabinet where information is neatly arranged in tables with rows and columns. Each row represents a record and each column represents a specific detail about that record. For example, a database for a library must have a table for books. Then the rows could represent individual books and the columns could include the book title, author, and the publication year. The main purpose of a database is to make it easy to store, manage, and quickly retrieve data whenever you need it. Databases are used in everything from apps and websites to banking system and e-commerce platform. Now let's look at our question number 10, which is explain the differences between SQL and NoSQL databases. So here's a simple explanation. SQL databases are structured, which means they can store in tables with rows and columns, like a spreadsheet. They follow predefined schema, meaning the structure of a data is fixed and you need to define it before adding any data. These databases are great when you need consistent and reliable data, like for banking system or inventory management. Examples are MySQL, Oracle, MS SQL, PostgreSQL, etc. And SQL databases are also known as RDBMS, which is Relational Database Management System. Let's talk about NoSQL databases. So NoSQL databases are flexible and do not use table. Instead, they can handle unstructured or semi-structured data. So NoSQL database is dynamic, where data is primarily stored in JSON objects, key value pair, graph nodes, etc. They don't have a specific structure. Such databases are mostly not preferred for performing complex query operations, and the examples include MongoDB, CouchDB, Elasticsearch, etc. So now let's move on to question number 11, which is what is a table and a field in a SQL? So a table is like a spreadsheet that stores data in an organized way using rows and columns. Each table contains records and the details. For example, a table named employees could store information about employees in a company, whereas a field is a column in a table and it represents a specific attribute or property of the data. For example, in the employees table, fields could be employee ID, name, and department. So here's a simple example of the table. You can see here the fields name, or we can say column, and we also have the records or the rows, we can see that. So in this table, the entire table is called employee. Each row or record stores information about one employee, and each column or field represents specific details like employee ID, name, and the department. Now let's move on to question number 12, which is describe the select statement. Well, the select statement in SQL is used to retrieve data from a table or multiple tables. It's like asking databases, show me the specific information. Here's how it works. You can specify which columns you can see. For example, to retrieve all customer names from a customer table, you can select name from customers. If you want to retrieve all the data, just write this query, select star from customers. Remember, I told you before in the first question, we are using star if you want to retrieve all the data from the table. And if you want to just retrieve from a particular row or a column, just simply write, select name from customers, the field name. You can also apply filters. You can use the where clause to filter the results. For example, you can write select name from customers where the city name is New York. You can also sort the results. Use the order by to sort the data. For instance, to sort customers by the name, you can just write select name from customers and then order by name ASC. ASC means ascending order. So in short, the select statement lets you choose what data you want to see. Now let's talk about what is a constraint in SQL and name a few. So if you ask this question, just simply answer a constraint in SQL is a rule applied to a table that ensures the data stored is accurate and consistent. It also helps in maintaining data integrity by restricting what values can be added or modified in a table. Here are some common constraints: primary key, we have foreign key, then we also have unique key, check, not null, and default. So we have already discussed about primary key. It ensures that each row in a table has a unique identifier and the column can't contain null values. Foreign key links to a column in one table to a primary key in another table to maintain relationship. Unique key ensures all the values in a column are distinct, that is, there are no duplicates. The check ensures that data meets a specific condition before being inserted or updated. Not null ensures that a column cannot have null values. The constraints are essential for maintaining reliable and valid data in your database. Now let's talk about what is normalization in SQL. Normalization in SQL is a process which is used to organize data in a database to make it more efficient and reliable. The goal is to reduce redundancy, which is duplicate data, and ensure data consistency. This is done by splitting a large table into smaller related tables and then linking them using relationship like primary and foreign key. For example, imagine a single table that stores customer details and the orders. If the same customer places multiple orders, then their information like name and address would be repeated for each order. Now, using normalization, you would separate this into two tables. First, we would have customer table, which will store customer details like customer ID, name, and the address. And then we have order table, which will store order details like order ID, customer ID, and the order date. Now, by linking these tables using customer ID, you can also reduce duplication and ensure that any changes to customer details are updated in just one place. Now, let's talk about question number 15, which is how do you use the where clause? It's very easy. So just answer the where clause within SQL queries serves the purpose of selectively filtering rows according to a specified condition, thereby enabling you to fetch exclusive those rows that align with the criteria you define. For example, select star from employees where department is equals to HR. Now let's move on to question number 17, which is difference between union and union all. So union is used to merge the contents of two structurally compatible tables into a single combined table. The difference between union and union all is that union will omit duplicate records, whereas union all will include duplicate records. Very easy. Union will omit duplicate records and union all will include duplicate records. The performance of union all will typically be better than union since union requires the server to do the additional work of removing any duplicates. So in cases where it is certain that there are not any duplicates or where having duplicates is not a problem, then we can use union all. It would be recommended for performance. So now let's move on to the question number 18. So here a table is given below and you will have to say what will be the result of a query. The query is select star from runners where ID not in, select winner ID from races. So the answer is, given the simple data provided, the result of this query will be an empty set. So the reason for this is as follows. If the set is being evaluated by the SQL not in condition contains any value that are null, then the outer query here will return an empty set, even if there are many runner IDs that match winner IDs in the races table. Question number 19 is what are indexes in SQL? Indexes in SQL are just like having a shortcut to quickly find data in a table. Instead of searching through every row one by one, an index creates a sorted structure based on one or more columns, making data retrieval much more easier. For example, you can think of an index in a book. If you're looking for a specific topic, you can go to the index at the back and find the page number instead of flipping through every page. Similarly, in database, an index helps the system quickly locate the rows you need. So here's how it works. If you often search for customers by their name, creating an index will speed up those queries. You can just write create index IDX customer name on customer and then the customer name. The database uses the index to find the row, so you just have to run a query which is select star from customers where name is John, and then you can use the index to find the row with name is equals to John much faster. Let's move on to question number 20, which is explain group by in SQL. The group by clause in SQL group rows with the same values in a column, allowing you to apply functions like sum, count, or average to each group. For example, in a sales table to find total sales by region, you just simply have to write this query which is select region, some amount as total sales from sales group by region. So the group the sales by region and calculates the total for each. It's a quick way to summarize data by categories. So now let's talk about question number 21, which is what is an SQL alias? A SQL alias is a temporary name you can give it to a table or a column in a query to make it easy to read or work with. It's like giving a nickname to something for clarity. For example, if you have a column named first name, you can use an alias to rename it as first name in the query results. You just simply have to write this query as select first name as first name in capital letter, last name as last name from employee. Here the AS keyword assigns the alias and the output will show the columns as first name and last name. Aliases are also useful for tables. So for this, you can just write the code as select E first name from department table. So this shortens table name for easier referencing. Aliases are not permanent, they only exist while the query is running. Now let's talk about the question number 22, which is explain order by in SQL. So you can answer this question like the order by clause in SQL is used to sort the result set of a query based on one or more columns. You can specify each column sorting order, ascending or descending. For ascending, you have to use ASC, and for descending, you have to use DESC. Okay. So just have to simply write this query as select star from product order by price DESC. Now let's talk about question number 23, which is differences between where and having in SQL. The where clause is employed to restrict individual rows before they are grouped, such as when filtering rows prior to a group by operation. Conversely, the having clause is utilized to filter groups of rows after they have been grouped, like filtering groups based on aggregate values. The having clause, it cannot be used without the group clause, whereas the where clause specifies the criteria which individual records must meet the selected query. It can be used with the group by clause. Question number 24 is what is view in SQL? One more important question. So, an SQL view is essentially a virtual table that will derive its data from the outcome of a select query. Views serve multiple purposes, including simplifying intricate queries, enhancing data security through an added layer, and enabling the presentation of targeted data subsets to users, all while keeping the underlying table structure hidden. Now let's move on to question number 25, which is what is a stored procedure? So if you are asked this question, just simply say a SQL stored procedure comprises of pre-compiled SQL statements that can be executed together as a unified entity. These procedures are commonly used to encapsulate business logic, improve performance, and also ensure consistent data manipulation practices. That's it. Now let's move on to question number 26, which is one more important question, which is what is triggers in SQL? A SQL trigger consists of a predefined sequence of actions that are executed automatically when a particular event occurs, such as when an insert or delete operation is performed on a table. Triggers are employed to ensure data consistency, conduct auditing, and streamline various tasks. So you can use insert trigger, update trigger, or delete trigger accordingly. Now let's talk about what are the aggregate functions, and if you know them, name a few. It's very easy to answer. Aggregate function in SQL perform calculations on a set of values and return a single result. At first, we have minimum, which will get the minimum value from the resultant set. Then we have the max function, which will give you the maximum value from the resultant set. The sum will give you the sum of values from the resultant set. Average will give you the simple average of the resultant set. And the count will count of numbers records from the resultant set. Now let's talk about question number 28, which is how do you update a value in SQL? The update statement serves the purpose of altering pre-existing records within a table. It involves specifying the target from the update, the specific columns to be modified, and the desired new values to be applied. For example, if you want to update, you can use query like update employees, set salary is equals to 6,000 where the department is IT. Now we'll be moving on to some intermediate SQL interview question and answers. So one of the question is, what is a self-join and how would you use it? I would like to repeat again, these join types of question is very important. These are often asked in interviews. So talking about what is a self-join in SQL is a type of join where a table is joined with itself. It's useful for comparing rows with the same table or exploring hierarchical relationship, such as finding employees and the managers in an organization. So imagine if you have an employee table. So you have employee ID, name, and the manager ID. So if you want to find each employee and the manager, you can use a self-join. You can just simply write a query as select ename as employee, mname as manager, from employee, left join employees on manager. So I've already discussed with you before what is the meaning of left, right, and self-join. So here the table joined with itself using manager ID to link each employee to the manager. A self-join is helpful for comparing rows in the same table or working with hierarchical data. So now let's move on to question number 30, which is explain different types of joins with example. At first, we have inner join. The inner join will gather rows that have matching values in both the tables. Then we have the right join. It will gather all the rows from the right table and any matching rows from the left table. Left join will gather all the rows from the left table and any matching rows from the right table. And the full join will gather all rows where there is a match in either table, including unmatched rows from both the tables. Very easy. Now let's move on to question number 31, which is what is subquery, and provide it using an example. So subquery basically refers to a query that is embedded within another query, serving the purpose of fetching information that will subsequently be employed as a condition or value within the encompassing outer query. So you can just use this query, which is select name from employees where salary is greater than select average from salary from employees. Now the next question is how do you optimize SQL queries? So basically, the answer to this question would be something like SQL query optimization involves improving the performance of SQL queries by reducing resource usage and execution time. Strategies include using appropriate indexes, optimizing query structure, and avoiding cost operations like fully table scans. Now let's talk about question number 33, which is what are correlated subqueries? It's a type of subquery that makes reference to columns from the surrounding outer query. This subquery is executed repeatedly, once for each row being processed by the outer query, and its execution depends on the outcomes of the outer query. Now we'll be talking about what is a transaction in SQL, and it's very important. One of the most important questions asked every time in SQL interview questions. So basically, a transaction in SQL is a group of one or more SQL commands that are treated as a single unit. It ensures that all the operations in the group either succeed completely or fail entirely. This guarantees the integrity of the database. Imagine you're transferring money from your bank account to a friend's account. Then the bank first deducts the amount from your account and then it adds the same amount to your friend's account. These two steps together form a transaction. If one of these steps fails, example, the system crashes after deducting money from your account but before adding it to your friend's account, then the entire transaction is rolled back, meaning no money is transferred and the database returns to its original state. So you can also explain this question with the help of example that would be more, clear to the interviewer. Now let's talk about what are ACID properties in SQL. So basically, ACID stands for atomicity, consistency, isolation, and durability. And these are key properties that ensures database transactions are reliable and maintain data integrity. Atomicity, you can think of it as all or nothing. A transaction is a single unit of work. If any part of the transaction fails, then the entire transaction is rolled back and no changes are made to the database. For example, if you're transferring money between two accounts, either both the debit and credit operations happen or neither does. The second we're going to talk about is consistency. The database must always be in valid state. A transaction takes the database from one valid state to another, following all the rules and constraints. For example, if a transaction adds a record that violates a rule, like a duplicate primary key, then the transaction fails, keeping the database consistent. Isolation, transactions don't interfere with each other. Even if multiple transactions are running at the same time, each transaction works as if it's the only one happening. Example, if two people are updating the same record, then one transaction will wait until the other is complete. Talking about durability, once a transaction is committed, it's permanent. Even if there's a power outage or system failure, the data is saved and it won't be lost. After you complete an online purchase, the transaction is stored securely even if the server crashes immediately after. So this was for the ACID properties. And now we'll be moving on to our next question, which is how to implement error handling in SQL. Error handling in SQL is a process to manage and respond to errors that occur during query execution. Different database systems have specific ways to handle errors. In SQL Server, the try-catch block is commonly used. The try block contains the main operation, while the catch block handles errors if they occur. For instance, in a transaction, you can use rollback in a catch block to undo changes if something goes wrong. Similarly, in Oracle, the exception block within PL SQL is used to handle errors. If an error arises, the exception block executes, rolling back the transaction and then logging the error message. By implementing error handling, you ensure that operations fail gracefully without corrupting data, making the database operations more reliable and secure. Next question, which is describe the data types in SQL. SQL supports various types of data types which define the kind of data a column can hold. These are broadly categorized into numeric, character, data type, and binary types. So we have numeric data types like integer, float, then we have character string like char, varchar. We also have Unicode character string like encat, enttext. Then we have binary, which includes binary image, date and time, which includes date and date and time. Then we also have some miscellaneous data types, which is XML and JSON. So the next question is explain normalization and denormalization. Often this question is asked in this way also, or it could be asked something like explain the difference between normalization and denormalization. So to answer this, you have to just simply explain what normalization is, which I have already discussed before. Once again, I'm saying you normalization and denormalization are ways to organize data in a database. Normalization is all about breaking big tables into smaller ones to remove duplicate data and improve accuracy. For example, instead of repeating customer details in every order, you create one table for customers and another for orders, linking them with a key. Denormalization, on the other hand, is when you combine or duplicate data to make it faster and retrieve. For instance, you might add customer details directly to the order table so that you don't need to join tables during a query. Normalization helps you space and maintain consistency, while denormalization makes data retrieval quicker depending on what the database needs. Let's move on to the next question, which is what is a clustered index? It's very easy. Just simply answer by saying that a cluster index in SQL determines the physical order of the data rows in a table. Each table can have only one clustered index, which impacts the table's storage structure. Rows in a table are physically stored in the same order as the clustered index key. Now we have next question, which is how do you prevent SQL injection? So talking about this question, SQL injection is a security risk where attackers insert harmful code into SQL queries, potentially accessing or tampering it with your database. To prevent this, you can use parameterized queries or prepare statements to handle user input safely. You can validate inputs to allow only expected values, use stored procedures to separate logic from data, limit database permission, and escape special characters. These steps help you secure that your database is free from SQL injection attacks. The next question on the list is explain the concept of database schema. In SQL, a database schema functions as a conceptual container for housing various database elements such as tables, views, indexes, and procedures. Its primary purpose is facilitate the organization and segregation of these databases elements while specifying their structure and interconnections. The next question is how is data integrity ensured in SQL? Just simply answer by saying that data integrity in SQL is ensured through various means, including constants, example, primary keys, foreign keys, check constants, normalization, transactions, and referential integrity constants as well. These mechanisms prevent invalid or inconsistent data from being stored in the database. Question number 42, which is what is an SQL injection? We have already discussed about how we can protect our data from SQL injections. So now let's discuss what is basically a SQL injection. So SQL injection in cybersecurity attack that involves insertion of malicious SQL code into applications input fields or parameters. This unauthorized action enables attackers to illicitly access a database, extract confidential information, or manipulate the data. The next question is how do we create a stored procedure? You use the create procedure statement to create a stored procedure in SQL. A stored procedure can contain SQL statements, parameters, and variables. So here's a very simple example. You can just simply create by writing this query as create procedure, get employee by ID, at employee ID integer as begin, select star from employees where employee ID is equals to at employee ID. And then you just have to write end. That's it. So next question is, what is a deadlock in SQL and how it can be prevented? One more important question often asked in interview. So you have to answer something by saying that a deadlock in SQL happens when two or more transactions are stuck because they are waiting for each other to release resources. It's just like two people trying to go through a narrow door at the same time, each refusing to step back and let the other pass. Transaction A locks table 1 and waits to access table 2. Transaction B locks table 2 and waits to access table 1. This is just a simple example. So we can see that both the transactions are waiting for each other, neither can proceed, creating a deadlock. So it's very simple. And how we can prevent this deadlock is by locking hierarchies. Always access resources in the same order so that transactions don't block each other. Timeouts. Set a time limit for transaction to wait out for the resources. You can also use deadlock detection and resolution system to detect deadlocks and cancel one transaction and let the other proceed. Now let's move on to a last question on the list, which is difference between in and exist. In basically works on list result set. It doesn't work on subqueries, creating a virtual table with multiple columns. Compares every value in the result list. Performance is comparatively slower for large result set of subquery. Whereas the exist works on virtual tables, it is used with correlated queries, exist comparison when match is found, and the performance is comparatively fast for larger result set of subquery.
So what is Tableau? So before we understand what exactly is Tableau, let us imagine a simple situation. Imagine that you're an office worker and you get some loads of data, maybe like millions of rows or billions of rows, and you are supposed to extract the insights of that particular data. So what do? You basically load that data into a database and try to write the SQL commands and then try to extract the insights of that particular data. So this kind of approach is basically time consuming and you get exhausted. Now, what if you had a tool which could write all the SQL commands for you in the background and all you had to do is just to drag and drop the data? Sounds interesting, right? So Tableau is just the same. All you have to do is just drag and drop the data and it will automatically write all the SQL commands you ever wanted to write on that particular data, and it will give you live data interactions and advices for the future. Now with this, let us understand the definition of Tableau. So basically Tableau is a business and analytical software tool developed in America. Tableau helps people to understand, visualize, and make data-driven decisions in real time with extreme agility and accuracy. Now with this, let us continue with the next topic, which will be about the various versions of Tableau. So at first, we have the Tableau Desktop. So Tableau Desktop is a data visualization application to facilitate you to examine virtually any kind of structured data and generate highly interactive, beautiful graphs, dashboards, and reports within minutes. Once a quick installation, you can tie to virtually any data source from spreadsheets to data warehouses and display information in several graphic perspectives. Designed to be easy to utilize, you'll be working more rapidly than ever before. Next, we have the Tableau Server. It is a business intelligence application that offers browser-based analytics anyone can utilize. It is a rapid-fire alternative to the slow pace of traditional business intelligence software. It is an online solution meant for sharing, distributing, and collaborating on content created in Tableau. What makes Tableau different? It is proposed to everyone. There is no scripting required, so everyone can grow to be an analytics expert. You can grow your deployment as you require it. Train online for free, find answers in minutes and not in months. That's the speciality of Tableau. Now followed by the Tableau Server, we have Tableau Online. So Tableau Online is a business intelligence application that offers browser-based analytics anyone can utilize. As discussed before, it is a rapid-fire alternative to slow-paced traditional business intelligence software. So Tableau Online is a secure cloud-based solution for sharing and collaborating on Tableau views and dashboards. Next up, we have the Tableau Public. So now I want to give you guys a serious heads up if you're a beginner in Tableau. Tableau Public is like an open source. Whatever the data you choose to work on, using Tableau Public, it goes to public. So kind of like Tableau Public is not preferable if you want to work on your company's sensitive and confidential data. Tableau Public is a free software to facilitate anyone to get connected to a spreadsheet or a file and create interactive data visualizations for the web. It is delivered as a service that permits the user to be up to and running overnight. With Tableau Public, users can construct amazing interactive visuals and publish them quickly without the help of programmers or IT. It is designed for organizations to facilitate their websites with interactive data visualizations. There are higher limits on the size of data you can work with, and among other features, you can keep your underlying data hidden. And lastly, we have Tableau Reader. Tableau Reader is a free desktop application that you can use to open and interact with data visualizations built in Tableau Desktop. With Tableau Reader, you can filter, drill down, and discover humongous loads of data. Now moving ahead, we have the features of Tableau. So these are the few important features that you might want to consider. Those are the first one, robust security. Tableau takes special care of data and user security. It has a foolproof security-based authentication and permission systems for data connections and users access. Tableau also gives you the freedom to integrate with other security protocols such as Active Directory, Kerberos, etc. An important point to note here is that the Tableau practices low-level filtering, which helps in keeping the data secure. Followed by that, we have the collaboration and sharing feature. Tableau provides convenient options to collaborate with other users and instantly share data in the form of visualizations, sheets, dashboards, etc. in real time. It allows you to securely share data from various data sources such as on-premise, on-cloud, hybrid, etc. Instant and easy collaboration and data sharing helps in getting quick reviews or feedback on data, leading to a better overall analysis of it. Another extremely useful feature of Tableau is the use of time series and forecasting. Easy creation of trend lines and forecasting is possible due to Tableau's powerful backend and dynamic frontend. You can easily get data predictions such as a forecast or a trend line by simply selecting some options and drag and drop operations using your concerned fields. Next up, we have live and in-memory data. Tableau ensures connectivity with both live data sources and data extraction from external sources as in-memory data. This gives the user the flexibility to use the data from more than one type of data source without any restrictions. You can use data directly from data source by establishing live data connections, or keep that data in memory by extracting data from a data source as per their requirement. Tableau provides additional features to support data connectivity such as an automatic extract refreshes, notifying the user upon live connection fail, etc. Next, we have informative view and even the mobile view. One of the key features of Tableau, and the one that got its popularity, is its wide range of visualizations. In Tableau, you can make visualizations such as bar chart, pie chart, Gantt chart, bullet chart, motion chart, tree map, box plot, and many more. Like you name it, Tableau got it. You can select and create any kind of visualizations easily by selecting the visualization type from the Show Me tab. Apart from that, it is capable to represent data in mobile view as well. Tableau acknowledges the importance of mobile phones in today's world and provides the mobile versions of Tableau app. The next and the last feature is that being capable of accessing data from various kinds of data sources. Tableau offers a wide range of data source options where you can get connected and fetch data from data sources ranging from on-premise files, spreadsheets, relational databases, non-relational databases, online cloud data, data warehouses, and many more. So followed by the features, now we'll discuss about the advantages of Tableau. So following are the advantages of using Tableau. First one, it has remarkable visualization capabilities. Of course, the unparalleled capabilities of visualizing information is on top of the list of Tableau's software benefits. Followed by that, we have the ease of use. The tool's intuitive manner of creating graphics and a user-friendly interface allows non-developers to utilize the basic app's functionalities to the fullest. Users arrange raw data into catchy diagrams in a drag-and-drop way, which facilitates information analyzing and eliminates the need for the help of IT department and pattern building. Next, high performance. Apart from its high visualization functionality, users rates its overall performance as robust and reliable. The tool also operates fast on big data, which makes it powerful performance on an important point on the list of the advantages of Tableau. And next is the mobile friendliness. One of our best advantages out of the Tableau benefits is its efficient mobile application, which is available for both iOS and Android. It adds mobility to Tableau users and allows them to keep statistics at their fingertips, as well as supports their functionality that desktop and online versions have. And finally, we have the thriving community and forum. Tableau has a rich community. The number of Tableau fans who invest their expertise and skills in the community is increasing rapidly. Business users can beef up their knowledge on data processing and reporting and get many useful insights in this community. Also, forum visitors are ready to help settle any user issues and also share their experience. Next up, we have the disadvantages of Tableau. The first major disadvantage is the high cost. The Tableau is not the most expensive visualization software, especially compared to such business intelligence giants such as Oracle's and IBM solutions. All the same, the license is quite costly for small and medium companies, which makes it one of the considerable Tableau's disadvantages. Next is the inflexible pricing. Tableau's sales team is not flexible enough to provide case-by-case approach for their customers, ignoring the fact that each company has its own unique requirements for visualization tool package. The Tableau sales model requires clients to purchase and extend license from the start. As a result, a lot of companies that use Tableau arrive at the conclusion that they don't need all their license features. They would prefer to buying a set of requirements and scale them if necessary. Followed by that, the next disadvantage is poor after-sales support. On multiple message boards, users complain that Tableau software lacks proper after-sales maintenance. If customer has software performance problem, the support team does not settle the matter by investigating the problem's root and eliminating it. Next, we have the poor BI capability or the poor business intelligence capability. As previously mentioned, the tool provides best-in-class information visual interpretation. However, it lacks the functionality required for a fully fledged business intelligence tool such as large-scale reporting, the building of data tables, and statistic layouts. And lastly, the poor versioning. Only the recent Tableau versions support revision history, while for the older ones, software rolling back is impossible. Now, with the advantages and disadvantages discussed, let's move into the top companies hiring. The companies which are desperately looking for Tableau experts are Accenture, EY, PepsiCo, Deloitte, Wells Fargo, Capgemini, and many more. Now let's discuss the humongous and handsome salaries offered by these tech giants. So according to Glassdoor, the average salary of a Tableau expert in America is 82,000 grants, and for a beginner it is somewhere around $60,000 per annum, and at the highest rate it is $110,000 per annum. Similarly, the average salary of a Tableau expert in India is 5,06,000 per annum, and for a beginner it is somewhere around 3,60,000, and for a highly skilled, experienced Tableau expert, the salaries range from 8,75,000 per annum.
Here's a story about these two gentlemen talking about Tableau. The first gentleman comments on how the IPL Cricket League was very entertaining this year and how he believes that De Villiers scored the maximum runs. But the second gentleman says he has stats which shows that Kohli outperformed this time. How did you come up with these stats? There's a tool that helps visualize data by creating interactive charts and graphs. It's basically a business intelligence tool used by many organizations for visual data analysis. Tableau helps us gain insights by visualizing the data that you already have. So Tableau is important when it comes to visualization. It has many advantages. First, it has speed of analysis, so you can get into your data and start analyzing it very quickly. Second, it helps users be self-reliant and not rely on very difficult analytics tools to start digging into their data. Third, it allows you to do visual discovery, so as you're building, you can learn information and insights about your data. 4, you can use it to blend diverse data sets. And 5, you can use the data sets that are centralized, so after you've put together a data set, you can publish it out and more people can use it than just you. That sounds interesting. How about we visually show the stats of IPL? So first, we'll look at connecting to data. This will be the first step in Tableau. So if you've opened up your workbook and you see this page, you can click here, connect to data, and we're going to choose a text file. and we're going to join our deliveries data to our matches data. So when we click deliveries, it brought in deliveries, and we can click add and bring in another text file called matches. Next, we'll talk about joins. We will make use of joins when we have multiple data sets to work with. Suppose we want to join these two data sets, one of which has a team ID and what city that team is in. The other one has a team ID and tells you the name of the team. There are 4 ways to join data sets. An inner join, the resulting table contains values that have matches in both tables. So we can see here that we have Delhi and the Delhi Daredevils. We also have Chennai and the Chennai Super Kings. We have Bangalore, and then we have this team that doesn't exist in Bangalore. And so, since these two don't match, since we have 2, 2, 3, 3, but then we have 4 and 6, these two don't exist in our resulting table because they don't have matches in both tables. In a left join, resulting table contains all values from the left table and the corresponding matches from the right table. So we have Delhi, Chennai, and Bangalore, and then we have their matches. However, Bangalore does not have a match, so it is left null. In a right join, we have the opposite. The resulting table contains all matches from the right table and the corresponding matches from the left table. So we have the Daredevils, the Super King, and then we have King Punjab, and they all exist. However, number 6 does not have a corresponding city, and so that's left null. And in a full outer join, the resulting table contains all values from both tables. So we still have Delhi and Chennai, and we have Bangalore, and we have the Kings, but their corresponding nulls exist as well. So since this one doesn't have a match, it still shows up, but you get a null, and then this one doesn't have a match, it also still shows up, and you get a null. Now it's going to allow us to join our 2 different data files together. So we have to decide which field to join on. In this case, it is match ID. And then on the matches, it's just called ID. And that is ID. We'll do an inner join that will select only the records that match between the 2 fields. So it's given us some sample data underneath from our 2 things. And we look at match ID here, and where it's 1 here, we'll scroll over and see that it's 1 here for ID. If we scroll down and find a different number, so here we have 2 for ID, and we scroll over and match ID is now 2. And we have our join in place. Dimensions and measures. Dimensions are qualitative fields that cannot be aggregated. For example, batsman and batting team, etc. However, measures are numerical values that mathematical functions can work on, like batsman runs and extras. So for the case of batsman runs, you can sum up all of the runs for an entire game, or that took place in a city, or for an individual batsman, and that's how you can tell that it works with a mathematical function. Now we'll move on to the last part of dashboard designing. So we can move on to sheet 1. It will take a second and load our query. And now we have the worksheet space, and this is where we can build our visualization. This is called a worksheet. You can also build a dashboard, which is where you can put multiple worksheets together. And you can build what's called a story, which is where you can take worksheets and dashboards and put them in an order to tell a story. So on our worksheet, we'll have this space here in the middle, which is where you can build the visualization. You have columns and rows where you can drag on your data, which is here on the left. Here's our data, dimensions on top, measures on bottom. We'll talk a little bit more about that in a second. We have columns and rows where you can drag your information, and it defines where the columns go, or where the data goes to define the columns, and where the data goes to define the rows. We have places here, these are our cards, and when you drag things onto these different cards, it will do different things to your visualization. And let's talk about our dimensions and measures. So Tableau will take its best guess at what your data is. So it's guessed that all of these blue fields on the top are dimensions, And dimensions are qualitative data, so data that defines and describes the rest of your data. And so usually it can be things like city, so you can say here's a city, and then we can look at our different measures by the city that it took place in. For example, with financial data, you could pull on city and you could look at sales by city, and city is the dimension, which is a quality. And then sales would be a measure, which is something that is quantitative and it is able to be aggregated. Whereas dimensions are not things you would like to aggregate. So some things can be a number, but they're still not a measure, such as a phone number. Nobody is going to want to sum up different people's phone numbers and see what the sum of the phone number is. However, you might want to look at a customer and see their phone number, and it puts it up in the dimension area. Another thing that Tableau does in this case, by default, it will make little folders for your different data sources. So we have our deliveries data source and our matches data source. If we go back to our data source section, that corresponds to our two different files. You can also look at these sample fields here, and the part where it's blue at the top represents the blue table. And if we keep dragging, we'll see the orange coming in, which represents the orange table. So here we are back at sheet 1. And let's start building our first visualization. I'm going to right click here, click rename, and we're going to call it matches in each venue. So we're going to start off by making a map. Tableau has recognized the word city here and put this little globe next to it, meaning that it has recognized it as having the geographic role of city. So if I double click on it, it maps out some cities. Now it's having a hard time mapping the cities, so we're going to click edit location, and it doesn't recognize these places, or it could exist in multiple places because it's defaulted the country to the United States. So if we change that defaulted country to India, then we have much fewer unknown fields. So we're going to focus on India and not look at these other locations because some of these are not in India, but we're going to make this visualization for India specifically. If you wanted to show what countries they were in, you can define from what field you can find the country information. So if we had two fields in here, one was city and one was country, that told you what country it was, then you would choose this from field and you'd choose that country dimension, and that would fix our problem, assuming things were spelled right and put in the right countries. In this case, we don't have country, so we have defined India, and that's where we're going to focus. Next, we're going to bring city onto color as well. And now they each have their own colors, and here's our legend. And we want these to have a different size based on how many matches they've had. So we're going to bring on ID onto size. And we wanted to actually count those IDs. So we changed it to account distinct. And now you can see the littlest ones have around 2, and then as they get bigger, this size is 20 and this size is 85. And when you hover, you can see exactly how many they have. You can adjust the size using this size marks card. Make our circles a little bit bigger. We can adjust our color by adding a border, maybe like a black border, but then changing the opacity so we can see through it a little bit for those that go over borders and start to overlap. And if we wanted to see the exact number without having to hover, we could take this ID onto label, and again, change it to count distinct. There we go. And now you can see exactly how many there are in each location. You can change where the labels show up by adjusting the alignment. So we could have it in the center, and it kind of shows up inside their circles, but that's kind of hard to read in these smaller circles. So we could define that we always want it at the top, or something like that. We could also have it say the city name. So if I drag city on the label, now it shows 9 and then the city. But if I want to change the order of that, see how it does the count and then the city? I could drag. So you saw right inside of here we have 2 that are on label, so they have this little T inside of a box. And now city is on top of count of ID. So city and then count. We could also allow people to filter. So if we click show filter here, and if we just want to look, it'll zoom in on the countries you select. So if we just wanted to look at a couple of them, then we could select individual ones. Or if we wanted to exclude certain ones, then we can make it easy to exclude. Great, so now we have our visualization for matches in each venue. Next, we're going to make another worksheet by clicking down here, and we're going to name this one Top Run Scorers. And this will allow us to be able to find who scores the top runs. So we're going to make a visualization called a tree map using this Show Me button. We haven't explored Show Me yet. Show Me will show you what visualizations you can build based on what you've selected over here. So when we selected city, it shows us that we can make maps using city. What we're going to do is look at city, and I'm going to hold Control and click Batsman, and I'm going to hold Control and click Batsman Run. And now you can see that tree map is filled in and not grayed out anymore, so we can select that. And it is showing us what batsmen have the most runs. We want the color to be based on city, so let's drag city onto color. And now we can see that it's separated out by city. And you can see that the person at the very top right with the biggest square has the most runs. But then you also get a second benefit of being able to know which city seems to have the most runs associated with it. So it looks like Mumbai has the most runs. Let's also filter this information. So let's bring on batsman runs, and then we can choose sum. And let's filter out batsmen who didn't get a total of 400 runs. There we go. So now we only see batsmen and cities that have a sum bigger than 400 runs. Okay, so we have city on label, but maybe we just want to be able to see that on hover. So we'll take city off of label, and now we just see the batsmen who have the highest runs for each city. And we'll also bring on the number of runs onto label. So now we can see the batsmen and their runs and exactly how many runs they have. You can always get to how many they have based on hover. We'll go on to our next visualization, and that's going to be win percent based on toss decision. So we're going to see which decision you make based on the toss leads to a win more often. So you can choose to bat or you can choose to field. And if you choose to bat, do you win more than if you choose to field? So let's take a look. We have our toss decision, and we also have if they won the match or not, match winner. And I'm going to control click toss decision, and we're going to select pie. So here we have a pie chart that colors it based on toss decision, which is bat and field, and makes the angle and the size of the circle based on the match winners. Now we're only going to have the angle be based on match winner or not, and then we can define the size ourselves so we can make it bigger. I'm going to change this visualization to fit the entire view so that we can see the pie better. Great, but we don't see a percentage. So let's change this sum of match winners to a table calculation. So we're going to click Add Table Calculation, and we're going to change it to percent of total. We'll close that. So now when we hover, it says 60% of the matches were won by the people who chose filled, and 39% were won by the people who chose bat. Let's make this into a label as well. So I'm going to control drag toss decision onto label, and what that does is make a copy and add it to label instead of pulling it off of color. So let's see what happens if I don't hold control. So if I just drag toss decision on the label, it got rid of it off of color and just put it on the label, and that's confusing. There's two pieces, but they don't look any different. So control drag fixes that. We'll do the same thing for that match percent of total that we made, match win percent of total. One of the benefits of having these labels here is that it allows you to be able to use this visualization even if you take a screenshot and send it to somebody and they can't hover over the top and see what everything means. Another thing you can do is annotate it, and so we can click annotate the point or the mark, and it will give you this box, and then it will put in some information that's showing up in your tooltip, and you can modify this, and we could change this so it's not bold anymore or leave it bold. And when you hit OK, it makes this box that you can move. Tells you information about that point or that mark. We can do the same thing here. It draws a line. And this allows you to put notes about it. You can see that these parts are dynamic, so it just fills in toss decision based on your field from over here, and it will change if it changes. So will the percent match winner. So for example, this is for everybody over all time, but if we show a filter for city, it adds it to our filters card up here, and then we could filter it to just this city, and you can see that they have updated. And in this city, they have more people who have chosen to bat win the game. And so you don't end up with old static information in either place. But if you did want to make a note manually about what you think is happening here, then you can do that as well. We could also do the same thing with date. And now you could choose just what year you want to see, so just 2017. And in 2017, the field advantage was a lot higher. And here's 2016. And that's all time. Our next visualization is going to explore the idea of if you win the toss, how likely you are to win the game. So we're going to look at historical data and see what's happened in the past. So we're going to call this advantage of toss winning. So we're going to bring on all of the toss winning teams, And we're going to also bring on all of the teams that actually won. So, how it works is we can see all of the teams, and then you can see if they won or not. So, we're going to quickly make a couple of changes to this. The first one is this team changed its name to this team name, so we're going to group those two teams into the same group so that they are treated like just one. And we're going to create a group based off of winner. And we're going to grab the two team names by control clicking and click group, and it puts them together. Let's replace winner with our winner group. There we go. So now you can see those two teams are together. Do the same thing with toss winner. Create group. One disadvantage to creating a group is that it's very manual. And so you have to manually create the group and you have to manually update it. So if they change their name again, you have to change it again. And it's nice to have the functionality in Tableau to make those changes in case you don't have the functionality to make the changes to the data source itself. But do keep in mind that if you have to manually group things together, you have to manually keep it updated as well. Next, we're going to exclude some data. So we have this null here that we'll just click exclude on, because that would be perhaps when a winner was not declared. And we're going to remove some of these teams that have holes in their analysis. And that could happen because they didn't play all of the teams, or so there was never a match with that team. And so here, for example, they played and they could have won, or this team could have won, this team could have won, or this team could have won. But these other teams don't seem to have any matches against them. So we can come across here for the winners, and I'll control click the teams that we're excluding, and then we'll just come over here to exclude, and you can exclude a bunch at a time. It just adds it to the filters right here. So if I right click on edit filter, you can see all of the teams we've excluded. And then we'll do the same thing on the toss winners. And we'll control click and exclude. And now we are left with all of the teams that seem to have available data between them. And now we want to see, of these toss winners, who won the game. So we're going to count all of the matches, and that will give us the information we need. So I'm going to grab ID and put it onto text. Now what it's doing is giving me all of the IDs. So I've got to right click on it and change it to a measure, and change it to count distinct. And now it will show you how many matches fit these categories. So for this team, if they won, when this team wins the toss, then this team usually wins, which is the same team. So I'm going to widen this out so we can see the names better. So when the Super Kings win the toss, the Super Kings won the game 42 times. Let's right click here, and we're going to change it to a table calculation again for % of total. And what that is saying is that of all of the games where the Super Kings won the toss, they also won the game 64% of the time. Now, you can read this with the numbers fairly easily, but it'll be a lot easier if we can also show it in color. So I'm going to change the marks to square. And I'm going to control drag this onto color. And now we have what's called a heat map. And the color is stronger where the percentage is higher. You can see our range over here. So you can see there's a pretty clear advantage to the person who wins the toss. They tend to be the one that wins the game. When the Daredevils win the toss, the person who wins the game the most is the Daredevils. Let's take this visualization and use it to analyze a different feature of the game. So I'm going to right-click on the worksheet and I'm going to click Duplicate. So now we have the same visualization twice. And I will rename it to be called Batting First Advantage. So here, instead of Toss Winner, we're going to bring on Batting Team. But let's first create a group again. So we're going to, don't be confused by Group By, that's not the same thing. We'll go to Create and click Group. We're going to put together, Control-click the team names that have merged. Okay. And let's drag. You see how it's not up here right next to Batting Team? That's because they put the calculated fields that we've been making outside of the folders. So if you're looking for a calculated field, you can scroll down to the very bottom. And let's drag Batting Group right over top of Toss Winner. And it will replace it right out of there. And we have our gaps again, because the toss winners that we excluded only applied to that toss winner, so I can pull off this toss winner filter. We don't need it anymore. And then we will Control-click on the ones with the gaps that we wanted to remove. Click Exclude. Okay. And now we have an analysis showing how the batting team does. In our next visualization, we're going to explore who the leading batsman is. And this could allow you to find out who's the best if you were in charge of putting together your team. So we can take all of the batsmen and put it on row. So now we have a list of every batsman. And we can bring batsman runs onto columns, and it will sum up all of their runs. Now what we can do is sort it from biggest to smallest, and we can see who are our top batsmen. We can bring batsmen onto color, so I'm control dragging again. And then they each get their own color. One nice thing that you could do here is filter it by the team. So here we have like team 1 and team 2, but what we would be doing is filtering it on batting team. So we're going to click show filter. And so if you wanted to see, well, like this is the best overall, but let's see who was the best to ever work for this team. And then it will sort it from best down. And you can switch the team. And if we choose this one, we should choose this one as well. And then we can see who's the best. Another thing that could be really useful is seeing who's the best by year. So we can come here to date and click show filter. And now we can see this is the best overall of these years. But if we just want to see most recently who's the best, that's a very different story. So filters can be very handy for looking at a bar chart here and getting the exact information you want. We could also maybe just look at the top 5 batsmen. So what we'll do is we'll drag batsmen onto filters, and we'll create a conditional filter based on top here by field. So we'll say top 10. We wanted to look at the top 5, so we'll change that to 5. And we're looking at the top 5 batsmen based on the sum of their runs. So you could choose something else to filter it by, but we want it to be based on their runs. And we hit apply. And there we go, we just see the top 5. And again, if you just want to see the top 5 for 2017, here's the top 5 for 2017. Maybe 2016 and 2017 together, those are your top 5. Now, if we wanted to be able to change how many we see, as the developer, we could go in and change it here. But if we wanted our end user to be able to change it, then they can't, because when this is published, you can't change your filters. You can't change the filters that are the top conditional filters. We can change these filters that we show on the report called quick filters, but not this guy. We can see now that it's choosing top 5, but we can't select it. How many? So let's get rid of that card. And let's make a parameter that will allow them to select it. So create a parameter, and we're going to call this top n. We're going to make it an integer, and it's going to be a range. We'll let them choose between 5 and 30, and they can go up and down by 5. We'll click OK. So now we have here at the very bottom parameters, and we can right click on it and click show parameter control, and now we have this parameter over here called top n. It's set to 5, and then if I change it to 10, nothing's happening. And that's because we made the parameter, but we haven't put it anywhere in this sheet. So we're going to put it right inside of this filter. So you come here, and we want to choose top how many? You can do it based on a parameter, and we'll do it based on our top n parameter. Okay, so now when we change it from 5 to 10, the parameter updates the filter. So in presentation mode, the user can come in and choose how many they want to see. Now we've only let them go up to 30, but that's to your discretion. You could have this parameter do whatever you need. So we could say they can go up to 100, and that changes our parameter. Now we have all these little marks in between, and here I chose 80, 55, or you could even make it so that they don't have a step size. They just have a range, and then they have just this little slider, and it could be any number in between, but not lower than 5 and not bigger than 100. Let's remove this filter, and we will also hide this card because we won't give them the option to choose how many they want to see in this case. We'll just show them all. So for this next visualization, we're going to look at our top 5, and we're going to see how they do over time. So again, we're going to start on by bringing on our batsmen, but we only want to see our top 5. So let's bring batsmen on the filters, and we'll do what I just showed with top 5. Now, since we don't have anything else on this visualization, it's not sure how to define the top 5. So we're going to do it with batsman runs, and we're going to have the sum of the batsman runs. So top 5 players over all time that have the highest sum of batsman runs. Highest sum of runs. So here we have them. And we're going to bring on their runs, and we'll sort them biggest to smallest. And next we're going to bring on a time element so we can see it over time. So I'm going to drag date over here. And now it's doing a line chart for with a dot for every year. And I'm going to change year from the discrete year to the continuous year so that it's an axis down here. And now we can see that over time. We can bring batsmen onto color so we can see the different color for each batsman. And here's how they're trending. And then we'll also bring the batsman runs onto label. And now you can see how many runs they had. Next, we're going to take a look at finding out who our leading bowlers are. So let's bring all of our bowlers onto a visualization. One way to look at this would maybe be to see which bowlers have the least runs associated with them. So we can bring the runs up here and then sort it smallest to biggest. However, they could have very few runs associated with them because they don't bowl very often. So let's bring on match ID and change it to be a measure that is a count of match IDs. And we can see that a lot of these with the least amount of runs also have the least amount of matches. So it's not a very good indicator. We have here what's called a dismissal kind. And you can see the reasons that the batsman was dismissed. And one of them is hit wicket. So you can see any of the bowlers that hit the wicket. So let's bring dismissal kind onto filters, and we'll just look at those that hit the wicket. So we have these ones that have hit the wicket, and let's see how many times they did that. So we'll actually bring on down here number of records, and we'll sort it biggest to smallest. So now we can see that this bowler has hit it twice in our limited set of data. If we include all of the dismissal kinds, except for null, so this means that they were dismissed for any of these reasons, we can see which bowlers had the most dismissals. And let's bring bowler onto color. Great, and we'll rename it. To leading bowler. And we're going to do a similar thing as we did with top 5 batsmen with bowlers. So we could start with this visualization and replace by right-clicking and click duplicate. Let's bring it to the end. And now, instead of top 5 batsmen, we can change it to bowlers. But first, let's bring in our dismissal kind and only choose the ones. So here we can click exclude, and we're going to exclude null and hit apply. So we don't have the nulls anymore, we just have the ones that were dismissed. And we're going to bring in the bowler on top of the filters, and we're going to have it be based on the top count of dismissal kind. Top 5. Great. And we'll put bowler over top of batsman. And we'll take out the sum of batsman runs. And put on our number of records. And batsman didn't get removed when I pulled bowler on top of it, so I must have accidentally pulled it in front of it. There we go, batsman's gone. Now here's a disadvantage to making a copy and then changing it, because it's like, what's happening here? But it's because batsman is still on color and sum of batsman is still on runs. So let's take number of records and put it onto runs, onto the text. And then let's take bowler and put it onto color. That clears things up quite a bit. So now we can see the bowlers over time. If we take year of date off, we can see which ones are the best overall, and we'll sort it. There we go. And then we'll put year back on by dragging date up here, right-clicking and changing it to a continuous. There we go. So now we have our top 5, and we need to rename this to top 5 bowlers. Okay. So now we have all these visualizations, and we can start putting them together into dashboards. So let's make our first dashboard. We're going to have the size be automatic, so it fills the screen here. You have some options with the different sizes. You can have it be a fixed size, or you can define the width and the height. You could also define the width and the height based on some of these presets, like a desktop browser or a laptop browser. You could have it be automatic, so it fills the space. Now this will have it fill the space on any screen, so if they're looking at a much smaller resolution, then it'll try to squish all of your visualizations into one size. So I don't recommend automatic for a lot of visualizations, because you need to have extra space or if you define this should be here and this should be over here, then it will all squish it all together. There's also a range where it's sort of like it's automatic and it will adjust based on what screen you're looking at it. However, there is a minimum size, and it will never be smaller than that, and a maximum size, and it will never be bigger than that. So it won't stretch or shrink your stuff too far before adding scroll bars. So here we have automatic and our first dashboard. So we're going to rename our dashboard. We're going to call it overall performance. Oh, the first one we're going to make is going to be looking at venue and run scored. Great. So this is our dashboard space. So it says drop sheets here. And then these are our dashboards. And we have other objects down here that you can also bring on. And then over here we have layout, which after you have brought things on, you can change their layout here. And it will show your item hierarchy based on how they're nested down here. So on our dashboard, we will first bring in our matches. And we will bring in our top scorers. And we have all these different places for matches, and we have our different cities for our top scorers. And so if we go back to this sheet, top run scorer, we can do that in 3 ways. We can come down and find the right sheet and click on it to go to that sheet. We can look at our visualization and click this go to sheet, and it will take us to that sheet. We'll go back. Or we can come over here to our sheets and click go to sheet, and it will take us to that sheet. So let's take our filters off of the sum of runs so that we're showing all runs for all cities. You know what? Instead, let's just edit it so it's filtering out only those that never scored more than, say, 100. Okay, so we have a lot more in here, but it will filter out some of the lowest ones. And we'll go back to our dashboard. And now there's one thing you can do, which is called an action. And so we can click use as filter. And now when we click on a city over here, it will filter the remaining sheets on this dashboard to what you've selected. So we can see how many matches have been done in different cities. And if we want to see, well, who are our best players in Mumbai, it will filter down to the top run scorer. So that's called an action. So let's get rid of that, and we'll look at doing it manually as well. So here under dashboard, we have our actions, and you can see there are no actions in here. But then when I come and click use as filter, then we go to dashboard and actions, and now we have an action called filter 1 generated. And what that has done is made an action based off of the matches in each venue sheet, and it affects the other sheet on select, and when you unselect, see it says clearing the selection will show all values, and it's doing it based on all fields. Okay, so if we wanted to make a different action, which is a URL action, on these 2 sheets, when you select, it'll take you to this website. So this is the Wikipedia beginning page. But let's say we wanted to take you to a specific Wikipedia page. In Wikipedia, if you append on the name of the Wikipedia page to the end of this URL, it will take you straight to that page. And we're going to assume that there's a Wikipedia page for all these different cities. So we have city put in there. And if we hit OK, and now when we click on a city, then it will bring up the Wikipedia page for that city. So if we come back and we unselect that, and then we come over here and we pick a different city, it'll do the same thing and bring up that Wikipedia page. So right now it's if you click on either chart, it will bring up the Wikipedia page. We can edit that by maybe changing it so that it's only when you pick it in the top scorer chart. So when you select something over here, it filters the top scorer chart, but when you select on something in the top scorer chart, it brings up that city. And that's just an example. And now it's bringing up that page on a separate screen. So there we go. Now we're back. Okay. And some more things that we can do is we'll get rid of this visualization that is a legend for how big the circles are and what that means, because we have the labels right over top of the circles, so we don't need a legend for that. We'll close that. We have the capability of filtering on city right now, but when we do filter on city, it's only affecting this visualization and not this visualization. So we can change that by hovering over Apply to Worksheets and then changing it to Selected Worksheets and clicking All on the dashboard. And when I click Show All Worksheets in the workbook, you can see the rest of the worksheets that are not on the dashboard are not affected. Unselect, okay. And now when I filter these, it does it in both places. Another thing we can do to make this look a little nicer is make this a multiple values drop down. So now it's in a drop down form. We can also a horizontal object up here and put city up inside of there as kind of like a header. But we can have some more filters. So if we wanted to be able to filter by the date, we can put the date on filter there. We'll click Use All for now. Let's go back to our visualization. We'll click on the visualization we added it to and hover over Filters. And look, you can add year of date. Here it is. Let's put it up next to city. And we'll also change it to a multiple value drop-down list. And we'll also have it apply to selected workbooks all on dashboard. Okay. So now we can see the different years. If we only wanted to see maybe 2017, they both apply. Or they apply to both visualizations there. And we can have those. And we can add a blank object over here on the other side of city so that it doesn't take up quite as much space. We could put a text object up here too with the name of maybe the whole workbook or the sheet. There it is. But if we want to edit it, then we can make it bold and we can make it big. And those are some of the things we can do to update all of our different dashboard things. Our next dashboard is the one that's going to be about overall performance. We're going to change it to automatic again. And we're going to bring in information about performance. So we'll bring in the leading batsman and our leading bowler. Our top 5 bowlers will go underneath the bowler information, and our top 5 batsmen will go underneath the batsman information. You can see that any filters we had or any different legends we had are showing up here. We don't need these legends because we have the names right next to them. So let's get rid of those. When I clicked on the bowler in that last visualization, or in the last legend, it highlighted that particular bowler. So I had to unselect it before I closed it out. Okay, and then we had batting teams filter here, which we will not use. But we will use this year filter, and now if I change it, it will only affect this visualization, but I want it to affect all. So again, this is just a good habit to have, to make sure all of your filters affect everything on the dashboard that you want it to affect, and that it's very clear which ones it's affecting. Let's give it some space. We can move this whole piece to along the top here. It doesn't need that much space. And we'll change this to be a drop-down filter. And it doesn't need all of the space, so we can add some blank to either side and have it a little bit more in the middle here. So now we just want to look at 2017. We can see our leading batsmen and our leading bowlers, but then you can't see it over time anymore. So let's change our minds, and maybe we only wanted to apply to worksheets, these two worksheets, because we want these worksheets to still show it over time. So if we click selected worksheets and we remove our top five, now we can see that these worksheets update and these ones do not. But one thing to keep in mind is that these are the top 5 over all time, whereas these 1, 2, 3, 4, 5 are the top 5 for this year. And so these top 5 are not the same people, you can see, as these top 5. Well, this one is. And this one is. But it's going to change. And so that's the point, is that it's important to recognize that these top 5 could update to just the top 5 for the year we selected if we still had it applying to these worksheets. So it's just your call. Information over time, when filtered to just one period, can be not very useful. So our next dashboard is going to be about advantage. And we're just going to make it so that we can see the advantage of the toss and the advantage of batting just side by side. So let's add a blank up here, blank down here. And it just gives you a visualization where you can see the advantage of winning the toss and the advantage of batting first. One thing that we're seeing here is that we're getting a scroll bar because it's too wide to fit in the selected area. So we could change the visualization to fit width, and then it will make this shrink to fit inside the area instead of giving us a scroll bar. We'll do the same thing here, fit width. If we change it to entire view, then it will also change the height to fill this area. Entire view. There we go. So as a recap, we have looked at different ways to look at data so that you can use it to help you in your decisions. You can use it to find out who are your top scorers in which cities. You can use it to figure out who is the advantage. You can use it to help you figure out if you should choose to go to the field or to bat. You can find your leading batsman and who should be worth more to try to get them on your team. Same with bowler. And you can put them together into dashboards that are interactive, even out to websites. Today we're going to talk about building dashboards in Tableau based on cricket data from the Indian Premier League. Please comment below for access to this dataset, and somebody from the Simplilearn team will get back to you, and then you can follow along. If you have any questions about creating a data source off of a text data set, then go ahead and comment below or check out tutorial part 1 in which we go over that information. So we're going to get started, and in this visualization we're going to look at batsman information. So let me rename the sheet, and I'm going to call it all innings score. And so by the end of this, we're going to have 2 visualizations, 2 dashboards. One of them focuses on batsmen and one of them focuses on bowlers. Some of the use cases behind this is if you are trying to figure out who did the best of the batsmen and who did the best of the bowlers, for if you were trying to put together a team. So let's get started. We're going to look at batsmen. And here we have listed out all the batsmen. We're going to make this visualization so that you can look at just one batsman at a time. So I'm going to right click on batsman and click show filter. And now we have a filter over here with all of our batsmen, and we can choose just one or all of them. Let's just look at one for now. And then we're also going to look at their information across all of their matches. So we're going to bring on match ID. And now we have all of the matches for this batsman. Now we have quite a few matches, so we're going to allow them to filter to just one season, 1 year. So if I right click on date and click show filter, it gives me this automatic year filter. So we'll just filter to maybe 2014. And now we have all of those matches for 1 year for one batsman. And we want to look at the runs for this batsman. So we'll pull runs out here onto rows, and it now gives us bars for all of those rows. If we were looking at multiple batsmen, so I select all here, it'll section them out by their names, but it's a little bit difficult to tell where one batsman ends and one begins. Sometimes it's not that visually easy, even though there are lines, so we could make those lines darker, or another thing we could do is take batsman and pull it onto color, and now each batsman gets their own color, and it's a lot easier to tell the difference. Let's go back to just looking at one batsman. And let's sort the matches from smallest to biggest as in number of runs. So here we have all of the runs for this batsman per match. If we look at multiple batsmen, you can see how he did as opposed to other batsmen. There we go. Let's move on to our next visualization. It's going to be about, I'm going to click on the sheet, click rename, and click type of dismissal. So now we're going to make a chart that shows you for one batsman for 1 year what kinds of dismissals they had. So we want the filters we made on all innings scores over here to also apply to this worksheet. So let's talk about filters a little bit. When we right click on filters, we can hover over apply to worksheets, and we have these options. We have all using related data sources, all using this data source, or only this worksheet. And that's because we haven't built a second worksheet yet. We have another worksheet, but it doesn't have the batsman information on it. Come right click on year, same thing. So when I bring or any information on this worksheet, we just need to have some information on this worksheet for it to start being taken seriously. So I drag dismissal on to color. I go back to this sheet, right click, and now we should have another option. Only this worksheet, selected worksheets, all using this data source, or all using related data source. We're going to use the option selected worksheets. Now why would we use the option selected worksheet instead of all using this data source? This is because we're going to apply these filters to all of the batsman worksheets, but as I mentioned before, we're also going to make visualizations based on the bowlers, and we're not going to use this same filter on the bowlers worksheets. So I'm going to click selected worksheets, choose my worksheet, and hit OK. I'll do the same thing here on year, apply to worksheet, selected worksheet, and do the same thing. Okay, so because of filters and because how you can have different filters per worksheet, or one filter that affects 2 worksheets but not the other worksheets, it's best in my mind to do all of your filters at the end when you're actually building the dashboard, so that you can keep track of what the filter affects and what it doesn't. In this case, for our purposes, we've done it already, so now we're looking at just one batsman, just 1 year, but my preference is to do it at the end. Now we brought on dismissal kind and put it onto color, and I want to make a pie chart, so I'm going to click on marks and change it to pie. And right now there's nothing telling this visualization how big each slice of the pie should be, so you need to drag something onto angle. Let's first make the pie bigger just so that we can see it better. And then let's also remove the dismissal kind of null. So we have null dismissal kind, and that's when the batsman did not get out. However, we're trying to keep track of how many times they did get out, so this isn't relevant. So I right-clicked on null over here and clicked exclude. What that did was made a filter right here on dismissal kind. And we click edit, and you can see it's excluding null. So that's what right-clicking and clicking exclude did. So right now it's doing 50 and 50. It doesn't know how big to make each angle, and we want it to count the dismissal kind, and that's how it'll determine how big to make each angle. So I'm going to drag dismissal kind onto angle, and I get an error. Why would I get an error? I would get an error because it's treating it like a dimension, and a dimension is by definition not something you use to measure things with. And so you can't say this angle should be this big based on a dimension. So we're going to change it to a measure, which is when we're going to count the dimensions. So we're going to do a count of dismissal kind. So if they got out because they were bowled out, then we'll count how many times that happened, and that will determine the red angle or the orange angle. And if it was caught, that will determine the red angle. So count. Great. So now we can see 5 and 6. So for this batsman for this year, he was out 11 times, 5 times because it was caught, 5 times because it was bowled. Let's control and drag dismissal kind onto label. So now we can quickly see the 5 and the 6. And we're going to control drag dismissal kind onto label, and we can see which kind of dismissal it was. That keeps us from having to need this legend. So we can click hide card, and we don't need that anymore. Now we're going to make another pie chart based on runs. So since I'm making a second pie chart, I'm going to duplicate this. There are some pros and cons to duplicating it. One of the pros is when we come up here to filters and we come to selected sheets, we can see that the filters that applied to type of dismissal are automatically applied here onto type of dismissal too. And so that's great news because we do want it to be filtered to just one batsman and just 1 year. However, we don't want it to filter out dismissal kind of null anymore because now we're looking at runs, and runs need to have the times when they didn't get out. So we're going to pull dismissal kind off. And if you weren't paying very close attention or you copied it, then you might be confused as to why things were getting filtered out, but it was because it copied your filters as well. So that's one of the disadvantages of copying. Let's rename it runs distribution. And I'm going to pull off all of this information here so that we're starting from scratch. So here we have basically blank pie chart. And we're going to look at batsman runs. So there are a couple different kinds of runs that you can get. So I want batsman runs to determine color, but when I drag batsman runs onto color, it's doing a sum of batsman runs. And it's just trying to make it darker or lighter depending on how many runs there were. But that's not what I want. I want to use it as a dimension. And now we can see we have 0 through 6. And that means that a batsman either has 0 runs or 1, 2, 4, or 6 runs. Now there is 3 runs as well. However, because we're only selecting 1 year and 1 batsman, this particular batsman for this particular year only had either 0 runs, 1 run, 2, 4, or 6. So when we change it to a dimension, it's now, instead of summing up all of the runs, it is now just showing you their options. But it's still doing it like a scale from light to dark. I want 6 distinct colors, 1 for each. So I'm going to change it from a continuous type of field to a discrete type of field. And now I have 0, 1, 2, 4, and 6. Now I want to exclude 0 runs because I'm not trying to keep track of how many times they didn't get a run. I'm trying to keep track of how many times they got different kinds of runs. So again, let's exclude it. And now we have our 4 different kinds. And just to show this, I right-clicked on year, I click show filter, and if I show all the years, you can see our 5th kind of run where they got 3 runs on 1 ball shows up. So it does exist, it just didn't happen for this particular batter or batsman during that year. Now we want the angle to be determined by batsman runs. However, we don't want to sum up the batsman runs. We don't want to take every time that he got a 6 and do 6 plus 6 plus 6 plus 6. What we want to do is count how many times he got a 6. So we're going to change it from a sum to a count. And you can see he got a 6 24 times. And so before, let's go back, it was taking 24 and timesing it by 6, which is 144, and summing up each of those times. But instead we want to count each of those times and see how many times he got a 6 and how many times he got a 4, not how many points were scored when by getting a 6. So that's a little bit of a confusing thing to think about. Another thing you could do is, instead of doing a count of batsman runs, let's pull that off, you could use this number of records field, and that will show us how many, meaning the number of records, how many records did we have from this batsman in this year that showed that he batted a 6. So drag number of records onto angle, and you see we get the same thing that we had before. So those are 2 ways of doing it. Either change the batsman runs to a count, or grab number of records. Number of records is a little bit simpler. So let's also bring number of records onto the label, and we can see quickly that mostly he got 1s and got more 4s than he got 2s, actually, which might be interesting to people who are trying to see how well this batsman does. Our next visualization has to do with the batsman's strike rate. So we'll make our new sheet, season strike rate, and we'll need to make a calculated field to be able to determine the strike rate for a batsman. So we'll come here to this arrow, click on it, and click create calculated field. We'll call it strike rate, and we're going to find out how many runs that a batsman gets basically for every 100 balls bowled. So we're going to get the total of the runs by doing a sum of batsman runs. We're going to divide it by the number of balls bowled. We know that this data set is 1 row per ball bowled. It's the ball by ball data. So we're just going to divide it by the number of rows, number of records. And we're going to put all of that in parentheses. And one thing I need to do is, instead of just number of records, I need it to be the sum of number of records, so that it adds them all up before it divides it. Okay, so sum of the runs divided by the sum of the bowled balls, and we will multiply that by 100. And that is our strike rate. Okay, so now that we have our strike rate, we can start building our visualization. We would like to have both of these filters, so I'm going to quickly apply it. So first build the visualization and then apply it. We're going to come here and bring date onto columns, and it's giving us 1 per year. We're going to change our marks card. No, let's leave our marks card the way it is. And then we are going to bring on our bowler, and we're going to bring on our strike rate next to bowler. Okay, so now that we have kind of the beginnings of our visualizations, let's go here And we can now apply it to our new worksheet, apply the existing filters. One of the reasons it's so important to apply the existing filters to our worksheet. There we go. Now we can quickly see his strike rate for 2014. I'm going to control drag strike rate onto label, and we have it there as well. Okay, one of the reasons it's so important to use the same filter that is applied to all of these selected worksheets, instead of just bringing batsman back on and making our new filter each time, is we want on the dashboard to just have one filter that applies to all of them. So you can see here when I change this to 2015 and remove 2014, and then we go to season strike rate, we can see this one's also 2015 now. And we'll go back to 2014, season strike rate, and this one's also 2014. So we want, whenever a filter is changed, for it to affect all of the visualizations associated with our dashboard. And so all of our visualizations that are about batsmen and their information, we want to be able to use the same filters. So I'm going to click Show Filter quickly, and we're going to see what happens to this dot when I add more years. So this is going to allow them to see the strike rate per 100 balls over time if they select more periods. Our next visualization is going to be called Team versus Player. And we're going to see how many runs a batsman scores against particular teams. So we're going to bring on bowling team, because that's the team the batsman is against. We're going to bring on batsmen and their batsman run. So now we can see how many runs each batsman scored against all of these different teams. And again, we're going to apply our filters. There we go. Let's also bring batsmen onto color again, just for when we're looking at multiple batsmen at once in our filters. And we're going to bring the batsman runs onto label. There we go. So now we can have it in both places instead of just pulling it off and putting it on the new one. Great, team versus player. And our last visualization for the batsman dashboard is going to be called balls per boundary. So we're going to see how many balls bowled it takes for a batsman to get a boundary. But we have balls per boundary calculated here, and also a boundaries count calculated here. However, we're going to show you how to make our own versions of these calculations. So I'm going to create a calculated field. I'm going to call it boundaries count. And it won't let me save it as boundaries count because I can't have it saved as the same name. At least in Tableau Desktop, that's true. It looks like Tableau Public isn't getting mad at me for that. So, but I'm going to change the name to boundaries count calculated, so we can tell the difference between the one that existed and the one that we calculated. And we are going to do an if statement. So if the batsman runs, the individual batsman's runs, not the sum over whatever we select. If batsman's run is greater than or equal to 4, then 1, else 0. So it's giving me an error because I always need to have an end whenever I do an if statement. And this shows that whenever a boundary happens, so if they scored 4 or 6 on one ball, then we'll count it 1, otherwise 0. And if I sum this up, then we'll be able to count how many boundaries they had. So apply. Okay. And for example, if I brought on a batsman all the batsmen, and I brought on boundaries count calculated. This should be counting up how many boundaries they had over all time. So that's the numbers we're getting here. Okay, let's back it out. Now we're going to make our new calculated field called balls per boundary. Calculated. Just so that it's clear which one is which. And we're going to count all the balls. So this is for every ball bowled. So we're counting the balls. And we could also use the number of records here, similar to what we talked about earlier. And we're going to divide it by the sum of the boundaries count calculated. So this will show us how many balls it takes to get a boundary. Apply. Okay. Great, now we can start building our visualization. And we are going to bring on batsmen onto columns. And we're going to bring balls per boundary calculated onto rows. And now it's showing us how many balls it takes for the boundaries. Let's also bring batsmen onto color. I've got to hold control when I do that. There we go. So we have batsmen here and batsmen here. And we're going to do the same thing. Hold control, drag this down to label. And we can see the exact number. And for the final time, we're going to apply our filters. Now, I could have waited and applied my filters at the very end once I had all of these built. Again, I do recommend applying your filters at the end. Now we're going to put together the first of our two dashboards. So I'm going to click on dashboard here. I'm going to change it to automatic size, which will fill my screen. And I'm going to change it back to fixed size. So now we have our width and our height based on what automatic size was. Let's just round it out a little bit. So instead of 1678, I'm going to change it to be just an even 1600 and same even 900. So now we have our fixed size here. There's also, you could change it to a laptop browser or a full screen. So if we click full screen, there's that size. Generic desktop. I'm going to go back to my size. The size that works for you is going to be based on the size that works the best for all of your users. So that will take some research on your side. And before I get started, I'm going to do some formatting of my dashboard. So I'm going to click Format here, and I'm going to change the default shading for the dashboard to this particular shade. You can use this color selector or all these different kinds of basic colors. And so it just gives it a different color than just the basic white. So that's a quick way to change the whole dashboard color. And I'm also going to bring on some text for the title of the dashboard. Let's name our dashboard. We're going to call it Batsman Performance. Let's actually spell it out there. Okay. And then down here it says show dashboard title. So I'm going to select that, and we have Batsman Performance there at the top. If you don't want the title here to match what's here, you have a couple options. So you can click edit title and put in whatever you want. You can also we'll click floating here, and we're going to just drag text on here. And that allows you to be able to make your own title like that as well, or just whatever text you need to put on your dashboard. So we'll just remove that from our dashboard, and we're going to bring on our visualizations, but we're going to bring them on as floating visualizations. So I've selected floating here versus tiled. Floating allows you to bring something on and drop it and wherever it lands is where it lands. And you can move it around, and it's not going to try to automatically fill this area. If I change it to tiled, and I bring this on, it'll fill the area, or I'll put it to the left or the right, and it will fill those sides. So back to floating. Floating has some benefits where you can just drop things and they will land there. However, if you make it floating, then you have to adjust the size of each individual thing instead of just, say, if we brought it on, undo that, as tiled, and we brought on this, and we brought on this, if I wanted to adjust the size of these things, I can just drag this little line in between, and it just tiles them and they fill the space you give them. Versus with floating, when I bring on this, and I bring on this, then I have to, if I want to adjust the sizes, I can make this one smaller, and then I need to make this one bigger independently of that. So, there are some pros and cons of doing it either way. But we are going to do it the floating way. And we are going to bring on team versus player first. And put it here. Then we're going to bring on, underneath that, type of dismissal. So basically all of our dashboards, one at a time. Here's where our balls per boundary goes. My runs distribution goes over here. And it brings in whatever filters you showed at the time and all the legends that are showing up on that visualization. So if I go back to runs distribution, you can see we had gear and that legend on there, and it brought them in as well. Let's also bring on season strike rate, which also had year, and all inning score. Okay, so this is the one that had all inning score, if you recall, was the first one we made that originally had our two filters. So we're going to change our filters from multiple value list to multiple value drop down. And that causes it to take up way less space. It still has an incredible height, so we're going to go to layout and we're going to change the height to something more reasonable. 100 just brings it onto the screen so that I could drag it like that. There we go. And then year of date. We're going to edit this one, let's see, to be multiple value drop down as well. And again, a more reasonable height for a multiple value drop down. Okay, so we've got started. We have this legend here for color for batsman, which we're going to remove because it has the name on it generally. And we're going to figure out how wide we want these to be. So we need all three of them to fit in our width 1600. So that would be a width around 500 each. So let's go to layout here, and we're going to change the width from 533 to 500 on each of these visualizations. And that gives us some extra space to go in between them all. It's a little bit more reasonable, the space in between. There we go. And run distribution. So once I've kind of figured out my spacing to go in between them, I can line up these bottom ones by matching the Y or X value. So this X is 25, and this one I want it to line up with it up and down, so I'll change my X to 25, and it shifts it over. This one is 555, so I'm going to change this one. And this one, I'm just going to copy and paste this one into this one. Now we kind of have the X figured out, and I want them all to line up along the Y as well. So I'm going to take this 170, and I'm going to apply the 170 to all three of these so that they line up perfectly. This is another benefit of having it be a floating object, because on a tile object you can't determine their position exactly, otherwise it would mess up all of the tiles around it. But you also don't need to put them quite as precisely in order, because when you do tiled, it kind of lines them up along lines as they are tiled. Great. So this is a lot more straightforward. Let's get these. I'll get this guy about where I want it, and then I'll line this one up with it. Up and down. There we go. We can also come here and edit the title and just make the font a little bit bigger on both of these. And now let's make the worksheets here individually a little bit closer to the color that we picked for our background. So I'm going to right click right on top of the chart and click Format. Then I'm going to go to the shading section, and on the worksheet I'm going to choose more colors. You see the color that we selected before for the background is in this little palette of recently used colors. And I want one that's slightly different than that, so I'm just going to enter in the one that I want, and I'll copy that so I can use it on the others. However, if I did want the same color as I had there, I could just select it right out of the recently used colors. Okay. And there we go. We'll come here, right click on the chart, click Format, Shading, and gonna paste in that color. And you see when I clicked from here to here, it kept me right on that same sheet. However, you see that this went to white instead of the darker color I had before. And so I don't even have to click Format again. I can just come here and paste in my color. So I have a color that matches more closely to my background color, but is still different enough that I still have the outline, kind of the shape of having like cards on this dashboard. We go full screen here. We now have our dashboard that allows us to see all of the batsman performance information for whatever batsman we choose and whatever year we choose. So when we change the year, all of the charts update. We want to change the batsman to one of these Chris's. There we go. Some of them aren't in the year 2014, which is the problem we were having. There we go. So now we see all of the same information, but for Chris instead. So now that we've made our batsman dashboard, we're going to move on to making our bowler dashboard. Our first visualization for the bowler is going to be called Bowler Performance Against Team. It's very similar to the one that we made for batsmen, only it's showing how the bowler has performed against batting teams and the wickets that they got against those batting teams. So we're going to bring on the batting team so we can see all of the batting teams against them. We're going to bring on bowler so that it separates it out by bowler. One more try. We'll also put bowler onto color. And we're going to bring on player dismissed. No, sorry. We're going to bring on dismissal kind. We brought on dismissal kind, but I want to change it to be a measure and a count of the dismissal kinds. And let's put it here. So now we have a bar chart for the dismissal kind. You can see that it's going 0 to 30 for each of these. And that's because we have some that go all the way up to 30 against a team. And if we wanted, we could edit the axis and change it to be independent axis ranges for each row or column. So now we can see that it is 0 to 2 for this guy, but 0 to 30 for this guy. and that can be nice when you want to be able to look at them independently. However, when we're looking at them side by side and you're trying to compare, we would think that maybe this person did just as good as somebody like this person. So we're not going to do that because it could be misleading. Also, in the end, I'm going to have filters so that we're looking at one bowler at a time and 1 year at a time. So we won't need to see them all at once. Okay. We have bowler on color. Let's also control drag the count of dismissal kind on the label. So now it's labeled. Some of them are going to have a lot fewer against teams. Maybe they didn't play as many seasons and that they might have a lot more. That's why we're going to have the filter for a per season number. But we're not going to do that right away. Okay. Next worksheet. And we're going to call it bowler versus player. So when we're looking at this at one bowler at a time, we can see how the bowler has done versus particular players. So we're going to bring on the batsman here. And then we're going to bring on dismissal kind here. And again, we're going to change it to a count measure. And we can count all of the dismissals against particular players. When we filter it down to one bowler, we can see how they did versus certain players, and then in just 1 year. Let's sort biggest to smallest. We're going to bring batsman onto color. And that way when we switch from bowler to bowler, we could kind of see which batsmen fall in certain areas. It also just makes it quick to follow it along to the edge. And we could put count of dismissal onto label here so that it's easy to quickly see. However, when we filter it down to just one bowler and 1 year, then there's going to be a lot fewer dismissals per batsman. So it'll be pretty easy to see. So let's not do that. Let's go on to our next worksheet. And this one is going to be called bowling average. So we need to create a bowling average calculation. It's going to be runs conceded per wickets taken. So we have to come up with our runs conceded, which is all of the batsman runs. We'll sum those up and divide it by the number of wickets, which is the count of dismissal kind. And now we have our bowling average. There is a bowling average that already existed, so again we're going to call it bowling average calculated so that we know which one's ours. Okay, apply, done. And we're going to bring on the bowler and bowler onto color. And let's bring on our bowling average calculated. We're going to sort it biggest to smallest. It might be better to sort it smallest to biggest. But some of these players might not have played or bowled, so that's why we'll have nulls. So, biggest to smallest it is. And let's also bring the bowling average that we made onto the label. Great. Our next sheet, we will also need to make a calculated field for this one. And let me hurry and name it, and then I'm going to go back to bowling average because I had one more thing to do there. Economy rate is our next sheet. Okay, so for bowling average, we have a situation where maybe somebody doesn't know what the bowling average means. So you can right click on your chart in the outside area, outside of the graph area, and click on caption, and the caption will pop up, and it's automatically making a caption, which is bowling average calculated for each bowler. It's just describing what's happening. And then it says color shows details about the bowler, which it does, and the marks are labeled by the bowling average calculated. So when I double click on the caption, I can change it to be whatever I want, which I'm going to put runs conceded per wicket taken. And now we have a caption that kind of is describing what this visualization means. So on economy rate, the economy is defined as the number of runs conceded for each over bowled. So instead of the runs conceded per wicket taken, it's for each over. So we're going to create our calculated field. We're going to call it economy calculated. Again, we have to get a sum of our runs. There's our runs. We're going to divide it by the count of the balls. So this will tell us how many balls were thrown. But we don't want how many balls were thrown. We want how many overs there were. So just to make this a little more clear, I'm going to put parentheses around this. And we're going to take, there are 6 balls thrown in an over. So we're going to take the number of balls and divide it by 6. To get the number of overs. So we'll take batsman runs, and then this is per over. Hit OK. And for this visualization, it's going to be pretty similar to the last one, where we're going to bring on economy, and we're going to put economy onto, I'm going to hold control and put it onto label. Sum of economy. Oh, it's not even using my calculated field. So, economy calculated. There we go. Now it's much more reasonable. We'll drag economy calculated onto label. And since this dashboard is going to be meant to be viewed one bowler at a time, we're going to not split it out by bowler in this situation. But you could. And if you do split it out by bowler, that means they could select more than one bowler at a time and see their economy side by side. Also here, we can see that it says economy calculated for our label. And if we hit edit axis, we can change the title. So we're just going to call it economy. Probably need to do the same thing for bowling average. There we go. Edit axis. Bowling average. Okay. It got mad because I didn't close it. And then there we have it. Again, I'm going to right click in some empty space and click caption. And then we have our caption here. Edit caption. And we're going to put average runs conceded. Okay. There we go. We have our caption, we have our chart, and we have one more visualization to make for our dashboard. Remember, if you have any questions or comments, please put them below, and somebody from the Simplilearn team will help us answer those questions. Or if you have an answer to somebody else's question, feel free to chime in. We'll get a good discussion going. The last one is called a dismissal. And we're going to look at, kind of like we did before, a type of dismissal. But this was the batter and how they got dismissed, whereas this is the bowler and how they took the wicket. So we are going to also make a pie chart, which means dismissal kind goes on to color, and we change the marks to pie. So we have a pie that shows a color for each of the dismissal kinds. Again, let's remove null. So again, I came over here, right-clicked, and clicked exclude. But you can do it right on the visualization. Dismissal kind, and you say, oh, it's blank instead of bold or cotton bold. And click exclude there. So there it makes our filter. Next we need to determine the angle size. We're going to bring on number of records. And the more records that fall under that dismissal kind, that means the more often that kind happened. And let's bring number of rows, number of records onto label as well. And also we're going to entire view so that it's nice and big and easy to read. And we're going to add a caption. And we're just going to put dismissal types. We'll see how that comes up on the visualization. So now that we have made all of our visualizations for our dashboard, let's add our filters. So just on this last one, I'm going to bring bowler onto filter, and we're going to click use. Let's actually select a bowler. You can use this box to search. There we go, and it's popped up. You see how I didn't even have to start searching it at the beginning of the name. It's just smart enough. So we have our bowler. Let's bring on date. We're going to choose years. And let's choose 2016. And we have our year. And now let's apply it to all the worksheets that it applies to. So dismissal, economy rate, bowling average, bowling versus player, and bowler performance against team. Same for year. Okay, and you can see how much quicker that is to apply instead of doing it every time you make a new dashboard. So, much quicker, saves you some time, can be confusing, so make sure you do it, because if you forget to do it and then you change a filter on a dashboard and it only changes one of the visualizations on that dashboard, then it can be really confusing. And like on the batsman performance, if we had forgotten to add these to all the visualizations and we left it off of this visualization, then people could be confused as to why that's not changing. Or off of this visualization, if it's not changing, it's hard to know if it's not changing because it didn't change from year to year. Maybe his types of dismissal were the same from year to year. Or it's just hard to tell the difference and see if it's not affecting it. So always be sure to double check that your filters are applied to everything you need them to be applied to. Let's make a dashboard. Okay. We're going to make it what we made it before. 1600 by 900. And you can see all of our sheets are showing up. But let me show you a quick trick here. This dashboard uses all of the batsman sheets, and we don't use any of the batsman sheets again inside of the second dashboard. So if I right click on the batsman performance and I click hide all sheets, it doesn't hide all sheets, it just hides all sheets associated with that dashboard. And now you no longer see those sheets. And then I come to dashboard 2, it's only showing me the sheets that are not hidden for that dashboard. Let's get started by first changing our dashboard color. So I came to dashboard and I hit format. And I'm going to change the color to this blue color. And there's our background. And then I'm going to click show dashboard title, which is dashboard 2 right now. So let's rectify that right now. And we're going to call it bowler performance. And here we have bowler performance. Let's do floating, which is already selected. And we're going to bring on bowler performance against team. And we're going to go side by side with bowler versus player. And it's brought on, both of these have brought on legends that are actually not helpful because we have labels that tell us these things. So we're going to get rid of these legends. Sometimes I wait till I have brought on all of my dashboards before I remove legends or change filters. So all of my worksheets. Sometimes I wait till I've brought on all my worksheets. I'm gonna bring on bowling average and economy rate and dismissal. Here's an actually useful legend, so we'll keep that around. Remove this legend, because right there, it just tells you right next to it. And now let's start adjusting our charts. So I'm going to make these two side by side up here, so they need to split the space. So let's try a width of 750. which gives you a little bit of space side to side, but still uses the space a little bit better. You can see that this visualization is too tall to fit inside of the area we've given it, so it has a scroll bar here on the side. If you change how this fills in its space, so right now it's standard, you can have fit width, which it's already fitting the width of the area that is provided. If you do fit height, it's going to force everything to fit inside of that area, so there's no scroll bar, and it does not look good for this visualization. And then entire view, it's the same thing. It's trying to make everything fit inside that area. So we're going to go back to standard. Another one that's good for things where you do want the scroll bar up and down is fit width. So either of those look good. These two are going to share space underneath this one. And so I'm going to make them both, let's say, 300. How does that look? That looks good. Let's make this one the same size as this above it. 750. Bring it over. Okay. You notice one thing that's happening here is we cannot see at this point the filters. There are no filters popping in here, even though we added filters. Now, why would that be? That's because we have no filters being shown on our visualization. None of our worksheets showed the filters, they just existed here. So, if we come and we click on one of our visualizations, click the drop down arrow, and we go to filters, we can see all of the filters we can select from. We're going to bring on Bowler. Let's make it the drop down. And again, it's just made it a really unreasonable height because it was trying to fit all of those bowlers. But 20 is too small. There we go. And we'll go here and also bring on year of date. What's the height on this one? 55. 55 is a good height. Now it's time to clean it up a bit. So we have all of our pieces. Let's first make sure when I change this that everything changes. So when I unselect 2016, they should all go to null, and when I click fit 2015, they all update. That's what we want to see. Okay, so we have all the pieces. We just need to get them lined up, looking nice, and just getting things a little bit more clean. Like here, we want to show our caption that we added. And here. And here. So this kind of is something that you can use on your dashboard to describe things that are happening or different pieces of it. It's just an easy way to add a caption. And then let's line them up and down. I think that we could probably make both of these a little taller. What do we think about 350? Maybe even 400. And we'll bring these ones down. That's really nice for this visualization to have more space. Just a little bit more space. Whatever you can give it, honestly, is really helpful. Sometimes with these visualizations that are up and down, I like to give them the whole side to themselves. So maybe we would move this over and make it smaller, and these all three would fit right here, and then I'd give this one all of this up and down space. I'll undo that. We can move this legend over a little bit more. There we go. And then let's start lining things up. I like where this one is positioned on the y-axis, so I'm going to copy that and bring it over here. They were pretty close. There we go. And then I'm going to do the same thing with the y-axis for these ones. just to make sure they're perfectly lined up. These, it looks like I could make a little bit wider, if you would like. One thing that's happening here is it looks a little bit like this one has more up and down space than this one does. And that's because it's missing this label. And it also isn't colored the same as these other ones as it represents the bowler. Well, we can fix that because if you remember, we did not put bowler onto the columns. We put it on there. There's our label. We also didn't put it onto color. And there we go. So that gives us a little bit more consistency between these two visualizations. However, they're still labeled economy rate and bowling average with their captions at the bottom there. Okay. And since these are the same width, I would like to line them up on the x-axis. So I'm going to take this there, and that lines those up. I want to make sure that these are lined up and down, pretty close, but not quite there. There we go. And also, year of date is not necessarily what I want. The of date part is just not useful for what we need. So I'm going to change it to year. I'm also going to center it. We'll come here for bowler and center that one as well. Center. And also, let's make it a little bigger. See how it did not make it bigger? That is because the formatting in here, such as changing the font or bolding it, requires you to have whatever text you want selected. So now it's bigger. There we go. I like the white on the blue, so I won't change these individual dashboards or individual worksheets to be a different color. Let's take a look. Here we have our second dashboard. If we come here and we click Hide All Sheets, now you can only see the two dashboards in these tabs at the bottom. And you can see that we can have different years for the two different dashboards. You could tie the year together. Oh, we have year of date on this one too. Let's change that. So, that's not what I meant to click. There we go. Edit title. We're going to make it centered. We're going to make it bigger. Don't press enter when you're not done. Now we're going to erase of date. So that's just year. Do the same thing over here. This just adds a little bit of consistency. They are two separate dashboards. But if people are going to look at them side by side maybe, or one right after the other, it is nice to have some consistency. There we go. So, there you have it. We have made two dashboards. One of them about batsman performance, one of them about bowler performance. During this time, we learned about formatting our dashboards, we learned about floating versus tiled, and about positioning legends and filters, some of the options we have for changing filters. We learned about different ways to make different visualizations, so we made pie charts and bar charts. And we also learned about applying filters to just the worksheets that you want for those dashboards. And finally, we learned about adding captions.
So at first we'll understand what exactly a set function is, then we'll understand the sort function. Next we have the join and union and why do we use it. After that we have the highlight function in Tableau, then we have the device designer, and finally the forecast. Now these are the functions in Tableau that we will be discussing today. Don't worry, I'll explain each one of them with practical examples so that you have a better learning experience. Now let's dive into the first one, which is the set. So what exactly is a set? So sets in Tableau are basically a set of elements. Basically, if you have some variety of columns and rows, then you customize some selected data. For example, if you have a set of cars sales data and inside that you have some details about the horsepower, the price values, the resale values, etc., etc. And you wanted to make a set of the cars with the highest horsepower. Then you can do that just by adding some conditions onto your data. So that's what the set functions in Tableau basically do. So we have an example on our screen right now. So this is how the set function will be implemented in Tableau, and you'll be getting some similar kind of output. Now we'll go back to Tableau and try to do it practically. Now we are back on Tableau, and in Tableau let's try to make a set, and for that let's create a new sheet. Yeah, now let's rename this sheet as set function. Okay, now let's try to drag the engine size onto columns. Yeah, now we have the engine size on our columns. Now the next, let's choose the horsepower. So we have our horsepower on the rows. Now you can see that we have a resultant dot, which is the total number of engine size values and total number of horsepower including of all the cars. Now let's try to drag the manufacturer into the details part, so that we have the kind of which manufacturer has the horsepower values and the engine size, etc., etc. So we have the Ford, and the overall, according to the data set we have, the overall engine size is 36.60. Now it's not, this is not the kind of data you want to look at. So now let's remove the manufacturer from here and let's select the model. Yeah, now we have a little more detailed one. Just hover onto, yeah, you can see this. So we have the model Corvette, and the engine size is 5.7 liters and the horsepower is 345. Now let's try to drag the manufacturer again onto the details so that we can have also the name of manufacturer. So we have the manufacturer Chevrolet, model Corvette, engine size, and horsepower. Now we have the data what we needed. Now let's try to create a set. Now to create a set, you might have to select the, let's undo that. Yeah. Now to create a set, you might want to select the values on here. So these are the selected parts we have with the highest horsepower. Now let's right click, and then we have an option called create set in the last option. Now let's just try to rename the set name. Now we have it as set 1. Now let's try to name it as horsepower set. And before we select OK, if you want to eliminate some names or cars, you can do that as well. For example, if you want to eliminate Cadillac DeVille, you can just select and remove it. Or you can also do it in this way. Cadillac Escalade, you can just exclude it and it'll be gone. Yeah, something like that. And if you want this set to be added onto the filters tab or filter shelf, you can just select it over here and it will be automatically done. For now, I think we don't need it onto the filter shelf, so we'll just select OK. And there you go, we have the horsepower set over here. Now to watch the set what we created over here in a pictorial way or a graphical way, you can just drag that and you can just add it over the chart pane. Now if you wanted to look at the data which you have in your set, then you can just drag that set onto the color option, and you'll be having a different color on your data which is present in your set. Now you can just right click on it and you can make some changes to it. If you wanted to make, or if you wanted to keep this, you can just click on the option keep only, and if you wanted to exclude it, you can just select exclude and it will be gone. So this is how you use sets in Tableau. Now let's move on to the next function, which happens to be the sort function. So what exactly is sort? So when you open Tableau, you can see some options on Tableau which are the some bar kind of things on the toolbar. So these are basically sort options. So sort in Tableau is a function which is readily available for the user to sort the resultant data in the form of ascending or descending order. So we have a sample picture which shows the sort functions used in real time. Now let's get back to the Tableau and see it for real. So now we have the highest pricing chart over here. Yeah, you can see, yeah, let's select this one. So we have multiple car manufacturers and the car models available in that particular section. Now these are kind of irregularly sorted. Now one press of this button, which happens to be sorted descending by sum of horsepower within model, you see, within model, all the models are sorted according to the horsepower. So the first one in Buick, the Regal model, which has the highest horsepower 240, and the next highest is 205, second 205, and then 175. So this is how the models have been sorted. Now you can make this look a bit more colorful just by dragging the model onto color, and you can see the different colors. So that's how it is. Now followed by sort, we'll move on to the next one, which happens to be the join and union. Now the join and union are completely similar to the join and union functions which you basically use in the SQL and database. So you can see on the left part we have the 4 different types of joins, which are the inner, left, right, and full outer.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So join and union in Tableau are used to combine data from different sources, and they're completely similar to the ones in SQL and database operations. Now imagine that you have various kinds of data sources, and you need to work on those various types of data sources in Tableau. For example, consider that you have some shopping data, some store data. So you have the customer data separately and the product data separately. And let's assume that in both the tables we have one common column, that is the order ID. So the customer will be requesting for a product and will be creating an order ID. And in the product table, you'll be having the product data along with the requested product with its order ID. When you have such kind of common column, then you can basically join the two data sets. And no matter what, if you have the orders data in Notepad and the product data in Excel format, you can do it. You can join them. It doesn't matter if you have the data source in different formats. So that's why we have join and union in Tableau. So let's get back to Tableau and try to do it manually. So now I have kind of Excel. Now let's select the store data. Repeat, and you have the store data. And now let's try to add the new data set. Now for that you just need to select the add option. Now we have the other options. Now we have already included Microsoft Excel. Now let's try to include the CSV file, the text file. So I've already created one. So this happens to be the returns data. Now there you go. You have both the data sets over here, which is the Microsoft Excel and the not Microsoft, it's text file. So you can see the new union option over here. You can use new union option and try to combine both of them based on the order ID which is present in both the tables.
So this is how the join and union basically work in Tableau. Now let's try to continue with the next one. The next one is highlight. The highlight function is pretty simple. You just have to, select the option which you want to showcase. It's as simple as the name is. So the highlight in Tableau is a function readily available to help the user to highlight a specific data out of the complete file. So basically you can see my screen, and on the screen we have the data set and we have a resultant bar chart, and on that we have the highest pricing of a particular car manufacturer, and when you hover on to that particular bar and select it, then you can see that that particular bar has been highlighted. Now this data is also the same one, and on the right side part I've just selected the BMW car manufacturer, and you can see the cars highlighted are based on that particular car maker. Now we are back on Tableau, and now we have the same data over here. Now let's just kind of sort it again, and you see here, and now if I select the Mercedes-Benz, you can see that particular car has been highlighted over here. So that's how we use highlight function. And you can see if you want to disable highlighting, you can do it by just clicking this button, disable workbook highlighting. So now with this, let's move ahead into the next kind of function, which happens to be the device designer. So device designer is really simple. There is no rocket science in that. It's basically the kind of device you're working with. So if you have the Tableau installed in your tablet, then you can just select the tablet option so that your dashboard is clearly visible according to the screen size of your table or tablet. And if you're using a desktop, then you can select the desktop option and you can directly do it. Now let's get back to Tableau and check the device designer. So basically the device designer is used to check the layout of the dashboard you have. You can select the fit width, fit height and entire view. So you also have the options for making your dashboard look in the phone mode. And you can either select the default where your device automatically selects the kind of view it wants to show. So that's how the device designer is used in real time. Now let's get back to the next one, which is the forecast. So forecast is one interesting function used in real time. So let's imagine that you wanted to have an information based on the future sales on the product based on the current data available. Now you can do that by using the forecast function in your Tableau. So as you can see on my screen, I have some information available based on the sample data. Now we have the sales charts on 2014, 15, 16, 17, and if you wanted to predict the data of sales in the next upcoming year, which is 2018, I'm saying 2018 as the future year here because the data set what we have only has information until 2017. So that's the reason I'm saying the future year 2018. Don't worry a lot about it. We can actually change it in the data set if you wanted to. Now let's see this practically happening in Tableau. Now we are back on Tableau and we are about to create the forecast thing. So we have the measures and dimensions on the left part. Now let's try to drag the sales. Now we are dragging sales onto rows and we're going to drag the order date onto the columns. So we have the graph over here. Now if you kind of press that little plus button, and then you can see the sales happening according to 14, 15, 16 and 17th year. Now let's try to select the analytics to create the forecast thing. Now you just have to you can see the forecast button over here, right? You can just have to double click on that and you can see that the Tableau is predicting the sales over here, and this is the best case and this is the worst case of sales, and this is kind of the average. So this is how the forecast works in real time. So we will get started by understanding the proper definition of the parameter in Tableau. So what exactly are parameters in Tableau? So a parameter will allow you to provide a value to pass into Tableau. Parameters allow you to produce scenarios or options that are not available in your data, or create these values to put it into your visualization. After creation, end users can control the input to see the results of the parameters effect. So this is a little complex to understand, so let me just break it down to a simpler version. So parameters are completely similar to filters. So when you apply a filter, just imagine that you wanted to find the sales of top 10 subcategory items. So which are, is it phones, is it furniture, is it something else? So which are the top 10 items which are finding me the most profitable sales? So you'll apply that filter to that particular sheet. So what if you wanted to apply the same filter to 10 sheets? Yeah, by brute force method you can do that, and you can apply that to the 10 sheets. But what if you had hundreds of sheets, right? So in that scenario you might prefer using parameters, because once you set the parameter, you can use that particular parameter for all the sheets in your visualization, and even you can use these parameters in your dashboards as well. So I think this was a little simpler to understand. Now what are the use cases that we will be discussing today in parameters? So there are multiple parameters that you can use in your day-to-day Tableau usage. So we'll learn the most frequently used parameters. We're going to use the top n parameters: date field parameter, dynamic measures, dynamic dimensions, dynamic measures and dimensions, reference lines, and some sets. So I hope so far so good. Now let's begin with our practical session. So let's get back to Tableau. So we'll be using the Superstore dataset. We have dates and etc columns which we need for the parameters to be applied. So we'll go with that. So you can see that I've already worked on some sheets which include the parameters such as date parameter, dynamic measures, dynamic dimensions, dynamic measures and dimensions, etc. So don't worry, I'll save this book for your future reference. We'll be creating new sheets and we'll be applying new parameters for a better understanding in a practical way. So for now, let's create a new sheet. So you can see the icon. By clicking that, you can just enter into the new sheet. Now for our reference, let's rename it. So we'll rename it as top n. So we'll be beginning with the top n parameters, so we'll rename it as top n for now. Enter. Yeah. So for top n, let's drag sales into rows and subcategory from dimensions to columns. Now we have a bar chart on our screen. Let's kind of twist it or change the orientation. Yeah. Now we want to find the top 10 or top 5 items which are giving us the top sales. So let's kind of order it in descending. To do so, or to know the top 10 items which are giving us the maximum sales, we'll apply filters onto it. So to apply a filter, let's drag the subcategory into filters, and you can see a drop down menu or a dialog box where we can find the option called top. So here we can specify the top ideas or top items or top categories, whatever it is, which are giving us the top sales. So we'll be selecting by field, and inside that we have a top 10. Now okay, we are not going to create a parameter right away. Yeah, we have to create a parameter right away. Now just select a new name for your parameter. Now let's select top n parameter. Hyphen, or let's place the number in the starting for our better identification. Okay. Now let's select list. Now we have, if you remember, we had the minimum and maximum values as 1 to 100 in the previous dialog box. Now let's select that to 10, and here 5 or 7. Now let's select or let's do it 15, 10 and 5. Now let's rename them. display as top 15. Now display the 10 as top 10 and the 5 as top 5. Now the parameter is created. You can see the number, second, top and parameter on my parameters section over here in the bottom left corner. Now the aggregation is sum by default. Now let's select apply and OK. Now let us right click the parameter and select the show parameter icon, and here we have the top 15. Now let's try to select top 10. Now you can see that the sheet has changed the data. Now we just have the top 10 subcategory items which are providing us the maximum number of sales. Now if we kind of select label and show mark labels, then we have the numbers, right? You can see the numbers which are providing us the maximum sales over here. Now let's kind of select top 5. Yeah. So that's how the top and parameters works in real time. Now let's continue with the next type of parameter in our list, which happens to be the date field parameter. For that, let's create a new sheet. Now let's rename it as date sheet for our reference. Now we have the date sheet over here. Now to create a date parameter, we need a date. So we have the order date over here. Let's drag that to rows. Now let's select profit and let's drop it down to here. Now we have the profit on a particular dates over here. Now to create a date parameter, let's select the icon over here and we have a create parameter option. Now let's create a parameter. Now let's rename it as second hyphen date parameter. I'm renaming it as second hyphen because we have already worked on this particular sheet, and if you have seen this particular parameter section, we have a date parameter already existing in my sheet. So for that, I'm renaming it as second date parameter for the reference. Now we might have a doubt about selecting the data type for the dates. I'll go with string over here. Now let's select the list and add the values. Now for a date we have year as well as quarter. Next we'll have month. We'll have a week, and we'll also have a day. So that's our parameter, which is number 2 date parameter. Let's select OK. So once we have created the date parameter, the next step is to create a calculated field. So this particular calculation field will help us with the calculation of days, quarters, months, weeks, and years. Now let's rename this as well. Rename it as to date calculation. Yep. Now in this particular tray, we'll be writing the formula. You can see that we already have a date calculation over here. Let's try to see the formula over there. So here we are, we have the date parameter and year, quarter, month, week, and daily. And we have the order date parameter over here, order date, and this particular hyphen Q is used for dividing the year into quarters. Now we are going to use the same formula. Now let's create a new calculated field. Now let's select case, and remember the date parameter we created in the parameter section, you need to drag that in. So that's dragged. Now let's paste the formula and end. So there you go. We have the parameter dragged into the calculation field, and we have the calculation for year, quarter, month, week, and day, and we have the calculation as valid notification over here. Now let's just select OK. Now there you go. In the measure segment, or yeah, there you go. In the dimension segment, we have the date calculation field available. Okay. Now we have the sales and year-wise data over here. Let's change the type of graph to bar graph. Let's change the orientation. Yeah. Now let's select the label option to provide us the details of sales. There you go, you have the sales now. Let's select the date parameter, show parameter option, and we have the year-wise sales now. Let's select that to quarter. So the parameters is shown on the right hand column. So you can see the sales are according to year now. When you select quarter, you have the quarters. When you select month, you have month-wise sales, and when you have week, week-wise sales, and finally the day-wise sales. So you can see that on the 18th of March 2014 we have the maximum amount of sales. So that's how you do it. Now moving ahead, we have the dynamic measures and dynamic dimensions. Once we are done with the dynamic measures and dimensions, we'll also execute dynamic measures and dimensions together. Then we'll continue with reference lines and sets. Let's get back to Tableau. So what exactly are dynamic dimensions? So you can see that on the left hand column we have so many dimensions over here. So we'll be creating a filter and we'll be passing all the dimensions or the number of dimensions what we want on our filter to be. So we'll pass those number of dimensions into the filter, and for the same we'll be creating a parameter and we'll be running all the values of dimensions through that parameter. Now let's go ahead and create a new parameter. Let's select the icon, create a parameter, and now we are in the new workbook to avoid confusion. So we'll rename this as dynamic dimensions parameter. We'll select the data type as string, current value, and list. And inside the list, let's write in the category, shift mode, and segment. Let's select OK, and you can see that we have the new parameter over here which says dynamic dimensions parameter. Now once the parameter is created, the next step is to create a calculation field. Let's select the calculated field option, and inside this let's rename this calculation as dynamic dimension calculation field. And inside the tray let's write in the formula. Now let's write in case, and let's drag the newly created parameter, and now let's select one category, then category from dimensions, followed by that one shift mode, then shift mode from dimensions, followed by that one segment, then segment from dimensions. Now end. Yeah, the calculation is valid. Let's apply. Okay, so you can see that we have a newly created dynamic dimension calculation in the dimensions section. Now we have the newly created dimension calculation here. We'll drag that to columns. Now let's drag sales to rows. Now let's drag the category to columns. So there you go, we have the different categories: furniture, office, technology. Now we have the parameter displayed on the right hand side. Now let's select according to the shift mode. So according to the shift mode, we have the first class, second class, same day, standard class, etc., etc., and these are the categories happening in that particular fields. And if you select the category or parameter by segment, we have these results: consumer, corporate, and office. Now this is how the dynamic dimension parameter works. Now let's get into the dynamic measure parameter. For that, let's create a new sheet. We are in the new sheet now. Now dynamic measures are completely same to dynamic dimensions. The only thing changing here is instead of dimensions, we'll be dealing with measures. Now we'll follow the same steps again. First, create a parameter. Let's rename this as dynamic measures parameter, and in the list we'll be using sales, profit, and quantity. Let's select OK, and our parameter is done. Now let's create a calculated field similar to dynamic dimensions. Let's rename this calculation as dynamic measures calculation. And inside the tray, let's type in case. Let's drag the measures parameter. There you go. Now when we have used sales, profit, and quantity. So sales, then sales. When profit, then profit. When quantity, then quantity. And yeah, the calculation field is valid. Apply and OK. Now let's make use of show parameter option so that we can see the parameter on the right hand corner. Now let's select the category from dimensions, and the newly created dynamic measures calculation onto rows. So we have the bar chart over here. Now let's select profit. So you can see the profit by category wise, and you can select the label so that we can have a clear picture of the numbers. Now if we select the quantity, we have the details according to the quantity. Now to just make things look a little better, we can drop the category off and make use of subcategory to have a better visualization on the subcategories which are bringing us maximum sales. You can rearrange them in descending order, and we can see binders are giving us maximum profit in the number of quantity. In the profit, yeah, copiers, and in sales we have phones. So that's how we use dynamic measures in real. Now the next part is both dynamic measures and dynamic dimensions together. For that, all you need to do is just select the calculations from dynamic measures and drop it down to rows, and dynamic measure dimension calculations onto columns. We're using both the calculations together, and now let's kind of use the option of show parameter where we can see the dynamic dimension parameter and dynamic measure parameter together. Now when you select category and sales quantity, now we have both dimensions and measures here. Now let's select the label option so that we can have a detailed appearance on the numbers. Now we have the segments over here: consumer, corporate, and office. When we select sales, we have the sales number. When we select profit, we have the profit number. When we have the quantity, we have the quantity number. So that's how the Dynamic dimensions and dynamic measures are used in real time. So the next parameter that we'll be dealing with is the reference lines. Now we are back on Tableau. Let's create a new sheet. Now for reference line, let's select the order date and drop it down to columns, and now let's select sales from measures and drop it down to rows. Now let's make a change to year. We'll check that to day, and we have a line over here. We need the sales in continuous day format. Yeah, so this is how it looks like. Now let's create a new parameter. Let's rename this as date parameter. Let's select the data type as date and current value, and let's select the date as, so according to dataset we have the dates between 2013 to 2018, so select anything between 2013 to 14. Let's select 2014. Yeah, now let's select OK. So now we have the newly created date parameter over here. Let's select the show parameter icon. Now let's get back to analytics and try to use a line. So we'll use a reference line. Let's select table. Let's select the type of line and color. Okay, so you can see a reference line over here which is got created. Now let's get back to data once and date parameter. Let's edit it once. I think we forgot something important. It's fine here. Yeah, let's recreate the line again. Let's use a reference line, table, and here we created a date parameter. We need to select this. I think I forgot that. Okay, now let's select the type of line. Let's select a medium thick line and dotted line. Let's select the color as pink. Yeah, that should be it. Let's select OK. Now let's select the show parameter option. When we have the date parameter option over here, let's kind of change the date, and once we change the date, you can see there is a shift in the line. So that's how we use the reference line in real time. We have the date parameter over here. This is how we use it. Now let's move on to the next option or next parameter in the list, that is the set parameter. For that, let's create a new sheet. Now let's drag the sales to columns and subcategories to rows. Now select subcategory and let's select subcategory from dimensions, right click, and let's use the create option, and from there we'll be creating a set. Let's rename the set. The subcategory set is perfect. Let's navigate to top, and inside that let's select by field, and now let's select the top n parameter. We are in the subcategory. We have created a new parameter which we had in the earlier sheet. So again, let's navigate to top and let's rename this. Now by field, by top n parameter, select OK. Now you can see that we have a new set over here. So now let's select the show parameter option. And now let's drag the set into color so that we have different colors. So that's how you use set in real time in parameter calculations in Tableau. So now let's discuss the differences between parameters and Tableau filters. So these are the few differences between Tableau parameters and Tableau filters. So Tableau parameters are used for static data and Tableau filters are used for dynamic data. So parameters are implemented to entire workbook, whereas filters are implemented to only specific sheets. So this is what we discussed in the earlier part. So using parameters cannot select multiple values, but using filters can select multiple values at a time. And parameters use calculated fields while filters do not use calculated fields. And finally, parameters support multiple data types, whereas filters do not support multiple data types.
So let me now begin with connecting to data. Now in this particular topic, we are at the end of this lesson. You will be able to understand how you can connect to Tableau data server. You will be able to differentiate between a join and blend. How can you perform a join on a data? How can you blend a data? We will discuss the various connection options available. We will understand how Tableau server works in terms of the Kerberos authentication. All right. We will understand various performance optimization techniques as well, shadow extract, as well as different methods that we can prepare in terms of the data that we want to analyze. All right. So let me begin. Now, the very first topic, which is connecting to Tableau server. So I'm going to first take you through a couple of presentation slides here, and then quickly move on to the environment where we will actually then start exploring the topic. So now, when you want to connect to a data source in Tableau server, it's pretty simple. You can connect to a flat file in your local machine. So one is you will click on to the server in the start screen, and you can specify the server name. You can specify and show your log in your credentials, the username and password, and based on that you can perform you can have your connection to the database. All right, so that's how you can connect to the Tableau server as well. All right, so that's the very first basic. So the Tableau administrator is the one who assigns the roles and creates these data sources. All right, and you have Tableau has the facility in order to import different forms of data for the analysis for your ease. And once you connected to the Tableau server, then you need to select the Tableau server data source. On the data menu, you will need to select the data source to download a local file, a local copy. You can select and create a local copy, and then you can also duplicate a duplicate of that data source will be added up into your data window. So that's how you can connect to Tableau server as well. All right, and it basically promotes various features wherein you can then connect to the Tableau server for your data. So you are in this example, you can see that you're able to connect to the Tableau server as an admin and connect to the sample superstore, and it downloads, it creates a local copy and duplicates all the data in that particular data window. That's how we can see the sample superstore, and you can connect to the server. Next, we are going to also understand what is joining and blending. So before I move on to the presentation slides here, what I'm going to do is I'm going to move on to the environment directly. Let us start exploring these blending and joining features right therein. All right, I'm going to simply just clear these sheets that we have, and let's go back to the connect to data source window. All right. Now, in terms of this is where you're able to connect. You can see the Tableau server. So it's through the server that you can connect, wherein you can specify your server credentials and you can click on connect. And based on that, that's how then you can provide the credentials and log in. All right. Now, I do not have a server connection wherein I can show that example, but this is how you can click on any of these servers. You will have to type in the URL, click on connect, and then provide the usernames and login provided, and that's how you can connect to your data source using a server option. All right, I'm going to show you the file option wherein you can connect to an Excel, and let us discuss the join and the blending part here, right? So let me click on itself. We have the sample super data store here, and in this, when I pulled in order, all right, I pulled in the first sheet, so there are 3 sheets in that particular Excel file. When we pull in order, this is how now you can identify that whatever are, these are the header names, these are the dimensions and measures, that's how it's getting identified. So you can notice all the dimensions are first place. You have all your measures, then you're able to identify the data type and the role, and ABC, which is a contextual value or numeric value, that means it's a dimension with a pound sign. What kind of a data role is it? Tableau is automatically identifying each of these roles as well, all right? Even in the metadata, that's how you can see the field names, the field name that you're going to see onto your view, and the table from which it's going to be getting pulled in from. In this, you can rename in case you want to change the particular name, hide it, alias it, or describe it. All right, so this is how you connect. Now, connections is where you have the option to connect between live and extract. Now, if you connect to live, that means you connected to this particular sheet live. That means any update happening onto your sheets, any kind of updates on the sheet, there is a live connection. It will automatically update your views as well onto your sheets that you're creating. And in case if you select on an extract, all right, this is what it means, that it allows, what it does is it imports that data into the Tableau data engine first. In the data engine where it's going to perform the queries, it will create an extract, and based on these, we can then start using the connections. All right, so what it does is it disconnects. It's more like a small extract, more like a cube if you understand it in that manner. Tableau creates an extract of that file, providing you a disconnected, wherein it allows you to give you a better performance, a better query. That's how you can then work on and start creating and working on these extracts. Now you can refresh these extracts at a timely manner as well. So that is what Tableau extracts are, where it extracts it as a copy of the data and saves it in the engine, and that's how then the performance as well gets better in terms of using, where you can connect to your particular data. All right, so you can work with multiple data sources. Data sources can be of any type. All right, wherein you can edit from the number of lists that you can see. It can be a flat file, a server file as we saw, or the saved one. And we can also then join multiple tables within the data, or we can also blend when it's coming in from different data sources. Then we can also perform a blending. So let me first show you an option for join. Now you can see we have the order table here. When I drag and drop the people sheet as well here, you can see that Tableau has automatically created a join. All right, it has automatically created a join when we have pulled in 2 tables coming in from the sheet. And by default, all right, we have the inner join that Tableau creates. So it creates an inner join here, wherein again you can then click on the join option here, and you can specify and modify the join based on whether you want it as an inner join, which is a default, you want a left join. Now if you see, the right join has been disabled here. Okay, I will show these options here. By default, the right join is disabled by Tableau by default, and to enable that you will have to connect to your Excel sheet in a different manner. I will show that to you shortly. So that's how you can change and you can perform your joins. This is where you can explore and show the join clause. And here again, then you can specify, like you can see a join that's being created amongst the data source, which is region and region people among these 2 data. All right, so it's also showing you the join and whether it is equal to or not equal to. All right, so you can connect to multiple tables, and based on that, you can add in tables, you can specify the different joins, and based on that, then when you click on sheet, you will then be able to see that there is a join being performed. There are 2 tables now, the people's table also that has been added in, and it has now performed an inner join on our data, and you can start using this particular option. So let's say I'm going to pull in the region on my columns, and I'm going to have my sales onto my rows. It's now providing me details of my sales at a regional basis. Now, let's say I also want to analyze the people belonging to these regions depending on the color. So it's going to change the colors based on the central, east, south, and west. All right, that's how these are the people, number of people belonging to each region that it has identified. So that's how it has taken up the region people. As you saw, there was a join that was created and it's given us that particular option. And based on that, you can see here, we just have this particular data source here. And that's how you can see. Now, I've used it earlier as well. If you remember, we had pulled in one particular table. Hence, the blue tick mark sign here enables and shows us that this is the primary data that's being used. Now, this comes in picture when we're using a particular join. So let me right now just use this particular detail here, and we're not going to require this. All right, so let's just close this. We just need one right now because we're discussing on blending. I'm going to show you the blending part later. Right now we're discussing on joins. So that's how you can join in your data sources, and you can combine multiple fields using these joins. So when you have multiple tables, you can simply connect to the data. Let me go back to the data source page. This is the startup page, the data source page. And you can see the joins that's being performed. Now, let's say you want to create a join where you want to force, due to certain situations and scenario where you want to force a right outer join, all right, or right join, or for that matter, you want to write a custom SQL. Now, you're not able to write a SQL right here in the drag area pane where you can drag and drop your sheets from the Excel file or any kind of a file that you're connected to. For that, and to enable the right join, you will need to connect to your data in a specific manner. So let me open up a new instance of Tableau here. And let me show that to you as to how we can enable the right join and how we can have our custom SQLs as well. So in case if we want to write in a custom SQL on our view, then how can we perform that initial custom SQL, all right? Okay, so let us connect to our data here. And I'm going to take you on to the Excel file. Now, when I click on the sample superstore here, okay, what we had done is we clicked on open, and that's how we opened up the file, all right, and that's how we could see the sheets. Now, instead of using the open option directly, what I'm going to do is in the drop down, all right, here instead of open, we have an option that says open with a legacy connection, all right. This is what is going to enable us to write a custom SQL where we can specify a query rather than using the entire data source or pulling in the entire table. So clicking on the second option in the drop down in the open tab here, you will be able to see the open with legacy connection. I'm going to ensure that you've selected that, and that's how you will then connect to the data source. And with that, you now have a new custom SQL option that's opened up for you all. This is where you can, once you've connected, you can double click on the new custom SQL and you can write in your query. You can write in the SQL where you want to perform the query and pull in your data. All right, so you can have your select from, and let's say orders. All right, so that's how you can perform, and you can write in custom SQL, and you can pull in the required data. You can have your required table that you can pull in terms of creating a SQL that you want to pull in and have your data. All right, so you can have your select from the orders and preview the results. So here you can see the orders table has 9,940. We have a preview of the data available in that particular sheet that we pulled in. All right, and we can now parameters is what I'm going to cover when we come on to that particular topic. So I'm going to leave this for now. So that's how you can write your custom SQL, and you can click on OK, and that's going to pull in your entire data. And as you can see now, instead in the earlier view, I'm going to just switch to the earlier instance of Tableau. You could see the name of the table that I dragged and pulled in. You could see the name order. But in case when we write a custom SQL, then it gives us the name which is written as custom SQL query. Alright, and this is where you can get the information, you can edit the query in case you want to change the results and requirements. So that's how, instead of clicking on open, you click on open legacy connection and you can have your own custom SQL defined. Now along with this, alright, when you open and when you click on a legacy connection, when I drag in the people's table here, you can see that even the options for right joins have now been enabled. So by default, Tableau disables the option for right joins, and in case in certain situations and circumstances you want the right join to be enabled, you will in the same manner have to import and connect to your data using a legacy connection, and you will have the right join which is going to be enabled there for you all. So you can have your custom SQLs or the right join in that case which gets enabled, and you can use a custom SQL or a right join, right? So that was custom SQL. Then joining is where you can, as I mentioned, identify and choose between the clauses and the clause that you want to add in, right? Now let me show you an example of blending as well. So I'm again going to open a new instance of Tableau, all right? And with that, I'm going to show you the example of blending. So let's say you have you want to join in, and when is the best time, when is the best way that you should use. Now joining is when you have all your multiple tables that you want to join coming in from one data source. Blending would be required when you want to join in multiple tables coming in from different data sources, or for that matter you can also blend even though the tables are coming in from a single data source. There might be instances that you might want to have still perform a blend instead of a join. So let me show that option to you. All right, so let me connect to the data. Let's connect to Excel, pull in our sample superstore file that we have. We have the order table, all right, and I'm going to go on to the sheets here. All right, so we have one order, we have one data, which is the order table. Now I'm going to again click on add a new data source coming in from the same Excel file. And this time I'm going to have the people's table and move to the sheet. So now if you notice, we can see two data sets here, which is one for the orders and one for people here. And in here, now this is where the blending will take place. This is where you will have a blend automatically when you pull in a view, if there is a common view that comes into picture. Now let's say I'm going to first pull in the order date onto the columns, all right? And as soon as I pull in, you can see that my order table has now got a blue check mark, which has become a primary data source, all right? And now let me pull in sales onto my rows. And from people, let me have from the people's table, let's have region pulled in and added to the colors. So region has become a secondary data set, and now you can see a blend sign, right? A linking or data blending that has automatically been performed on both these two data sets, all right, that we have the order table and the people's table, blue being primary and people which is being secondary in this case, all right? So that's how you can mention. Now in terms of blending, what happens is you cannot specify the joins here in this case. There is a primary and secondary data, and it is automatically blending in the data for you. It is automatically pulling in the data. You will not be able to here select on the kind of join. You will not be able to manipulate the join. So that's how, even though at times you have the same tables that are coming in, as I mentioned, there are times where you might want to perform and change the joins. So that's when you can use the joining table option that comes into picture. So that's the difference between your blending and between joining the tables, right? So you can see this available link, and you can see how it was simple to drag a particular view and pull in data. And here as well, region has been added to the color fill, because of which the legends have been created, identifying all 4 regions present in the data. And it's also letting us know here in the marks that region is coming in from the secondary table. You can see the orange amber tick mark here, and that's how you can identify that region is coming in from the secondary table that's being created, all right? In terms of connecting as well, wherein you can combine and have the joins enabled. Now, depending on the kind of data, all right, going back to the data source, depending on the kind of tables and the kind of data that we have, that's when we can enable and have the joins that we can decide on, all right? So one is you would require and need to have a multiple legacy connection with which you can then define the right outer join, all right? And that's how you can proceed and have additional joins that you can work on. We also discussed how we could create and connect to a custom SQL query, all right, and that is how we could, using the legacy connection, also enable the right outer join, wherein we could then perform a right join on our tables as well, all right. And in case if it's a query, then it gives in the name of the query as a custom query, which is what we saw onto the preview and the extract there, all right. Now, in terms of extracts, all right. Now, extracts are basically your saved subsets of the data source, which will help you in improving the performance. So instead of, as I mentioned, instead of being connected to a live connection, it is better that we select an extract which creates a subset and stores it in the Tableau engine, wherein it performs the queries, and it takes advantage of this functionality where it is not connected to the original data source. And with this, it can actually reduce the total amount of data in terms of defining and limiting it. So that's how you can create an extract. And let's say once you've created an extract, you can then perform, like I said, you have the edit option where you can edit the additional detailings. You can allow an incremental fetch happening, where then you can refresh the data each time your data is updated. You can provide an incremental fetch. So this can help you in improving your performance. You can take advantage of the functionality in terms of the data source for using the discounts, the distinct counts as well. And moreover, it's more like an offline mode. You're actually accessing your data as an offline access where it's not directly connected, and you're able to use it like a data, local data. All right, so that is the difference between a live and an extract. So that's how you can make use of the legacy connections as well. So let's go back to the presentation slides and have a recap. Now, these are the joining tables. That's what we discussed, that in terms of the tables that we have, we can join a table and we have various joins available where it makes it easy for us to analyze the data that we want to view. We can join to multiple tables, and based on that, we can customize the inner, the left, the right, or the full outer join. Now, the full outer join also depends on the kind of data source that you're connected to, all right? So in case of an Excel file, we still do not have the right outer join option, which is enabled. So this possible option, again, when you open with a legacy, depending on the data type, is how you will have the right outer join that you can post and have it enabled. So this would be depending on the kind of data source file also that you have. And you have these 4 join types that you can use in terms of joining tables in Tableau. Now, when would you want to use a join? All right, so a scenario is that you have a sales manager of an online shopping website, and he wants to analyze the customers who have returned at least half the number of orders that they have placed. Now, to fulfill this requirement, he will require a worksheet wherein he can join the orders and the return table on a particular common dimension. All right, so that's how then he can create a join. He can change this between the inner default to a left join between the order tables and the return tables, and based on that, he can then get to know the customers who have returned at least half the number of orders that were placed. All right. Now, in terms of enabling a right outer join, this is taken care of by the Microsoft Jet Data Engine driver. So in case if you all are facing a trouble where you're not able to connect and see that particular option, it's throwing an error. This legacy connection options comes in only when you're using a Microsoft Jet data engine driver. This is easily available. In case if you do not have it, you can install this driver, and with this it will enable the right outer join and the custom SQL for us. Alright, to enable the right outer join here, that's how you open it with a particular legacy connection. Now, in terms of a right outer join, we saw an example. We can force and use a right outer join. We can select on a new custom SQL where we can type in and have a custom SQL generated. And that's how we can work on with the SQL, where we can provide the SQL syntax, and based on that, the data source will then be generated. Now, in terms of blending, this is what happens when you have multiple data sources in your view, or when you want to establish a link between them, or you want to blend your data. It does not create a row level join. So in case, like the example that we did, although it was coming in from the same sheet, from the same Excel file, but we did not want to create a row level join, then that's when data blending would come in handy. You can use it with the related data across multiple sources that you want to analyze in one particular view. So that's how you can blend your data, which creates a primary and a secondary data. So we saw that in this example, you can see that there's a customer segment, department, and sum of sales, wherein the bars are being created, which are coming in from the primary connection. But in terms of the sales plan, alright, these sales plan are coming in from a secondary data. You can see the amber connection here, the amber line here, that is allowing you to understand and segregate and differentiate that it is a secondary connection. So in Tableau, that's how you can identify, as you saw, that your primary source and you have your secondary source, wherein you can identify and distinguish. You can distinguish between the common fields that are present in your data, and you can establish a connection. In case if it has not established a link, you saw that there was an automatic link, then you can provide a link by explicitly defining a link as well. Let me take you back to the environment. All right, so this was the custom SQL. Now, in this case, in case if there is no link provided, then you can provide a particular link onto your view. You can have the option, if it has not enabled, then you can select your particular, you can see that it has not implicitly defined, but it's giving you an option that there is possibility of linking. So you can explicitly define, you can click on this link and use person as a linking field, and this has also linked in your data with the previous data that you have. All right, so that's how you can define and explicitly mention the way that you can blend your data and you can identify. Another way can also be wherein you can edit the connection in the mapping, and that's where you can perform. So you can go back to your data sources and you can explicitly define, you can identify whether the first rows are the names, whether the rows here are automatically generating a field or not. All right, so that's how you can have these two tables, and you can define the blending whether you want it or not. You can disable the linking as well in case you don't want to perform a particular link. So coming to that, now let us understand, I've already discussed the difference between the joins and blends and where you can use it. So let's have a recap again. Now in terms of joining, joining is a SQL term wherein it's combining two data sources coming in from a single data source. While in terms of blending, it's more about combining two different data sources into one single sheet. All right. Joining is done once at the data source, and this can be used for every worksheet, while blending will be done individually for every worksheet. Okay, and both the tables that are joined must exist in the SQL database. While in blending, it helps us combine the database which is coming in from different sources, different locations. And in case if it's a multi-dimensional source, if it's a cube, then you cannot perform a join. And in terms of blending, you have a primary source, and but in terms of a primary source, it cannot be a cube, but your secondary source can definitely be a cube that you can use in terms of performing a blend. All right. So that's how you can optimize your connections. You can select whether you want to have perform a blend on your connections, you want to perform a join depending on the kind of connections that you have, and that's how you can work with them with the different data sources that you have available.
So at first, we will understand what exactly is an LOD expression in Tableau. So LOD expression stands for level of detail expressions in Tableau. The LOD expressions will allow you to compute values at data source level and visualization level. However, LOD expressions give you even more control on the level of granularity that you want to compute. They can be performed at more granular level, that is, we use include LOD expression there, a less granular level where the exclude LOD expression will be handy, and finally an entirely independent level, that is the fixed LOD expression. So in this tutorial, I'll explain you the types of LOD expressions you can use in Tableau, as well as when to use them and how to format them. I will also use an example to demonstrate how to create simple LOD expressions in Tableau. Now in this image, you can understand that the aggregation and granularity levels are inversely proportional. That means as the level of aggregation or as the level of ordering in data increases, the granularity level gradually decreases. So this particular example will help you understand the inverse proportional relation between the aggregation and granularity. Now let's move into the next part where we will understand the two types of LOD expressions in Tableau. So basically there are two types of LOD expressions in Tableau. The first one is the row level LOD expression and the second one is the view level LOD expression. So in Tableau, expressions referring to unaggregated data source columns and are computed for each row in the underlying table are the row level expressions. So in row level expressions, the dimensionality of the expression is considered to be at the row level only. Now the second type of LOD expression, that is the view level LOD expression. So by contrast, which is the opposite to row level, the expressions referring to aggregated data source columns are computed in the dimensionality defined by the dimensions in the view. In the view level LOD expressions, the dimensionality of the expressions is confined to the view level only. Now the next part is about the syntax of LOD expressions in Tableau. So as you can see on my screen, we have a sample syntax to be followed for the level of detail expressions in Tableau. So we will be following the same kind of syntax in our real-time examples. Now moving ahead, we have the types of LOD expressions in Tableau. So basically, as discussed in the definition, we have three different types of LOD expressions in Tableau. So the first one is the include level of detail expressions in Tableau. The second one is the exclude level of detail expressions in Tableau. And finally, the last one, that is the fixed level of detail expressions in Tableau. Don't worry, we will understand each one of them in a bit more detail along with a practical example for a better understanding. So the first one, the include level of detail expression. The include level of detail expressions compute values using the specified dimensions in the addition to whatever dimensions are in the view. Include level of detail expressions can be useful when you want to calculate at a fine level of detail in the database and then re-aggregate and show at a coarser level of detail in your view. Fields based on include level of detail expressions will change as you add or remove dimensions from the view. Now let's get back to Tableau and try to execute a simple example for include level of detail expression. Now we are back on Tableau and we are going to use the sample dataset in the Tableau, which is the Superstore dataset. Now to create LOD expressions in Tableau, we have some steps. So the first step is to set up a visualization first. So we need to use the data from the dimensions and measures, and we need to create a visualization on the sheet. And once the visualization on the sheet is ready, then we are going to create the LOD expression. So for that, we are going to use the analysis button on the toolbar, and then we are going to create a calculated field, and inside the calculated field, we are going to create our expression for LOD, that is the level of detail. So once the calculated field is set up or the level of detail expression is set up, the third step is to use the level of detail expression in the visualization. That is, we'll be getting the newly created level of detail expression field in this particular dimensions or measures, and we'll be dragging that into the rows or columns, or we'll be dragging that into the details tooltips text size, color, etc, etc. Basically we'll be using that particular new field which got generated using the level of detail expression, and we'll be creating the new visualization using that particular LOD. Now we have a brief idea how to create an LOD. Now let's begin with the first type of LOD expression, that is the include type of LOD expression. Now let's try to rename this sheet. I'll rename it as include LOD. So before getting started, I would like to tell you guys that we will be using color, size, label, detail. So only these 4 boxes or only these 4 shells will be affecting the level of detail visualization in real time, and the tooltip and filter, pages, etc, etc will not be affecting that much. Now let's begin with the first one. Now as the first step, we are going to create a visualization on the screen first. So for that, let's drag the region into columns. Now let's drag the sum of sales into columns. So now we have a bar chart visualization on my screen which tells about the number of sales happening in different regions. So if we have an example that is central, which is near to 500k, and east is around 678k, and similarly south, and similarly west. So basically we have created the first step, that is create a visualization on the sheet. Now the second step, to create the new calculated field, that is the LOD expression. For that we'll be moving to the analysis button on the menu bar. Click that, and you can see in the drop down menu we have the create calculated field option. Select that. Now let's rename this. Now let's rename this as sales per customer. Let's select the region where we have to write our expression. So for that we'll use the include option. Next we have the customer. We'll select the customer name, or even we can select the customer ID. Let's go with the customer ID. Then let's select the sum of sales. So we have our LOD expression ready. Okay, this shows that the calculation has some errors. Yeah, this should be resolved. Yeah, let's go with customer name and let's select OK. Yeah, I think we forgot to mention the flower bracket at the end. Let's try that. Yeah, now the expression is proper. So the best part of Tableau is, if there is an error in your expression, Tableau will not allow you to continue with that. It will show a warning over here. That's the best part. So now let's consider the ID back again. Yeah, this should be fine. Now let's select OK so that we have the new field, that is sales per customer, in our dimensions part. No, the measures part. Yeah, we have the new field in the measures part, that is the sales per customer. Now the next step is to use this particular field and generate the level of details. Now we have the newly created field over here. So that is basically the third part we are going to do right now. Now we are going to drag this and place it into the rows. So we have 2 different bar charts now, the sales per customer and another bar chart which is of sales. Now we are going to select the sales per customer and right click on it. Now we have the drop down menu, and inside that we are going to select the measure. So we have the sum measure right now as default. Now we are going to change that into average. Now we have the average sales per customer according to regions. So the average sales per customer is 796.9 units, and that is in the central region. Next we have the east region, south and west. So that's how we use the include level of detail expressions in Tableau. Now we are done with one example based on include level of detail expression. Let's try to execute another example. Now we have this sheet 2. Let's try to rename it. Let's rename it include LOD hyphen 2. Now in this particular second LOD expressions, we are going to calculate the sum of sales on per state basis. Now let's move to the analysis button on the menu bar. Let's try to select the create calculated field option. Now let's try to write in the expression name. Average sales per state. Now inside the tray, let's try to add the expression include state now sum of sales. Now let's try to close the flower bracket. Yeah, now we have the valid expression. Let's just select OK so that we find the average sales per state option or the newly created field in the measures section. Now let's drag the category into columns and the newly created average sales per state into rows. And we have the level of detail visualization on the screen right now. So the furniture is about 742 units, and the next one is the office, which is 719,000 units, and the last one is the 836,000 units. So this is the average sales happening in particular categories. So remember, we have 3 different categories in our sales superstore dataset, which is the furniture, office, and technologies. So these are the average sales happening. Now with this, we have the calculation placed on rows shelf and it is aggregated as an average, but we still have to find the sales happening by state. So with that, we have the calculation placed on the row shelf and it is aggregated as an average. So the resulting visualization averages the sum of sales by state across categories. Now let's drag this segment option into the columns. So when the segment is added to column shelf and the calculation is moved to label, the LOD expression results update. Now you can see how the average sum of sales per state varies across categories and segments. Now we have all the bars in one particular color. Let's try to change it by dragging the category into color. So we have different colors for different categories. Now let's try to drag the average sales per state into color so that we have different colors again. So this is how it works.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now with that, let's move into the next type of LOD expressions, that is the exclude LOD expressions in Tableau. So the exclude level of detail expressions declare dimensions to omit from the view level of detail. Exclude level of detail expressions are useful for percent of total or difference from overall average scenarios. They are comparable to such features as totals and reference lines. Exclude level of detail expressions cannot be used in row level expressions where there are no dimensions to omit, but it can be used to modify either a view level calculation or anything between, that is, you can use an exclude calculation to remove dimensions from some other level of detail expressions. So to understand exclude level of detail expressions in Tableau in a much more detailed way, let's get back to Tableau and try to execute some examples. Now we are back onto Tableau. Let's create the exclude level of detail expression example. So I'll be renaming the sheet exclude LOD. Now we have created a new sheet and renamed that as exclude LOD. Now this particular sheet will be used to calculate the level of details which excludes the region from a calculation of sum of sales. Now for that, let's try to create a new calculated field. For that, let's select the analysis, select create calculated field. Now let's rename this as exclude region. Now let's select OK. Okay, we didn't write the expression over there. Now let's edit it, and in the tray let's write the expression. Let's select exclude, and in that let's select region. Then let's write in the sum of sales. Let's close the flower bracket. Now let's select OK. Now we have the new field over here, which is the exclude region. Now we'll be using this particular field to create a new visualization on the screen. Now let's drag the region to columns. Let's drag the sum of sales to columns. Now let's drag the order date to rows. Now let's select the month. Let's kind of change this chart to bar chart. Now this is more likely good to view. Now let's drag the newly created field, that is exclude region, onto color so that we can have different colors. Now this particular step will help us to view the total sales by month without the regional component. So this is how the exclude level of detail expressions will be used in real time. Now we can actually make a little change to this by selecting this one and right click it, or we can go to colors directly and right click the colors and select the edit colors, and inside this we're gonna select kind of orange to blue. Orange to blue diverging, so that we can have a good level of visualization. Now let's move on to the next type of LOD expressions in Tableau, which happens to be the fixed level of detail expressions. So the fixed level of detail expressions compute a value using the specified dimensions without reference to the dimensions in the view. Now let's get back to Tableau and try to execute an example based on fixed level of detail expressions in Tableau. Now we are back on Tableau. Let's create a new sheet and rename that sheet as fixed LOD. Let's type an enter. Yeah. Now let's get back to the analysis menu. Let's create a calculated field. Let's rename this as sales by region. So we have the sales by region over here. Now let's get back to the tray and try to add in our expression. So we shall be using a fixed expression over here, fixed, and now let's type in region, then sum of sales. Let's close the flower bracket. Now the expression is valid. So we have the sales by region LOD, which is the fixed LOD. Let's select OK, and you can see the newly created field on the measures section. Let's drag the region onto rows, and then let's drag the state into the region of rows. So now we have a text table. Now the view level of the detail is region plus state, but because fixed level of detail expressions do not consider view level of detail, the calculation only uses the dimension referred in the calculation, which in this case is region. So because of this, you can see that the values of the individual states in each region are identical. If the include keyword has been used in the level of detail expression instead of fixed, the values would have been a little different for each state, because Tableau would add the dimension in the expression, that is the region, with any additional dimensions in the view state when determining values for the expression. Now with this, let's get back to the presentation again. So the next segment in this particular today for our discussion is the tables versus LOD expressions. So now we'll be discussing the differences between the tables and LOD expressions. So the first one is filters. Filters involved in table calculate behave like hide, and filters involved in LOD calculations behave like exclude. The next difference is table calculations are generated as query results, whereas the LOD expressions are generated as a part of query to the underlying data source. The third difference is table calculations are capable to generate either equal or less granular than the said LOD or level of detail. But whereas on the LOD expressions case, the level of detail expressions can generate results independent of the said level of detail. The fourth difference between the both is table calculations are used as aggregated measures, whereas the level of detail expressions can be used in other constructs. The final differences between the table and LOD expressions is the dimensions that control the operations of a table are separate from the calculation syntax, whereas in the LOD expressions, dimensions that control the operations of an LOD are embedded into the expression itself. Now with that, let's continue with the next part of this particular tutorial, where we will be discussing the limitations of LOD expressions in Tableau. So following are the limitations of LOD expressions in Tableau. So the first one is LOD expressions behave unreliable views when floating values are involved. So LOD expressions that reference floating point measures tend to behave in an unreliable fashion when used in a view that requires a comparison of the values in the expression. The next one is LOD expressions will not be shown in the data source. So the LOD expressions will not be available in the data source page when you are using them in real time. Followed by that, the next limitation is you should always keep in mind when referencing a parameter in a dimensionality declaration, always use the parameter name and not the parameter value. Followed by that, the next limitation of LOD expressions in Tableau is with data blending, the linking field from the primary data source must be in the view before you can use an LOD expression from the secondary data source. So first up, what exactly is data blending? So data blending is a method for combining data from multiple sources. Data blending brings in additional information from a secondary data source and displays it with data from the primary data source directly in the view. So it might be a little complicated to understand, so let us make it a little simple. Let's imagine that you have data. Some of your data is present in your SQL database, and some of your data is present in Excel database or Excel worksheet, and some data is present in your cloud, say Salesforce. So your duty is to combine all your data from different sources, that is SQL, worksheet, Salesforce, and work on it. So you might have a question here. We already have joins, but joins and relations have their own limitations or drawbacks. So to cover that up or overcome those issues, Tableau has come up with data blending. Now let us take a step further and understand what exactly I meant by joining and relationships and data blending. So as we discussed before, the data blending is a method for combining data from multiple sources. Data blending brings in additional information from a secondary data source and displays it with data from the primary data source directly in the view. Yeah, this was a definition. You can take a screenshot of this and you can keep it for further reference. Now, as we discussed, there are some existing ways to combine your data, such as relationships, joins, etc., etc., and then we have the data blending option. So first, relationships. So why exactly we do not prefer relationships in a few situations? Relationships cannot be formed between tables from data sources published to Tableau Server or Tableau Online. So relationships can't be formed based on calculated fields. When you use data blending, you can create calculation fields. Those are called as data blending calculations. Now next thing is the joins. Joins combine tables by adding more columns of data across similar row structures, and this can cause data loss or duplication. So when you use joins and create the relationship between multiple data sources or multiple tables, then there is a chance that the data can be duplicated. So just imagine that you have two different tables, and the two different tables have one common field, such as ID. So even a student ID has ID and employee ID has ID. If you use a join, then there are chances that you might get IDs of both employee and student. So that's a duplication, right? So to avoid that, you can go with a data blending. Now, data blending, unlike relationships or joins, never truly combine the data. Instead, blends query each data source independently. The results are aggregated to the appropriate level, then the results are presented visually together in the view. That's the reason why we use data blending. Now up next, we have the data blending example. Now this is where we get into the practical mode. We'll get back to our data first. We'll see what kind of data we are going to use for this particular example and what are we going to do with that data in the Tableau.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
So this is the Excel sheet which has the car sales dataset that we'll be using today. So this is one of the datasets, and we have another dataset. Let me So we have another dataset which I personally created. So this is a little similar to the cars dataset. So I've created this dataset a little bit similar to the car sales dataset so that we can use this in the scenarios of data blending so that you can understand the concept in a much better way. So we have the following columns: the manufacturer, model, resale value, engine size, horsepower, wheelbase, fuel capacity, fuel efficiency, annual sales, and region. And when we come into the bike sales, we have the same kind of columns. So we have the manufacturer, model, engine size, horsepower, fuel capacity, fuel efficiency, annual sales, and zone. So you can see that this zone and region from the car sales dataset are similar, but the name is different. So there's a reason I've created a different name for this particular column, so that while we are working on Tableau data blending, we'll be actually blending these two columns as a custom blend. So this is why I've named this particular column as zone. And yeah, so far so good. I think we are good with the dataset. Now we'll get back to Tableau and start working on these datasets. Yeah, so now we are on Tableau. Let's since we're working on Excel, let's create the Excel. And yeah, here we got our Excel files. First, let's click in car. Yeah, there we go. We have the car dataset over here. And if you see, we have got some additional columns which we don't need. So the actual column we had was this. When I downloaded the dataset, this was the actual column which has sales into 1000. Actually, we had 16.919, which I multiplied here. Okay, so I had made some changes to the dataset in the Excel file, and I've hidden the actual dataset, so we don't need this one over here. So we'll do the hide option over here as well. So that's gone over here. Now let's kind of rename this as annual sales. Enter. And we don't need this F column, so this particular F column was created for a formula on Excel into sales into 1000, so we don't need this one as well. We'll remove this, hide, and the resale value, and another F1 here. We'll remove this. Now engine size 1, why don't we rename that as engine size? Done. And do we have any other extra things? No. And annual sales too, yeah, that's gone as well. So the region, manufacturer, model, annual sales, resale value, engine size, another engine size. Okay, this was a problem. So when you look into the engine size over here, okay, and here, so when you look at the engine size here, this is the actual engine size from the datasets, the original one. So it is represented in the form of liters. So basically the car engines are always represented in the form of liters. So 1.8 liter engine, 3.5 liter engine. But when you come into bikes, they represent the engine size in the form of cc's, that is cubic centimeters. So the bikes have 650 cc engine, 1030 or 1340 cc engine. Yeah, that's how we represent the engine size in bikes. So to make things similar, I have created the engine size in cc in the form of cc over here. You can see that over here. So 1.8 is equals to 100 or 1800 cubic centimeters. So we don't need this particular column here, so we'll eliminate this or we'll hide this. So far so good. We have horsepower, engine size, resale value, fuel capacity, fuel efficiency, region. Yeah, everything is fine now. So now the next step is to add the second data set or the second data source. So you can do that by selecting this particular icon over here and select a new data source, or there is another way. You can enter into your worksheet, and you don't have to enter into your worksheet. You can do that from here as well. You can select the data and add new data source. So these are the various options. You can select a new data source from here, or you can select a new data source from here, or if you're on the sheet, then you can go again to the data section and you can select the data source from here as well. Or you also have a shortkey. So when you see it, so you have a shortkey here which says Control Okay, sorry. So you can read it right on the right hand side of this particular dialog box, Control D. You can directly press Control D and add your new data source as well. So now we'll add the new data source. So since another dataset that you're working on is also an Excel file, we'll select the Excel file. So that was bike sales, and yeah, there you go. We have a bike sales dataset right on my screen right now. So in here as well, you can see some excess or unnecessary columns. So we'll remove that as well. So we'll hide this, we'll hide this, we'll hide this as well. Now we have engine size, horsepower, fuel capacity, efficiency. Okay, we have our annual sales here. So I've changed a few numbers in this particular annual sales column. These are not accurate. So I've created some random numbers just so that they're different from the car sales. So yeah, so far so good. We have this zone over here, the regions column from, yeah, let me show you that. Let's go to the sheet. Yeah, so when you see cars, we have region over here. Okay, so when you get into cars, we have the region over here which has the north, south, east, west, and similarly when you get into bikes, we have the zone which has the north, south, east, west, etc., etc. So we are now going to create the blending between the two data sets. So we have the data set over here which is the bike, and we have another data set over here which is the car. So to create a blend, let's get into data, and you can see the edit blend relationships row in the dialog box, or the option in the dialog box. So remember, when you just have one data source, just imagine that you only had a cars data set, only one data set. Or let us remove this. How do you remove this? Close. So we just have one data set over here, which is the bikes data set. So now when you click on data, you don't have that option. See it, you don't have that option, edit blend relationships. But when you get a different data source, so we have car sales over here. Now let's get back our okay, did we had the cars over there? Sales bike, we have the bike sales over here. Now let's get back our cars data set. Yeah, okay, sorry, we can make the changes again, not a problem. So we'll remove this, we'll rename it. On this note, let me tell you guys, if you are getting some errors, or if you're getting some kind of troubles while you're learning, it's a sign that you're trying your best. So we have Simplilearn community, which has the solutions to your problems. So if you have any problems while you're learning, then you can directly post your query over there, and our team of experts will be really happy to help you out with the solutions. So we have our annual sales over here, and another annual sales which we don't need, so we'll hide that. We have the manufacturer, model, annual sales, resale value, engine size. So I think we don't need this engine size, which is in the liters. Now we'll rename this as engine size. Great. Yeah, we're done. So we'll get back to our sheet. Now when you hover over to data, and you can find the data blend relationship option over here. So this happens when you have multiple sources only. Now let's click that, and you can see we have the automatic option, and Tableau has automatically found a data blend option for the columns which have the same names. So we have manufacturer, model, and manufacturer and model in both bikes and cars. So we also have the same names for annual sales, engine, fuel efficiency, horsepower also. So they are in the measures section. That's the reason the Tableau has ignored them. So, and remember that we have regions in cars and zone in bikes, but we can't find that relationship over here because they have different column names. to get a blend between those columns, we can always choose custom. So when you choose custom, okay, we don't have a zone over here. You need to make some changes, I guess. Yeah, we need to press add icon, and from add you can see the region from the cars dataset and zone from bikes dataset. Select OK, and then you can find a blend relationship between the region from cars and zone from bikes. Now we have the blend successfully applied. Let's select OK and we are done. So let's begin with our operations. So currently we are in bike sales dataset. So if we start the operations on bike sales dataset, for an example, let's choose zone into columns and annual sales into rows. So you can see a little tiny blue tick over here. So this particular little tiny blue tick represents that this has now become your primary data set or primary data source because you're currently working on that particular data set. Now if you remove the zone and annual sales, and again if your sheet is completely empty, and if you enter into the cars data set and again choose regions and regions onto columns, again the same thing, drag the annual sales into rows. Like I'm just showing you, if there is some operations happening with the particular data set, then you can find the blue tick icon which says that you're working on this particular data set. So that's how we see it. Now, so this is how you find the sales happening in that particular region. And yeah, we can create another sheet, and now we'll see which model has the biggest engine. Now let's kind of sort it. So Viper has the biggest engine, Dodge Viper. Yeah, a muscle car of America. Now let's create a different sheet. Now let's get back into bikes dataset. Which is the most fuel efficient bike? Row and model. So now, according to the dataset what I created, Multistrada 950 has the biggest mileage. That's great. Okay, it shouldn't give 50. Maybe I think I entered some wrong value. Yeah, SV650. Or we can actually take a manufacturer over here. And so SV650 belongs to, let's sort it. Where is SV650? Yeah, SV650 belongs to Suzuki. Great. So SV650 has a good mileage next to Multistrada 950. So this is how you can use sheets and data from different datasets. Now moving forward, let's create some data blending calculations. For that, let's create a new sheet. Now we have created a new sheet. Now let's rename it as data blend calculations. Now we have successfully renamed our sheet as data blending calculations. Now we are in car sales. So let's drag the manufacturer into columns and sales, annual sales of the manufacturer into columns. So we have the report of annual sales of different car manufacturers over here, Ford leading, and we have Porsche, Subaru, Suzuki, Hyundai, etc., etc. Now let's get back to bike sales and drag the same annual sales from the bikes dataset into rows. So as you can see on my screen, you have the annual sales for cars and bikes together on one single screen. So here we have Suzuki as well, which is a bike maker, and Ford, etc., etc. are the car makers. So other than bikes, we have another 28 nulls which do not belong to the bike section. Now our aim is to create a new calculated field which is about the data blending calculation. So you can see that a little icon over here which represents the blend icon, and you can always select that to stop the blending, and you can click on that to use it as a linking field. So that's how you can use the blend icon. Now we are about to create a new calculated field, so you can right click and create a calculated field, or you can always choose the icon over here and create a calculated field. So now we have the calculated field over here. Let's rename it as data blend calculation. Now we have successfully renamed our calculated field as data blend calculation. Now we'll find the sum of sales happening in cars and bikes. So for that we'll be using the summation of sales or annual sales. Now we have the annual sales sum of bikes. Now we'll add the cars one. For that I'll be selecting plus and sum of annual sales of cars. So you can see that we have two sums over here, so we don't need that second sum, so we'll eliminate that. So we have another bracket over here which we don't need, so we'll eliminate that as well. So now the calculation field is valid. Let's click apply and OK. So now you can see a newly created calculation field over here with the icon equals to hashtag, which says that it's a calculated field. Now let's drag this calculated field into the rows icon, and you can see the sum of both sales happening in this particular segment here, which shows you the sum of sales of both cars and bikes. Now you can see that we have 28 nulls over here, right? So we should be having all the, when you're calculating the sum of annual sales of both the data sets, then you should be having something over here. So for that we need to make a little addition over here. That's a function zn. Now after adding zn, okay, we lost the sum, so we need to add the sum again, and sum of annual sales, or we can just add it over here. Okay, this should be pretty good. Now we need to add another zn over here and another sum over here. Close the bracket. Yeah, this should be good. Yeah, the calculation is valid now. Let's add apply and OK. Now we have the annual sales of both cars and bikes and Suzuki combined, BMW combined as well. So that's how we do the Tableau data blending operations. So with that, let's get back to the presentation mode again. Now the next part in our tutorial today is the data blending versus joins. So what are the differences between data blending and joins? So this particular short data table should explain you the differences between them. So in data blending, the data gets aggregated first, then the data gets combined. But where in joins, the data will be joined first or combined first, then the data is aggregated. And the second difference is when we use data blending, the data set is from different data sources. But when you use joins, you need to make sure that the data is coming from a single source. Now when we come into the data blending again, you can only use left join. So you can consider data blending as an advanced version of joins, but only the left join can be applied. But when we come into joins, we have the different types of joins like left joint, right joint, etc., right? We have different types of joins. So that's how we have a difference between joins and data blending. The fourth difference is data can be available in different level of granularity in data blending. So the level of granularity can be maintained at a different level when you have, or different levels when you use data blending. But when you use joins, all the granularity of all the data should be maintained at a same level. And the last difference between the both is data blending sends separate query to each dataset and aggregates, then performs blending. And the last difference between the both is when you use data blending, the data blending sends separate query to each dataset, then aggregates them, and finally performs data blending operations. But when you use joins, the queries will be sent to the data at a row level. So with that, let's enter into the next segment where we will discuss about the limitations of data blending. So the limitations of data blending are as follows. Data blending compromises the query execution speed in high granularity. So when you have the higher rate of granularity on your datasets, then obviously the execution speed will be compromised. Next, while sorting a calculated field that uses blended data, that field is not listed in the sorted field drop-down dialog box. And the last limitation is cube data sources can be used only as a primary data source to the blend data in Tableau and cannot be used as a secondary data source. Now without further ado, let's directly begin with the one-point agenda, that is the charts in Tableau. So for the charts in Tableau, I'm using two different datasets. to just make things look a little bit more interesting. So the first dataset that we will be dealing with is the Amazon Prime TV dataset. So this particular dataset has the following columns: the serial number, name of the serial, year of the release, number of seasons, language, genre, IMDb ratings, and age of viewers. So we will be using this particular data and we'll try to extract some insights from this data using the charts in Tableau. So followed by Amazon Prime TV dataset, we have another dataset called as the Tableau Superstore dataset. So this particular dataset is a sample dataset available in Tableau Public and it is open for all. You can take this dataset and try to extract some insights from this as well. Now without further ado, let's try our first chart, that happens to be the bar chart. So what exactly is a bar chart? As you can see on the left side, we have a sample image which explains how a bar chart typically looks like. So a bar chart basically represents the data in the form of rectangular bars with the length of the bar proportional to the value of the variable. Now this might be a little deviated, I can understand that. So to understand this in a much more better way, let's get back to Tableau and execute some practical examples and understand what exactly is a bar chart in a much more detailed way. So here we are on the Tableau. So you can see I have already executed some examples on the Amazon Prime dataset, and we have all the charts that we'll be going to discuss today. We have the bar chart, Pareto chart, side-by-side bar chart, text chart, tree map, etc, etc. Now why am I showing this? So I have actually saved this dataset, or what do you call it, as book. Yeah, we call it as a book in Tableau. So I've executed all the charts and I have saved this in the form of a book in the Tableau Public. And I'll also give the link to this particular book so that you can have a reference to this and you can try to execute your examples on your own in your local system. Now for our reference, let's try to create a new sheet. So we can name this new sheet. Just double click on that. So I'll rename this as bar chart 2 so that we don't have a confusion between the existing bar chart and the new bar chart. Just press enter and it's done. So to execute a bar chart, let's select genre and drag it down to columns, and the Prime TV shows and drag it down to rows. Now you can see that we have a bar chart here which explains us we have different genres such as action, comedy, adventure, animation, etc, etc. So now let's kind of sort it. So now you can see in the particular type of genre, which is drama, we have the most number of Prime TV shows. So basically the audience would like to see the drama based seasons or serials at the most compared to others. So remember we discussed the length of the bar which shows the volume of the variable. Let's get back to the definition once more. So you can see a bar chart represents data in the form of rectangular bars. That is, we have the data represented in the form of rectangular bars, and continued with that with the length of the bar proportional to the value of the variable. So we have the drama at the maximum number of series, so 125 number of shows based on drama. So this happens to be the biggest one, and followed by that a little smaller one which has a little less number of seasons or shows, which is the type genre comedy. So you can see that if the value is bigger, the volume of the length or the length of the bar is bigger. So that's how the bar chart works in real time. So it basically shows the biggest bar for the biggest amount of data. Now followed by the bar chart, the next chart we have is this side-by-side bar chart. Now what exactly is a side-by-side bar chart? So a side-by-side bar chart is completely similar to the bar chart. No rocket science or nothing big difference in between the bar chart and the side-by-side bar chart. If we get back to Tableau, you can see that we have different genres here. So we have drama, comedy, kids, action, etc, etc. So if we wanted to change this into a side-by-side bar chart, then we can add one more data into the columns, which happens to be the name of the show. So what exactly will be happening here? So we will be getting few more bars over here. So those few more bars will be of the name of the show. So in the genre of drama, we'll be having different shows, right? For example, the show name A is in the form of drama, show name B is in the form of drama, and followed by that we have AA in comedy, BB in comedy. So that's how you categorize. So basically the bars will be represented, that's for sure, and the data is represented in the form of categories. So we have few serials in the drama category, we have few serials in comedy category. So that's how it happens. Now let's see that practically. Now let's drag the show name to columns and we'll see that happening. So you can see that happening over here. Now let's kind of sort it again. Yeah, it's sorted. So you can see we have the first category, that is the arts, entertainment, culture. So in that particular category we have different shows, Tommy Little and Son of Abisha and Paul Chowdhury, etc., etc. So basically we have categorized them and we have the side-by-side bar charts comparing each other. Now we'll get back to a little farther, and there you can see we have the genre here and the series happening in this particular genre. So this is the drama genre, and inside that we have various amount of series, The Good Fight, The Good Doctor, etc., etc. So that's what the bar chart does in real time. So basically we had the same bar chart, but the only difference is the fields were divided in different categories. Now followed by the side-by-side bar chart, the third type of chart that we will be having today is the Pareto chart. Now what is a Pareto chart? So Pareto chart has bars and a line graph. So far we have discussed bar charts. We will also discuss the line graphs in the further section. So line graph is no different from bar charts, but the only difference is you can see here, right? So if we pull out the names, so we have this bar chart. So we can actually change this chart into a line chart just by clicking on line. So you can see this has converted into line chart. So we'll deal with that in a little more detail. We don't worry about it. So this is how a line chart basically looks like. So I have explained you the line chart just because we have the two different types of charts in the Pareto chart. So there is an inclusion of a bar chart as well as a line chart or the line graph. So a Pareto chart has bars and line graph. The individual values are shown in descending order by bars, and the ascending cumulative total is represented by the line. So we will understand the definition in a bit more detail practically by getting back onto Tableau. Now let's get back to Tableau 1. So now we are back on Tableau. Now let's create a new chart or new sheet. Let's rename the sheet as Pareto chart. Don't worry, we have already a Pareto chart over here. I'll just rename it as Pareto 2. Don't worry, at the end of the video I'm not going to save anything onto this particular book. We'll be having the book as it was when we started the tutorial, so that you don't have to face any duplications in this particular book. So Pareto chart 2, enter, and now we have the Pareto chart 2 over here. So to create a Pareto chart, let's drag the genre into the columns. Yeah, now we have the genre into the columns. Now into the rows we'll drag the number of Prime TV shows based on that particular genre. So now we are back on the bar chart now. Tableau has automatically selected the type of chart to be used for this particular data, which is the bar chart. Now let's right click on the genre, and now you can see a sort option. Now we have the dialog box over here. Let's select the sort by option by field, and let's select descending order and aggregation by count. So we'll select this, and the aggregation is count, and it's done. Let's close it now. Now the second step is we will drag the Amazon Prime TV show dataset again onto the rows. Now we have two different bar charts. Now everything starts from here. We'll change few things so that we create a proper Pareto chart. Now we will select or right click the second count Prime TV shows, and now we will select dual axes. Now you can see the chart has changed itself into the dots type. Now you might have a doubt, We had two different bar charts. Now we just have one axis, that is y-axis and x-axis, and the two charts have gone into one. So what's happening here? So what's basically happened here is we just merged the x-axis of both the measures. So we have the measures over here, right? The count of prime TV shows and the second count of prime TV shows. So we have basically merged the x-axis of both these measures. Now we'll enter into the step 3. So now you can see on the marks card, we have two different count prime TV shows. So we'll now select the first one, and inside that we have the pop-up of marks card where we have the options of selecting the kind of charts for our data. And now for the first one, we will select the bar type of chart. Now you can see that we have the bar type of charts over here. Now we will select the color for our bars. So to select color, you just need to select the color option, and inside that we have various types of colors. Now let's select kind of green. So we have green over here. Now let's get back to the second count of prime TV shows, and inside here let's select line. So we have line over here. Now we can actually kind of select the color for that as well. Now we'll select some opposite color for that. Let's select pink. Or you can also go with orange, kind of more visible. Yeah, we are done with the color selection. Now the next step. Now we'll get back to the second measure over here. Now we'll right click it, and inside that we will select add table calculation. Now we'll select the calculation type, and we needed the running total of this, and we're gonna compute this using table across. And the most important step is the last step, to select the add secondary calculation. By clicking on this, we'll have another dialog box, and we need to add some more details into this one. So here we'll be selecting the difference from, and we'll change that to % of total. And next we'll select the table across, which is the default one over here, and we are done. So as discussed in the definition, the individual values are shown in descending order by bars, and the ascending cumulative total is represented by the line. So you can see the individual values of the genre are represented in the form of bars, and the ascending cumulative total is in the form of line. So this is how we use the Pareto chart in real time in Tableau. Now moving ahead, the next type of chart that we will be discussing today is the text chart. There is nothing much of a rocket science in text chart. It's just a simple tabular way of expressing your data. Text charts are created by placing one dimension on the row shelf and another on the column shelf. Text tables are also called as crosstabs or pivot tables. Now let's get back to Tableau and try to execute a simple example. As you can see in this particular book, I have already executed a text chart. Now to avoid confusion, let's try to recreate another sheet and rename it as text chart 2. It's done. Now let's drag in the genre and the name of the show to the rows. So you can see that the Tableau has automatically selected the text chart for this particular data, and we have our text chart over here, which shows us the genre, which is action, the name of the show's under genre category, and similarly action, comedy, adventure, animation, etc., etc. Now with this, let's continue with our next type of chart. So the next type of chart that we will be dealing today is the waterfall chart. So the waterfall chart displays the cumulative effect of sequential positive and negative values. It shows where the value starts, ends, and how it goes there incrementally. So the waterfall chart is a little complicated than the other charts. Now I want you guys to follow me up a little bit more cautiously. Now let's continue with the waterfall chart. So for that, let's drag the language from dimensions into columns and prime TV shows data from measures to rows. Now we have our bar chart over here. Now the next step is select the prime TV shows data, which is in the rows. Now the same thing is in the measures as well. So keep in mind that you need to select the prime TV shows from the measures. Let's right click on that and you can see a create option, and inside that select the calculated field option. Now let's rename this, and remember to add a negative symbol. Now I'll tell you why we are going to add the negative symbol. As we progress into the waterfall chart, we convert this particular bar chart into a Gantt chart as a step of the process. So in that particular stage, we might have to make some space between the bars. So that's the reason we have selected negative of count over here. You'll see that happening in the next steps. Now you can see we have a new measure, which is the negative of count. Now let's drag and drop that onto our size option in the max card. So you can see I've selected the negative of count, which is in this particular case. The complete uppercase is for the first waterfall chart what we made. So we have our chart over here. Now let's get back to our rows. Click on this option. Now we have our quick table calculation option, and that will be selecting the running total. Now we are almost done. Just one step is remaining to convert this particular chart into a Gantt chart. So there you go. We have our waterfall chart over here. Now the next one in the list is the heat maps. So you can see how a typical heat map in real time looks like. So a Tableau heat map is used to display the data along with colors. We can create a heat map using one or more dimension member and measure value. Now let's get back to Tableau and try to create a heat map. Let's create a new sheet, rename it as heat map 2, enter, and there we have our heat map. Now let's drag in some data to create a heat map. So for that, let's select genre from dimensions and drop it down to, no, we're not going to drop it. So we'll be selecting both the data at once. So the genre one. Now let's hold the control button and select the number of seasons from measures. Now we will go to show me option, and you can see that we have various options over here. So this particular icon is for heat maps. Now let's select that. Now we have the heat map. Now let's drag the IMDb rating from the measures into size. And this one, IMDb ratings into size, so that we have the different sizes for the boxes over here. So the biggest one here and this next leading one over here. Now the problem is we have the same color for all the boxes. Now for that, let's try to drag the genre into color so that we have different color for different genre. So that's how the heat maps are done. Now the next chart in the list is the Gantt chart. So a Gantt chart looks something like this. Now what exactly is a Gantt chart? Gantt chart shows the progress of the value of a task or resource over a period. It is used in project management and other types of variation study over a period. Now to create a Gantt chart, we will be using the second dataset, which is the Tableau Superstore dataset. So I have already created a Gantt chart over here. This is how a sample Gantt chart looks. So we have discussed that a Gantt chart is used to study the variation in the standards for over a period of time. So here we are selecting the first class, same day, second class, standard class deliveries over a period of time. So we have the dates over here, or we can say that the period of time has been selected in the form of dates or day. Now let's recreate a Gantt chart and see how it's practically done. So for that, let's create a new sheet, G. Now we'll follow this in a step-by-step way. First, let's drag the order date into columns. Now let's select this or right click it and change the order to day. Now we have the days 1 to 30 in a month. Now let's move on to the menu bar and let's select the analysis button, and in that let's select create calculated field. Now we have our calculation tab over here. Now let's type in the calculation. Now we are going to use this particular Gantt chart to study the shipment. Now once the creation of Gantt chart is done, we will study how the shipment is done based on what kind of class is selected for shipment as the days passed. Now inside the calculated field, we'll write the formula date difference. So this is the one, and inside that we'll be going to select the day, next order date, next ship date, so these particular order date and ship date are from dimensions, so just when we type them, we had them readily available. Now our formula is ready. Let's just select OK. Now in the measures segment, you can see we have a new input or new addition, which is the ship, the formula what we just created. Now we are going to select this and drag this onto the marks card, and on the marks card we are going to drop it on the size. Now our Gantt chart is almost ready. The only thing remaining is to drag the ship mode to rows so that we can have the details of that particular shipment mode, the standard one, the first class one, etc, etc. So for that, let's drag in the ship mode from the dimensions to rows. So there you go, we have a shipment mode. Now the next type of chart that we will be dealing with today is the pie chart. So pie chart represents data as slices of a circle with different sizes and colors. The slices are labeled volume and the volumes are represented in the form of a chart. Now let's continue with the pie chart. So to create a pie chart, let's select the language option from dimensions and hold Control button and select the number of Prime TV shows, and you can see the show me icon over here. Let's select that, and inside that you can see a pie icon over here. So just select that and we have a pie chart over here. Now I can see that the pie chart what we created looks a little bit smaller, so don't worry. Now let's just select the standard option here. From that, let's select the entire view, and there you go, we have a little bit more bigger pie chart. If you're still not convinced with the size, you can just go to the size option and try to increase the size, and there you go, you have the pie chart. Now the next type of chart available in our list is the bubble chart. So the bubble chart looks something like this. So bubble charts display data as a cluster of circles. Each value in the dimension field represents a circle, whereas the values of measure represent the size of those circles. Pretty simple. Now let's get back to Tableau and try to execute a bubble chart. So this is how a standard bubble chart looks like. Now let's create a new sheet. Rename this as bubble. Now let's select genres from dimensions and number of seasons from measures. Now the genre will help us to know a particular value, and that particular value will be a circle in the bubble chart, and the number of seasons will provide the size of the bubble. That means the highest number of seasons for a particular genre will be having the biggest circle. Now let's select the show me, and inside that you can see the bubble chart. Let's just select that, and you can see we have different circles and different sizes of different circles. Now we have the same color for all the circles. To change that, let's drag genre into color, and now we have different color for different genre. Now the next type of chart that we will be dealing is the histogram. Histogram is one of the simplest charts available and also easiest to create. So histogram is a chart that displays the shape of a distribution. Histogram looks like a bar chart but groups values for a continuous measure into ranges or bins. Now to understand this better, let's get back to Tableau and try to create a new chart. So we are back on Tableau. Let's rename this as histogram. Let's just select enter. Now let's select the IMDb ratings, Now we'll be using the IMDb ratings measure to create a histogram, and we'll be having the biggest bar for the highest rating of IMDb. Now we have selected IMDb rating. Just hover over to Show Me tab, and in that you can see the histogram tab over here. Let's just select that, and we have the histogram chart on our window. So there are many shows, and each and every show has specific number of IMDb ratings. So a maximum number of shows are having 7.2 as the IMDb rating. Now followed by histogram, we have the next type of chart, that is the highlight table. So highlight table is completely similar to the text table that we have already dealt with. The only difference is we have various colors for various data cells inside that particular table. Now, in Tableau, highlight tables are used to compare categorical data using color and represented in the form of tables. That's what we discussed. Now, let's get back to Tableau and try to create a highlight table. Let's create a new sheet and rename it as HD. So to continue with the highlight table, let's select genre from dimensions and hold Control button and select the number of seasons available. And when you hover over to Show Me, you can see a table called Highlight Tables. Let's select that option, and you can see we have the highlight option over here. Now you can see that we have different colors for different number of seasons available in that particular genre. Now you can see that they are not ordered, so let's just select the sort option and sort from descending order. So there you go, we have the highest number of seasons available for drama, that is 339. Now the next type of chart that we will be dealing is the line chart. So a typical line chart looks something like this. So the line charts connect individual data points in a view. They provide a simple way to visualize a sequence of values and are really useful when you want to see trends. Now let's get back to the Tableau, and here we are going to use the Superstore dataset so that we can have a look on the trends. Now let's create a new sheet and rename it as line 2. Now let's drag the profit into rows and see if the profit is increasing day by day or not. As you can see, the Tableau has automatically selected the line chart for us, and there you go, we can see that the profit is increasing day by day or year by year. We can just kind of select the plus icon over here and see we can have a quarterly update over here. So Q1, Q2, Q4 of the year 2014 and 2015, 2016 and 2017, the Q1, Q2, Q3, Q4. So that's how we use the line graph. Now the next type of graph that we will be dealing is the bullet chart. So a normal bullet chart looks something like this. So a bullet graph is a bar graph that replaces dashboard gauges and meters. It is used to compare performance of a primary measure to one or more measures. Now let's get back to Tableau and see how a bullet chart is made. Now let's create a new sheet. Let's rename it as bullet 2. Enter. Now for a bullet chart, we'll start with the analysis button on the toolbar or the menu bar. Click analysis and now select create calculated field option. Now inside that, let's try to set an average for profit. So we can kind of estimate a profit over here. So let's rename it profit estimated. So basically we are going to use the bullet chart to estimate the profit in future. Now inside that, let's have an average value. So average value of profit must be something nearly 250 to 300. So just write in 275,000. Just select OK. So this is the average what we're expecting. This must be the average amount of profit that we should be facing in the near future. Now we have a new measure in the measures section, that is the profit estimated. Now just select that and hold Control, and now we're going to select profit. Now we are going to hover over the Show Me option And there you go, we have the bullet graph option over here. We're going to select that, so we have the bullet chart over here. So there you go, we have the bullet chart over here. We can kind of increase the size of that as well. So there you go, that's how we use the bullet chart in real time. Now the next type of chart that we will be discussing today is the scatter plot. So scatter plot shows how points are scattered in Cartesian plane. It is created by plotting values of numerical variables as x and y coordinates in the Cartesian plane. Now let's get back to Tableau and see how scatter plot is used in real time. So we are back on Tableau, so a scatter plot should be looking something like this. Now let's try to recreate a new scatter plot sheet. Let's rename it as scatterplot 2. Now to create a scatter plot, let's try to drag the genre from dimensions into columns and the sum of seasons from measures. Now we have the bar chart by default. Now let's just select the marks card, and inside that let's select the shape option. Now we have the data scattered across the different points in the Cartesian plane. Now just select the genre and drag it into color, so we have different colors for different genres. So this is how the scatter plot looks like. Now let's continue with the next type of chart, that is the area chart. So an area chart is a line chart where the area between the line and the axis is shaded with a color. Now let's get back to Tableau and see how exactly an area chart looks like. So an area chart looks something like this. So let's try to recreate area chart once again. New sheet A2. Now we're going to see how the sales are happening according to a particular area. For that, let's select order date and hold Control and select quantity, so that we can have a sheet which shows us the sales happening in quantity on particular dates. Now we have the Show Me tab and we have the area chart option over here. Let's just select that and we have the area chart over here. Now you can see that we have one single color for all the sales and quantity. Now to have the details of the regions, like in what region what kind of sales are happening in what quantity, we want to select the region and drag that over color. So we have 4 different colors for 4 different regions: the central, east, south and west. So this is how we use the area chart. Now followed by area chart. Now the next type of chart that we will be dealing is the dual axis chart. So what exactly is a dual axis chart? So a typical dual axis chart looks something like this. So dual axes are 2 independent axes that are layered on top of each other. According to Tableau, dual axes allow you to compare multiple measures. Now let's get back to Tableau and try to create a typical dual axis chart. So a typical dual axis chart looks something like this. Now let's try to recreate this one. Create a new sheet, D2. Now the dual axis chart is really simple to create. Let's select order date from dimensions, hold the Control key. Now you want to select the quantity from measures. Now again hold the Control key. Now you also have to select the sales options. So we have selected the order date, quantity and sales. Now we are going to select the dual axis chart from Show Me. So we have the dual axis chart on my screen right now. So what we are going to learn from this is we are going to learn the quantity of sales happening according to the years. So in the year 2014 we have the quantity of sales which is something around 7.5k, and it has grown gradually from 2015, 16 and 17 and reached above 12k. So this is what we get to know from dual axis chart. So the number of sales happening and the quantity of sales happening. So the line shows us the number of sales and the bar shows us the quantity of sales. Now with this, let's continue with the next type of chart in our list. So the next type of chart that we will be dealing is the symbol map. So the symbol maps are simply maps that have a mark displayed over a given longitude and a latitude. So now we are back on Tableau. Now let's try to execute the symbol map. So symbol map looks something like this. So we have the number of sales happening in a particular country and a particular city. Now to create a symbol map, let's select city, hold control, country, and again hold control and select sales. Now you can see that we have two different maps over here. The first one is symbol map and the second one is maps. Now let's select the symbol map, and there you go, we have the symbol map over here. Now we have the same color for all these sales. Now let's kind of select sales and drag it to color. So we have different colors for different amount of sales happening. So the darkest one shows the highest number of sales and a lighter one shows the least number of sales. So that's how we use symbol maps in real time. Let's get back to the presentation again. Now the next type of chart that we will be dealing with today is the map chart. So a map view is one data point created since geographic role is assigned to a country. Tableau creates the map view as shown in the image here. So similar to the symbol maps, we can use the maps which shows the amount of sales or profits or anything happening in that particular country or city. Now let's get back to Tableau and try to create a map. Now a sample map looks something like this. Now let's try to create a new map. M2. Now to create a map, let's select country and hold control, and now let's select kind of profit. Yeah, so let's select the map icon here, and so now we have different colors for different profits. So this particular state or country says that we have a profit of 286,397 numbers, or it might be even dollars or something. We can also select the country and hold control and select sales. And now we can also select maps again. So this is how the map chart looks like. Now let's get back to the presentation. And the next type of chart that we will be dealing with today is the tree map chart. So what exactly is a tree map chart? So the tree maps are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measures to define the size or color of the rectangles. Now let's get back to Tableau and try to create a tree map. So you can see that we already have a tree map. Now we are back onto the Prime TV dataset. So we have used the genre and we have used the sum of IMDb ratings to create the tree map over here. Now let's create a new sheet and try to recreate the tree map so that we can understand how to create a tree map in real time. Let's rename it tree map. So the tree map is being recreated. Now just select the genre, and from that hold the control key and select the IMDb ratings. And now hold the control key again and select the number of seasons available. And now when you hover over to the show me tab, you can see the tree maps icon over here. Let's just select that. So there you go, you can see the tree map on the screen right now, and we have different colors for different genres. So the darkest color for the drama has the number of, or the highest number of IMDb ratings and the highest number of seasons available, and similarly so on. Now the least one is the comedy, arts, entertainment, culture, with the least IMDb rating of 6.2 and only the number of seasons available are 1. So this was the last type of chart that we had to deal with today in this particular Tableau charts tutorial.
Today we will be building dashboards from start to finish. First about world population, then health. Next we'll build a dashboard about economy, and finally we'll build a dashboard about business ease. I would recommend getting access to the dataset before you start this tutorial so you can build along with me. If you would like access to this dataset, please comment below and we'll get you access. So first we're going to build a dashboard that revolves around population. So we're going to build a map based on country. So I'm going to double click on country, and it's going to map out all of the countries. And then on our marks, I'm going to change it to map. So it's a filled in map. And we want this to be colored by population total. And we can see who contributes the most to population. We're going to label it with population as well. But you can see that it's labeling it the total population, and what we want to label it is how much it contributes to population by percentage. So let's add a table calculation, and we're going to have it do percent of total based on country. Okay, so now we can see which countries contribute what percent. Let's also bring the country name onto the label, and let's put it on top. So country name's on top. Now it's getting a little bit crowded in here, so we're going to unclick Show Marks Label, and we're just going to show the ones that we want to see specifically. So when we can right click on China here, hover on Mark Label and click Always Show. And on India, since these are our two biggest contributors, we can see that this one's a little bit darker than the others in that area. And here, and that's just a manual way to choose which ones have indicators and labels and which ones do not. And we're going to put a note here, so we're going to annotate an area that explains that China and India contribute the most to world population. Just calling out this section of the visualization. And let's name this sheet. So here we have our visualization, and when you hover you can see both the total population and its percent contribution and the country name. Our next visualization for this dashboard is going to be population over time. So let's bring on our time element. But one trick for bringing on a time element, if we just drag it on, so year with the calendar mark here, if we just drag it on, it'll default to a discrete version. So let's take it back off. And then we could edit it there. But one thing you could do is if you, on a Windows machine, you right click on it and drag it on, then it will pop up with a dialog box that allows you to select what kind of date value you want to use in the first place. So we're going to use year here. And now we have, instead of discrete, we have a continuous axis. And we're going to bring on population total. And we can see that over time. One thing you can do when the value is up so high in your axis is you can uncheck this box that says include 0, and it will not always include 0 in your axis, but this can be misleading. So you can see that it looks like population growth is something really dramatic by increasing that slope of the line, whereas it really wasn't quite as dramatic as it seems. So as long as it's communicated well and you're not doing it to mislead your users, you just need to keep in mind that this include 0 can change what your graph is saying. So we're going to not include the 0 at this time, just so that we can focus in on our data a little bit. Now we're going to add our forecast. So we're going to click on forecast and drag it on, and it adds the forecast to our visualization right there. And now we can right click here and see forecast result is actual and forecast. So you can see that the forecast picks up here in 2012 and pushes out what it thinks it'll be in 2013 as well. You can change how far out that forecast goes by right-clicking on the line and clicking forecast option. And we can change, it says automatically the next 2 years, but we could change it so that it's the next 10 years. And it will go out into the future, out to 2022. You can change prediction intervals, or if you don't want to show them, you don't have to show them. And this is just kind of a visual guide for those prediction intervals. Okay, and then you can also have your trend line show, where it shows your trend line following out from where your population growth is, and also the trend line for your forecast right there. And we'll call this world population, trend. Excellent. And we're going to make one more visualization for this, and it's going to be a pie chart. So the pie chart is also going to be based off of population. So we're going to click on population, and we're going to control click on country and come over to show me and click your pie chart. Great. So I'm going to make this the entire view so we can see the pie chart better. And this is getting really crazy in here. And so I have changed my mind, and instead of country, I'm going to drag region over top of country. And now we see something a little bit more manageable. So we can see that here's Asia, and it makes up the biggest piece of the pie, and then here is everybody else. So right now, each of these is population total, and we could keep it that way, or we could do what we did last time and change it to percent of total, so that on hover we can see the population and the percentage of population that it contributes. So for this pie chart, we're just going to show Asia versus everybody else. So we need to make a group. And what we'll do is select all of these, and we're going to right click and click group. So now we have all of those things we selected, and we have other. Let's edit our group. Right click, edit group. We're going to rename this group Asia because that's all that's in there. And we're going to rename this group rest of the world. Okay, so now we have our group. We can drag it onto label, and we can see Asia and rest of the world. And now see how it's breaking it up into those different sections? That's because we still have region on our detail right here. So we pull region off. Now it's just split Asia, rest of the world. We can change our colors, make it a little bit more visually interesting. Now we can still see our percentages. And now let's rename it, and then we'll put it all together on a dashboard. Great. So let's make our dashboard. We have this new dashboard button down here, and you can choose what sizes you want. So we have a fixed size where you just select the width and height. We have automatic, which will just fill your screen. And we have a range, which has a minimum size and a maximum size. Some of the good things about fixed is that once you have it, you can have it always look that way, so no matter where they're looking at it, you know that it's going to be laid out the way that you expected. However, if somebody's looking at on a screen that is bigger or smaller than yours, then it doesn't fill up the screen, or it will fill up the screen too much and they'll have to scroll up and down and left and right. If you have automatic, then it will fit the screen that it's displayed on. However, the things that you've placed might get squished too close together. And then the range gives you a minimum size and a maximum size, meaning if the screen is too big, it still won't fill up the screen, but it can get closer. And then as they get smaller and smaller screens, you at least know that it will never make it get smaller than this particular size. So there's some benefits to that as well, where you still have a little bit of control of what it will look like at the end. Great, let's bring on our worksheets. And you can see that where you hover, it fills up that space, and that's where it's going to show up. You can also adjust the lines in between different visualizations for things that need more space or less space. Another important thing to recognize is that when you click on a visualization, like this one, up here it will tell you how it's viewing that visualization within that space. So if you click standard, then it will do a standard fit, versus if you have entire view, where it will make it fit inside the box. Over here we could have fit width or fit height. On some of the visualizations it doesn't make as much of a difference. However, when you have a visualization that maybe has a lot of text in it and they need to be able to scroll, you'll want to have it fit width, but you don't want it to fit height, because then it will shove all of that information into the box and not allow you to scroll up and down. So if you saw, as we dragged these on, it took these legends and added it to the left here. We can modify that and make them floating and drag them next to the visualizations that they are relevant to. And this particular one has a couple of things wrong with it. We might not want the title of this to be region group, so we could come in and we could edit the title and then maybe just call it region. However, I don't think we need this legend at all because it's very clearly marked on the visualization there. So you could also just remove it from the dashboard. And this one is telling you how big of a circle it would need to be before it gets to that population number. So it belongs to this circle as well, but again is unnecessary potentially because we have our two population numbers showing up right as we hover. So we'll remove that as well. So at this point we have a visualization, or 3 visualizations all on the same page, which is the basics of a dashboard. However, we might want to be able to interact with them a little bit more than just hovering. And so this is where we should look into adding filters. So we have information over time, we have information by country, and we have some information by region here. And one of the quickest things you can do to add functionality to the dashboard is by clicking this Use as Filter button. So if we click this, that means whatever country we click on here will filter the other visualization. And then you can unselect it to go back. Now, that Use as Filter button actually creates an action here, filter 1 generated, that it's made on its own. Now you can see that when we click on China, it doesn't make a lot of sense to have this pie chart update based on that China click because it's just going to show duplicated information. So it shows the 20% or the 20% here and the 17 billion. And then here it does the same thing, except for it shows 100% because it's filtered everything else out of the chart, so it now makes up 100% of the circle. So that doesn't make a lot of sense. So there are ways to format your visualization or your actions, modify your actions so that they only affect the things that make sense. So we can come here and click Edit. We're going to call this country action. And we want it to use the population by country sheet and then modify only the trend. So now when we click on China, we see China's trend over time. And it doesn't affect our pie because that doesn't make sense for it to affect our pie. We might want to select on our pie Asia or rest of the world and have that affect the other visualization. So we can click Use as Filter here and click Asia, and now it zooms into Asia on our map and shows us just the Asia world population trend, and here's rest of the world, and we can see that Asia is grayed out, and there's the rest of the world, and here's the rest of the world population trend. We might also want to be able to use this to filter to a certain year. So if we click Use as Filter, then we click on 2011, you can see these numbers are slightly updating. So this is 19%, and we come here, 19.5%, come down here, and we can see that the pie updates a little bit, although it hasn't been anything dramatic, but you can kind of see it over time. So that's one way to add filters to your visualization. Another way is to use actual filtering instead of just actions. So if we come back here to our trend, we could take the year, we're going to control click and drag it onto filters. And now we have a year filter, so we could have it the actual year number, so just look at 1 year at a time, or a range of dates. So if we click range of dates, that makes this slider from 2000 to 2012. So if we hit OK, we'll right click and we'll click show filter. We can see it here. And as we drag this, it updates, but kind of messes with our forecast. So let's not do a year filter in this case. So we click remove filter there. But maybe we want a filter just on this for the different years. So let's drag year onto the filters. We're just going to do the year number next. And here's all the years. We're going to let all of them be selected for now. And then we're going to show the filter. And here's all of our years. And we can change the way that our quick filter shows up. And we can make it like a drop down, so they can still select multiples, but it's a drop down. Or maybe we want this visualization to be just 1 year at a time. So we could choose single value in a list, and it lists out all the years, or in a drop down, and we want it to be 2012. And then we want this to show up on our dashboard. So we come to the dashboard, and we click more options here, hover over filters, and we can see the filters available, and we can click year of year. And now our formatting hasn't passed on. So that's one thing to remember, that formatting it just on the workbook doesn't necessarily mean that the formatting will pass over to the dashboard. So I tend to not do any formatting on the workbooks and just format it on the dashboards, because the dashboards are what I publish. So we're going to single value drop down. We're going to add it, we're going to move it to the top. So now how we do that, let's talk a little bit about what each of these sections are. Come here to layout, and you can see we have this layout here, item hierarchy. So tiled is the whole screen, and inside of that we have a horizontal container. And inside this horizontal container, we have another horizontal container. And when you click on something in this view, it shows you where it exists. So we can see this horizontal container is outlined now, and then we change it to vertical, and it outlines this. Now, a horizontal container allows things to be side by side, and a vertical container allows things to be one on top of the other. And so in our vertical container, we see all this extra space for extra things to be on top of each other. But if we wanted to have it at the top, we would maybe want things to be able to be side by side. So if we go back to the dashboard and we grab horizontal and drag it to the top, it adds a horizontal container up here. And now you can see everything that's floating kind of stays in the place that it was, even though all the other things shifted. So that's one of the disadvantages of floating, is that you're kind of just manually choosing where it will stand using your X and Y position, and it's not dynamic. So let's give us a little bit less space up here. We can add a text box into our horizontal container, or we'll say population dashboard. We can format it. Now we have our title up here, and then we can add our filter. We're going to drag it to be on inside of our horizontal container, but on the side here. We can give it more or less space. Let's bring our legends down to places where they make sense again. Perfect. And so now we have this that will affect this only and show you just 2012, 2011, 2010. So we don't want it to affect the trend, because we want the trend to show all of time. And just looking at 1 year for this trend that is only at a yearly part and forecasts into the future doesn't make any sense. But we maybe want it to also affect this worksheet so that these two are in sync. And so that the dashboard is basically for 2012, except for the trend, which shows you the past and the future. So one way that you can do that is clicking Apply to Worksheets here. And you can choose Selected Worksheets. and it will show you all the worksheets in this visualization, or in this dashboard. And you can click show all worksheets in workbook, and then if there were other worksheets, it would show them. So we wanted to do Asia versus rest of the world and population contribution by country. Okay? And that's another way we can change what year they show. So it's only going to show 1 year at a time, unless we select all. And then this visualization isn't affected by it. If we don't want to click on a country and have it make the change, if we instead want to have a filter for country, we can do that by taking country and dragging it onto filters. We'll have it show all for now. And then when we go back to our dashboard and we come to this visualization, we can go filters and add country. And it's just added it side by side where we had our other filters, so that's a nice feature of Tableau where it can kind of guess where you might want things. We're going to do multiple value drop down, and right now it only affects that visualization, and we can just look at one country at a time. And we might not want it to affect this visualization because it doesn't do us any good to just look at one region in a pie chart. But maybe we want it to affect the world population trend, so we can do the same thing we did before. And we want it to affect these two. We'll click OK. And so now we could look at all of these countries, and that would update both these visualizations. Another thing I like to do on a filter is customize and click show apply button. And this means we can make all these changes in here. See, I've selected none, however these visualizations aren't updating. And then I wanted to look at Turkey, so I found Turkey, and then I hit apply, and that's when they update. Perfect. So now we have a dashboard complete with filters and actions. We also have a title on our dashboard. We can give it a little bit less space, and some legends. We have titles on each of these pieces. However, if we didn't want a title here, we can click hide title, and it will just show our visualization there. And this is dashboard number 1. Here's what it looks like in full screen mode. Full screen mode is a good opportunity for you to test it to see what it will look like to the end user. I press escape and get back out, and it doesn't give you these highlights when you hover over things that are dashboard formatting related. You can see that all those extra lines went away, and it just gives you the opportunity to test out your dashboard in a more real way and see how they will use it instead of giving you the dashboard editing options.
Next, we're going to make a dashboard revolving around health information. So first we're going to make a map about birth rates. So we're going to call it birth rate rank map. And to make a map, we're going to double click on country, and we're going to change it to a map type, so we have a filled map here. And then we're going to bring birth rate onto color. So let's define our colors a little bit by clicking on this color part of the marks card. We'll click edit colors, and we're going to change it to red and gold. And the idea here is that the red is for a higher birth rate, which is more associated with countries that have poor health. So we'll hit apply, and now we have our higher birth rate countries highlighted in red. Next, we're going to create a class. So we're going to duplicate birth rate, and let's edit that field. We're going to call it birth rate class. And so we're going to say that anything that is in the top 50 countries with the highest birth rate is categorized as having an alarming birth rate. So we will first do the average birth rate, and then we're going to do a rank on that So you see sometimes when you're auto-completing your statements, it will replace one of these functions that you have with the one that you pressed tab for. So if I type if, or I start to type if, and then I come here and click on if, it replaced my rank with if. So keep an eye out for that. If you're like, where did my thing go? It's because I was typing it right next to it. So if I put a space and then I start to type if and I click if, it will not delete rank. So we're going to say if the rank of average is less than or equal to 50. So if it's in the top 50, then alarming birth rate. Else if, and we can take this again, is greater than 50, then normal birth rate. And always make sure you put on the end. Also, we didn't necessarily have to have this else if statement. So if we had just done else normal birth rate, that would have covered all of our bases. So with these if statements, just make sure that you're always getting all of the different options that you want. But in this case, we defined both. However, we didn't have to define the second calculation, because if it is not in the top 50, then it's obviously in the bottom, the rest. So we're going to hit OK. And then we're going to put birth rate class onto label. And it's gone around and labeled everything. And I am seeing alarming birth rate on everything. So let's see what the problem is. So if we open this back up by right-clicking and clicking Edit, you can see it says results are computed along table across. So we're going to click Default Table Calculation here. And instead of compute using automatic, we're going to change it to compute using country. We'll hit OK and hit apply. And that didn't seem to fix it. So this is the first place I would look if it's not doing what you would expect. So we'll put it back to automatic. Okay. The second place I would look is inside of the table calculation that is created. So when we defined rank here, we put a table calculation on it. So when we right click here, we get edit table calculation. And we're going to choose that we want to do the rate based on the specific dimension of country. So now we can see, using the logic, the calculation assistance, that we no longer have just alarming birth rate. We have normal birth rate and alarming birth rate on our screen. So we can close this. And we are done here. One thing you can do is, when we have allow labels to overlap other marks selected, then it will make sure that every label shows up, but it gets super crazy in there. So there are some times where the labels may overlap a little bit, and so you'll want to select this option. In our case, we don't want that. And now we have a visualization showing birth rate map based on rank. Our next visualization is going to be about average life expectancy, male versus female. So we're going to do a chart across time. So we're going to click year and bring it onto columns, and we're going to change it to this year in the continuous section. So now we have an axis, and we're going to double click on female life expectancy. Oh, there we go. Double click on female life expectancy and then double click on male life expectancy. So what that did was made us two charts, one on top of the other, but we don't want that. So we'll take this off, and we're going to drag male life expectancy right onto this axis for the female life expectancy. And what this has done is made what's called a blended axis chart. So it's not a dual axis chart where we have another axis over here for the second visualization. This one is a blended axis chart. So they necessarily use the same axis, and they necessarily have the same kinds of marks. So we'll take a look and see what the difference is there. So if I were to change this to a bar chart, we would have bar chart for both of them, and I can't define one separately from the other. Change it back to a line chart, and they're both a line chart. Now if we go back to when we just had female life expectancy and we drag male on next to it and we have two charts, now we can change it to a dual axis and we have one on top of the other. However, our axes don't line up. We can see at the top here is 15K and over here it's 14K. So we're going to synchronize the axis, and you can see one on top of the other. And we have two marks cards, so we could have this one be a bar chart and that one be a line chart. So that's some of the differences of those two. We're going to do a blended axis chart. So I'm going to take male and drag it here, and we have our blended axis chart. And now you can see that our scale here is really strange. So what it's doing is it's adding up all of the life expectancies for all the different countries instead of averaging it. So we're going to change that by right-clicking on the measure down in this measure values card, hovering over measure sum, and we're going to change it to average. Since I only changed one of them and they share the same axes, it's really spread out now and it almost looks like a straight line down there. And then let's change the other, and it should get everything a little bit more in sync. There we go. So now we can see the average life expectancy over time, which for both of them seems to be going up. However, it seems to be higher for females. Now let's take a look at our analytics and let's drag on forecast. So it's forecasted out the next 2 years for both lines. And we'll bring on trend onto linear. And let's change it to a square. So now we see each individual point for the life expectancy for females and males. And we can see what they're expected to be in the future and our trends. And our next visualization is going to be a heat map about multiple different measures. So we'll just call it a heat map for now. And for our heat map, we're going to look at the different countries. So we'll bring country onto rows, and we're going to look at their birth rate. So I just double clicked on birth rate and brought it on. We're going to look at their health expenditure percentage on GDP, so how much they spend on GDP. So when I double clicked on it, it did what we did before, where we have a measures value card, and so now whenever we put measures on here, that determines what goes here, because we have our measure names on columns. So every measure in here, their name is going to define the name of the column, and the values define what's in the text right here. Great. We're also going to bring on infant mortality rate and the life expectancy for females. Okay. So now it has changed these to not have decimal points after them, which is not as helpful. So we're going to format those, and you can format it field by field. So for birth rate, we definitely want to have decimals afterwards. As a matter of fact, the birth rate is a percentage. So instead of doing a number standard, we'll just go to percentage. And now we don't need to have those decimals afterwards. We can just look at the birth rate as a rate. And for percent of GDP for health expenditures, we can come click there and do the same thing. And for infant mortality rate, okay. And to make this make a little bit more sense, we again need to change it from a sum to an average. And for some of these, we could change it from a sum to an average right inside of the, well, for all of these, we could change it from a sum to an average in the default properties under aggregation, so that it will automatically average it whenever we bring it out. Default is sum, but if we make it automatically average, then we won't have to do that again for any other visualizations. I won't do that at this time because I get a little bit confused sometimes when I don't have my sum on there by default, because that's what I'm so used to seeing by default. Great, so we now have a matrix by country and by our different metrics here, and so we can take our measure values and drag it onto color, and we'll make our marks from automatic to square, and it will make our heat map. Now, what happens with a heat map is it colors darkly the higher the number it is in this case, and right now it's doing it for the whole area. So 1% is obviously much smaller than 82. But if we wanted to be able to look at birth rate independently from life expectancy, we can right click on the measure values on the color and click use separate legends. And so now we have a legend for each one of these. Let's change the colors on those legends so that we can see them separately a little bit more clearly. So we'll change the colors by coming over here to each of the legends, and we'll leave one the same, but we'll change this one. If we click edit colors, you can see our different palettes. You can see some of them just have one color, others have one color to another color. We used the red gold before, so now you can see that one is changed. We could use another one that goes from green to blue. Great. You can also define your own. So you can make a custom one that could go from light to dark, and then you can choose what color you want as your dark color. So we could pick a lighter blue, and then we see that last one. And now with these separate color palettes, you can quickly see the difference with birth rate and spending on health. And that is our heat map with separate legends. So let's build this all into a dashboard now. We're going to call it our health dashboard. And for simplicity, we're going to make it automatic so it fills our screen. And then we're going to first bring on our map. We're going to bring on our health related map with birth rates. Then we're going to bring on our heat map. And we'll bring on our life expectancy lines. Now, as we brought on all of our charts, it brought in our legends here. And we're going to move our legends up to the top. So let's add a horizontal container. And then let's put our legends into the horizontal container. And let's put these ones in order. So life expectancy. Oh, so birth rate is going to be over here. Great. Now, one thing we can do is make these smaller. Well, that's actually just making that one bigger, huh? Okay, so you would make them smaller by making something else bigger or by adding in a blank space, which would then help you adjust the size by taking up the space that you're not using. Another thing to pay attention to is this fixed width. So once you start to drag the size on something, it no longer is dynamic. So if we unfix that width so that it's only taking up whatever space is left. Oh, and that one is not fixed width. And then we can edit the width on this to be even bigger. Then it will squish things over to where we would like them to be. So that's one of the ways you can add space or make things the size you would like them to be. Now let's take a look at filters. Oh, before we take a look at filters, I want to look at this map one more time because I think that it would be useful for our colors to be a little bit more distinct. So one quick way to navigate to your worksheet from your dashboard is to click this Go to Sheet button. And while we're here, I'm going to click on Color, Edit Colors, and we did red and gold, and we're going to change it from this sequence to a stepped color, and we're going to change it to 3 colors. So it's going to either be this color, this color, this color, and when I hit OK, you can kind of see it's a little bit more dramatic in our differences, and it's put everything into the 3 categories we defined. So let's go back to our dashboard, and we can see the difference there. And now we're going to take a look at our filters. So we want to be able to filter by country. So let's bring country onto filters. And we're going to allow it to use all. And we're going to, here you can click apply to worksheets. And you can click selected worksheets, and it's going to pop up with all the worksheets in the whole workbook. And so one disadvantage of doing it on the worksheet is that you can see all of the worksheets in the workbook, and you have to differentiate between which ones are on the dashboard and which ones aren't. And these are the 3 on this dashboard, so we're going to hit OK. And we're also going to do it by year. So when we drag the year onto filters, we're going to allow them to choose years. So we're going to do the distinct number of years. We'll click use all. Okay. And we're going to apply to the worksheets this one with the birth rate and the average life expectancy male versus female. We're not going to filter down our line chart by year because we want to be able to see it over time, and if we filter down the time, then we don't get as much context. So we'll hit OK. Let's go back to our dashboard. If I click on more options here and hover over filters, you can see that year filter and that country filter. You should also be able to see both of those filters on the heat map because I told it to apply to that one as well. So here's the country. Oh, I made a mistake. Let's go back to this visualization and apply to worksheets. Selected worksheets. See, I wanted it to be on the birth rate and the heat map, not the line chart, and I clicked the wrong one. So that was a good test. So when we go here to the heat map and click down, you can see now we get the year of year as well. So we'll click year of year, and let's put it over here, and we're going to make it a multiple values drop down, and we'll bring it over to the middle. And let's also get the countries filter. Great, so now that we have these in here, we don't need this to be so big, so let's edit the width and make it 300, even smaller, 200. Great, and let's change our country to be a single value drop down, so you can pick one at a time. And let's also change it, or this year of year, since we can select multiples, let's change it so that on customize that you show the apply button. So here, since they can only select one, we don't have the apply button because it will just automatically apply. And here, since they can select multiples, we'll let them unselect all and pick their years and then hit apply, and then you'll see the changes. And you can see that even though I've selected only 2011 and 2012, you still see all of the years on this line chart as expected. And there is our health dashboard. Our next dashboard is going to have to do with economy. Our first sheet is going to be another map that is going to have to do with overall GDP. And as we usually begin with maps by double clicking on country and changing it to a map mark type.
And this time we're going to bring on GDP onto color and change it to average. And we can edit the colors. Let's this time do a custom diverging, so you get to pick both colors. And let's pick a little bit lighter. Okay, red for there, and then we want to do maybe like a deeper green. And that way you can see who has the highest GDP, which is green. We hit apply. Okay. And then it will eventually get lighter and lighter until it goes to gray, which then it will lead to green. Okay. And next we're going to make scatter plot, which we will call GDP versus GDP per capita. So GDP, or gross domestic product, versus gross domestic product per capita or per person. And to make a scatter plot, you have one measure on one axis, and then another measure, which is going to be GDP per capita, which we will now create on the other axis. So let's start with GDP, and we'll hit duplicate, and let's edit that, and we're going to call it GDP per capita. And we're going to take sum of GDP and divide it by the sum of the total population. So population total. What is my error? Opening parenthesis. There we go. And then we have GDP per capita. So what this will do is sum up the GDP across whatever measures we have in place, across whatever dimensions we have in place, and then sum up the population for those same dimensions, and then divide it, instead of dividing it per row and then doing an aggregation on it. Okay? So now we're going to bring on GDP per capita on the rows, and we have the sum of GDP and the GDP per capita, and to make it more than just one little mark on our scatter plot, we will drag on country to detail. And now we have one mark per country. And you can see some countries have a high GDP per capita, and some countries have a high GDP overall, but not as high of a GDP per capita. And so on. We have some middle of the road people here. So we can change this from automatic to circles, and now they're dots like you might see on a scatter plot. And you can drag region onto color, and now we can see our different regions, and we see a lot of reds here, and it's quick to see what region things belong in. Also, you can click to highlight, and you can see all of the Americas highlighted in context. The next visualization we're going to make is going to be showing how much countries spend on healthcare as a part of their GDP. So we're going to rename it to be GDP on healthcare. And we're going to look at each of our countries. And we're going to make a bar chart that shows the health expense GDP. And we're going to change this to average. And we're also going to show the health expense per capita. Over here it shows how much is spent per person on health. And this is showing how much is spent on health based on GDP.
Click at the top and click sort, and it's sorting by this first one. And you can see which countries spend the most of their GDP on health. We can again bring region onto color, so we can see the different regions highlighted. And let's bring on labels. So for our different marks cards, we're going to want to control click this and drag it onto the labels. And we can see that it's a percentage, but it's coming up as a number, so we can right click and click format right there. And we're going to change the number to percentage. Maybe just do 1 decimal place. And then for this one, we're going to control and drag that onto labels. And maybe we'll change this one to currency. However, if you don't want to change it to currency, since we aren't sure necessarily what currency this data set is in, it's worth checking out what currency it is in. So for now, we'll just have it as a number. And now we're going to customize our tooltip. So we're going to go to the overall marks card, and we'll click on tooltip, and we want it to tell us the country in the top. So we'll erase region, and we're going to erase country label and center country. And then we're going to put this country spends this percentage on healthcare. And if you want to preview it, you can hover or click here on preview, and it will show you an example. Marshall Islands spends 2.1% on healthcare. We'll hit enter, and then when we hover, it tells you the country, and it has our custom tooltip on both visualizations, or on both of the different axes. So let's build our dashboard. We'll bring on our map. We'll bring on our healthcare visualization and our GDP versus GDP per capita. And we'll move our legends to the top again by adding a horizontal container to the top and bringing them up here. One thing we can do also is to give this more space. We can have it go all the way to the top, and these legends are just side by side, just above the map and the GDP per capita scatter type plot. An interesting thing you can do in Tableau is you can see this outlier of the United States is making it difficult to see the rest of the information or to visualize if there's any trend there. So you could right click on it and click exclude, and then it will exclude it from your data set very quickly. And then you'll just click this back button to get it back. Great, now let's take a look at filters. We are going to do a single filter. So let's go to this visualization, and we'll bring on country. We'll click use all, okay. And we're going to apply it to worksheets. So I showed you how we can apply it to worksheets here. You can also apply it to worksheets once it's on the dashboard. So if we come here and look at filters, we can see that country's on the filters for this visualization. But if we come down here and look at filters, we still see country because it's in the details of the information. So either way, when we add country, since I added it from this visualization, it only affects this visualization. Okay, but we want it to affect all on the worksheet. So we're going to apply to worksheets, and we can click selected worksheets, and we can click all on dashboard. Okay, let's bring this over here. We're going to allow them to see all at once
and be able to scroll and select the ones they want. And now, when we select different ones, it affects all 3 worksheets. We're also going to add an action for a URL action. Add action, go to URL, and when we click on a country on the overall GDP map, we want it to take us to the Wikipedia page that talks about the economy for that country. So that is this URL, and it's going to say Wikipedia for economy of, and we're going to add our country to the end. So we hit OK. We have it running on menu, so let's change it to run on select. And as soon as you click it, it will take you there. Okay, so now let's try it. And we can click on Canada, and it will take us to the Wikipedia page for the economy of Canada. Great. We click on Brazil, same thing. So if we unselect on Brazil, then it will make our map highlighted normally again. We can also use this one to filter the other visualizations. And so we could click use this filter here, and then when we click on France, it will filter these 2 other visualizations to France. You can see that when we filter this visualization to a particular country, so if we look at Germany, Germany wasn't green before on our map, but now it is. That happens because our scale has changed just for the ones selected. So if we control click France and Germany and Switzerland and Austria, we now have a scale that reflects only these countries, and the biggest is going to be the darkest green, or the highest GDP is the darkest green, and the lowest is the lightest pink. And there is our economy dashboard. You can see that we have some nulls on these visualizations. That occurs when we don't have all of the data for every point. You can ignore those and they won't show up on the final visualization when you publish it to server, or you can deal with those by clicking on them and filtering that data out, or showing that data at the default position, which is showing the null values at 0. Our final dashboard is going to be about the ease of doing business in a country. So our first visualization is going to be a bar chart, which we will call days to start business. So how many days it takes to start a business is important to know when you're trying to start a business in a country, and also can be an indicator of how easy it will be to do business in that country. So let's make a bar chart that includes every country. And then we're going to bring on days to start a business. And we will sort it smallest to biggest. And we have some days or some countries that don't have any days. So let's filter out those countries. And we're going to filter it to only those that have a good market. We're going to make a calculated field. We're going to define business-friendly market. Well, we're going to define our market based on how easy it is to start a business and how many days it takes. So if it takes less than 25 days to start a business, we'll consider that a good market. And so we're going to do if the days to start a business is less than or equal to 25, then else if days to start a business is greater than 25, then business might or might not work. Doing less than or equal to 25 or greater than 25 allows us to be able to define these 2 different markets. So we'll hit apply there. And we're going to filter it just to a good market.
And we're going to look at just 1 year. We'll look at 2012, our most recent year. And we're going to color it based on region. And we can see which regions tend to have the shorter days to start a business. And we're going to move on and build our next visualization, which is also a bar chart, which we will call ease of business. So we have this ease of business field, and we can bring on the country and we can bring on ease of business. And we want to make it a measure. So ease of business is at this point looking at it like it's a string, and we can change that in our default properties and convert it to a measure, or use it up here and change it to a measure. When we try to change it to a measure here, it wants to treat it like a string, so it wants to take the minimum or the maximum. But if we here convert it to a measure, then it also automatically made it a count. So the first thing to do would be to change the data type to a number. And now we can change it to a measure and aggregate it. So we could do like the sum of ease of business. In our use case, we're actually going to do the average of ease of business, and then we want to have the smallest on the top. We do have some that don't have ease of business ratings, so we're going to filter that data out. And again, we want the year to be 2012, but how we're going to do that is by coming to this visualization and by applying this particular year of 2012. So we'll do it on select workbooks and select ease of business. Okay. And now this one also has the year of 2012 there. And we're going to segment this by creating another header. We're going to call that business friendly. And we're going to say that if the ease of business is, so I guess this is a nice thing to know. So if we start typing in what we want to see, then we can select it from a list here. But you can also interact outside of this box, so you could just grab ease of business and drag it into the dialog box here, and that's really nice. So we're going to say if it is greater than or equal to 1 and less than or equal to 3, then we're going to say it has the most business friendly regulations. Give us a little more room to look at. Okay, and this statement won't work because it's saying and what is less than or equal to 3. So you have to have ease of business in both places. And then this should say then and not the. Great. So now we're just getting an error because we don't have an end. So if that's all we wanted to do, then that's what we would do, but then we'll just do another else if. And it's already taken, this if statement goes through one condition at a time. So it's already classified everything that's between these two numbers. And so now we can just say if ease of business is less than or equal to 10, then we'll call it very, very business friendly regulations. And we'll keep going. Else if ease of business is less than or equal to 50, then we're going to call it moderate. And we're just going to say moderate business
regulations. Copy that for later use. Less than or equal to 150, then strict. So the reason that this doesn't grab everything that is less than or equal to 150 is because these sections 1 to 3, and then 4 to 10, and then 11 to 50 have all been classified up to this point. So it's just getting everything else. And we're going to finally say else, everything else is going to be called not preferred for business. And see if we get any errors. Calculation is valid. Let's see if this works as we expect. So we'll hit apply, and we'll bring business friendly onto our rows. And now it categorizes everything based on what we said. So we want to define what order these go in. So we're going to click sort, and we want the most business friendly at the top. Then we want moderate, then strict, then not preferred. Okay. So we have our top 3 that are the most business friendly, and then we've got 4 through 10, which are very, then we've got our moderate, our strict, and our not preferred. So let's bring region again onto color, and we can see which regions are the most business friendly. And we have our year of 2012 there. And now we're going to make this even more useful by adding the business tax rate onto the label so that you can see that business friendly is like Singapore, but they have a pretty high tax rate of 27, whereas if you get down to some of these that are not preferred, some of them have really low tax rates. So let's make sure that we're getting the right tax rate. So you can see that 27 is definitely not the highest tax rate that we have for business. But you can also see that there are places that have even lower tax rates, like Saudi Arabia, and we have 8% here. It looks like we don't ever go to that second decimal place. So let's quickly format this. Oh. Business tax rate is also text. So if we could convert our data type to decimal, and then we will format it to be a percentage, and we just need the 1 decimal place. Okay, now let's make some annotations. So we could come and click here on this mark, and then we can annotate that mark, which will make this dialog box, and it's already filled in here. And so we could use some of this information. So I'm going to copy that, and I'll put some hard returns there. So we're going to say that this country is the most business friendly, but has a business tax rate of, and let's grab the tax rate. And then we'll erase this. And we'll hit OK. And I made a typo. So Singapore is the most business friend is not what I meant to say. So I can click edit, business friendly, but has a tax rate of, and you can move this around. Draws the line to Singapore, which is the mark that we wanted to annotate. So that is an annotation on a mark. If we wanted to just make an annotation for the area, then we could point out that more business-friendly countries often have high business taxes. We could change that size, make everything fit. Now we have this second note where our user can come in and see some more information about what's being presented here. Great. And now we're going to make one more visualization. And it's going to be about phone and internet usage. Because you may want to know about the phone and internet trends when you're looking to start a business. So we're going to do this one over time. So it does not need to have that year filter on it. And we're doing our axis. And we're going to look at mobile phone usage. So I double clicked it, it shows mobile phone usage over time. And we're going to change it to average so that it's averaging it across the countries. And then we're going to bring on internet usage. So we'll bring it on side by side, so we have two visualizations. And we're going to also make that average. Now, we might not want these to share an axis because they are measured a little bit differently. And so we can make it a dual axis, but allow them to keep their independent axes. Or you can synchronize the axes and see them at their rates. However, the usage is just a little bit of a different measurement. We can have one of them be a bar chart and the other one be a line. Let's have this one be the bar chart. Okay, and then the line is in the front. You can also change which one's in the front by coming and clicking on the axis itself. And you can click move marks to front, and that moves that one to the front. Okay, and now it's made each of these wide, and there's like a start point and an end point on the axis for the bar, and that comes here under size, where they're all fixed. Or you could have it be manual, where we can define the size of the bars. So we're going to make those bars like this. And we can see them going up over time. We can also change the width of the line itself. Make it thicker or thinner. And we can change the colors here. So let's change it to orange, since red might imply that it's bad in some cultures. And now we can see our internet usage and our phone usage over time and how it's trending. And so this will all come together on our new dashboard, which is about ease of business. You can see that I have a sheet called Ease of Business and a dashboard that I've called Ease of Business, but it won't let you create a dashboard with the same name as your worksheet. So, Ease of Business dashboard. Let's have it fit the screen. And we're going to bring on our days to start business visual, our ease of business visual, and our phone and internet visual. Let's put our legends at the top again. So we'll make our horizontal container. And we'll bring our region legend into there, and then our measure names for internet versus mobile phone. And we have a filter that already is pre-applied to two of the visualizations called year of year. And it's selected 2012, and if we select 2011, it's only changing this one, it's filtering out all the information for this visualization and changing this one to 2011. So let's see why that's happening. If we go to this visualization and click the Go to Sheet, we can see year of 2012 is here.
Let's click Show Filter. And if we change the filter to 2011, okay, it's not showing up here, and the only filter I can see that could be removing it is this average ease of business. That is removing anything that is null. So if I pull that off, you can see that we don't seem to have any information for 2011 for ease of business. And the more years I select, I'm not seeing any ease of business information. So we're going to want to set this to 2012 only, because that seems to be the only information that is useful for this visualization. So let's go back until we're back to the state we were in when we started. Okay, so here we are. Now we're going to want to remove this filter, and we're going to give it its own filter that only selects 2012. That is not connected to the other filter. So now, when we change year of year, it only changes this visualization. Sometimes that's useful to note, sometimes it's useful to put, let's do a single value drop down. Sometimes it's useful to put this right next to the visualization it affects. So if we could change it to floating and just put it like here, that makes it clear that it's just changing this chart so that people don't get confused. Another thing that we can do, that we should do on all of our visualizations, is change the titles so that they're more business or user friendly. Great. And so we have our filter, and let's use this as a filter, and that way we can click on New Zealand, and we can see its most business-friendly regulations, and we can see its internet and phone usage over time. We can click on a lot of different countries to see those changes. You can see that some countries have a steeper change, so some of them have adopted phone and internet usage and have stayed pretty similar, whereas other ones have only really adopted it in the last couple of years. Also, if we wanted to filter to just one country, we could do what we did before and create a country filter. Here's another way to go to the sheet. You can click this down arrow and click Go to Sheet, or you can come over here. You can see that it's highlighting a visualization over here, or a sheet, and whatever sheet I click on is highlighted over here. And there's this little pop-out arrow here that also takes you to the sheet. And we can bring country on, use them all, go back to our dashboard. We'll go to filters and select country. We'll make it a multiple value drop-down. We're going to add the apply button, and now we're going to make it apply to all the visualizations by clicking apply to workbooks, selected worksheets, all on dashboard, okay. Now we can see that if we just want to look at Afghanistan, okay, we can see how many days it takes to start a business there. It's not preferred for business, and it's internet and phone usage over time. And those are our 4 dashboards. So as a review, we have made a dashboard on population, we made one about health, we made one that had to do with our economy, and one that had to do with our ease of doing business.
So today we'll be dealing with the Tableau project. So the first dataset that we will be using for the Tableau project is based on COVID-19 data. Followed by that, we'll have another project based on the airline data. And finally, the third project will be based on space missions data. Now let's begin with our first project. So in this first project, we'll be dealing with the COVID-19 dataset, and using that dataset, we'll be getting some insights. So what are those insights? Those are, what are the total number of confirmed cases in different nations? What are the total number of recovered cases in different nations? So we'll be using the map chart for these, and we'll be finding out the insights about how are the cases going on in the current situation or in the current date or year. Followed by that, we'll also look into the insights of the confirmed and recovered cases in India as well. Followed by that, we'll enter into the next query where we'll find out the trend line of COVID-19 in the international level, like how it started, how's it going on. And moving forward, we'll create a group of Indian states and we'll find out the COVID hits there, and then we will discuss about the death rates. So highest death rates at international level and the least death rates in the international level. Then we'll enter into the next segment where we'll find out the variation in COVID-19 cases around the world. And then finally, we'll discuss the future of COVID-19 in the international level. Basically, we'll create a trend line which will give us the forecast levels of the COVID-19, like is it going to increase or is it going to decrease, or what's going to happen in the near future. So I hope I made myself clear with the queries or the insights that we're going to take from the COVID-19 dataset using Tableau. So without further ado, let's get started with the Tableau. So we are on Tableau right now, so we'll be using an Excel data file. So we'll be using the COVID-19 data file. So this particular data set is available on Kaggle, and if you don't find it there, don't worry, we'll be attaching that particular data set in the description box below. You can use that as well. Now let's just select open to get connected with that particular data. So you can see that we just got connected with that data, and there will be some minute errors in the data, or there will be some problem with the data which the Tableau might identify, and when it identifies something messy with the data, it will show you an option. Maybe you might want to use the data interpreter, so I prefer using that. So whenever I see that particular option on the left hand side, I better use it for the safer side, for being on safer side with the data. And let's also select these, not a problem. Yeah, so the data got clean now. You can see that over here. So to do that, you can also check the review results. So when you click that review results option, then you'll get into this particular Excel document, which will help you with the changes made to that data set. So you can see that the orange color one says the data is interpreted as column headers or field name, and the green box suggests you that data is interpreted as values in your data source. And now you can see that. There you go. So now we'll get back to Tableau. Now you can see that the data has been interpreted successfully by the Tableau, and everything is as expected by the Tableau. Every data element in the dataset is as expected by the Tableau, and it's really fine now. Now we'll check the columns what we have in our dataset right over here. So we have the serial numbers, observation dates, province, state, and country or region, last update, and confirmed death recovered. So basically these three columns will be telling us the confirmed cases in that particular region, country, or state, and the deaths happened in that region, country, or state, and recovered rate, and the last update, when was the last tested done, the latest tested done, and in which region, and what's the observation date, what's the observation results on that particular date, and the serial numbers, etc., etc. So we have the clear understanding of a data set now. Let's get started with the first sheet what we have over here. So according to our first query, we had to find out the total number of confirmed cases in different nations. So for that, we might want to select the country or region, and then the confirmed from measures. So for that, we'll be selecting the map chart for this, so that we have the data shown in a more appealing format. So now we have the bluer color of map on our screen right now, where the darkest color shows the maximum number of cases confirmed, and the lighter ones represent the lower number of cases confirmed. Now let's make this look a little more interesting. So for that, we can select the edit color options, and inside that, let's select the red to green diverging. Yeah, this is it. Red to green, white diverging. And as you can see, the colors are a little opposite right now. So we want the greener one in the lower side, and the red colored one on the higher side. This should be good. So let's select OK and apply and OK. So you can see that the red color now represents the highest number of cases, and a lighter red one here, you can see a little touch of red, which shows that the India's got some good amount of cases as well, and in the Brazil and etc. etc. So even Russia has a little light green, so this shows it also has some good amount of cases, not completely green though. Yeah, so this is how it looks. Now let's rename the sheet as confirmed cases. At the international level. Now, according to our second query, we are supposed to find the total number of recovered cases in different nations. So now let's create a new sheet for that. Now for that, we'll be selecting the country or region, and then we'll be selecting the recovered, and hover over to the show me icon, and let's select the map for that. Now you can see that we have a lot of recovery happening in India. So according to the stats, we get to hear that the virus which we have in India is a little, kind of harmful than comparatively what we had in China and other states of the world, or the other nations of the world. So yeah, we have a good recovery rate in India. Now let's rename the sheet as recovered cases. International level. Yeah. So I'm naming these sheets separately because we'll be using these sheets to create a dashboard at the end. Now let's get into the third query. What we have right now is find the total number of confirmed cases in India and what are the total number of recovered cases in India. So for that, let's create a new sheet, and let's select country or region and confirmed. Now we'll be selecting the text table, and we have the complete data set right now. We have all the nations over here. So what we are looking for is just India. So for that, now we'll drag the country or region into filters, and inside this you can see we have an option of selecting India. Now let's search for India. GHI. So we have India over here. Let's select apply and OK. So we have the total number of cases in India. Now we can drag the state or province into rows, add all members. So in India we have all the states, and so all the states have their own confirmed cases. So this is the total confirmed state or confirmed count in India. Let's rename the sheet confirmed cases in India. Similarly, let's find the recovery cases in India. Let's create a new sheet for that. Rename it as recovery cases in India. So now let's select the country or region, recovery, and then let's close the show me icon, and now let's drag the country or region to filters, then none, select India, apply, OK, and let's drag the state or province here, add all members. Yeah, so you have the text chart here which represents the total number of recovered cases in India according to the state wise. Now yeah, this looks okay, but we can make it look a little more appealing so that it's more visible and understandable, readable. So we can make that happen. So let's make a duplicate of this and recovery cases as well. Now I would like to change the confirmed cases in India into a pie chart, which looks a little bit more readable and understandable. Let's select the entire view so that we have a bigger pie chart and a little bit understandable or readable. Let's increase the size a little bit, and let's select the label and select the show mark label so that we have all the numbers over here. We can even select the province or state and drag it into detail, so we have the state's name as well. Or should we tag it into label? Yeah, now the recovered into label again. Yeah, there you go. We have the state and we have the confirmed number over here. So this is how we can make the data look a bit more appealing and understandable. So we can see that Maharashtra has a larger number of confirmed cases. It's the biggest state of India. So maybe, yeah, that's true. And now we'll get back to the duplicate sheet of recovery cases in India. And now let's make it look a bit more appealing by changing the way the data looks. So for this, we can select the packed bubble option. Now we can see the packed bubbles which show the recovery states happening in the Indian states or the recovery cases. So you can see that everything is looking in blue color, a bit difficult to understand. So for that, let's drag the province or state into color so that we can have different colors for different states. Yeah, now this is good. We have the country name and state name. This is fine. Now we can make it a bit more readable by dragging the recovered icon into, or the recovered pill into the label. So we have the count of recoveries happening in that particular state and that particular country. Now it's a bit more readable. Now we have Maharashtra at the leading place. We have a good recovery in Maharashtra. Yeah, that's fine. Now let's get back to the presentation mode and see our next query. So can we forecast a trend line of COVID-19? Yeah. So how it started, how is it going on? So we can do that. Let's get back to Tableau again. So let's create a new sheet. We have the new sheet over here. Let's rename that as trend line. Yeah, the sheet got renamed. Now let's select the observation date from the dimensions, since we're making a trend line. So let's keep it observation date, or you can even select the last update. Let's go with the last update. Now let's select the confirmed pill from measures. Let's select a line chart, or we can do that from here as well. Okay, so we're not getting the line chart, so there might be some problem with the date format over here. So we have to change the data type of, so I think this might be something with the date. Yeah, let's select the date pill and change data type to date or date and time from string. So you can see we had string first, so now it's changed to date and time. Now we'll be getting a proper trend line. So now we have it according to the year, so we can make it according to quarter, and even in the form of months. And so if you see this a little bit readable, you can keep it that way, or you can even change to days. So yeah, I think there is some problem with date and time value. So let's keep it in the form of months. It's more readable in one screen. So yeah, it's good. Let's remove this. So we have the month update. Now let's go to analytics to create a trend line, and you can select the trend line and drag it over here and select the linear option. So you can see here we have the trend line over here, which reads the R-squared and p-values and confirmed, and we have a formula for that. So basically Tableau creates a formula to create a trend line, so which is 5.280 exponent to the power of 8 into month of last update. So pretty complex formula, yet understandable. So this is how you create a trend line. So according to the trends, we have January, February, the quarters, Q1, Q2, Q3, Q4, and this is the first month of January. So here it is. So in January we find one. Okay, this is in billions, maybe, yeah, maybe even trillions, who knows. But based on the data we have in the last year, we have a decrement of the confirmed cases in January. So it's basically indicating that corona is basically or slowly decreasing. That's a good sign. Now let's try to find out the trend line for India. Let's duplicate this. So for that, let's drag the country into filters. We have the filter option, and let's select all. No, not all. We might want to select the Indian icon. Yeah, let's select apply. Okay. So now we have the trend line for India. Let's kind of rename it. Yeah. Even you can see a gradual drop of corona in India as well. So the number has decreased in India as well. In the earlier year, we had a lot of cases above 30 crores. Now we have nearly 20 crores. That's a good sign in India as well. Now let's get back to the presentation mode and try to select the next query. So according to the next query, can we group Indian states and find COVID-19 hits? Yeah, we can do that. Now let's get back to Tableau for that. Let's create a new sheet and let's rename it as grouped. So the sheet got renamed. Now we're going to select the country or region or province. Now for that, you can see the create option over here. Now inside that, let's select the group. Now we have to create a group of Indian nations. So select Andaman and Nicobar, hold control, select Andhra Pradesh. Now let's select a couple of states we know which are in India. Arunachal Pradesh, Assam. Don't forget to hold the control key for this, or else the options might vanish. We have Bihar. We have Chandigarh. We have Chhattisgarh. We have Dadar and Nagar Haveli, Dayu, Daman. We have Delhi. Yeah, we are going to just select a couple of states just to show how group can be done. So fetching all the states in this particular column would be a little difficult, or we might even miss a few. We have Gujarat. We have Haryana. We have Islamabad, Jammu and Kashmir, Jharkhand, we have Karnataka, we have Kerala, Ladakh, Lakshadweep. We have Madhya Pradesh, Maharashtra, Nagaland, we have Punjab, we have Rajasthan, we have Tamil Nadu, we have Telangana, we have Uttar Pradesh, we have West Bengal, and let's rename the group as Indian States Group. Let's select apply and OK. So after selecting the apply option and clicking OK, so we can have a new pill in the dimensions section that happens to be Indian States Group. So what we're gonna do is drag that pill into detail option so that we can have the results on our screen. So there you go, the states what we selected are right over here, all the Jammu Kashmir, Ladakh, and Punjab, Maharashtra, Gujarat, etc., and our Lakshadweep and the Andaman and Nicobar Islands. Right, so we have all the states of India right on our screen. Okay, let's expand it a little bit. Scrolling on Tableau is a little bit difficult. I don't know how to select the default option for the screen. Yes, we can see these states. I don't know where the scroller is at. Yeah, we can always undo what we did in Tableau, so that's the best part. Now let's drag the states pill again so that we can have a perfect map in the screen right now. Yeah, I would like to not to mess with it again. It's pretty good right now. Let's keep it as it is. Now let's quickly get back to our presentation and check out our next query. So find the highest death rates at international level. So we are basically going to find which nation or the country has the highest death rates, and which is the country with the least amount of death rates, so which is the safest country. Now let's get back to Tableau. Now we're not going to mess with this particular sheet. Let's create a new sheet. Let's rename the sheet as highest death rates. International, INTL. Let's enter. So the sheet got renamed successfully. Let's drag in country. And let's drag in confirmed cases. So we have a map over here. So Tableau basically kind of selected the map as default. We can drag the deaths, and now we can actually change this to a text chart. Now let's drag the measure names into rows, so we have a little bit more, sorted kind of data. So you can see we have the confirmed cases over here and death rates here. Now if we kind of sort it in the descending order, yeah, so the order is being changed now. So we have our charts processed by Tableau for a better visual. So our chart got rearranged or ordered in the descending order. So with that we have the highest deaths and confirmed cases in US. So we can even do that using a parameter where you can create the top 10 or top 5 nations with highest confirmed and death values. So for that you can drag both, or no, you need to create a parameter. I think it's not required over here. Let's continue with the next sheet, or you can just simply duplicate this. Since the dataset is a little huge, it takes a little bit of time. Now let's rename this. Yeah. Now let's rename this sheet. It's still taking a little bit of time. Yeah, now I think we can rename it least death rates. So now for that we're gonna rearrange it in the ascending order. So yeah, after sorting and changing some layouts, we have the least number of cases or death rates in the country called Macau, where we have least number of deaths and least number of confirmed cases. So with that, let's move into the presentation mode again. And in the presentation mode, we have our next query that says, can we find the variation in COVID-19 cases around the world? So for that, let's create a new sheet again.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So after changing some arrangements, or by making an ascending order arrangement and changing the layout or the orientation and everything, we have our final result, which states that we have the least number of deaths and confirmations of COVID-19 in the country of Afghanistan. So yeah, so we have the pretty well sorted, arranged data over here on the screen. Now let's get back to the presentation mode, and in the presentation mode, the next query that we have to deal with is, can we find the variation in COVID-19 cases around the world? Yeah, we can do that. So let's get back to Tableau and create a new sheet. Let's rename the sheet as variation of C19. Yeah, it's done. So to find out the variation of COVID-19, we might want to use the boxes and whiskers chart. Let's select the country or region pill from dimensions and confirm from measures. Let's over to the show me tab and select the box and whisker plot. Yeah, so you can see that we just have one box or whisker over here. When you see something like this happening on your sheet, then directly head over to analytics and uncheck the aggregate measures. So we have this kind of visualization. Maybe we forgot something, so we forgot the country or region to be placed in columns. So when you place it in the columns section, then you find out all the countries and the variation of COVID-19 in their region. Now let's sort it in the descending order so that we can find out the maximum variation which is happening in France. So of course there are less number of confirmed cases, but there is a lot of variation which states that they have something wrong with the climatic conditions or the weather conditions there. Yeah, we have a larger confirmations in, or larger cases in US, but there is some data which shows that France is leading in some variation. Yeah, so Since we are calculating the variation of the confirmation of COVID-19 presence, we have France in the first place, where it shows that there is a lot of variation in the confirmed cases in France rather than US. Yeah, that's how we can find the variation of presence of COVID-19 in a particular country. So with that, let's move into the next query. So the next query is, can we forecast the sheet of future and reference of COVID-19 presence? Yes, we can do that. Let's get back to Tableau. For that, let's create a new sheet and rename it as forecast of COVID-19 presence. So the sheet got renamed successfully. Now we'll select the observation date from the dimensions and confirmed fill from measures. So we'll use them, drag it to columns, and the confirmed from, yeah. Now we're going to change this. Okay, there is something wrong with the observation date. So for that, let's select the observation fill and change the data type to date. Yeah, so far so good. Now let's select this to day. We can change that to year. Now let's select forecast option. Yeah, so this is how it's gonna be. So in the year of 2020, we had the confirmed cases around this number, which is 760,705,3464, so which is nearly 76,370 lakh. And in the 2021, the number got a little decreased, which is 17,130 lakh cases. And in the end of 2022, which is the forecast, we can see there is a little more drop. So it's a good sign that the COVID-19 is getting decreased. So this is the forecast of the COVID-19 presence in India. So we can change the path to step 1. The line is okay. The line is pretty good. No worries on that. So basically we've finished the queries on our presentation mode. So yeah, if we get back to the presentation mode, so all the queries on the COVID-19 data are finished. Now let's create a dashboard. Yeah, we have the dashboard right now, so we can change the layout of dashboard. Let me increase the width to 1320 and decrease the height to 70 or 760. So we have the entire screen right now. Now let's drag in the confirmed cases of international level and the recovery cases of the international level. Yeah, now we have it. Okay, or let's keep it in the top and that in the bottom. The trend line of COVID in the international level and the highest death rates in the international level. It takes a little time. It's still taking a little bit more time. I don't know what's wrong. Okay, it should be done in some time. Let's wait. It's basically taking a lot of time because we have a lot of data in that particular sheet. Let's kind of change that a little. Now let's change the sheet to yeah. Or we can just remove this from the dashboard and select the least death rate or the top 10 least death rates. So we have the sheet right over here. We have the top 10 ones only here. Yeah, this is good. So this is how we can have the dashboard. And now let's create another dashboard for Indian results. So again, let's change the dimensions of the screen. Yeah, it's pretty good. Now let's take the confirmed cases in India and drop it over here, and recovery cases in India and drop it over there, and trend lines in India over here, and Indian states, and the forecast somewhere over here. And if we get back to the dashboard 1, we can even add the forecast data or the variation data somewhere over here. And we can always change the height so that it's a bit more visible. So we can rename the dashboard C19 International Dashboard, and this one as C19 Indian Dashboard. Yeah, so with that we have finished the first project based on the COVID-19 dataset. Now we'll continue with the next dataset, that is the airline dataset. So now we are in the second project, and the second project is about the airline dataset. And in this particular dataset, we're going to take the insights, which are as follows. What are the total number of flights which are taking off in a day from the San Francisco airport? And followed by that, we have the next query, which reads out, find the busiest day of San Francisco airport. We'll be finding out the top 5 busiest days in the San Francisco airport, and followed by that we'll also find what are the total number of flights per day in a month. Then we'll find out what are the top 10 busiest flight routes. Then we'll find out what are the top 10 longest flight routes from San Francisco airport. Then we have to represent the flights flying outside the San Francisco towards different parts of the world using a map chart. So these are the queries that we'll be executing in our second project. Without further ado, let's get back to the Tableau. So now we are back on the Tableau dashboard. So let's select our dataset for today. So our dataset is somewhere here. Yeah, this is the air travel dataset we were looking for. Now we got our air travel dataset loaded onto Tableau. So remember I said about the interpreter. I'll select that and show all the. Okay, let the query execute. Yeah, so the interpreter query got executed. Now the data has been cleaned. We can review the results by clicking on review results option over here. We have another query executing now. So basically this query will take us to the Microsoft Excel sheet where our cleaned data is readily available for us. There you go. You can see that the red colored data is the data that is interpreted as column headers or field names. The green color one is the data interpreted as values in your data source. So it looks something like this. So we have our data fine over here, just looking fine. Now when you come into the root column, you have San Francisco to the other parts of the world. For example, we have Los Angeles here, etc., etc. But we don't have a separate field for origin and a destination. So what we'll be doing is we'll be splitting this particular column right away here. So let's navigate to the last column, which will show us the root. So you can right click this and select the option of split, which will basically split it into two halves, which will give us the from destination or the origin of the airplane and to or the destination of the plane. So from, to, or the origin, destination fields we have right now over here. You can see that. So far so good. So let's quickly begin with our worksheet. Now we are on the worksheet right now. So what was our first query? So our first query was to find the total number of flights in a day. So for that, we have a simple step. So basically we'll have a particular number of rows, right? For the dataset what we've selected, we will have some thousands of datasets. So each and every row is actually a flight. So what we will do is just create a calculate field and just name it as number of rows. Okay, since we are trying to calculate the total number of flights, let's kind of not name it as rows. Instead we'll name it as flights, and inside the calculated field just write 1 and it should be done. So you can see the number of flights just over here. Just hover down the text and we'll have the number over here. So this is the total number of flights per day which takes off from the San Francisco airport. Let's kind of increase the text size so that it's a bit more visible. Yeah, that should be it. Let's rename the sheet. From here I would do the renaming from here because it's a little simple. Total number of flights. Yeah, that should be it. Now let's get on to the presentation mode again. Now let's execute the second query. Find the busiest day at San Francisco airport. So to execute the second query, let's just simply duplicate the sheet and rename the sheet as busiest. Okay, we can actually schedules of flights, or no, not schedules of flights, number of flights, or we can rename this as flights taking off. So when we get the count of flights taking off, then we can actually find the date which was really busy, like the date with the maximum amount of flights taking off. That would be the busiest day. So the data type is date by default. That's great. Now let's drag it to columns. Now the sum of numbers at this place. Analysis, let's uncheck this to get a map. Let's make it by month, or day. Okay, we don't need this. We don't need this. We don't need this as well. Now we have a chart over here. Let's change it to scatterplot maybe. Yeah, so we have the chart. No worries on the scatterplot thing. It's really a scatterplot. No worries on that. So right now we need to find out the busiest days. So for that we might want to drag the date into filter, and let's select the individual dates. Select next, and inside the top we have the we need to select by field, and now we have the top 10 number of flights. We need the top 10 flights. So let's select apply. We needed top 1, but why not top 10? You will select top 10 for that. Now we have the scatter plot on my sheet right now. So let's kind of arrange it in the descending order. This shows the highest number of flights, or okay. We need to change this value to sum. Yeah, it is sum. So yeah, I got to know where we made a mistake. So inside analysis we were supposed to aggregate the measures so that we can get the sum of number of flights. Now we have the total number of flights. Now let's quickly arrange this. Now we have the 3166, 3200, 3295. Yeah, so 3295 happens to be our busiest day in the year 2020, that is the 6th March, which had the maximum number of flights taking off. So we can actually make a set of these. The set of these, which happens to be in the March. So March happens to be the busiest month for San Francisco Airport. So with that, we have finished the second query. Now let's create a new sheet for our third query. Let's get back to the presentation. And the third query reads that what are the total number of flights per day in a month? So for that, let's get back to Tableau. Let's try to rename it total flights in a month. Done. So for that, let's select date and drag it to columns, and let's make it to month. Let's remove this. Let's remove this. Let's remove this as well. Now let's check it to day, and now number of flights. So automatically we have a line chart, and we have the flights taking off from March 1st to March 31st, which happens to be the busiest month for San Francisco Airport. Now let's just tick the show mark label so that we have the number of flights taking off every day. So as we got the result in the previous sheet, 290 or 3,295 flights on the date of 6th March, or is it 3rd March maybe? Yeah, that happened 6th March. That happened to be the busiest day of San Francisco Airport. Now let's get back to the presentation and check the fourth query. So the fourth query reads, what are the top 10 busiest flight routes? For that, let's get back to Tableau again. Let's rename the newly created sheet busiest routes. Now the sheet is being replaced or renamed. Now to find out the top busiest routes, we need a calculated field to remove the effects of San Francisco Airport first. So create a calculated field, and we can name it as busiest route, busy. And now inside the calculated field we need an if condition. Then if route 1 split 1 is equals to SFO, Then route 2 split 2, else route 1. And yeah, the calculation is valid. Let's apply and OK. Now we have the newly created calculated field somewhere here. I will drag that into rows, and now we'll drag the number of flights to columns. So there we go. We have the bar chart over here. Let's rearrange it in descending order so that we get the descending order. Now we needed the top 10 or top busiest routes. For that, let's drag busy into filters, select top, and by field we have top 10. Let's just select apply and OK, and we have the top busiest routes from San Francisco Airport, or SFO. Now let's get back to the presentation mode, and in the presentation mode the next query is which are the top longest flight routes from SFO. So to find out the longest routes, we'll create a new sheet and rename it as busiest, no, not busiest, longest routes. Yeah, the sheet is renamed, and you can see that we have geometric coordinates 0, 0, 0, 1, 1, 0, and 1, 1. So these not 0, 1, 1 and 1, 0 coordinates basically provide the origin information, and 0, 0 and 0, 1 provide the destination information. So we'll be creating a calculated field for that. Now let's create a calculated field. So let's rename the calculated field as origin, and inside the origin we'll make use of make point, and inside make point we'll write geometry coordinates 1, 1 and geometry coordinates we'll need the geometry coordinates 1, 1 and geometry coordinates 1, 0 separated by comma, and done. So we have the origin. Now let's create another for destination. We are creating a calculated field destination, and inside destination we are going to use the same make point and geometric coordinates 0, 0 comma geometric coordinates 0, 1, and select apply. OK. Now the origin and destination are created. Now we need to create another calculated field for distance. So we'll write it as distance, and inside that we'll use the distance function, and we'll write origin comma destination, and we'll represent the distance using kilometers. And select apply. OK. Now we have the newly created distance measure in the measure section. Now we'll drag the busy into columns and distance into rows. Okay, we made something. Oh, there's no problem. We can actually change the orientation. And now let's rearrange it in the form of descending order. Now we have the distance sorted in the descending order, but there is a small change. We have to change the sum to average. So once you change that, you want to arrange it again. Now we have the BLR, Bangalore, as the farthest airport from SFO. Yeah. Now we might want to drag the busy into filters again. Now we have the top 10, apply. Okay, so we have the top 10 longest routes from SFO. So with that, we have finished our 5th query. Let's get back to presentation mode. And the 6th query: represent the flights flying outside SFO towards different parts of the world. Yeah, that can be done. Let's get back to Tableau again. Now for the 6th query, let's create a new sheet. Let's name it as map flights from SFO. Okay, so for that, let's select the latitude and longitude and select a map. So we have the map right here. Now let's change that to map. Yeah, it's in the map section by default. Let's create a calculated field called lines. So we are basically using lines to represent the flights taking off from SFO. So I'll name it as line, or we can name it as flights line. Okay, and inside the calculated field, let's type in make line, and so inside the field, let's make use of make line function, and inside that, let's write an origin and separated by comma destination, and the calculation is valid. Apply OK. Now we have the newly created flight line over here. Now we'll drag that flight line to detail. Now once we drag that flight line to the detail, we have the lines or flights taking off from SFO to different parts of the world. Now we can make it look a bit more appealing or more informative by dragging the routes, or into detail. So we have the details of routes, and we can even drag the distance into detail. So when we hover over to the line, we'll have the route and the distance as well. Yeah, so that's how it is done. Now we're basically done with all the queries. Now let's create a dashboard. So now let's kind of arrange the dashboard size convenient to our monitor. So I'll increase it to 1320 width and decrease the height to 760. So that's the proper size what I was looking for. Now we'll drag the details into the sheet. Longest routes. We have the flights taking off, busiest routes, longest routes, and total flights into here. Now it looks more readable. Fine, so we have the busiest routes, we have the longest routes, we have the flights taking off in the month of March. The busiest month was the March, and the busiest day was 6th of March. I don't know what was so special on that day. If you know it, please let me know in the comment section below. And yeah, so totally we created a dashboard. Now let's rename the dashboard as SFO flight data dashboard, and we are done. So we are done with the second project. Now let's get back to our presentation and let's check the last project, that happens to be the space missions dataset. So now we are in the third project, which is based on space missions dataset. So using this particular dataset, we're going to get some insights which are based on the queries on my screen right now. So we're going to find out what are the average temperature details of the launch sites. What are the average wind speed details of the launch sites? What are the average humidity details of the launch sites? So we need all these to, before launching a satellite or a rocket into space. Everything needs to be in ideal condition. So followed by that, we have what are the different varieties of launch vehicles used by different companies. So there are a lot many companies. Few are from government sector, few are from private sector. For example, USA military satellites belong to government, and private satellites like SpaceX, yeah, and few others. Next, we have what is the mission status of the company. So we have a list of satellites launched already, right? So we need the mission status of that particular satellite. Is it a successful launch, or was there some failure record or something like that? Next, at the last query, we have the track records of launch sites. So what are the track records? So what are the successful launches? What are the failure launches? What are the satellites launched by different companies, etc., etc. We'll have a complete track record of that, of all the launch sites which are available in our dataset. Now, without further ado, let's get back to Tableau and start the project. So we are on Tableau. Now we're going to extract the dataset. So the dataset we need is the space missions dataset. You can get this in the Kaggle, or you can even have the access to this dataset from the description box below. Select open to open the data. So yeah, the data got successfully loaded. Again, use the interpreter, and it's a good habit of using the interpreter to clean your data and make everything understandable or look understandable. Show all the answers, everything is fine. So we're good to go with the dataset what we have in our Tableau right now. Now with that, let's get back to the first sheet. Now let's check the first query that we have in our presentation. What are the average temperature details of launch sites? So for that, let's create a new sheet. Yeah, it's created. Rename it as AVG temperatures. Or launch site temperatures. So now we need the launch site and select the temperature, and hover over to the show me tab, and let's select the bubbles chart. So now you can see the temperature is in the sum, but we don't need the sum here. We need to change that to average. Now we have the average temperatures of the launch sites. Now let's kind of select label show marks here. So we can do one more thing. We can drag the temperature onto the label. Now we have the temperature here. Now let's again change the measure to average. Now we have the average temperatures of the launch sites in Fahrenheit. Yeah, that's pretty well. Now let's get back to the presentation, and the next query is what are the average wind speed details of the launch sites. Let's get back to Tableau again. Let's create a new sheet, launch site wind speeds. Now let's drag the launch site into columns and wind speed from measures into rows. And you can see automatically we have a bar chart, but to make it a little bit more readable, let's select the boxes and whiskers chart. Yeah, you know what to do now. Go to analysis, uncheck the aggregate measures options, and let's drag the launch site again onto columns. Now we have the different box and whiskers for different sites. So let's kind of arrange it. Yeah, so the wind speeds at Kennedy Space Center are here, 20 miles, and 23 at Vandenberg, and Marshall at 9. Yeah, so this is the wind speeds at different launch sites. Now let's get back to the presentation mode, and now we have to find the humidity details of launch sites. So let's get back to Tableau. Now we are back on Tableau. Let's rename it humidity launch site Now let's select the launch site and humidity, then a pie chart. The pie chart is really small, so we can select the entire view. Now we have the sum of humidity, but we need the average humidity. And now let's drag humidity onto label and launch site to label. Now we have the detailed humidity. No, we need to select the measure to average again, and here to average again. Yeah, so we have the humidity percentage of launch sites on the pie chart over here. So with that we are done. Now let's get back to presentation again. Now our fourth query, which states that what are the different varieties of launch vehicles used by different companies. For that, let's get back to Tableau. Now let's create a new sheet. Launch vehicle details. Yeah. Now this query is pretty straightforward. Select company and vehicle type, and we should be done. So there we go. We have the company name and vehicles used for the launching of satellites process. Now let's get back to the presentation mode. Let's select the next query. What is the mission status of companies? Now let's get back to Tableau. Let's create a new sheet and rename it as mission status. Now we are back on Tableau. Now let's select the company, drag that to columns, and mission status to columns, and we'll select one parameter from measures so that we can get a good bar chart, side-by-side bar chart. And now we can drag the company to color so that we can have different colors for different companies. So we have the mission details. So SpaceX found a maximum success in the recent days and little failures, and yeah, Boeing found good success as well and some failures. So these are the mission status of different companies and different satellites as well. So we have even US Air Force here faced some satellites here, some failures in some satellites. It's okay. So now let's get back to presentation mode. Now the sixth query is track records of launch sites. Okay, we had the payload as sum, so we change it to count, distinct count. So now we have a better observation of failures and successes over here. So as we discussed in the sixth query, now we need to find the track records of launch sites. Now let's create a new sheet, rename it as track records. And now let's drag the company to columns and mission status to columns again. And now let's drag the launch site. Yeah, I think we might want to drag the mission status to rows. Yeah. Let's click on text. Now let's drag the space missions count to color and space mission count to labels. Now let's use this one. Yeah. Now we have the stats or the track records of different space centers or launch sites, and we have the failures and success rates over here. Yeah, so basically we have done the last sheet or last query executed. Now let's create a new dashboard. As we always do, change the resolution according to the monitor we have. So I'm going to use 1030p. And height as 760. Now let's drag the sheets. So we have the launch temperatures, launch wind speeds, and launch site humidity at one place. Now the launch vehicles used, mission status, and the track records. So we'll kind of drag it here, and this one over here, this little bit over here, and this one over here. So now we can actually, select the track records of Cape Carnival. We have the site temperature, we have the site humidity, we have the site wind speed, and the track records of that particular site, and launch vehicles launched, mission status, everything on one single dashboard. So that's how you make use of dashboards in real time.
Today we'll be going over answers to common interview questions for Tableau positions. First question is, what are the data types supported in Tableau? We have string, date and time, numerical, Boolean, so true or false, and geographical. In Tableau, you can tell what kind of data type you have. So when you're on the data source tab, you can see that this is numerical and this is string. Here we have a date. We don't have any date times here. That would have the little clock icon. And we also have geographical. These are set by default, and you can change them by clicking on the icon. And say we wanted row ID to allow text, so we'll change it to string. And you can see the icon changes there. The next question has to do with how well you understand dimensions and measures. So a key thing to remember is that dimensions are qualitative and measures are quantitative. And if you can remember those particular words, it helps convey what the interviewer is looking for. So dimensions are qualitative, and you can use them to categorize your data. So for example, you can categorize your data by what country it comes from. And measures are quantitative and can be aggregated. So you can do a sum of sales, or you can do the average profit. Did you know that Tableau automatically assigns each field a data type and a role, and that automatically aggregates your measures using sum? But you can change what the default aggregation is. Question 3. What do you understand by discrete and continuous in Tableau? So we have discrete values and continuous values. Discrete is represented as blue and continuous is represented as green. So let's look in Tableau. When we go to our worksheet, you can see that all of the dimensions are automatically blue and all of the measures are green. However, you can have a continuous dimension and you can have a discrete measure. So we have discrete dimensions, which is a blue dimension, but also continuous dimensions, and date is a good example of that. Let's take a look. So we pull on order date. We right now have year, and it's making categories instead of a continuous axis, so it's making a finite list there. But we can change it to be, you can see now it's marked as continuous here, and it's green, and we can change it to be an axis. Instead of different categories, it would be a continuous axis. So you can also have discrete measures, which are blue measures, and continuous measures in the green. So for example, let's say we had a visualization that had the region and sales and profit. But instead of having an axis for profit, maybe we just wanted to have a number for the profit listed right next to the region, and then we could have the sales visualization. So what we could do is change it to a discrete value and put it next to region, and now it's part of the labels. And that's an example of having a discrete measure. Did you know that continuous is infinite and discrete is finite? Those are some key words that you could use also to describe the difference between continuous and discrete. And also just remember that discrete is blue and continuous is green. The next question, number 4, is what are filters? And name the different filters in Tableau. So filters are a way to restrict the data that allows you to only see the data that you want to see in your workbook or dashboard. And there are these different types of filters, and they also have a specific order. So if you can remember the different filters, that's helpful. but also if you can remember what order they apply in, that'll get you some definite bonus points in your interview. We have extract filters that filter the data as it extracts, and it will affect how big your extract is. We also have data source filters here, which will filter the data out of the data source. However, the extract will still be the same size. So let's take a look at this handy visualization that Tableau has on their website. We have the order of operations, and in blue we have our filters. So extracts is first, and it filters down your extract to just what you've selected. Then we have data source filters that will apply to the entire data source. So any visualization that uses that data source will have these filters. We also have context filters, which are next, which come before some of these level of details. That's the major difference, is that it applies before some of these sets and conditional values. And then you will do dimensions and then measures. So any filters that happen on dimensions happen before any measure filters. The last type of filter we have is a table calculation filter, which happens after all of the rest of them and basically just applies to your visualization, just the one visualization. Question number 5. There are 3 customer segments in the Superstore dataset. What % of the total profits is associated with the corporate segment? Perfect. So in some Tableau interviews, you may be asked to build a visualization. For our examples here, we'll be using the Superstore dataset, and if you don't have access to the Superstore dataset, just comment below and somebody on the Simplilearn team will help you get access to that. Also, this is a fun opportunity to pause the video, and then you can work on this on your own, and then come back and see if what you did was the right thing or how we did it differently. Also, you can comment below on what your answer is, and we'll see if we can all get the right thing. So let's build this. 3 customer segments in the Superstore dataset. What % of the total profits is associated with corporate segment? Great. So we're going to bring on our segments, and we have consumer, corporate, and home office. And let's bring on our total profit. So I just did that by double clicking, and now it's just bringing on the sum for each of those by default, but we want to figure out what % of the total each of these are. So we can change this to be a table calculation. We can click add table calculation, or we can do a quick table calculation and find % of total. So let's go back to our question. We wanted to know the % of total profits associated with the corporate segment. And the corporate segment has 32.12% of the total profits. And here's our solution with 32.12%. So did you get it right? Comment below if you got that. What are the different joins in Tableau? Give an example. So in Tableau, you can join your data. So if we wanted to look at orders and tie it to people, we can pull on people and it will give you this visualization, and you can see all the different joins here, and we'll discuss those in just a second. You also have the opportunity to union information, which would be if we had maybe 2 Excel sheets that had orders information. Perhaps one of them had 2012 and one of them had 2013. Then you could take your orders and pull it. So you see that pop up, drag table to union. And that's another way to add more data. And so those are all worth mentioning. Let's take a look at the different kinds of joins. We have our inner join, which will only give you the values that have matches in both tables. Our left join, that will give you all the values in the left table and its matches in the right table. And then the right join, which will give you all the values in the right table and its matches in the left table. The outer join, also known as a full outer join, will give you all the values in the left and the right table. And then as we discussed the union, you can see it's represented by a more vertical join, and what it does is it adds more rows. All the rest of these are about adding more columns, but this will add more rows in the same columns that you had before. If you have the opportunity to draw out the answer to this question and make these Venn diagrams, it's a really helpful way for you to explain your point, and it really portrays that you know what you're talking about. What is the difference between a join and blending in Tableau? So I just showed you how to make a join here, and we are joining an Excel sheet to another Excel sheet, all within the same connection to that Excel file. So when you're joining data, we'll look over here at the joining side, that's when you're bringing 2 or more tables within the same data source, and that's how you join it. And so we're all inside of a data source here, which, when I go to sheet 1, just has one data source here called orders, whatever we wanted to call it, and that is all within one data source. However, let's say we already had 2 different data sources in Tableau, and we wanted to bring together 2 of them. So in this case, it's an Oracle table, and we brought in an Oracle table and we made a data source, and then also an Excel table that had a second data source, and you can blend it together to get your combined data set. So the major difference, what you're going to really want to take away from this, is that blending is from 2 separate Tableau data sources, and that joining is all within one data source, and it ends up just being one data source in the end. In blending, each data source contains its own set of dimensions and measures, and when you join, it will combine it into one set of dimensions and measures. So let's go back to our example here. Let's bring on people. It is automatically said we're going to join it on region, and we're going to do an inner join. That's fine by me. And so we come here, and now we have just one set of dimension and measures under orders. However, if we were to add a second data source, which we will, it'll be an Excel file, and it will be based off of this rank example. We'll open that up, and now when we go to sheet 1, we have 2 data sources. And if we were to blend this data together, we would still see 2 separate sets of data, only we would be able to pull in from this set some information, and we'd pull in from this set some other information. So that's a visual difference between blending and joining. Question number 8 is, what is the difference between a live and an extract? So first we'll talk about live, and we'll say that your dashboard is connected live to a database. And so a live connection will query that database every time you open up the dashboard or visualization, so that you're getting the most recent information each time. And it's useful for if you need information that's a little bit more real-time. However, it can be slower, especially if your queries are complicated. With an extract, it will run the query beforehand and store the information on Tableau server or on your local machine, and so that it's faster to get to. However, it is not real-time information. So if you had a refresh of your extract that runs every day in the morning, and then during the day somebody has made a change to your database, they won't see that change on your dashboard until the next time the refresh runs for your extract. In Tableau, you can set if you want the connection to be live or extract when you first are making your data source. And this is in Tableau Desktop. In Tableau Public, you don't have that option. Did you know that the reason that extracts are faster is because Tableau doesn't need to access the database each time it builds the visualization? And did you know that you can set up a refresh schedule on Tableau server in order to be able to see your extracted data update? Question 9. What is a calculated field, and how will you create one? So if we look at our data set here, we have the opportunity to see the difference between order date and ship date. So to create a calculated field, you click Create Calculated Field with this drop-down arrow at the top, or you can right-click in white space, Create Calculated Field, then you give it a name, and we're going to call it Shipping Delay, and we are going to do a date diff. So if you don't see this dialog box here, you can click this arrow to see that. Our date part is day, the start date is order date, and the end date is ship date. So to remember how to create a calculated field, it's by clicking this down arrow and clicking Create Calculated Field, and then writing your query here. And a calculated field is an additional field made up using the data that you already have. So we've made a new field here, and it has the equal sign at the beginning. That might be worth mentioning, how to tell if it's a calculated field or if it was an original field. And then we can bring shipping delay here, and we can see the number of days that it took between the order date and the ship date. We could also duplicate a calculated field. So now we have shipping delay copy, and we're going to call this average shipping delay, and we're going to encapsulate it inside an average function. And now if we take off the order ID, the order date, and the ship date, it's automatically summing up those days, but we can bring on our average shipping delay. And you can see on average how many days it took. And let's change our number here to include decimal places. So a calculated field is a new field made from existing data. It can be used to create more robust visualizations, and it does not affect the original data set. For example, we made our average delay function here using data from our original data set. Question 10. How can you display top 5 and last 5 sales in the same view? You can show top 5 and last 5 sales for a same dimension by creating a set. So let's take a look at doing that here. We have our customers. So let's bring on customer name. And we're going to do it based on profit. So now that we've done it on profit, we can see these are our top 5 profit, and I've sorted it by profit. And here's our bottom 5. And we can create a set by coming and clicking on the dimension that we want the set to be based on. We'll right click there, and we will come to create and click set. And we're going to call this top customers. Top by field, top 5 by sum of profit. And now we have a set. It makes a set section here. Now we're going to make a second set off of customer name. Create set. Bottom customers. Bottom 5 by sum of profit. We'll hit OK. And now we're going to combine these two sets. So I'm going to control click, and then we have both of them selected. And we're going to click create combined set. Top and bottom customers. And we're going to have it include all members of both sets. And now we can pull top and bottom customers onto filters. And you can see our top 5 and our bottom 5. So if we control drag profit onto color, then it's colored by that as well. So key thing to remember is that you can use sets to show both the top and the bottom in the same visualization, and that you can combine those sets. Is there a difference between sets and groups in Tableau? The answer to this is yes. You can describe a group as being simpler and using only one dimension to determine the group, whereas a set can be more complex. So you could say sets are more complex, and you can use conditions to create the sets, and you can also use multiple dimensions and measures to create the sets. For example, here we create a group of subcategory. So we grab all of these things together and can group it, and that we'll have copiers and envelopes, and then we'll have one group of all of these together. Over here, you could create a set that looks at sales and profits to create a set. So the best way I can describe this is by looking at what we did here. And so we were able to use dynamic filtering here to create our sets, and where it will look at the top 5 or the bottom 5. And let's do the same thing we did there, but use a group. So for a group, we could see that these, we've sorted it, and we can say 1, 2, 3, 4, 5. This is the top 5. So we could create a group. That's this paperclip here. And now we have a group of the top 5. And it's added that group. It makes a new group, customer name group. And it put it on the color for us. Now let's go to the bottom. And we're going to go 1, 2, 3, 4, 5. And we'll create our group. So now we have a top 5 group, a bottom 5 group, so let's name them that. And we'll do that by clicking Edit Alias. Top customers. Okay, and we'll come here and we'll rename that. Bottom customers. Okay, and we'll put our top customers on top. And then let's hide all of the others. So we'll click Exclude there. And now we have a similar visualization as we had before for our sets. Top, bottom. However, a key difference here is that we had to go through and select the top 5 and the bottom 5. So let's say that maybe let's say Henry Goldwyn has suddenly had much more positive profit associated with them. If that changes, he's going to still stay in our group. This group is just using these customer names to determine who's in the group. So the group is Henry, Sherelle, Luke, Grant, and Cindy, no matter if their data changes. So say tomorrow all of this data is different, it's still going to put these people into the group. However, the sets, as you saw before, is based off of the profit, the sum of profit, and who has the top 5 and who has the bottom 5. If Raymond suddenly has a lot less profit and falls out of the group, then the groups won't pick it up, but the sets will. So that's one thing to remember, is that it could be based on conditions. And then you saw how we took 2 sets and put them together into our combined group. You could also have a set that is based off of 2 different dimensions or 2 different measures. And that's how you could put those 2 sets together and get dynamic sets. So the major differences, as we saw, is that a group is just based off of 1 dimension, and a set can have conditions and be based off of other dimensions. Also, you need to know that groups cannot be used in calculated fields, but sets can. Question 12. What is a parameter in Tableau, and give an example? A parameter is a dynamic value that a customer could select, and you can use it to replace constant values in calculations, filters, and reference lines. So, for example, here we determined we wanted bottom 5 and top 5 customers, but let's give them some options. So we'll create a parameter, and we'll call it select number of top, bottom customers. And we're going to let it be a range with a minimum of 5 and a maximum of 20 and a step size of 5. So we'll let them go 5 at a time. Okay? Now if we click show parameter control, we can see our parameter control, and you can do 5, 10, 15, or 20. But since it's not in any of our calculated fields or sets or filters, then it's not making any difference. So let's put it inside of these. We'll edit our set, and instead of bottom 5, we'll click bottom, select number of top bottom customers. So now it's taking our parameter and inserting it in to our set there. We'll do the same thing with top customers. Okay, and now right now we see top 5, bottom 5. If we change it, now we see top 10, bottom 10, 15, and there's our 20. So it replaces a constant value and allows the end user to select the value. Question 13. What is the difference between tree maps and heat maps? So let's first talk about what each of these are. Heat maps compare categories using size and color. I think the biggest thing about heat maps is the color. Size is somewhat optional, so let's build this visualization quickly. So we have region, category, and subcategory. And we're making a heat map, so we want to bring profit onto color. And you can see we've got hotter and colder. In this case, for a heat map, we might want to change. So in this case, what it's doing is hotter is negative, but we could reverse that, and then hotter is positive. And so hotter maybe means this is where more activity is. We can also double click on profit. We can also bring profit onto label, and we'll change this to square, and now it's marked at what everything is. So a heat map will use color to draw your eye to the places where there's heat or maybe activity. We could also use size in this case. So it's not just defined by color necessarily. Maybe we want the size to be defined by sales. So we get things that are bigger but they're blue, which means that they are bigger in sales but their profit is negative. And it draws your eyes to technology. So machines in the South are doing a lot of sales, but they're not having positive profit necessarily. Also, you can see some things that have darker colors but are smaller. So high profit, but not a lot of sales. So that is a heat map. A tree map is used to represent hierarchical data. Now, hierarchy is the term you need to remember when you're talking about the difference between a tree map and a heat map. In the heat map, none of these boxes have to do with the hierarchy with each other. Whereas with a tree map, you can see that this box has a thick white line between it and the other ones. And that means that that section are all connected. So these are all technology. And the bigger this section is, that means the bigger the, size is based off of profit. So this bigger section means that technology has more profit than furniture. So let's build this one. When I build tree maps, I like to use our Show Me tool. So here's a tree map, and it says 1 or more dimensions or 1 to 2 measures. So we're going to grab category, and we're going to control-click subcategory, and we're going to control-click profit and sales. And we'll click on our tree map. Perfect. And so the darker the color, that means the more sales there is. And that's pretty similar to our heat map over here. So the color indicated, in this case it was profit. So the color indicates the difference and the size indicates the difference. And that's true over here. The color indicates a difference and the size indicates a difference. However, there is a hierarchy to it. Over here you can see that there is hierarchies because we have furniture, and then that puts that all together under furniture. And then here's the subcategories. However, if you were trying to compare furniture to office supplies, it's really difficult to tell which one has more sales. But if we go over to sheet 7 that has our tree map on it, you can see really quickly that office supplies has much more sales than furniture. In this case, office supplies has much more profit than furniture. The biggest difference is that tree maps have the hierarchy. Question number 14. What is the difference between TWBX and TWB? So these are all Tableau file formats, and the TWBX contains all of the necessary information to build a visualization. So it's called a packaged workbook, and it compresses it all together. However, the TWB just contains instructions about how to interact with the data source. So when it's building a visualization, Tableau will look at the data source and then build the visualization. With an extract, it contains all of the information that you need, so all of the data is wrapped up inside of there, and there's no connection that has to be made between Tableau and the data source because it's all right inside. Whereas with the TWB, it has to connect to the data source or else it doesn't have the data to build the visualizations. It just knows, it has the instructions of what to do with that data. So the biggest difference is TWBX has the data inside of it, whereas a TWB only has the instructions. Question 15. Explain the difference between Tableau worksheet, dashboard, story, and workbook. Perfect. Here's a breakdown and explanation of each of those. And in Tableau, this entire thing that we've been looking at, all of these sheets, is a workbook. However, this sheet 7 is just one worksheet. All of them together is a workbook, and sheet 7 is a worksheet. The big difference between worksheet and a dashboard is that the worksheet is just one visualization, and so it is only one set of columns and rows here. And a dashboard could contain multiple visualizations. So if we wanted to see our heat map and our tree map on the same page, that would be a dashboard. And then a story is somewhat similar to a presentation mode. And so you can have different pages. And so we could say here is our heat map. And then we could make another page and look at our tree map. And then look at our heat map. And then we could duplicate that page. And we could say, let's focus on furniture. So we're going to highlight furniture. And then, so if we were to go through these one at a time, we would say, here's our tree map, and then we would look at information there, and we would say, here's our heat map, and then the next screen we'll say, let's focus on furniture, and you can see that it highlighted furniture for me when I went to the next scene. So a story can show you things one at a time. It's like a presentation mode. So the differences are the workbook contains the sheets and the dashboards are the stories. The worksheet is a single view, dashboard is multiple views, and a story is a sequence. A sequence is a good keyword to remember when you're describing a story. And did you know that the only place that you can access the dimensions and the measures and custom fields we've made is on a worksheet? So when you're looking at a dashboard, so on a worksheet we see dimensions and measures. When you're looking at a dashboard, you no longer see dimensions and measures. What you do see are all of the worksheets. Similarly, when you look at a story, you no longer see any dimensions and measures, but you do see all the worksheets and the dashboards. Question 16. What do you understand by blended axis? With a blended axis, you can use two measures that share an axis, and that means they necessarily have the same scale. So let's build something with a blended axis. So we can make a visualization that looks at sales over time. We'll bring on order date. And let's just do order date by month. There we go. So we can see sales over time. And say we wanted to also see profit. This is two visualizations that have two different axes. But if we wanted them to have the same axes and just the same marks card, you see how I made two different marks cards? We could bring on measure values and take off all the measures that we don't want. We just want. When we take them off here, it's creating this filter here for measure names. And let's take off these two extra visualizations. And now we have a visualization that has a blended axis for sales over time and profit over time. And you can see that they necessarily have the same axes. There is no second axis. What is the use of a dual axis? And how do you create one? Perfect. So a dual axis allows you to compare measures and you can have two different scales. So if we had this same visualization, that same information that we wanted to see with, again, profit and sales over time, we'll do, okay, great. And we wanted them to have the same axes. We could right click on the second pill of the measures and click dual axis. And now you can see that they do not share the same axis, and you can see profit is much higher here, right there. And so the use of this would be, sometimes you need things to have different axes. If you come here and you click synchronize axes, you end up getting a pretty similar visualization, but you do get two separate marks cards. So a key thing to bring up if you are asked the difference between a blended axis and a dual axis chart is, one, that the blended axis uses the same scale and a dual axis could have two different scales. And two, a dual axis has two marks cards. So let's say we wanted our profit to not be a line chart, but to be a bar chart. That gives you that option. When you go to the blended axis, we only have one marks card, so we change it to bar, everything is bar. But back over here, we change it to circles, and we see the circles. So if we wanted to show sales by year and profit ratio by year in the same view, that's where two different scales could be handy. Let's build that visualization. So we'll make a new chart, and we'll bring on sales and profit ratio over time. That is profit. I still did profit, so I'll drag profit ratio right over top of profit. There we go. And you can see that they can't use the same scale because this is a percentage, and so if we had them on a blended axis, 20% is really 0.2, and it would just be so tiny. But if we wanted them on the same area to apply to the same space here, we could dual axis it. That you can still see useful information there. But otherwise, this would just be in such a tiny, tiny space. So our profit ratio would just show up right here, almost like a straight line. Question 18. What will the following function return? Left 3, Tableau. Here's the question again, and here are the potential answers: tab, or EAU, error, or none of the above. So just take a moment and see if you can answer this question correctly. Go ahead and pause the video, and if you get the answer, you can comment below, and then we will discuss. We've taken some time to answer this question, and let's go ahead and see what the answer is. The answer is it will return an error. That's because the syntax for left is that the string must go first. First you say left, then you put the string, and then you put the number. So let's talk about what left does. It returns a specific number of characters from the left, and if you had done it correctly, the left is this side. So if you had done the string first and you said you want 3, the result would be TAB. There's also one called right, and that would come from the other end and go EAU. So that's where these answers came from. Question 19. How do you handle null and other special values? Tableau is unable to plot null values or zeros or negative values on a logarithmic axis, and so it will display an indicator in the lower right corner, which looks like this, telling you that it is unable to draw those 2 points. So when you click on the indicator, you can choose from the following. First, you can choose to filter the data, which will exclude the null values from the visualization, or you can click Show Data at the Default Position. So we'll look at both of these. So you click on your indicator and it will say, what do you want to do with these 2 values? If we click Filter the Data, then you can see that it has filtered that blank space and drawn a line connecting those dates in between. Even though there is no point for the 29th or the 30th, it goes straight from the 28th to the 31st. So what's happening on our visualization is it's adding this filter. If we press the back button, we see that filter disappears. If we come down and select Filter the Data, it adds a filter here that then only includes non-null values. So those are all removed from our visualization. And up to this point, you can see that we have 1 point per day, the 21st, the 22nd, the 23rd, the 24th. But then when we get to the 28th, we don't have a 29th or 30th, and it just draws that line to the 31st. Assuming that during that time period, what we want is a straight line. Now the other option would be, we could also make the assumption that whenever there is a null value, that actually means 0 sales have happened during that time. So that's when you would click Show Data at Default Position. And now it draws those 2 points at the 0 line. And when you hover, it still shows sales null. So, and when you hover here, you can see the actual amount for sales during that time. So if a null in your data means 0, then Show at Default Position is good for you. And if it doesn't necessarily mean 0, then you can filter the data, or you can leave it disconnected like this. Question 20. Find the top product subcategories by sales within each delivery method. Which subcategory is ranked number 2 for first class ship mode? If you'd like to pause the video and work on this on your own and then see if what you did matches what we did, then you're welcome to now at this time, and comment below what your answer is. Okay. So we want to know by subcategory and by ship mode which subcategory ranks the highest for each ship mode. So in sales. So if we take sales onto the visualization, we can see that by the ship mode, it's already split up, and we could see that maybe this one for standard class, it would be chairs. You can kind of look through and kind of, oh, it's not chairs. Chairs isn't number 1 because we have this one, it's phones. So to make it easier, we're going to change sum of sales to a rank table calculation. So we're going to come here and click Add Table Calculation. And we're going to change the calculation type to rank. And it's going to rank them in order of sales. So, but right now, we can see that it's highlighting. That's called Calculation Assistance, helping us understand how it's ranking us. So if I unselect Calculation Assistance, then it gets rid of it. But you can see right now, it's ranking it across the table. So it says accessories has most sales in standard class, then second class, then first class, then same day. And that's not what we want to see. We want to see it up and down. We want to see for first class which subcategory has the highest sales and second highest sales. So let's turn back on our calculation assistants and we're going to click table down. And you can see now it's going up and down. Within first class, what are all the subcategories ranked? So that's what we want. Now, as soon as you click things in the table calculation, it applies it over here, so you don't have an OK button. So you can just close that out. And you can see now we have a rank up and down for the subcategory. So back to the question, was which subcategory is ranked second for first class shift mode? Here's first class. Let's find number 2. It's chairs. Question number 21. Find the customer with the lowest overall profit. What is his/her profit ratio? Let's go ahead and build this visualization. Customer profit. And we're going to bring all of our customers on. And then we're going to bring on profit. Let's do it as a visualization, so I'll bring it onto columns. And then let's sort smallest to biggest. So Cindy Stewart is the one who has our lowest profit. And now to figure out her profit ratio, we need to make a calculated field, which I've already made here. So in this calculated field, we take the sum of profit and divide it by the sum of sales. We do this so that it will sum up all of the profit per row. So for Cindy, we want to take all of her profit over all of her transactions and divide it by all of her sales instead of doing it row by row, profit divided by sales, and then summing that up at the end. So we'll take our profit ratio and put it on the label, and we can see what her profit ratio is. And since it's a ratio, here I have it in a percent. If you don't have your profit ratio set up as a percent, it will look like this, negative 1.65. Question number 22. What is the rank function in Tableau? We got a look at the rank function earlier when we figured out our top product subcategories by sales and what was ranked number 2. So I'm sure you're familiar with what ranking is, which is assigning something a position like first place or second place, usually within a category and usually based on a measure. So Tableau is able to rank in several different ways, where you can do rank or rank dense, rank modified, or rank unique. And we'll take a look at these in a visualization here and talk about the difference. But if you are asked about the rank function in Tableau, it's worth bringing up that there are several different ways to rank, and going into a little bit of detail on those different ways will be helpful for you. So let's build off of this rank example instead. So we're going to bring on our store, and we've got store A, B, C, D, and E. And then we'll bring on our sales. And store A had $10 and E had $40. So now let's create a calculated field. We're going to call it rank. We're going to do a rank calculated field based on sales. We're going to do a rank calculated field based on sum of sales. Perfect. Okay. We'll double click on rank, and we can see first place is the one who had the most sales, and fifth place is the one with the least sales. Now, we had a tie here at 20, and it gave them both third place, and then it skipped fourth place and went to fifth place. And that's how the basic rank function works. So if we duplicate it, and we edit our copy, and we're going to make this one rank dense. You know what? Let's do rank modified second. Okay. And we bring on rank modified. Let's have this happen in order. So sum of sales, then rank modified. Now you can see It's similar to rank, first, second, but then it skips third and goes to fourth, and then fifth. So over here it gave them a higher number when there was a tie, and over here it gave them the lower number when there was a tie. So if you could remember that rank gives them the higher number and rank modified gives them the lower number, that will be helpful for your interview. Now we're going to take a look at rank dense. Rank dense, apply. And rank dense doesn't skip a number. So it goes 1, 2, 3, 4, and it condenses the ranking without skipping any numbers. And now let's do our last one, which is going to be rank unique. Okay, and with rank unique, it refuses to give two the same rank. And how it determines when there is a tie is it will look at the dimension that's in the visualization and do whichever one comes first in ASCII. So it goes 1, 2, and these are a tie, and since capital B comes before lowercase c, then it's doing B first, then C, then A. So in your interview, it would be really impressive to talk about the different versions of ranks and how they all work. Question 23. How can you embed a web page in a dashboard? So we're just going to build this and then explain it. So I have here my map by sales, and we're going to build a dashboard. We'll bring on, first we'll change our layout so I can fill up the screen. Then let's bring on my map. And I've added the state name and the sales on the map here. For an embedded web page, you can grab it from the objects section, the web page, and then you could put a URL right inside of here, and then that will embed that page underneath. So if we wanted to do Wikipedia or something, we can hit OK, and it will take you to Wikipedia. But what we're going to do is make this page dynamic based on what state you select. It'll look up that Wikipedia page for that state, so you could maybe look at some population data. We'll close that, and we'll try again. We're going to bring on our web page. It's going to ask for a URL, but we're just going to hit OK and not provide it with a URL. And then we'll use this dashboard action and create a URL action that then contains our URL with our state appended at the end, which is how Wikipedia formats their URL. So we'll hit OK. Oh, I forgot one more thing. Let's do it on select instead of on menu, so whenever we select something, it will run this. OK, OK, and now when we select Texas, it brings up the Texas Wikipedia page. When we select Nebraska, it'll change. So the major points to know on how to embed a web page is you bring it in from the objects section, and then if they ask how to make it dynamic, you use dashboard actions and a URL action. Question 24. Design a view to show region-wide profit and sales. So one way you could do this is by bringing on region and then bringing on profit and sales. And that's a pretty simple view of profit and sales by region. However, one thing that interviewers may be looking for when asking a question about region is your mapping capabilities in Tableau. So what we could do is, region is not a geographic location, so it takes a little bit of creativity, but if you bring on state by double clicking it and it maps out the states, you can make it a map here and it fills it in, and then you can bring region onto color and that splits it up by region. And then if you bring on profit and sales on the labels, and let's also bring on the state onto labels. And then you can look at your profit and sales inside of their regions, inside of their states. And so that is another view where you could look at profit and sales by region. And it's a little bit more, takes advantage of some of the mapping capabilities in Tableau. It may be what your interviewer is looking for. So you could discuss multiple ways to look at it. but here is one way that we could recommend it. Question 25. How can you optimize the performance of a dashboard? There are multiple ways to optimize the performance of the dashboard. Some of the things that you might mention is that you could exclude any fields you're not using from your visualization, just keep them off, or you can use extract filters, and if you recall, extract filters will remove out rows of data from the extract, and so only focus on the data that you need. Another thing you can do is try and limit the amount of filters that you use, and when you do use filters, avoid using quick filters, and you can use action filters and parameter filters instead. Filters cause your queries in the database to be a little bit more complex and can keep them from running as efficiently as they could. Use min and max instead of average because average functions require more processing time than min and max. Also, you can try to use Boolean and numerical calculations because computers do better with integers and Booleans than they do with strings. So, quick things to remember is keep your data simple, use fewer filters, and when you do use filters, use parameters or actions. Avoid using average, use min and max, and avoid using strings by using Booleans and numerical calculations. Question 26. Which visualization will be used in the given scenarios? Here we have 3 scenarios of opportunities that you might want to visualize, and there is no perfectly exact answer for these, but there are some visualizations that tend better for certain types of data. However, there sometimes could be different ways to visualize it, and it doesn't mean that these are the very best ways. However, if you want to take a moment, go ahead and pause the video and go through and figure out what your 3 answers are and comment below, and we can discuss what we think the best ways are. So first we want to show aggregated sales totals across a range of product categories and subcategories. We want to show the duration of events or activities, and we want to show quarter-wise profit growth. So to show aggregated sales totals across a range of products, subcategories, and categories, you could use a tree map. The reason we bring up a tree map here is that they are known for allowing you to show a visualization using hierarchies. So let's take a look at that. We're going to show aggregated sales totals across a range of product categories and subcategories. So if we come here and make a sheet, and we want to see sales across control click category and subcategory, and then we click a tree map, what happens, it's showing it based on size and color, and so it shows the size, the bigger the size, the more sales, and the darker the color, the more sales. And the reason we choose a tree map over just a normal heat map is that it makes a category here. So we can compare this box that has all the technology in it, see how all of these are technology, to this box that has all of the office supplies. And you can quickly see that technology has more than office supplies, but you can also see that phones has more than art. And it breaks it up as a hierarchy and breaks it up based on your sum of sales. And question 2 is show duration or events, a duration of events or activities. And you would use a Gantt chart. Gantt charts are used to show duration. And each of these lines is a duration. So it's like it's got a start date and end date basically. And it shows you how long everything takes. And the last one is to show profit growth, and you can use a waterfall chart. And that looks like this, where you can see how the profit changes across every period and if it's going up or down, and each one of these show you how much up or how much down they go. But as we said, there are potentially other answers to this question, so if you have any questions about why we didn't say this chart or that chart, go ahead and comment below and we can start a discussion. Question 27. What would you do if some countries or provinces or any geographical entity is missing and displaying a null when you use map view? So when you start to map the geographical fields that you have, sometimes Tableau is unable to map them because their locations are unknown or ambiguous, meaning a lot of states have a city called Springfield, and it won't know where to draw that city. So for example, let's look at here. So we've taken city as our detail, and it's drawn a lot of cities. However, it's got a lot of unknown values here. So if this question comes up, you've got to remember these 3 things. You can edit locations, filter the data, or show data at default position. Edit locations allows you to correct the locations by putting in their unique names, We'll show you an example of this. Filter the data means just keep them off of the view, and show data at default position means show it at 0, 0 on the map. So edit locations. Here we can say, here's all of these cities that seem to exist in multiple locations, and we could say, well, we know what state they're in as well, and that should help you answer the question. So you could choose a field that will define the state. So here we're saying the state is from the state field, and we hit OK, and then it can draw the rest of those cities. Sometimes you want to keep them off. Perhaps maybe they spelled city names wrong, and you just want to exclude those. And the last one is show data at default position, which is 0, 0. 28. What is a level of detail expression? A level of detail expression, or an LOD expression, is maybe the way they will present it to you. And LOD stands for level of detail. So obviously it helps you get to the level of detail that you want in your visualization, but it also is used to run complex queries at the data source level instead of all in the Tableau interface. So we're going to take a look at an example here, which is adding a dimension to an already calculated aggregate field. In our case, we're going to exclude a dimension from a calculated field. So here we have a visualization that I built, and right now it's just looking at sales by category and subcategory, but say we wanted to look at the total sales for furniture and not break it up by the subcategory. So if we take off subcategory, then we get the total sales for furniture. But if we want a side by side, and so that you can see the total sales for furniture and you can see it broken up by subcategory, you can use a level of detail calculation. This, I already made the field for it. I've called it exclude subcategory, so that's right here. Right now it just contains sales, but we're going to use the level of detail calculation exclude, and we're going to tell it what to exclude, which is subcategory, and then we're going to do sum of sales so that it will sum it up for us. And once I apply these changes, it should change it here and our labels. Perfect. So now we can see that it's ignoring the fact that this is chairs and this is tables and this is bookcases. It's just doing the total for furniture and just ignoring these because we told it to exclude. So level of detail helps you to be able to define the level that you want to in your visualization, regardless of what else exists on your visualization. It also moves some of the logic from inside of Tableau to the actual database. And there are 3 level of detail calculations. This will be an important thing to bring up in interviews. They might give you brownie points when you can remember all 3 of the level of detail calculations, which are, we looked at exclude, but we have exclude, include, and fixed. So include, exclude are pretty easy to remember, and just always remember fixed as well. Question 29. How do you calculate daily profit measure using level of detail? Here's another opportunity for you to pause the video and take a look at calculating a daily profit measure using level of detail. We are going to get started. Profitable level of detail. So we want to have a daily profit measure, and I already made a place for it, profit per day. And we want to look at the profit for a day regardless of what else is on the visualization. So we're going to use a fixed instead of an include or an exclude, which will only take into account whatever you put in for include or exclude. Fixed will take into account everything. It will ignore everything else on the visualization and only look at what's in your list here. So we're going to fix it by day. And you have to put a colon. And we're going to do a sum of profit for each of those days. And close it off. So now we have our profit per day. And we'll hit OK. And now we're going to make a KPI, which for our purposes, if profit for a day is greater than 2,000, then that day is highly profitable. If it's less than 0, then it's unprofitable, otherwise it is profitable. So we're going to go if our profit per day is greater than 2,000, then we're going to call it highly profitable. Else if we're going to do less than or equal to 0, then profitable, else otherwise it is profitable. Always have to end with an end. Great. Okay. So now we're going to make some visualizations, and it's going to look at it by year. Now it all fits in one view. We can rotate these labels to make it easier to see. And we're going to bring on order ID. But now it's showing like a lot of orders. And so we actually want it to be used as a measure, and we're going to do a count distinct. Great. So now we can see how many orders were on each day. And so that's helpful for us to see how many orders are on this day each day, but we want to see the orders on each day that are highly profitable versus unprofitable versus just profitable. So we're going to use our level of detail and break it up into different sections. So we have highly profitable, profitable, and unprofitable. Let's also bring this onto our color. Highly profitable, profitable, unprofitable. And now we can see that the profitable ones are going up. Unprofitable ones seem to be going down in 2015, and that's nice, but they are going up. And highly profitable is not very many. Oh, in this case we did area charts instead of just line charts. To make that change, you change it from automatic to area, and that helps you see some of that spatially as well. Comment below if you were able to make this visualization on your own. Question 30. How can you schedule a workbook in Tableau after publishing it? So when you publish a workbook in Tableau, if you've used an extract, you're going to need to refresh that extract. So in Tableau, when you create a Tableau data source and it's an extract version of the data source, it will no longer update if the data from your database updates. So somebody's made some changes to your database or your Excel file, and you want to see that in your Tableau visualization. Well, you're not going to see it, but you can see it if you make a refresh. So you do that on Tableau server, and you can remember that you have to get all the way to your data source. So you can go to your data sources or to your workbooks, and then you look at the data source on your workbook, and you go Actions, Extract, Refresh. And then you select Schedule a Refresh, so that looks like this. You can press these three dots next to it and click Refresh Extracts, or you can go to Actions, and then here you click Schedule a Refresh instead of Refresh Now. And then oftentimes in Tableau you'll have several different options. You can choose daily at 7 a.m. or every 4 hours. If an interviewer is asking you about how to schedule a refresh, it might be worthwhile bringing up the fact that you only need to schedule a refresh if you are using an extract on your data source.
We will understand how Google Analytics works, how we can use it to measure the performance of our website. We'll also understand how to set up goals and create events that will help us keep our website on track. Next, we will look at Google Tag Manager, and towards the end, we will unlock the mystery of how to rank at number 1 position on Google. It's not that hard as you think it is. We have Rob with us, who has more than 15 years of experience in digital marketing and analytics, and he will take us through these topics. Over to you, Rob.
Welcome everyone, this is Rob Sanders with Simplilearn, and today we're going to talk about Google Analytics. I'm very excited to be with you today because Google Analytics is one of my favorite Google platforms and my favorite topics. So let's talk about what we're going to cover today, and we're going to start out with how to set up a Google Analytics account. And so we're going to talk about everything that entails, including creating your Google Analytics account. We're going to talk about setting up a property in your account and what a property is. We're going to talk about setting up a reporting view in your property, and we're going to talk about installing the tracking code. So those are the series of steps we're going to go through today in terms of setting up a Google Analytics account. So let's get right to it. And so really the one prerequisite here when it comes to setting up a Google Analytics account is to have a Google login and ID. So when you actually go to Google Analytics, you need to be able to sign up or sign in. And so once you actually sign in, then you're going to go walk through a series of steps. But really, that's really all you need to get the account going is a Google ID and login. So if you have a Gmail account or another email account that you use for other Google products, then you're good to go. That's all you need to do. So when you actually go to sign up for Google Analytics, you're going to be asked to set up a new account. And these are the series of steps you're going to walk through or go through to set up a new Google Analytics account. So you're going to choose an account name. And then you're going to choose a property name. Okay, so the account name can be anything you want it to be. The name of your company, your name, whatever you want to name it. The property name is really the website name. So what website are we talking about? So here I'm going to set up a fictitious website name for now. It's called Demo Simplilearn. So the URL for this website, Demo Simplilearn, is going to be demo.simplilearn.com. So that's the property. When we talk about properties in analytics, we're really talking about what websites we want to measure. And then you're going to be asked to choose an industry category. And so for Simplilearn, we're in jobs and education. But you have a number of different industries that you could choose from. It's as important. Go ahead and choose the most relevant industry that your particular business is associated with. Okay, and I'm going to talk about why that's important here in a minute. And then you're going to choose your time zone. And the time zone is also important because that's when the day starts in analytics and the day ends based on that time zone. So the data that Google Analytics collects starts and ends with that time zone. So very important to choose the time zone your business is located in. Okay, and then you have some additional options here. Okay, so you have some settings. And so the first setting is to allow Google products and services. So if you opt into this, then basically what Google's going to do is share some products and services with you via email. I would go ahead and opt into that. That's of course recommended by Google. It doesn't hurt to hear from Google on related products and services that may enhance your business. The second is benchmarking. So benchmarking to me is something you should opt into. So going back to that industry and category, we chose jobs and education. So by opting into benchmarking, basically what Google's going to do is share your data that it collects on your website, in this case demo.simplilearn.com. It's going to share that data anonymously with others in the industry, in this case jobs and education. And because you've opted in, it's going to do the same exact thing for you. It's going to share anonymous data on other websites in the same industry. And the benefit of that is we get to see what other websites or how other websites are performing compared to ours. What's the benchmark in our industry? And so the benchmarking to me is important, and I'm going to go over that in a few minutes when we go over the different reports. But to me, I would always opt into benchmarking because this is the only report Google provides in analytics about how others in your industry is performing versus your website. Okay, so it's a way to compare your website performance against others in the same industry. The other options here, technical support and account specialist, I would also recommend you opt into those because then it allows you to basically allow Google access to your account, and they'll be able to help you if you occur or run into any issues. So these are the options in setting up a Google Analytics account. It's very simple, very easy to do. You're just entering in a few fields. Note that we talking about a website right now, so I'm talking about demo.simplilearn.com. But just know that if you want to track a mobile app, Google Analytics will allow you to do that as well. You just choose the option mobile app. So we're tracking a website. We want to know how users behave when they get to my website. And that's what Google Analytics is going to allow us to measure and look at. We just need to do a couple more steps in the process. So once we fill out these fields here, we're going to click Get Tracking ID. Now, I'm going to accept the terms of service. I'm going to accept another terms of service in relation to data protection. I'm going to click accept. Once I accept, I'm going to be able to get some tracking code. The tracking ID is the ID associated with your account. And so this number is going to be associated with your account. So your account ID starts with UA, and it's going to be this number here. Now the -1 is the property you set up. So in this case, I set up demo.simplylearn.com. If I wanted to track multiple websites under that same account, then I can certainly set up multiple properties. Just know that every property I set up in that account is going to have a -1, -2, -3, -4, etc., depending on how many properties I set up. So by default, I set up one property, so my first property ID is -1. If I set up a second property, the same account number, it's just going to have a -2. And that's important because that ID, that account and property ID, is going to be associated with that particular property or website. So again, once you finish setting up the account settings, then you're going to be asked to add some tracking code to your site. And that tracking code is going to be related to the account and the property. So notice my tracking ID up here. Notice the tracking ID in the snippet of code. Now, this snippet of code needs to go on every page of your website that you want to track. And you don't have to put it on every page, but if you want to track website behavior on every page of your website, then it needs to go on every page of your website. So if you're using a platform like Drupal or Joomla or even more popular platform like WordPress, adding the tracking code site-wide is as easy as maybe adding a Google Analytics plugin to WordPress, for example, and then just simply plugging in the ID. Now, there's an alternative to adding the Google Analytics tracking code to your site, and that's Google Tag Manager. So Google Tag Manager is the way I would recommend going. So if you're not familiar with Google Tag Manager, I would recommend watching the YouTube video we have on Google Tag Manager. You can just go to YouTube, type in Simplilearn Google Tag Manager, and this will give you a nice overview of what Google Tag Manager is and how it works. But basically, this is the way I would go, and I would recommend that in addition to having Google Analytics, you set up a Google Tag Manager account. And then that way you can put the tracking code in Google Tag Manager. So if I go to Google Tag Manager and I just go into an account on Tag Manager, I can just simply put in the Google Analytics ID right into Tag Manager. And so if I have it in Tag Manager, then Tag Manager is going to be the place that holds the code and fires page view when somebody comes to my website. So that way I don't have to add the tracking code to my website if I do it in Tag Manager. So that's the recommended method for me, is to add the Google Analytics ID associated with Tag Manager. If you can associate it with Tag Manager, then that's the easier route to go versus putting code on your website. Okay, so again, take a look at the video we have on YouTube for Google Tag Manager. That's the route I would go. Now, once you do get the tracking code on your website, whether that be through Google Tag Manager or through a plugin, or just simply adding the script to your site, to pages on your site, then what's going to happen is you're going to start collecting data. So that's ideally the way it works. You need to add this code to your website. Now, if you're not ready to do that and you simply want to basically understand how Google Analytics works, then I would recommend getting access to Google Analytics demo account. And so if you just type in and search Google Analytics demo account, basically what you're going to do, you're going to choose the first listing there and you're going to go to demo account. So if you have a Google Analytics or Google login, then all you need to do is click on access demo account. And so what Google's going to do is put this demo account into your account. And so it's going to look something like this. So if I click on demo account here, it's going to add to my Google Analytics account. So I'm going to have then access to the demo account from Google in Google Analytics. So I would recommend going this route here if you're not familiar, you're not sure what you're getting yourself into. So think of the demo account as kind of a test drive. You're test driving Google Analytics before you even add any code to your website. So again, all you need is a Google account. And if you have a Google account and you add the demo account to your Google Analytics account, you're going to be able to see how analytics works. Okay. And so that's what I would also recommend. So if you're not ready to start adding code to your website, then what you can do is just simply add the demo account. And then once you add the demo account, you're free to peruse around Google Analytics to see the different types of reports it has to offer. Now, when you do actually set up a Google Analytics account, you're going to have some settings that you're going to want to pay attention to. So when you set up the account, you have the account name, and then you have a property. So under each property, you have, by default, you're going to have one view. And so here you can see this view here. So if we look at the account we set up a demo Simplilearn account. Property is demo Simplilearn. So that's associated with the website we're going to track. And then again, by default, under each property, you're going to have a view. And so by default, the name of the view is going to be called All Website Data. And so in that view is where all your analytics data is going to be stored. So you can see my screen here. There's a lot of different settings you have. You have settings under the account, you have settings under the property, and you have settings under the view. So we're going to talk more about these settings in future webinars for advanced Google Analytics users. But for now, know that there's a bunch of settings that you have that you can play around with when it comes to Google Analytics. Anything from adding users to your Google Analytics account, your Google Analytics property or view. You can actually set up goals, you can set up filters, you can set up segments, you can link up Google Ads, you can, set up remarketing list. There's a lot you can do in terms of the settings as it relates to Google Analytics. So know those settings are there. They're located right down here in this little sprocket icon. That's the admin icon. So if you need to get to these settings at any time, you could simply just click on the sprocket or the admin icon, and then you'll be prompted to choose any one of these settings here that you want to edit or alter. So now let's take a look at some Google Analytics reports. So once you've actually set up your account, you have a number of different reports that you have available to you in Google Analytics. So we're going to take a look at customized reports. We're going to look at real-time, audience reports, acquisition, behavior, and conversion. So these are all the different reporting buckets, if you will, that you have available to you in Google Analytics. So if I'm an admin and I'm looking at the Google demo account, let's start out by looking at real-time. So if I click on the real-time report and I just click on overview, so basically what this is going to do is show me at this point in time how many users I actually have active on the website. Okay, so that's why they call it real-time reporting, because it allows you to see the behavior of users who are currently on your website. And so this is the overview report under real-time. And you can see here, I can see that 79% of my users are coming from desktop, 18%, 20% are coming from mobile, and then approximately 3% are coming from tablet. Here I can see how they actually came to the website. So this is the referring source. If they came from, say, search or social, I can see the source there, and I can see what pages they're active on. And then here I can see what locations, where they're located. And so if I want to see a breakdown of everything in the overview, I can certainly do that. If I go to locations under real time, I can see a majority of my users are coming from the United States. Okay, where are they coming from? I'll just click on traffic sources. And here I could see the different sources and mediums. Medium is the means in which the traffic was driven. So if it's Google, it's either paid search or organic search. So I can see here it's organic. Then I can actually see what content they're looking at on my website. So I can see currently I have 3 active users on the home page, 2 active users on the Google's Women's White Tea page, so forth and so on. Now, Most importantly, if you have event tracking set up. So if you've taken a look at our Google Tag Manager webinar, you know that you could set up event tracking in Google Analytics to measure engagement on your website, whether that be a form submission or somebody clicking on the play button of a video. So if I click on events, I'll be able to see what events are firing. So here I can see we have event tracking set up, and I can see how many different events are firing on my website in real time. So here I can see e-commerce, somebody clicking on the quick view click, a couple of users clicking on add to cart, a couple of users clicking on the promotion click. And as these events are fired, you're going to be able to see them highlighted. So if something gets fired, it's going to get highlighted. And I could see that these are the current events that I have currently firing on the website. And that's what's currently firing now. If I want to look at the events that have happened in the last 30 minutes, I could just click on this link here, last 30 minutes, and it's going to give me an overview of the events that have happened over the past 30 minutes. Okay, so that's event tracking. And then more importantly, we can also look at what conversions are happening in real time just by clicking on conversions. And so now I could see I had one active user who entered the checkout. So that's goal number 4. So in analytics, you can have up to 20 goals. And so here I can see we have goal number 4 has already had one active user. And so if I look at the last 30 minutes, I can see I still have only one goal over the last 30 minutes, and that was somebody who entered the checkout. So that's real-time reporting. In summary, it just gives you an idea of what's currently happening on your website. And so for me, ideally, if I'm launching a campaign, or let's just say you do a new website redesign and you want to see how users performing and behaving, then real time is a good option for you. So you could see how things are happening in real time. Now let's jump down to audience reporting. So if I click on audience, which is just right underneath real time, I'm going to see a number of different reports available to me under audience. And so let's click on the audience overview report. So audience reporting basically allows us to get a sense of who is coming to our website. When I say who is coming to our website, it doesn't necessarily have to be a specific person. In fact, Google doesn't allow personally identifiable information in Google Analytics. Personal identifiable information such as a specific name, a social security number, credit card information, etc. However, we could still paint a nice picture on who is coming to our website, meaning what country, city, or state did they come from, what language, what device did they get to our website from, how old were they, okay, were they male or female or other, what interests did they have, what browser did they use. So we can paint a nice picture based on all this information that Google Analytics is providing us under audience. So if I go to audience overview, here I can see I have all these different options available to me to get a basic understanding of who is coming to our website. So for example, I could see a majority of the people coming to our website speak English and are from the United States. Okay, in fact, that represents 61% of the users. And so Google Analytics does a great job of giving me an overall percentage. So if I have 100% of the users, I could see 61% of those users represented English-speaking users from the United States. 7% represented English-speaking users from Great Britain. And so when it comes to analytics, we have users, and users are broken down into 2 categories. They're either returning or they're new. So when you add the Google Analytics tracking script to your website, what's going to happen is if a user or when a user goes to your website, they're going to get cookied. And if it's the first time they've been to your website, what Google Analytics is going to do is store a cookie in the browser. So when that same user comes back another day in the same browser, Analytics is going to recognize that that cookie is in the browser. And so then Analytics is going to categorize that user as a returning user. Okay, so that's how analytics is able to differentiate new versus returning. So if that user doesn't have a cookie in the browser, then analytics is going to recognize that, store the cookie, and then count that user as a new user. And so when you're looking at analytics, you're going to be able to see a breakdown of new versus returning. So here I can see over 3/4 of my traffic over the past week. Here I can see April 6th through April 12th, over 3/4 are new users to the website. Here I could see about 24% are returning users. Okay, so I can get a good breakdown of what type of users are coming. Am I driving new traffic? Am I driving traffic that's been to my website before? What language are they speaking? Okay, I can also paint a bigger picture. How old are they? What gender are they? Do they come from mobile? So let's take a look at some of these different reports under audience. And so if I skip down now to demographics, I can click on overview, and when that report loads, I can see now under demographics overview, I can see the breakout of age ranges. And so here I can see the majority of the traffic coming to my site again over the past week. Now, if I want to change this date range, I could simply do that. I can change the date range just by clicking on the date range and then maybe going, say, the last 30 days. And I can even compare it to the previous period or the previous year. I'm going to choose the last 30 days. I'm going to click apply. Now I'm looking at data over the last 30 days. And again, you can change the date range to any range you want. You can only go back as far as when you actually created the Google Analytics account. You can't go prior to that. So here I'm looking at the last 30 days and I can see almost 47% of my users were in the age range of 25 to 34. Now, when it comes to gender, I can see 66% represent males. So I can get a breakout of gender and age as well as interest. I can click on interest and look at the overview there and see what the interest is of the users who are coming to my site based on in-market segments or affinity. I can also choose language and location. So if I want to know exactly where my users are located when they're coming to my website, I can click on location. And here I can get a breakout. 43% of the users of the last 30 days were from the United States. More importantly, I can align my audience with goals. And we'll talk about goals here in a minute, but here I can see if I have an e-commerce website, I can see of those 43%, 0.29% of those converted or purchased something. And that equates to 94 transactions. So I can get a good sense of not only how many users are coming from a specific country, but are those users converting? If I click on mobile, and mobile to me is one of those reports I tend to spend a bit of time on because I want to know what devices users are coming to my website. And so for my website here, or this is the Google demo website, I can see mobile represents approximately 27% of the traffic. So desktop still represents a majority of the traffic. So for you, you want to keep an eye on mobile because mobile is definitely a majority of what people use nowadays. That's how people start their day. That's how they transact via mobile, whether that's purchasing something, communicating, or searching. It all starts with mobile. So you want to keep an eye on mobile, and more importantly, you want to keep an eye on behavior. So Google Analytics is telling me that, yes, I have approximately 27% of my traffic of the last 30 days came from mobile. How are they interacting with my website? So if I look across this report, I'm going to be able to see different metrics. So if I'm measuring specific metrics against my dimension, in this case, the dimension is what we're measuring. And in this example, we're measuring mobile. I can see that the bounce rate is approximately 48%. And bounce rate means that if a user, in this case from mobile, landed on a page, they left the site without going any further. So they consider it a bounce. If they don't go to another page, if they leave the site from the page they landed on and they don't go any further, that's considered a bounce. So a bounce rate is the percentage of people who come to the site and leave the site without going any further. So in this case, we have 48% bounce rate. That's almost half of our users who come from mobile leave the website from the page they landed on. So is that good? Is that bad? Well, it's open to interpretation. It's definitely subjective. But you want to keep the bounce rate as low as possible. You want to keep people on your site, especially if you have an e-commerce website. You want people who come to your website to purchase. And so here we can see 48% mobile. In desktop, it's a little bit lower at 41%. Now, if I look a little bit further at engagement, I can see how many pages on average do mobile users look at. So versus desktop, it's a little bit lower. You can see 3.86. On desktop, it's 4.5. Now, if I look a little bit further in engagement, I want to be able to measure how long somebody from mobile stays on the website. If they're bouncing at 48%, but they're also looking at 3.8 pages, 3.9, almost 4 pages per session, then that means in this report, analytics is telling me they're spending about 2 minutes on the site. And interestingly enough, I can see that mobile over the last 30 days had more transactions. So 51 transactions versus 34 transactions from desktop. And interestingly enough, the e-commerce conversion rate is at 0.29%. That's higher than desktop at 0.07. It's lower than tablet, but it's higher than desktop. And mobile has the most transactions. And since they have the most transactions, they have the most revenue at 2,380. So yes, the engagement isn't exactly as great as it is as desktop, but we can see that people are still purchasing with their mobile devices. So it's something to keep an eye on, and mobile is something I definitely look at. In fact, since it's such an important report, one thing you can do in analytics is if you actually like a report and you think you're going to look at that report multiple times, then you can simply just go ahead and click save at the top here. So if I click save, I'm going to enter a name for this report. I'm just going to call it mobile report and click OK. And then what's going to happen is it's going to be located under Save Reports. And Save Reports is located under Customization. Customization is located above Real Time. Okay, so if I close that up, you can see Audience, Real Time, Customization. If I click on Customization, if I click on Save Reports, I should be able to see my Save Report here, and I do. So here I can see Mobile Report. If I click on it, I can simply go to the report I was looking at before I saved it. So Save Reports to me is a good feature in analytics because it allows you to quickly access a report that you've saved in the past. So let's take a look at one more report under Audience. And let's go to benchmarking. So remember when we were setting up our analytics account, we had the option to opt into benchmarking, and I recommended you do so. And so if you did actually opt into benchmarking, then you're going to be able to see how your site compares to others in the same industry. So if I click on benchmarking and then click on channels, what I'm actually able to do now is compare my website with others in the same industry. So if I go back to say jobs and education, and I choose education, all education as my industry vertical, I should be able to see websites that are in the same particular industry and how I compare with those websites. So I'm choosing all countries. I can narrow that down if I wanted to. I can just search for the United States. I can choose a specific state, and then I can choose a particular site size. So here I'm choosing sites by daily session. So these are sites that have an average of 5,000 to almost 10,000 sessions a day. And so in this vertical education in the United States, sites that have 5,000 to 9,999 sessions per day that means that there are approximately 310 web properties contributing to this report, okay, based on this criteria I chose. Now, if my site is similar, meaning if I'm in the United States, if I'm in education, and I'm receiving 5,000 to 9,999 sessions per day, then I'm able to compare my site against 310 other websites. Now, Google's sharing this data anonymously from the other websites, and they're doing the same with your website to those particular websites' benchmarking reports. Okay, so it's shared data anonymously in particular industries and verticals. And so now I'm looking at a channel report. So if I want to see how I compare to others in my industry, then I can go ahead and see by channel. For example, am I driving as much traffic as others in my industry? And you can see I'm not. In fact, I'm 76, 77% worse in terms of the amount of traffic being driven from organic search. So anything in red is going to show as a negative result, a negative comparison, whereas something in green is a positive comparison. So if I look at engagement, I can see that I might not be driving as much traffic, but I can see that the pages per session are better than the site average or the industry average. I can see if I go over again, looking just at organic search, I can see the bounce rate is better than the industry average. So the channel report under benchmarking allows you to measure how you compare to others in your industry. And you could do so by looking at location and devices. So if you opted into benchmarking when you set up your account, then you'll be able to compare your website against others in your industry, in your country, region, and based on the size of your website in terms of how many visitors or sessions you're getting per day. So let's go from audience to acquisition. So if audience is who is coming to your website, acquisition allows us to see how the traffic was driven to your website. So how did these users get to our website? And so under acquisition, if we click on overview, we'll be able to see an overview of how users, whether they're returning or new, came to our website. And so what Analytics does by default is they have a number of default channels. And when we say channels, we mean Analytics is grouping different channels based on how users got to your website. Meaning, how did users get to our website? Did they come via organic search? Meaning, did they type something into Google and find you in the organic listing? Analytics also groups users based on whether they came to your site directly, meaning did they type in the URL directly into the browser, or did they bookmark your website and come back via the bookmark? So they're grouping users under direct. They also group users under referral, meaning did they come from another website? They group users by social. Did they come from a social media platform like Twitter or Facebook? If you're running paid search, meaning if you're running paid search on, say, Google, then do they come from paid search ads? Now, if you're running display ads on, say, Google's network, Google's display network, that's a default channel. So Analytics will group users there. So if they don't recognize a channel, then they're going to group it as others. So by default, Google Analytics groups users on how they came to your website via these default channels. And so I could see how many users came to the site from each channel. Now, if I want to drill down on this report, I can click on all traffic. And then if I click on all traffic, I can go to channels. I can look specifically at the channels report. And so now I can see organic search, again, over the last 30 days, is the #1 channel driving traffic. And they represent approximately, again, you can see this number here in parentheses next to the raw number of users. I can see that number is about 56%. So 56% of my traffic over the last 30 days came from organic search. And so those are the number of users. Again, as a metric, you're also going to have sessions. And you'll see sessions a lot as a metric. So users are broken down between new and returning. So every time a new or returning user comes to the website, basically what they're doing is initiating a session. So you can have a user who can come back multiple times. Every time they come back to the website, it's a session. So session is simply the start of somebody coming to your website, and the session ends when they leave the website. And so just like we looked at with the audience reports when it came to mobile, we can also look at engagement by channel. So just like mobile, we looked at bounce rate, pages per session, average session duration. We can do the same thing here with our channel report. More importantly, in addition to behavior, we can see conversions. And since we're running an e-commerce platform, we could see what the conversion rate is by channel. So organic search did drive the most traffic, and they did have the most transactions over the last 30 days. And the conversion rate in this case is 0.17. Okay, so how Google determines the conversion rate? They basically take the number of transactions and divide that by sessions. So that means that over the last 30 days, organic search drove 38,123 sessions. And of those 38,123, 64 actually turned into a transaction, which equates to 0.17, which also equates to 3,000 in revenue. So I'm able to determine not only how users are getting to my website by looking at the channel report, I can actually see if they're engaging and if they are converting. And notice when you look at a report in analytics, you can look at it by channel. You'll also get a summary. So here I can see a summary or a total based on my date range. So I could see over the last 30 days, I've had 54,000 users, 49,000 of them were new. Okay, that meant that out of those 54,000 users, I had 70,000 sessions. I could see my average bounce rate was 43%. The pages per session were just over 4. And the average session duration, how long did somebody stay on my website on average? About 2 minutes and 55 seconds. The average conversion rate was 0.14, and I had a total of 97 transactions totaling $5,500. Okay, and that's all over the last 30 days. So any report you look at in analytics is going to have a summary. And note that any report you look at in analytics is going to allow you to save it. So if it's a report you think you're going to go back and look at a future date, then you simply just have to click on the save button. Conversely, if you don't want to save it, you can simply just export it. So you can export it as a PDF. If I click on PDF, it's going to allow me to export that as a PDF. Now you have other options available to you as well. You can do a Google Sheet. You can export it as an Excel, or you can export it as a comma delimited file. So here you can see I can save it as a PDF if I want to. And if I click OK, it's going to save to my desktop or location of my choosing. And then I can go back and look at it in that format at a later time. So that's the export feature available to you in analytics. Again, if you could save it as well, or you can export it. Okay, some other reports under acquisition. If you're running Google Ads, note that you can connect Google Ads to analytics. And this is key because now I can see how many people are coming from Google Ads to my website and are they converting? Now this is important because with Google Ads, I'm actually paying for the click. So you can see here, I'm running a report based on campaign data. So I could see what campaigns are driving traffic, how much I'm paying per click, and you can see on average I'm paying 34 cents per click. And then more importantly, I want to be able to see if they're converting. So you can see I've spent $810 over the last 30 days and received $858 in revenue. So you want to make sure that you link up your Google Ads account to your Google Analytics account. For this very reason, you want to be able to see how your Google Ads campaigns perform once the users get to your website. And so I want to see if they're engaging and I want to see if they're converting. So there are all sorts of reports under Google Ads. So you can look at it by keywords, by search queries, by hour of the day. If you're running display campaigns, you can look at display targeting. So there's all sorts of reports under Google Ads. You just have to link it up, and you link it up under the admin. Now, there are other reports that you can look at. So if I go to campaigns, I can look at all campaigns. So if you're running all sorts of different types of campaigns, whether that be on Facebook, whether that be email, whether that be, other types of advertising, let's just say Twitter or Instagram, you're going to be able to see those campaigns here. And that's under all campaigns. And again, you'll be able to see the campaign name, and you'll be able to see metrics associated with those campaigns. And more importantly, you'll be able to see your e-commerce if you're running an e-commerce platform, or if you have goals set up. So you'll be able to look at how your campaigns are not only driving traffic, but two, are they converting? Let's go from acquisition reporting to behavior. So behavior reports are going to actually show you how users behaved once they got to your website. Once they landed on a page on your website, how did they behave? So when we looked at audience, we got a sense of who is coming. With acquisition, we get a sense of how the traffic got to our website. Did they come from organic, direct, social, etc.? The behavior reports allow us to actually measure how that traffic behaved once they landed on a page on our website. And so if I go to overview under behavior, now I'm looking at this graph here. It's showing me how many page views I've had. And a page view is simply, once a page is viewed, it's counted as a page view. So if a user comes to my site, they're initiating a session. And if they look at a page, then that page is going to have a page view. Okay, so a user can look at a page multiple times in a session, and every time they look at that page, it's going to count as a page view. So here I can see in this graph how many page views I've had, again, over the last 30 days. And if I look further at my overview report, I can see the specific pages and how many page views they've had. And I can also look at some other metrics. Okay, the average bounce rate, the average time on page. I can look at the exit rate, which means how many people actually exited, or the percentage of people who exited from that page. So I can dig deeper into my behavior reporting. So if I click on site content and I click on all pages, then I'm going to look at a report by page. This is my dimension. This is what I'm measuring, my page. And now I can see how many page views each page had over the last 30 days. Now note, you also have something called unique page views. So unique page views is equivalent to one per session. In other words, if a user came to my site and looked at the home page, then the home page is going to have one unique page view and one page view. Now, if the user in that same session looks at other pages, then every page that user looks at is going to have one unique page view. However, if the user goes back to the same page in the same session, then it's still going to be one unique page view. But in this case, the home page, if they look at the home page a second time, then the home page is going to have two page views. If they look at the home page 5 times in one session, then the home page is going to have 5 total page views and one unique page view. Okay, so that's why unique pages is equivalent to one per session, where page views is an accumulation of how many times the page was viewed in the same session. So in other words, you're always going to have more page views than unique page views. Okay, so this gives me a sense of how my pages performed. So again, I can look at total page views and then engagement. So ideally what you want to do with a report like this is, if a user is not engaging on the page, then that should tell you something about the page itself. If they're not engaging, if the bounce rate's high, if the time on page is low, if the percentage of exit rate is high, then you probably want to do something with that page. Now, these are all pages, but if I jump down to landing pages, my landing page report is showing me how many people actually landed on that page. And so here I can see under my landing page report, I can see the home page had 36,017 sessions in the last 30 days. That's how many people landed on the home page. So here I can see 71% were new sessions, meaning that I had a lot of new users who landed on the homepage. In fact, 25,000 or 52% of the people who landed on the homepage were new. I could see the bounce rates about 42%, but of those who didn't bounce, they went on to look at about 4.5 pages per session and spent about 3 minutes on the site. And the one thing I like about the landing page report is I can also see whether that particular page, in this case, the home page, did it help contribute to a goal or conversion. And in this case, I can see of those 36,000 sessions, I had 22 transactions, totaling 1,200 in revenue, and that's an e-commerce conversion rate of 0.06%. So the home page over the last 30 days contributed to 0.06% of the revenue. So this gives you an idea of when somebody lands on your website and they land on a page, is that page helping to move that person along? Meaning, are they not bouncing? And is that page helping to move people towards converting? And so that's what the landing page in effect allows us to measure, is the engagement. And in this case, we're measuring transactions. Okay, so analytics also gives us some other reports under behavior, including site speed. So site speed to me is an important report to look at, just like the mobile report. To me, site speed's important because what Google Analytics does is they take a sampling of pages. And in this case, you can see over the last 30 days, they sampled 2,835 page views. And of that sample, they came back and said the average page load time is about 4 seconds. Now, ideally, you want to keep it as quick as possible. I would say even under 3 seconds. Okay, now there are other factors involved with page load time. The browser you're using, the country that you're actually browsing that page from might not have the best infrastructure. You may not even be on the best internet network, meaning you're on a cell network or the Wi-Fi is not that great. Or you can be on a page that just has a lot of images or a lot of code that may slow it down. So there are other factors involved. And so what Google Analytics does is show you what those factors are. So here I can see by browser what the average load time is. If I want to look at country, I could see what country is contributing to the load time. Now, the great thing about the site speed report is if I go to speed suggestions, okay, what speed suggestions is going to do is it's going to show me the page load time by page. And then it's actually going to provide a link where I can actually click on to get suggestions on increasing the page load time. So for example, I can look at this particular page here, this Google redesign shop by brand /YouTube page, line number 5. If I look at line number 5, I can see the average load time of this page is 8 seconds, almost 9 seconds. Okay, that's an eternity to some people. Now, notice this link next to it. So Google's recommending 7 total suggestions. So if I click on 7 total, what it's actually going to do, it's going to open up a new window and it's going to open up another Google report called PageSpeed Insights. And PageSpeed Insights is going to give me some information about what I can do to correct the page load of that particular page. So look at the site speed report. It's important because there is a correlation between site speed or page load time and user behavior of that page. And there's also a correlation between page load time and a page ranking organically on search. So page load time is very important. It's so important that I'm even going to save it. So I'm going to click save and click on site speed suggestions as my name and click OK. And now that report is going to be saved under customization under save reports. Let's jump from behavior to conversions. Now, conversion reporting is arguably the most important section in Google Analytics, because what the conversions reporting allows us to do is see how people are converting, or if they're not converting, on our website. And so in Google Analytics, we have the opportunity to set up goals. Now you have the opportunity to set up 20 goals in your Google Analytics view. And so to set up a goal, okay, so you're going to click on admin, and under the view, you're going to see goals. And so if you don't even have goals, the first step is to create goals. And so you have 4 different goal types in analytics. So you have pages per session. So how many pages per session is, so if your goal is set to say 3 or 2, if somebody actually looked at 2 or 3 pages per session, it's going to count as a goal. Okay, so if I look here, I can see I have pages per session set at 10. So that means that if a user came to the site, looked at more than 10 pages per session, then it's going to count as a goal. Another goal type is destination. So destination means that if somebody actually went to a specific page, then it's going to count as a goal. And in this case, I can see here that the goal is set to this particular page here. And so when somebody actually lands on that page, it's going to count as a goal. Now, there are two other goal types we can look at. One is duration. So just like pages per session, in our previous example, if somebody looked at 10 pages per session, it's going to count as a goal. With duration, it's based on time. So in this particular case, if you set up a duration goal, and the duration is set to say 1 minute and 30 seconds, then that means if a user comes to my website and they spend at least 1 minute and 30 seconds, then it's going to count as a goal. Okay, and then the fourth type of goal in Google Analytics is an event-based goal. So when you set up event tracking, you could turn that event into a goal. So if somebody clicks on, say, the submit button of a form, you can turn that event into a goal. So here you could see the category equals contact form. So you can always verify if a goal works just by clicking on verify this goal. And in this case, this event is turned into a goal. So anytime somebody fires this event, it's going to count as a goal. So you have 4 different goal types in Google Analytics. You have pages per session, destination, event, and duration. And so once you've set up a goal, then you can measure goals under conversions. So now if I look at goals overview, I can be able to see how many total goal completions I've had. So if I want to look at it by goal, I can just choose the goal option here. So if I want to look at, for example, goal 2, engaged users, this was the pages per session, I can see that I had a conversion rate of 10%, meaning that I had 7,000 of all the users who came to the website, 7,000 goal completions, meaning 7,106 users looked at 10 pages or more on my website. And so that's how you want to be able to measure whether users, wherever they're coming from, whoever they are, whatever pages they look at, you want to be able to look at the conversion reports to see if they're actually converting based on the goals you've set up, whether that's pages per session, duration, destination, or event. Goal conversion tracking reports can help you measure who is actually converting. And the great thing about Google Analytics here is that I can actually see by segment. So the default segment in a segment is just looking at a specific user set. So the default segment is always all users. However, I can choose a different segment. So if I want to choose, instead of all users, if I want to choose mobile traffic, I can select mobile traffic, hit apply. So I'm actually now looking at a subset of data. I'm looking at mobile traffic. So of all the mobile users who've come to my site, I can see 1,400 engaged or looked at 10 pages or more. Okay, and that's a 7% conversion rate. So the great thing about Google Analytics is you have the opportunity to set up 4 different goal types. Okay, based on those goal types, you can go to Goals Overview and look at the conversion rate of each goal, but you can also change the segment of that particular goal to see who exactly converted. Okay, another report I like under conversions is the multi-channel funnel report. So if I click on multi-channel funnel, basically what this allows me to do is see how different channels work together to convert. So remember the channel reporting we looked at under acquisition? Here I can see now how different channels work together to drive the conversion. So if I look at 3 channels, direct, organic, and referral, I can see all 3 together drive 2% of the conversions. If I look at direct and referral, 12.5%. If I look at direct and organic, 12.24%. So I can see how different channels work together. And so if I look at top conversion paths as an example, I can actually see how channels work together to drive the conversion. So in this example, I can see over the last 30 days that my top channel grouping was direct times 2, meaning that somebody came to the website directly, meaning they typed in the URL in the browser, or they bookmarked it and came to the site. Okay, they came the first time but didn't convert. But then they came back a second time via direct and then converted. So that combination is my top conversion combination of the last 30 days. My second best conversion grouping is organic search and direct, meaning that a user came to the website via organic search first, did not convert, and then came back via direct the second time and converted. So basically what analytics does is give credit to the last referral, meaning if you came to the website via referral, a referring website, and converted, then the referring website's going to get the credit for the conversion. But analytics does a good job of showing you how different channels work together. So a channel may drive a lot of traffic like organic search, but that traffic may not convert the first time around for a number of different reasons, whether it could be brand recognition, price shopping, reading content, whatever the case. Analytics is able to measure if that channel actually did contribute at a later point. And in this case, we could see organic search drove traffic that didn't convert, but that traffic came back a second time via direct and did convert. So that's our second best channel grouping. And so the multi-channel funneling report, top conversion paths, to me is a good report to look at. So you can actually see not only how channels work together, but you can see sources and mediums and campaigns and how all those different campaigns and different sources work together to convert. So that's just a good report to look at. There are so many different reports available in analytics. There's so many that we haven't even gotten to yet. So my advice, if you look at the demo report, you can get a feel for each of these reports under each section, whether that be audience, acquisition, behavior, or conversions. Take a look at these reports, see what makes sense to you, see what you can use to improve your website performance. For this particular webinar, we're going to jump into Google Analytics directly and spend all of our time there because it's about learning practical application. So goals are important. Goals, let me just say this, goals are in analytics something that should be aligned with your business. And we call goals that are aligned with your business KPIs, or key performance indicators. So it's very important as a precursor that you know how to set up goals in Google Analytics, because if you're using Google Analytics, you want to measure everything against a goal. So without further ado, let's jump right into Google Analytics. So if I go to Google Analytics and I log in, okay, what I want to do is go down to admin, click on admin here, and admin will take you to basically a screen that looks like this, where you have an account column, you have your property column, and then you have your view column. Now, the view column is where you're going to go to set up goals. Okay, so every view in every property has up to 20 goals. Okay, so by default in analytics, you're going to have at least one view for your property. So if I have a property, I'm going to have at least one view. But if I happen to set up multiple views like you see here, then I know for every view I set up, I have 20 goals to work with. So where are those goals? So under the view, I'm going to click on goals. And now I can see I have 20 at my disposal. Now you could see here by clicking on the recording column, I can see I have in this particular property, this particular view, I have 5 goals that are active. So you can use up to 20, but you don't have to have 20 active. Okay, you can have 1 active, 2 active. My recommendation is at least have 1 goal. Again, when you set up a goal, you're going to measure everything in analytics against that goal. Okay, so in this case, we have 5 particular goals we're measuring. So we have 5 active out of 20 total. So if I don't no longer want to use a goal, I can simply just turn it off. If I want to continue using it, just turn it on. Okay, it's that simple. You could turn on and off goals. So here I already have 5 set up. So if you want to set up a new goal, the one thing you need to know in Google Analytics is in order to set up a new goal, okay, you need to have edit access, at least the view level, I would say at the property level. So you want to make sure whoever's in charge of Google Analytics for your organization, or if you're in charge, okay, you simply just want to go to user management, and user management, you want to make sure the email address you're using to log into Google Analytics has at least edit permissions. So you're going to need edit permissions to add new goals. So I have edit permissions. I'm going to go to goals and I want to set up a new goal. But before we jump in and set up a new goal, what is it that we want to achieve? That's really the question we want to ask ourselves. What is the goal of the website? Well, if it's somebody downloading something, okay, are you measuring that download via an event? Okay, are they filling out a form submission before they download? So if they submit that form submission, is that the goal? Or do you have an e-commerce site? Is somebody purchasing something? So these are things you want to ask yourself before you actually set up the goal. What is it that I'm trying to measure? Now, when you actually do go to set up a goal, you're going to click on the red CTA button that says new goal. So Analytics actually has some templates set up for you. Okay, you can see them here. Okay, if somebody's registering online or creating an account or reading review, downloading something, sharing something, you could choose all of these options here. What I normally do is choose custom. 99% of the time, I'm just going to choose custom. It doesn't really matter if you use the template or not. It's just a template is basically some free pre-filled configurations, but my recommendation is always just go with custom. You want total control over how to set up your goal. So we already have in mind what type of goal we want to set up. So for example, if somebody goes to fill out a form submission and they go to a thank you page after that, well, what's the URL of that thank you page? We want to be able to track how many people go to that page, because we know if somebody does type in or fill in a form submission and goes to that page, we know that they filled out the form. And so, for example, if I go to continue, I'm going to name my goal first. So I'm going to say thank you page as an example. Notice Analytics is assigning an ID. So notice this is goal ID 15. That means that that's the next available goal. There are 20 goals available in Analytics. And so what Analytics does is they group goals together. So 1 through 5, 6 through 10, 11 through 15, 16 through 20 into goal sets. So for example, goal 16 through 20 is part of goal set 4. And why does Google Analytics combine these goals into different goal sets? Well, because it's easier to measure and look at data by goal sets. So for example, if I jump into any report here, if I go to all traffic channels, and I want to measure how many goals by channel, I can look at it by goal set. So if I have goal set 1 selected, then I know any goal I have active in there between goal ID 1 through goal ID 5, I'm going to be able to see those goals in goal set 1. And now I'm going to be able to measure every goal I have active in goal set 1 against the channel. So if I choose goal set 2, whatever goals are active there, goal set 3, etc. Notice I don't have any goals 16 through 20 active that are in goal set 4. Therefore, I don't have that option available to me. So back to admin, the bottom left, navigation, again, goals. Okay, we want to measure somebody going to the thank you page. We have edit access. We're going to choose custom as our goal setup. We're going to type in a goal name. I'm just going to say thank you. Okay, this is goal 15. Now, this is the important part. Google Analytics has 4 different goal types: destination, duration, pages per session, or screens per session. So screens per session is related to mobile because Google Analytics measures mobile app activity. And then you have an event. So we're going to cover all 4 of these, but for the sake of this simple example, I'm going to choose destination. Why? Because if somebody goes to that thank you page, we're going to go ahead and put in the thank you page as the goal URL. So for example, destination is my choice. I'm going to click continue. Now this is where I'm going to put the URL. So if my URL is just simply thankyou.html, I can just go ahead and put thankyou.html. Or if it's just thank you, then I can just do thank you. Depends on the website, depends on the URI structure. So whatever that URL is, that's what you're going to put in. And when you're done, you can verify it. So what Google Analytics does is actually will verify over the last 7 days if anybody's actually gone to that particular page. So if we click verify, we can see 0% conversion rate. So that tells us that if this is the correct URL, then we've had 0% people go to that page. This is just an example. However, if you didn't see a conversion, then you might want to make sure you check the URL here that you put in. And if you do see a conversion rate, then you know it's working. So Google Analytics actually has options. So we're saying thank you is equal to, so the destination URL is equal to thank you or thankyou.html or thankyou.asp or whatever that thank you page is. Okay, you do have options. So if you have a long URL, you could say begins with, and you could say begins with, say, thank you. So this is the logic. We're going to say, hey, if anybody goes to a URL that begins with thank you, then count it as a goal. Or you could say equals to. So if anybody goes to a URL that equals to thank you, then count it as a goal. You have one more option here, regular expressions. So Google Analytics understands the language of regular expressions. So regular expressions are just special characters used to communicate with Google Analytics in order to hone in on exactly what you're trying to track. So we can always say, starts with or ends with. So we can, use characters like the $, ends with or begins with. So we can always do that. So you can use regular expressions as well if you're familiar with regular expressions. If you're not, then you don't have to use them, but there are special characters that you can insert in that are used as regular expression. So if you're not familiar with regular expression, don't choose that option. You could choose the other option of equals to or begins with. Now note that on all three of these options, I didn't put the domain. So if my domain is ama-foundation.org/ and then thank you, I don't need to put the domain because Analytics already knows what domain we're tracking. So you don't have to put in the domain here when you're entering in this case, the goal URL. So you can omit the domain. So when you put in that URL, you know that you have 3 options to work with, and then you always want to verify that goal URL. You always want to verify it because if you see 0% conversion, and in this case over the last 7 days, then that should tell you something. Either your goal is not set up correctly or you just don't have any conversion. Either way, you want to double check that. Now, when it comes to the destination URL goal, you do have an option here for funnel. So if I turn on funnel, then that means I have the ability to track how people went through my funnel. So if I have a cart and I want to be able to track how many people go in and out of the cart, then I have the option of adding specific pages as part of the cart. So we could say, step 1, which is basically cart. We could say step 2 is billing information. That could be /billing. We could say step 3 is shipping information /shipping. And then step 4 could be, confirm. And that could be /confirmation. So whatever your URL structure is for your cart, and it doesn't necessarily have to be a cart. Basically, all I'm doing is putting in a series of steps with URLs as each step. And why do I want to do that? Because I can then track how many people go through my funnel that I've created. Okay, so here I could see this is my funnel that I've created for this particular goal. Okay, and the funnel is only available for the destination URL. So the funnel is available if you want to see traffic through the goal. Okay, and how people go through the funnel and where they drop off. Now you have an option here to make the first step required. So if you make that first step required, then that means you're measuring the funnel through the first step only. Now, if I turn that off, then I'm measuring the funnel through each step, meaning that I can measure people as they drop in and out of the funnel. Where if it's required, the first step, then I'm only measuring traffic as it enters in the top of the funnel. So you have that option available to you, the funnel. And then for all goals, you do have a value. So if somebody did actually convert, okay, Google Analytics is going to count it as a conversion, and you can assign a value. So if you're not an e-commerce website, then you may want to think about assigning value. If you are an e-commerce website, then Analytics has the ability to track e-commerce revenue for your website. So you don't need to add a value. But in this case, let's just say you're a nonprofit organization and you're collecting donations. And on average, over the past year, every donation that somebody contributed was equal to $5. Well, you can just go ahead and put $5 in there as the value for that goal. So that means that if somebody did go to, in this example, /thank you and convert, Analytics is going to count it as a goal and then assign $5 value alongside that goal. So if you're non-e-commerce, if you're, say, a nonprofit like this organization, or you're B2B and you want to track some value, then you have that option there. So with the destination URL goal, you have the option of adding a funnel. With all goal types, you have the option of adding a value. All goal types, and we're going to go through the rest of them, you have the option of verifying that goal. So that's the structure of setting up a goal. Destination URL is just one goal type. We're going to talk about the other 3 goal types, because in Google Analytics, there are 4 goal types. Again, destination is one of them. With destination, as you do have the option with all goal types, is you have to be able to choose your logic here. So we're going to cover that with the other 3, but just know when you set up a destination URL goal, you have the option of adding a funnel. Now, when you actually do set up a funnel, what's going to happen is Analytics is going to measure traffic as it goes through the funnel. So where do you look for that funnel information? Well, you want to get out of admin. You want to go to the left side navigation. You want to click on conversions, then goals, then funnel visualization. So based on the funnel you set up, you're going to be able to see traffic as it goes through the funnel. So notice on this particular funnel, we don't have the first step required. Why? Because I could see traffic as it goes in and out of each step of the funnel. So let's go through this funnel and see how people react. So here I can see the first step is the store front page. So over this particular period of time, I had 84 sessions enter the storefront page. So out of those 84, I can see 21 left the storefront page. 63 went on to the next step in the funnel, which is the cart page. I can then see 24 people went on to the cart page directly and 5 exited the site altogether. Okay, so that gave me 87 total. And from 87, I saw that 82 went on to the next page, or the next step. What Analytics does is they give you a percentage. So in the first step, we had 63 move on to the cart page. Out of 84, that's 75%. So from the cart page to the create your account page, we had 94% move on. So we didn't have anybody enter in the create your account page. We didn't have anybody leave the create your account page. So we have 82%, 82, create your account, and then we have 82 move on to the payment page. So that's 100%. Okay, we have 1 exit. So we have 81 that proceeded to be on the payment page, which was purchase. So 81 of 82 is 98%. And we started with 84. So that gave us, plus the 24 that we accumulated along the way, so that gave us a 75% funnel conversion rate. So 75% of the people who entered in the funnel went on to purchase. Okay, so don't be confused with the overall e-commerce conversion rate. So 75% is the funnel conversion rate. The overall conversion rate for this particular goal is 18.45% over this particular period of time. Why? Because that takes into account all sessions that have gone to the website. So 18% of all traffic went on to convert, but those that did go into the funnel, 75% converted. So that's a look at the funnel. So if you set up a funnel, that's what it's going to look like. You have the option to measure everything from step 1 and beyond, or measure as traffic goes in and out of the funnel. So the purpose of this is we're going to be able to see where traffic drops off, how effective our funnel is, what pages we need to address in that funnel. Okay, so that's the whole point of the funnel, and the funnel is available with the destination URL goal. So if I go back to admin, if I go back to goals under the view, I can actually see what that funnel looks like. So here we chose regular expression. So this is what the URL is. Okay, you can see our funnel in each of the steps we have set up. Notice we're using regular expressions here. And then if we verify this goal, we could see over the past 7 days, 19% conversion rate. So that tells me something's working in this particular, with this particular goal, because we do have a conversion rate. Okay, so that's the destination URL goals. Let's now talk about the other 3 types of goals. So the next goal type we're going to talk about is pages per session. So if you're not sure what type of goal to set up for your website, at the very least, you should try and set up either duration related goal or pages per session related goal. So let's talk about the pages per session. So basically what this goal is going to allow us to measure is, for example, if we set the goal to 3 pages per session, then we're going to be able to measure if how many people went to the site and looked at 3 pages per session. So let's take a look at that goal. So if I open up the goal, here I can see 3 pages per session is what we're naming it. So basically what we're asking analytics to do is anything greater than 2 pages, which would be 3 and beyond, count as a goal. So if anybody comes to the site, looks at more than 2 pages, 3 pages or more, then it's going to count as a goal. And so here we can verify it. So if we verify it over the last 7 days, we could see a 4.12% conversion rate. And that tells me that 4% of my traffic over the last 7 days looked at least 3 pages or more. So you're probably asking yourself, well, what number should I put in for the actual variable? So in this case, we see 2. Well, what you want to do is you want to look at, on average, let's just say year to date, you want to make sure you have statistical significance. So you want to look at a period of time. So if you go to analytics, go to audience, okay, and then if you go to overview, and if I change my date range to year to date, I could see on average right now, I have 1.21 pages per session. So that's on average. So we don't want to make our goal 1 page. We don't want to make our goal 2 pages. We want to make it 3. So we want to be able to basically measure at a higher rate. Okay, why do we want to measure at a higher rate? Because if 1.21 is the average, then 2 pages per session really isn't moving the needle. So what we really want to do is get people to stay on the site longer, look at pages more during their session. So look at more pages. And so we want to be able to see what segment of the audience is looking at more pages, what channels driving traffic that's looking at more pages, what pages are contributing to more pages per session. So the whole idea is you want to hone in on what your goal is and see what's working, and then see what's not working so you can make adjustments. The whole idea behind Google Analytics is to improve website performance. And so if our average is 1.2, then if we change it to just 2, it may not be good enough. So in this case, we want to up the bar a little bit. So we're going to choose 3. Now you can choose 4 or 5. That's perfectly fine. Just know if your average is 1.2, I wouldn't choose 1 page per session as my goal, and I probably wouldn't choose 2. So I'd set the bar a little bit higher. Now, the third goal type available in Google Analytics is also engagement related, and that's duration. So just like pages per session, we can measure how long somebody stays on the website, and we could set up a goal for that. So in this case, I have a goal set for 1 minute 30 seconds. So my goal type is duration. So if I click continue, then basically I'm asking analytics, in this case, anybody who stays more than 1 minute and 30 seconds on the website, count it as a goal. And so before you actually put in the number of hours, minutes, and seconds, you want to look at that average. So if you go back to audience overview, here I can see 1 minute and 7. So do we want 1 minute and 30? Maybe we could do that. Maybe we can go with 2 minutes. So again, the whole point is you want to set the bar a little bit higher than what the average is. And so here I can see over the last 7 days, if I verify this particular goal, I can see 8% of my traffic over the last 7 days stayed on the site at least 1 minute and 31 seconds. Okay, they stayed greater than 1 minute and 30. And so the whole point is you can hone in because this is a goal. I can go in, this is goal, okay, this is a goal here. And so I could see that this is goal 13. So now I can go to acquisition as an example. I can go to channels as an example. Since this is a goal, this is goal 13. So that would be in goal set 3. So I can actually see what channel is basically driving that goal. Okay, in other words, what channel is driving traffic that is staying on the site at least 1 minute and 30 seconds. And so that's the whole idea behind goals. So likewise for pages per session, we can go into channels. And here I can see we've have over this period of time, year to date, pages per session, we have 3% conversion rate. And here I could see, for example, organic search has a 13% conversion rate. Here I could see social media has a 10%. So I could see that people coming from organic search are staying on the site longer, or they're looking at more pages than any other channel. So just like duration or destination or any goal you set up, you can measure that goal against any dimension. Just because it's engagement doesn't mean you can't. You absolutely can. And so the whole point of engagement related goals is to figure out what's driving traffic to the site, but what traffic is engaging. So you want to be able to pinpoint that so you can improve website performance. Now, the fourth goal type available in Google Analytics is an event. So if you click on new goal, you choose custom, click continue, you have the option to choose an event. So an event is something that you can measure on your website that analytics can't measure by default. So if you want to measure PDF downloads or clicks on buttons or clicks on play buttons on a video or click on a submit button or click on an external link, I mean, you can measure pretty much anything with an event. Then you want to be able to turn that event into a goal. So let's quickly summarize what an event is. So again, we want to be able to measure a particular event that happens on the website. So in order to do so, we need to identify that event. So if I go to, for example, this particular website here, and I want to measure how many times somebody clicks on the Donate Now button. Well, if I can measure that as an event. So when you set up an event in analytics, you have to actually assign a category and an action for that event. So that's the first thing you need to do when you identify an event related goal. First, you need to set up the event. And in order to set up the event, you need to assign a category and action. Okay, so once you identify what you want to track as an event on your website, you're actually going to go in a tag manager or have your webmaster go in a tag manager and set up a tag. And in that tag, they're going to assign that particular category and action. And so here you can see we have this set up. Our category is named Donate Now, and our action is Click. And that's what we want to do. We want to measure how many people click on that Donate Now button. So anytime somebody does that, then the category Donate Now is going to appear in Analytics with the action Click. So when you actually do set up an event, you can go into Analytics and you could test that event. So if I go to the website and I click Donate Now, okay, the reason why I have this as an event is because I'm taking to a third-party website to handle the donations. So here I can go into Analytics and now I can see a category is being fired for header donate with the action Click. So that's my category and that's my action. So that category and action is what is firing after somebody clicks on that Donate Now button. So if I want to turn this event into a goal, I can easily do that. Now that I've set up the event, now that I've identified the category and action, I want to go back to admin and set up the event with these parameters in place. So it just turns out we already have the goal set up. So let's go through how this goal was set up. So first, we chose custom, we chose event, we gave it a name. So as a best practice, when you actually set up a goal as an event or turn an event into a goal, I would add the prefix event : to it. And then that way, when you're identifying goals in your reporting, you know it's an event. So I'm going to click continue. And now that I actually have set up the event already in Google Tag Manager, I've given it a category, I've given it an action. Okay, see here you can see we have a regular expression set up. So anything with the header donate or donate is going to fire this goal. So over the last 7 days, I have a 0.81% conversion rate. Okay, I could have easily put in equals to and put in whatever the action or the category, which is Donate Now, or I could have put action equals Click. I could have done that as well. So let me show you another example here. So if I do this, custom, continue, event, Donate Now. Here's my goal ID. It's going to be an event. So all I need to do is put in the category and action. So Donate Now and then Click. So that's all I have to do. And that's my goal. So I can verify it, okay, to see if anybody's fired it. And basically that's what I need to do to turn that event into a goal. Okay, so you need to set up for an event. First, you need to identify the event, set it up in Google Tag Manager, which is another platform. And once you've done that, then you have your category in action. Once you have your category in action, you're again going to go into Analytics and then simply put in that category and action into the appropriate fields to set up your event-related goal. Now, all events don't have to be turned into a goal. If you actually do set up an event and you're just not worthy of a goal, meaning it's not a KPI or doesn't align with your business goals, well, don't fret. You can always just go to behavior. Okay, you can always go to events. You can always go to overview and measure your events that way. So here you can see all of our events that are fired. Now we do have this one turned into a goal. So if it's important for our business, then we want to make sure we convert that particular event into a goal. Okay, if it's not important, for example, somebody's just clicking on a social button, then you don't necessarily have to turn that event into a goal if you don't want to. Know that it's sitting here under events, under behavior. So the point I'm trying to make here, if it's important to your business and you're already tracking it as an event via Google Tag Manager, then feel free to turn it into a goal. All you need is that category. All you need is that action. And so one final note on that event-related goal, just like any other goal, you can add a value. Okay, so if I have an event set up, I can choose to add a value here. Or in Google Tag Manager, if I've assigned a value to that event, so if I go back to the actual event in Google Tag Manager, you can see I have a value set up for $1. Then I could just go into Analytics and say, you know what? I already have the value added So go ahead and use the value added in Google Tag Manager. Okay, so I'm going to choose yes. Now if I choose no, I have the option to add the value here, just like I would with any other goal. So just keep that in mind. You can add a value to any goal type. With an event-related goal, you can add the value right into the tag in Google Tag Manager, just as I've done here. So remember, when you actually set up your goals, whether it's a destination, pages per session, duration, or an event, you can just go ahead and choose that goal set that it's in and measure any dimension against that particular goal. So here I can see e-newsletter signups by channel. I can go into another goal set. Here I can see contact form submissions. Okay, I can see what particular channels driving contact form submissions. Okay, so just know that you can align a goal against any dimension. So if you have e-commerce, you don't have to set up a goal for that. That's separate. But if you want to take a look at your goals in analytics on its own, you can just go to Conversions, Goals, Overview. Here, I can actually get a good sense of how my goals are performing over a period of time. So again, if I choose, for example, year to date, now I can see, based on the goals I've set up, how many total goal completions, value, which takes into account the value we've added into these goals, okay, the total conversion rate. And here I can see it broken down by the goal I actually have set up. And I can see it by page, or I could see it by source and medium. So I could see Google Organic is driving the most goal completions, then Google CPC, Direct, and then I could see some others in here as well, contributing to goals. Now, I do want to point your attention to another report in Google Analytics that does take into account goals, and that's multi-channel funneling. So again, under conversion goals, multi-channel funnels, if I go to assisted conversions, I can actually see what channel in this example is assisting with the conversions I've set up. And so what do we mean by assisted conversions? Well, that means that if a channel, let's just say organic search, drove traffic to the website, and that traffic didn't convert when it arrived at the website and left, but it came back a week later via another channel, let's just say email. And when they came back via email, they did convert during that session. Well, what analytics does is they give an assist to organic search because they help drive the traffic to the website. So it's similar to the game of basketball. If I have the ball and I pass it to my colleague, and my colleague's the one who scores because they had the ball last, well, they get the credit for the point, i.e. the conversion, but I get an assist. And so analytics works the same way. They're always going to give credit to the last click or direct conversion, but they will give credits to the channel in this case that assisted with the conversion. So that's under assisted conversion, and that's based on the goals you have set up. You can highlight any particular goal here. If I want to hone in on, say, the donate clicks only, then I'm going to be able to see what contributed to that particular goal. So there's another report in here, top conversion paths, that I think is important. So after you set up your goals, you can actually see what channels in this particular example help to drive conversions. Again, this is year to date. So I can see all the different combinations of channels that work together to contribute to a conversion. So again, I can choose a specific goal, or I can choose all my goals. So those two reports are under multi-channel funneling. There's also another report that I think is good, and that's time lag, meaning how long did it actually take somebody to convert. So here you can see most of our conversions, 265 year to date, happen on the day somebody arrived on the website. But I could see I did get some conversions a day later, 2 days later, etc. So you have time lag, top conversion paths, assisted conversions. They're all under multi-channel funneling, and they're all available after you set up at least one goal. And so if you're not sure what goal to set up, okay, don't fret. You can always at least set up an engagement related goal. So that's available to you. Duration, pages per session. You also have destination and event tracking. And they're all available to you. You have 20 available per view. Now, if you're not quite sure exactly what type of goal to set up, there is an option available in Analytics, and that's the gallery. So you can always import a goal from the gallery. So in other words, we could take a look at what other people have set up in terms of goals. So you just have to click on the button import from gallery, and it'll take you to the gallery, and you'll be able to see what other goals others have set up. Today we're going to talk about how to set up event tracking in Google Analytics. So let's get started. So many of you out there have a website similar to the one I'm looking at now. This is a nonprofit that I work with, AMA Foundation, and like this website and probably like your website, you probably have some interactivity on there that needs to be tracked. For example, buttons. If you have buttons like this one that says donate or newsletter sign up, or there's a PDF download or a video that needs to be, tracked based on the amount of people who click on the play button. So, all sorts of interactivity on a website. Have you ever wondered how to track that? Well, there is a way to track that because by default, Google Analytics can't track interactivity and engagement on your website like you probably want to have your website tracked. So if you have buttons and videos and things of that nature that you want to have tracked, well, you're going to need event tracking. And if you're in analytics and you're always wandering around the data and you happen to find yourself under events, well, if you want events on your website and you want data to populate under behavior top events, you're going to need to set up event tracking. So event tracking is a two-part process. And we're going to talk about that two-part process. The first part of that is to identify what you want to track. Okay, so if we go back to our example website here, AMA Foundation, again, we noted there's a lot to track here. We got a donate now button, we got a newsletter sign up, we have some social icons. Okay, we got a donate now button here, we got a play button here, we got all sorts of interactivity. We got a button here that says, purchase tickets for an upcoming event. I can go throughout the website and find different buttons and things to track. Let me just say this. There's no shortage of what you can track on your website with event tracking. So event tracking is just basically, in layman's terms, tracking engagement on your site. Because Google Analytics by default is only going to track page view data, meaning how somebody got to your website, what page they looked at, how long they stayed on that page, what page they left from. More or less, their timing, how long somebody stays on the website and what pages they look at. So there's more to a website than just how long somebody stayed on a page. And so in this example, we want to be able to track everything here, not just the donate now button, but everything, because once you get the hang of event tracking, then it's very easy to set up. Okay, so step one, identify what you want to track. Okay, so there's a lot we want to track. We're just going to use one example to start off with, and that's going to be this donate now button. Okay, so this donate now button we want to track. Now we have a newsletter sign up, we have Facebook, and that's fine. You could track all that, but for the sake of going through a step-by-step process today, let's just focus on the donate now button. Let's focus on the donate now button, then we'll come back and start tracking these other things. But this is what we want to track to start out with. Okay, so step one, identify what you want to track. Now, when it comes to tracking events on a website, you want to identify those events. So we did that by choosing this donate now button. Now, once we identify what we want to track, we need to assign two parameters for that event. So with event tracking, you have three parameters, but one is actually optional. So you have two mandatory parameters that you have to assign to everything you want to track on your website. And that's the category and then the action. So event label is the third parameter, but again, that's optional. Okay, so basically, when we identify an event on our website, we want to assign it a category and an action. Okay, so why do we want to assign it a category and an action? Because when we're in analytics, under behavior, under events, top events, we could see we have different categories here. and we have different actions, we have different labels. So if I click on any one of these dimensions, I'm going to be able to see some of the parameters I've entered in for previous events I'm tracking. Okay, so the whole idea is you want to be able to group different events together into a category and assign an action and assign a label to it. That's really what you're doing. You're just grouping and identifying the events you're trying to track. And so in this case, I have this Donate Now button sitting in the header. Okay, in fact, I have a lot of things sitting in the header. So if I wanted to, and I want to track all these buttons, I can create a category called header. And then if I track all these buttons can sit in that same category if I wanted to. Or I can create a separate category for each of these buttons. It's up to you how you organize your categories, because basically all you're doing is giving a name to what you're trying to track. And the name is equivalent to a category. So in this case, the Donate Now button is very important. I'm just going to call it category header donate. Now I need to give an action to each category. And so in this case, I'm just going to say click, because that's what the action is doing. It's somebody's taking the action of clicking. Now, if it's a video and it's a play button, I can assign an action of play. It's up to you whatever you name these parameters. You just need to be organized and methodical about what you name it. That's all. And so in this case, header donate and then click. Okay, and so that's our category in action. And so that's really step 2. So step 1, identify what you want to track. Step 2, assign a category, action, and or label. But remember, label is optional. So if I go back in analytics here, I could see some categories. And if I click on action, I could see some actions that I've named. Now, step 3. So we've identified in step 1 what we want to track. We've assigned a category and action. So step 3 is going into Google Tag Manager to set up the event. Okay, so if you're not familiar with Google Tag Manager, then you can easily just do a Google search for Google Tag Manager, and basically you'll have all sorts of information on it. There's a good video overview of Tag Manager here that you can watch. So Tag Manager basically is what we want to use to set up event tracking. Now, Tag Manager is used for a lot of different things, but the main thing we're doing here is setting up an event for our website. And so I'm logged in to the same email address I'm using for analytics. Okay, so now I'm in Tag Manager and I want to set up my event for this Donate Now button. So what do I need to do? Well, for every event I want to set up, I need to set up a tag. Okay, so if I go to tags, I can see I already have some tags set up, and some of these are events. And so when you actually set up a tag, I recommend having a naming convention. So here you can see any event we set up, we start out by calling it GA-event- whatever it is we're trying to set up. And so in this case, we want to set up a new tag for the Donate Now button on our website. So we're in Google Tag Manager, because Tag Manager is what's going to fire that event. So if I click on New, okay, and I click on Tag Configuration, I'm going to choose Google Analytics. And then I'm going to choose Event as my track type. So we want the data to show up in Google Analytics, and we're tracking an event. We're not tracking a page view, we're tracking an event. And so now, remember in step 2, you identified what you want to call that category, you identify what you want to call that action, and you have some optional parameters like label. So first things first, header donates the name of our category, and our action is click. And if you want to add in a label and a value, so if you want to assign a value, you can. If you want to add in a label, you can. Okay, those are optional. So you just need to focus on category and action. And then the last setting here that's probably worth mentioning is a non-interaction hit. Okay, so this is automatically set to false. And why is it set to false? Because it's a non-interaction. No, that's false. We want this event, if somebody clicks on the header donate, to be an interaction. So for example, if I land on this page here and I click on that Donate Now button that I'm tracking as an event, and I actually leave the site, because I have my settings set to false, I want that click to be an interaction. then Analytics is not going to count a bounce. If I change it to true, so from false to true, then that means it is going to be a non-interaction if somebody lands on the page and if somebody clicks on the button. So I don't want it to be a bounce. I want it to be an interaction. So my advice is leave it set to false. We're going to choose Google Analytics as our setting here. This is our variable for Google Analytics. So in other words, that variable is set to our Analytics property ID. And more or less, that's what you need to do to set up the tag, okay? You need to, in step 2, identify the category and action, and or label, and or value. Now, value can be anything you want. You're assigning a numerical value, so if you just assign 1, anytime that event fires in Analytics, it's going to have a value of 1. Okay, and so we have our non-interaction set to false. So anytime the event fires, it's going to count as an interaction and therefore not count as a bounce if somebody landed on that page. So that's more or less all you need to do to set up the tag in Google Tag Manager. Now, if somebody else is setting up the tag for you, then again, you want to revert to step 2. You want to be able to give that person the appropriate category, action, and or label, and or value. Why? Because you're the one that's going to be going into Google Analytics, and you're the one that's going to have to go to behavior, events, top events, and look for the particular category and action and or label. So you need to be able to communicate that information to whomever is setting up the tag. Now, if it's you, great. You already know what it is because you're entering that information into Tag Manager. So in this case, I'm going to go ahead and choose a variable for my label parameter. And why do I want to do that? Because in Tag Manager, I have something at my disposal called variables. And variables allow you to see specifically things that are being tracked. So in this case, I chose page path. Okay, so page path is a URL. And why did I choose page path as my variable for the parameter label? Because if somebody does click on the header donate button, and the header donate button on our website is on every page. So if I go to the children's page, I'm still going to see that header donate button. And so for me, I want to be able to see what page somebody clicked on that header donate button. And so this allows me to actually see in Google Analytics what page somebody clicked on the header donate now button. And so now if I go back to GTM, Google Tag Manager, I have a category, I have an action, and I have a label, which is a variable. Okay, so note that in Google Tag Manager, you have a lot of different variables at your disposal. And variables are there to help you identify specifically what is being tracked. So take a look at all the variables at your disposal in Tag Manager. In this example, I'm using page path. So now, once you set up your tag, pretty straightforward. Again, tag types, Google Analytics. Track type is event. You are assigning the category, action, and or label, and or value. You're changing or leaving the default in place for non-interaction hit. And then you're choosing the variable for Google Analytics, which is your property ID. So once you've done that, you have a tag. The second part of setting up a tag is to assign a trigger to that tag. So Tag Manager needs to be able to know when to fire that event. And so here I'm going to look at a trigger I've already set up for this particular event. And so if I click on it, I'll be able to see that what it is a click on some links, not all links, but some links. I'm actually saying, hey, Google Tag Manager, fire this event when the click ID equals header donate button. Now, it just so happens that if somebody did click on this donate now button, they're going to go to another website. In this case, networkforgood.com. So in Tag Manager, I could have set the trigger to equal URL equal. Instead of click ID, I could have said URL equal networkforgood.com. So that could have been my logic for my trigger. In this case, I decided to go with the click ID. And so in this case, that button has an ID associated with it called header donate button. So if you wanted to use click ID for your event, for your button, you could simply just go to the website. You can right click on that button and click inspect element. And so when I actually inspect the element, I can see now the button here. You can see it's highlighted in the upper pane, and in the lower pane, I can see where it's linking to. It's linking to networkforgood.com. But here you can see if I hone in a little, I can see ID equals header-donate-button. So that's the click ID. Notice there's also a class. I could have set the trigger to equal this class. Or again, I could have set the trigger to equal the URL or the page that this button is pointing to. I could have chosen any one of those, but I decided to go with the ID. So this is the ID I chose, and that's the ID I have in my trigger. Okay, so that is what's going to fire that event. So if somebody clicks on a button that equals header-donate-button, it's going to fire that event, which is going to equal category, header donate, action click, and then the label is going to be page path. So now that we've set up our event, we want to test to see if it actually works. So there's two ways to go about testing an event. And the first way is through Google Analytics. So if we go to Google Analytics and then we go to real time, okay, we can go to events, and here you can see one is already fired. So let's go ahead and go to and test this and go to the website. So if I go here, for example, and I click on Amagar alumni. Okay, so if I click on that, you can see I'm under our family. And if I click on that button, then go back to analytics and look at real time, I should be able to see this event fire. So if I click on it, I'm going to go to Network for Good. Now if I go back to analytics, here in real time, under events, per second, I can see that event firing. Category equals header donate. The action equals click. Now if I click on the category, here I can see the label. The label, remember, was page path. And here you can see this event fired on the Our Family page, which was the page I was just on. So that's one way to test to see if your event works. And in this case, analytics recognized the event, so it works, it fired, and so therefore it's going to show up under behavior, under events. You can go under overview or top events. Okay, and what am I going to look for? In this case, I'm going to look for header donate. Okay, if I click on header donate as my category, I'm going to be able to see my action. And if I click on action, I'll be able to see my label. In this case, homepage. And then later on, when the data propagates in analytics, I'll be able to see under label the page that I clicked on that header donate button, which is /our-family. Okay, the second way in which you can test to see if an event fires is if you preview. So if I click on preview in Tag Manager, okay, I'm going to go into preview mode. Okay, and preview mode allows you to see in analytics, in Tag Manager, and on the website what tags are firing. So here I could see I'm in preview mode now. So I'm going to go to the website and I'm going to refresh, and in my browser, same browser I'm using for Tag Manager, I can see the tags that are being fired on this page already. Okay, because I'm in preview mode. So here I could see remarketing, I could see page views, I could see Google Optimize, I could see some tags that are already firing on this page. Now, if I click on this button here by holding down my Shift command and then click on that button, I'll be able to see that the tag fired in preview mode. There's my event, header donate, and I could see it fired. So now I can see it fired in the preview mode. So in addition to Google Analytics, in preview mode, I could see that that tag is fired, and I know that it's working. So there you have it. You have two ways to test to see if the event fires. Again, you have real time and analytics. Okay, so in real time, if you just go up to real time, all you need to do is go down to events, go to your website, click on the button. If you see it firing in real time, then you know it works. The second version or second way to test your event is through the preview mode. Okay, if you see it firing in preview mode, then you know it's also working. Okay, so let's rehash our steps. First step is we want to be able to identify what we want to track. Okay, so it could be this newsletter sign up, it could be click on a Facebook, it could be anything we want to be able to track. An image, a click on a CTA button, whatever we want to track, identify it. Second step, identify the category, action, and label, because that's what's going to show up in Google Analytics. Remember, label is optional, value is optional. Third step, go into Tag Manager, actually set up your tag and your trigger. So if you set up a tag and it's an event, name it GA-event. So that way you can see in your list of tags in Tag Manager what event tracking you have already set up. So when you set up your tag, you set up your trigger. Your trigger is based on logic. That can be a URL, it can be a click ID, it can be a class ID, whatever you want to use to fire that event. And then once you do that, you want to test it. You could test it in GTM or you could test it in Google Analytics. If it doesn't fire, you want to tweak your trigger. If it does fire, then great. And then one thing I would recommend is if you're setting up various events for your website, that's a best practice. What I would recommend is set up a spreadsheet. And in that spreadsheet, you want to put a note. What's firing? What are you doing to fire? It could be, in this case, when somebody clicks on the Donate Now button in the header. You want to put the tag name in here, the type. Okay, then you want to record your category, action, and label. And then the great thing about events is you could turn those events into goals. And that's as simple as going back into Analytics. Okay, so if I go in Analytics and I go to Admin and I go to Goals, if you set up a new goal, okay, all you need to do is choose Custom, click Continue. You're going to choose Event as your goal name. And then from a naming perspective in Google Analytics for your goal, I would definitely put event first and then click on header donate. Okay, so if I click now continue, what is my category? It's equal to header donate. My action is click. And so I can verify to see if this is working. And here I can see in Analytics that the goal would have a 0.22% conversion rate. So that tells me that the goal is working and I can turn this event into a goal. And when you turn something into a goal in Analytics, then you can measure it across all dimensions. That's what I would recommend if the event is equal to a KPI or business goal, or it's of importance. It's something you really want to measure. Okay, if it's just a click, say on a Facebook button, I wouldn't recommend setting that up as a goal. Okay, so once you've set up your event, you recorded it in your spreadsheet, it's firing, you want to be able to then go back into behavior, back into events. Okay, you can go to top events. Okay, so top events tell you by category as a default what events are firing or what category is firing the most. Okay, so if I choose my date range, here I can just go to year to date. So here I can see my header donate button, fortunately for me, has the most total events. Now notice in Analytics, you'll also see unique events. And so the difference between unique events and total events is that unique events are equivalent to one per session, where total events means that somebody can come to your website, initiate a session, and click on that button multiple times in the same session. So if I go to the Alma Foundation website, okay, I can click on that Donate Now button 3 or 4 or 5 different times in the same session. So what Analytics is going to do is actually, in that session, count it once, but accumulate the number of clicks as a total event for that session. So you're always going to have more total events than unique events, because in some cases, users may click on the button more than once in the same session. And so here I can see total events, unique events, and if I added a value to that event, I should be able to see it here. So if I added $1 as an example to this particular event, because it had 164 unique events, I should be able to see 164 as my value. But since I see 0, that means that I did not assign value. And so average value basically is just giving me how much average I have per event. So it's taking into account the number of, or the value, the total value divided by the total number of unique page views or sessions. And so because I don't have value, I'm not going to have average value. But here you could see, because value is optional, here I can at least see how many events or how many clicks I receive for a particular button. Again, it could be a video. If I clicked on this video as an example, I can see how many people actually started it. I can see the unique and the total events. And if I click on label, if I have a label assigned, then I'll be able to see what page triggered that event. So if we go back again to our header donate button, back to category, if we click on label as our primary dimension, here we can see the home page had the most unique events, then followed by the children's page, the contact form, etc. So what you can do in analytics, you can also look at the pages that have driven events. So here I can see the home page has accumulated the most total events, followed by the contact us. So that's how you would look at the data in Google Analytics. Under behavior, under events, and then under top events or overview is where you can start analyzing your event tracking. So first you need to do, identify it, assign a category, action, and or label, set up that tag and trigger. Once you do that, once you test that it's working, this is where you're going to go to analyze the data. Let's start out with why GTM. So let's just say you're Sam and you have your own e-commerce website and you want to understand how people are interacting with your website. Well, Sam, today's world of websites contain a lot of interactivity, everything from videos to PDF downloads to commenting to form submissions to all sorts of chat functionality, interactivity going on throughout the website. So there's just a lot that you need to track outside of just page views. And so really what GTM does is they help you track all these things I just mentioned. Everything from somebody clicking on the play button of a PDF to somebody clicking on the submit button of a form to somebody entering in something on a chat function. So that's what GTM is. So why GTM? Because it helps us track all that interactivity. So all GTM is really allows you to really place a piece of Java code, which is just script, and this script that's added to a web page to collect information. So that's really what a tag is. It's just some script that gets put on a web page in order for you to collect information, like page views, clicks, etc. And they send it to third-party tools. Okay, so that's what GTM does. It basically allows you to take all these tags that collect information and you can use them in GTM. So if you want to, for example, collect how many people, enter a chat functionality and start chatting. Well, you're going to take that script and you're going to put it in GTM, and GTM will then allow you to start tracking that information. So that's really what GTM is. It just allows you to put tags into a container, or think of it as a toy box. You have all these toys and you want to track, well, you can put all those toys or tags in a toy box or container. And we're going to talk a little bit more about that. But before we get into GTM, let's just say you're communicating with your developer and there's a new user request on your webpage and you want to update the tag. Well, your developer, considering it's probably a small update to your website, is probably gonna not hesitate and is going to go ahead and turn around and do it normally. And so normally what happens is the developer is going to go to the website and update the tag. Well, what if you have a few things that you want to track? All those things I mentioned before, from downloads to clicks to, somebody checking out to watching a video. Well, your webmaster, your web developer is going to go, well, hold on a second. Now, all these requests are going to take time. I need to put them into the work queue, so to speak. Well, what happens is when they go into a work queue, usually it's going to take some time. And in some cases, you as a marketer need to launch a campaign. And you want to get that tracking added to the website in time for the campaign launch. So you want to go ahead and quickly turn around the tracking for that particular campaign. Let's just say you're launching a campaign and you're sending people to a landing page that has a form submission. And you want to be able to track how many people click on the submit button of that form submission. Well, if you need to turn that around, your developer's like, well, I need to put that in a work queue. The timing isn't going to always work out between you and your developer is my point. And so that's where GTM comes in. Because there is a solution to update your tags faster. And that's Google Tag Manager. So when we say GTM, that's what GTM stands for, Google Tag Manager. It's a place for you to add tags quickly and easily. So tags, remember, are just snippets of code that allow you to track things on your website interactively. And basically, when you have GTM, you can bypass the webmaster and do it quickly and easily. So that's what GTM is all about. So why GTM? Because we just identified two benefits. One, you could track all the interactivity on your website. And two, you can bypass your web developer or webmaster. And so that's the benefit of GTM. So the benefit, you get those tags updated very quickly via Google Tag Manager. Okay, so that's what Tag Manager is. So what we're going to talk about today is specifically what Tag Manager is and what it does. We're going to list some of the benefits of Tag Manager. We're going to show you how it works, and then we're going to show you how to get started with Tag Manager. Tag Manager, if you're not familiar with working with webmasters and dealing with JavaScript and tags and all this jargon is just new to you today, okay, well, don't fret, sit back. We're going to take it slow. This is an introduction into Google Tag Manager. Again, let's start out with what is Tag Manager. So we've already introduced it to some degree because we already introduced it as a tool where you can put all your tags into a toolbox, toy box, or container, so to speak, right? And we already mentioned that, hey, you can bypass your webmaster. So you're probably thinking, well, if you're not familiar with Tag Manager, how can I bypass my webmaster? Well, first of all, it's a free tool, and it's a Google tool, hence the name Google Tag Manager. And it helps you really, that's the main point, is deploy and track tags on your website, bypassing your webmaster. So that's Tag Manager. And so examples of tags that can be deployed via Google Tag Manager are numerous. These are just some examples like Google Analytics, Facebook's pixel tracking, or Google Ads. There's no limit into the number of tags you can track in Tag Manager. There is no limit. You can add any number of tracking tags in Tag Manager. Okay, so some of the benefits, well, again, we just listed two. You can put any tag into Tag Manager and track that onto your website. And we know you can bypass your web developer or webmaster. And what it also does is it also allows you to test and deploy your JavaScript codes quicker. So remember, these JavaScript codes or snippets of codes are just there to track certain things on your website, whether that be a page view or somebody clicking on a play button or tracking somebody who converts or even just goes to your website. So the biggest benefit is you can take that snippet of code, let's just say Facebook. Let's just say you're doing Facebook marketing and you want to put that Facebook pixel on your website so that you could track people who come from Facebook and convert. Well, you don't need to put that Facebook pixel on your website. You can go right to Tag Manager and you can put that snippet of code right in Tag Manager really quickly. And the other benefit here is all tags are managed in one place. And that to me is really a good benefit, because when you start adding tags on your website and you have some tags in Tag Manager, it just gets very confusing. So ideally, all the tracking code you have on your website needs to be in Tag Manager. Think about that. All the tracking. So if you're doing Bing or you're doing Facebook or you're doing Twitter or you're doing LinkedIn and you're doing Google, you're doing all this type of marketing on all these different platforms, you're going to have tracking code for all these different platforms. And instead of putting all that code on your website, return going to slow down the load time of your web page and website. You want to put them all in Tag Manager so they can be organized and you know exactly what you're trying to track. And the other great benefit of Tag Manager is there's a versioning control. So let's just say you have added tags to your website via GTM for the last 6 months. Well, and let's just say you add another tag yesterday. If you added that tag yesterday and something doesn't work, well, you can just roll back to a previous version. It's that simple. So you have versioning, and that's a good thing. When you have versioning, you can control what gets published, and if something doesn't work after it gets published, then you can roll back to a previous version. So it's a peace of mind, so to speak. Just because you've added code to your site, there's no guarantee it's going to work. And so you can always control what version you're dealing with in Tag Manager. And we'll talk a little bit more about that. So the biggest benefit here to me with Tag Manager is you have event tracking. And so we talked about some of the things you could track on your website, from videos, from play buttons to somebody clicking on the stop on the video or pausing it, all the way to somebody, again, chatting, or let's just say somebody clicking on that purchase button on your website. Okay, and you want to track all these different things, these different interactivities and buttons. Well, event tracking is what you're going to use to track all those buttons. And to me, this is the biggest benefit of Tag Manager. And I'll show you some examples as we go along. And if we didn't mention it already, I'll mention it again. It is free. Tag Manager is free. There's no limit. So once you have Tag Manager going, you can add as many tracking codes as you want. There's no limit on the number of tracking codes you can add to Tag Manager. Okay, so it's free and you can use it to its fullest advantage. Okay, so it's also high security, meaning that it has different levels of permissions. Okay, so you can have somebody just go in and look at the different tags and tracking codes you have in GTM, or you can ask somebody who is very familiar with Tag Manager and can go in and add the tracking code to Tag Manager and then publish that tracking code when it gets added. So those are all the benefits. Let's talk about how it works now. Specifically, how does Tag Manager work? Because you're like, Rob, okay, again, a lot of jargon. You know, you got tags and JavaScript and versioning and publishing and all this other stuff. Well, I know I'm throwing a lot at you at once, but just bear with me here. Okay, so let's start talking about how it actually works. So you have a website, okay? Whatever that domain is, you have a website, and there's chances are on your website, you have some form of interactivity, whether that be a video, whether that be a blog, whether it be a form submission. You have a website with some interactivity. And let's just say you're even thinking about getting ready to launch some type of campaign on maybe Google or Facebook, and you want to drive traffic to your website. Fair enough. You're joining the millions of other websites that are out there that have interactivity that also drive traffic to the website. So in comes Google Tag Manager. And so Tag Manager is important because, again, we know we want to track people coming from that Facebook campaign or that Google campaign and interacting with our site. So if you are running Facebook and you are running Google Analytics, well, guess what? You want to put that tracking code in Tag Manager. So Google Analytics, being a Google product, works very nicely with Tag Manager. Facebook has its own tracking code, but you still want to be able to track people who come from the Facebook campaign to your website. So you're going to get that tracking code from Facebook and put it in Tag Manager. That's generally how it works. So here, information from your website is shared with another data source through Tag Manager. So think about that. If I add Facebook tracking code to Tag Manager, or let's just say I add Google Analytics tracking code to Tag Manager is the one that's pushing out and doing all the heavy lifting. They're the ones that are controlling what code gets fired and what code doesn't. So if you're putting the code in Tag Manager is controlling the code. Think about it that way. And let's show you an example of what that looks like. So here I am, I'm in Tag Manager. I just went to tagmanager.google.com, and here I can see a list of tags. So in our conversation, we're talking about tracking Facebook and we're talking about tracking Google Analytics. Well, Google Analytics is easy because it's a Google product. So here, if I look at all the different tracking code I have on my website through Tag Manager, let's just take a look at Google Analytics. So if you're going to use Tag Manager, you might as well put the Google Analytics code in here. So here I can see I have Google Analytics as a tag in Tag Manager. Now, for Facebook, if I'm running a Facebook campaign, well, I can take that pixel tracking and put it in GTM as well. And here I can see Facebook pixel. That code is added to GTM. I just basically took what Facebook gave me and put it into Google Tag Manager. So you can see I can add Facebook and Google Analytics. And again, I can't stress it enough, any tracking code from any platform, I can add to Google Tag Manager in order to track the behavior from those sources. So let's take a little bit deeper dive into how Tag Manager works. So I just showed you an example of how you could take Facebook and Google Analytics code and put it into Tag Manager. But if you're not familiar with Tag Manager, then how do I do that? Well, let's talk about the structure and how Tag Manager works. So when you have a Tag Manager account, you have a container. Remember, I mentioned toy box earlier. You have a bunch of toys. If they're code and you're tracking different bits of code from different platforms like Facebook, think of those as toys, and you have a toy box. Okay, well, that's what this code is, and that's what a container is. The code is the code, and that's going to go into the toy box or container. And so the way Tag Manager works is you have tags, triggers, and variables. So if I take my Facebook tracking code and put it into a container, I need to set up a tag and a trigger. Okay, so let's take a look at what that is. So first, if I go back to Tag Manager, I'm going to have an account, and if I have an account, I'm going to have a container. So here I'm just going to click on an account with a container, and a container is nothing more than what website you're adding the tracking code to. Okay, that's all the container is. We're just letting Tag Manager know this is the website we're adding all this code to. So you have tags, triggers, and variables. That's the structure of Tag Manager. So tags are just what it says, tags. What are we trying to quote unquote tag? Well, if it's Google Analytics, that's easy. Here I could see I have Google Analytics added. So if I click on Google Analytics, here's my tag. And if I take a little bit of a deeper dive there, since Google Analytics is a Google product, it integrates already with Tag Managers. It's pretty easy. I can just choose Google Analytics, then I'm going to check page view, and that's my tag. Now, every tag needs a trigger. Okay, so I need to tell Tag Manager how or when to fire the Google Analytics tracking code. So in this case, I'm going to tell Tag Manager to fire on all pages. So if I get somebody, a visitor to my website, Analytics is firing on all pages. So whatever page that visitor lands on, Google Analytics is going to fire. So that's really what it comes down to, is I have a tag and I need to tell Tag Manager when to trigger that tag. That's really what the structure of Tag Manager is. It's tags, triggers, and variables. And variables we're going to talk about here in a couple minutes. But you have a piece of code. You're going to go ahead and put that into Tag Manager. You're going to tag it, and then you're going to fire that trigger. So let's take a look at another example here. If I go back here, you can see Facebook. Well, here's my Facebook pixel. Okay, that's my tag. So when is it going to fire? Well, it's going to fire on a specific domain or subdomain. That's basically what we're doing. We're trying to tell GTM when to fire that particular tag. So those are the three main components: a tag, okay, which is going to contain the JavaScript code that you get from, say, Facebook, the trigger. So you're going to go into Tag Manager and tell Tag Manager when to fire that code. That's the trigger. And then you have variables. And so variables are basically just additional information that Tag Manager may need for your tag and trigger to work. So that's what a variable is. It's there to get the tag and trigger to fire. So variables are divided into built-in and user-defined variables. So common used variables include, say, page path or page URL or host name or click class. Again, they're there, and these examples I just gave you are there to get your tag and trigger to work. Think about it that way. That's a component. And if I go into Tag Manager here, and here on the left side, I can see variables. So remember, I have built-in and user-defined. So built-in means that Tag Manager already built these for me. So in case I need to get my trigger to work with my tag, I can use a variable. So those are built in, and then I have user defined. So these are what I define. These are what I created. And again, the variables are there to get the tag and trigger to work. Okay, so that's the job of the variable. The job of the tag is to host that JavaScript code. Okay, in the case of Facebook or analytics, that's where we're putting our code. So here, if I click on AdWords remarketing, again, it's a Google product, so I don't really need to even deal with code. I'm just gonna select Google AdWords remarketing. Okay, so you could see GTM integrates nicely with some of the other Google products. But let's just say you have a Facebook pixel tracking code. You're going to choose custom and you're going to put the code here. So that's part of the tag. And then the trigger again is there to get the tag to fire. So you're telling GTM when to fire the tag. And the variable is there to help you make sure that that trigger and that tag work together. So that's how all three kind of work together. You need the tag to put the code. You need the trigger to tell GTM when to fire the tag and code. And the variables there to help you define when that tag and trigger should work or how it should work. So again, review, tags they're just small codes of JavaScript or tracking pixels on your website. And so tags are allowed to manage events like scroll tracking, remarketing, clicks, downloads, files, play buttons, you name it. Even clicks on external links. For example, let's just say you have a click or a Facebook icon on your site, and when somebody clicks on it, they go to Facebook. You want to maybe track that. You're going to create a tag. Okay? The trigger is there because you need to tell GTM when to fire that tag. So it's a certain condition, whether it's, fire the tag if the URL equals facebook.com or some other condition. So the tag cannot be created until the creation of the corresponding trigger. So tags and triggers go together. You can't just create a tag and not have a trigger. Otherwise, your tag will never fire. And then the variable is there again. It stores the information when defining a trigger or transferring data to tag. So a variable has a variety of data. Okay, so you pick and choose the variable you want to use with that trigger. Okay, so you're making sure that by defining a variable, you're making sure that you're telling GTM how that trigger should be fired. So let's take a look at another example here of how all three play together. If I'm in this account, I'm in this container. If I look down here, I could see Google Optimize. That's another Google product. So what I'm doing here is I just chose Google Optimize as my tag. It's already integrated. So what does that mean? I don't even need to deal with any code. I'm just going to select Optimize. Well, we have the tag Google Optimize, but we need to tell GTM how to fire that. And so here we're going to tell GTM to fire it on all pages. So that's basically a very simple example because we're firing it on all pages. So if I want to look at something specific again, Facebook, here's my tag, here's my code. What's my trigger? Well, my trigger is it's going to fire on specific pages. How do I know that? Well, if I look at the trigger, here I could see the trigger is a page view, but I'm telling it to fire on this particular hostname. So the tag and trigger go hand in hand. So how to get started with Tag Manager. So first things first, you have to create that account. So you're going to go to tagmanager.google.com, or you can do a search for Google Tag Manager, and you're going to create your account. And then when you create your account, what's going to happen is you're going to set up a container. And when you set up a container, you have choices. So you could set it up for your website, for an app on iOS, or maybe Android, or you can even set it up for AMP, an accelerated mobile page. So most people by default are probably going to set up Tag Manager for their website. And so when you do that, when you actually select website, what's going to happen is you're going to get some Google Tag Manager code in return. And so the whole idea here is you're going to do a swap. What you're doing is basically you're saying, okay, Google, I'm going to take this Google Tag Manager code and I'm going to put it on my website. I'm going to put it on every page of my website. So notice Tag Manager has two scripts. One goes in the head as high as possible. The other goes into the body tag as high as possible. And so what you're doing is you're making a deal. You're putting this tag manager code on your website, and in return, every code you deal with, whether that be Facebook or analytics or optimize or remarketing or whatever it is going to go in GTM. Okay, it's going to go into the container you created. So you need the tag manager code on your website in order for tag manager to work. Okay, so when you add this code to your website, then you're free to start adding all sorts of tags to your container. But if you don't have this tracking code on your website, then none of the tags you add to your container are going to work. So that's the idea behind the container. And then one thing I wanted to mention on the account is it's a Google account. So when you create your account, then make sure it's the same account you use with, say, Google Analytics or some other Google product. That's a good best practice, is always use the same email address when you set up your account so that it integrates nicely across all the different platforms. Meaning you can go from, say, Google Analytics right to Google Tag Manager in one browser without having to log out or log in. Okay, so when you create the account, you're going to create your container. If you choose web, then you're going to be asked to place code on your website. And when you place that code on your website, then you are free to start using Tag Manager. And that means you're free to start adding tags. Okay, so if you want to know more information about installing Google Tag Manager, then what I would recommend is visit the Quick Start Guide website of GTM. So again, if you're curious as to where that code is located in Google Tag Manager, well, when you create an account and you create a container, that container is going to have a specific ID. So if I click on that specific ID, here's where I can get my code. Okay, so again, when I'm logged in to Tag Manager, I'm going to click on Workspace, but in the top navigation, I'm going to see my unique GTM ID. If I click on that, that's where my code is going to be located. And so again, your code needs to go in the header, and there's another script that needs to go in the body. And if you're not sure how to add the code to your website, well, you can always click on the Quick Start Guide here. Okay, and that'll take you to a Quick Start Guide page, a reference page related to Google Tag Manager. So let's talk about creating a tag. So once you get Tag Manager installed, I'm sure you're excited to get going and create that first tag. So let's talk about how to create a tag in Tag Manager. So when you're in Tag Manager, all you need to do is basically you're looking at all your tags. If you click on tag in the left side navigation, you'll see all your tags, and there's a new button there. So you just click new. And so basically what you're going to do is you're going to create your first tag. And so what I would recommend, once you get Tag Manager installed on your website, I would recommend setting the first tag up as Google Analytics. So that will get you going with tracking page views on your website when somebody visits your website. Okay, so ideally that's what you want to do. You want to get Google Analytics as your first tag in Tag Manager. So what I'm going to do is, because Analytics is a Google product, it's already integrated nicely with Tag Manager. So I'm just going to click on Google Analytics. It's going to be a page view. That's what I'm tracking. And now I have to set up a variable. And so what it's going to do, it's going to ask me to select a variable. And so what you're going to do is you're going to select new variable. And what you're going to do is you're actually going to go and add your tracking ID here. That's going to be your variable. So where do I get my tracking ID in Analytics? Well, if I'm in Analytics, I'm going to go to admin. And then under property settings, I'm going to see my tracking ID. And all you need to do then is go to Tag Manager and paste copy. First, you got to copy over that tracking ID. Then you're going to go to Tag Manager and going to paste it. And then that's going to create a variable for you. And then when you create that variable, you're going to see it in the drop down here. So I've already created it. And basically, that's your tag with a variable. Then what are you going to do? You're going to set up a trigger. So see, I have some triggers already set up. You're going to see a default trigger already set up for you. and that's going to be all pages. So ideally what you want to do is you want to select all pages in order for analytics to fire on all pages. So that's what we're doing. We're setting up a trigger. We're basically telling Tag Manager, hey, if I get a visitor to any page on my website, then I want you to fire Google Analytics. So that's basically, in summary, how to set up your first tag. And my recommendation is your first tag should be Google Analytics. And when you set up Analytics, you're going to have to set up a variable for the tracking ID. And so you get the tracking ID again from admin, property settings, copy and paste that tracking ID over, save it, you have your variable. That variable is going to be included in with the tag. Then your trigger is going to be all pages. And there you go. You have your first tag, you have your first variable, you have your first trigger. So that's basically what you want to do. And once you've added that tag, once you've added that trigger, then the only thing you need to do now is basically publish the tag. And so anytime you save a tag, you're going to go ahead and submit it so that way it gets published. So again, what you're going to do is let's take a step back here. You're going to choose new tag. You're going to choose analytics from the drop down menu. You're going to choose page view. Then basically you're going to add your tracking ID so you can set up the variable. And then basically that's what you need to do. Okay, you're going to add that tracking ID and then voila, that's your tag with a variable. And then once you've done that, then you're going to click submit. So when you click submit, you're basically saying, hey, I want this tag to go live now, this tag and trigger. And once you've done that, then Analytics is ready to go. And anytime somebody goes to your website on any page, Tag Manager is going to fire Google Analytics. So the great thing here is you have something called Google Tag Assistant, and that's an extension that works with Chrome. And so when you've actually added Tag Manager to your site, or you have analytics running in Tag Manager, you can confirm if those tags are firing properly. So let's take a look at how Google Tag Assistant works. Okay, so if you just do a search for Google Tag Assistant, you're going to see here that it's basically just an extension that works in Chrome, and unfortunately it only works in Chrome browser. It doesn't work in any other browser. So go ahead and install that extension into Chrome. And when you do that, you're going to see this nice icon here in your browser. And now, if you go to any website and I click on Google Tag Assistant and I click on Enable, okay, so basically I'm loading Google Tag Assistant. And now once I refresh the page, I can see that this particular site has Google Tag Manager installed. And not only does it have Tag Manager installed, I can see that it's also has Google Analytics running. I have also Google Optimize running, and I have Google Ads Remarketing Tag running in Tag Manager. So that's what Tag Assistant does. It allows you to see if one, Tag Manager is on the site, and if it is, great, what other tags are firing on this particular site. So Tag Assistant's telling me I have these particular tags firing on that site, and they're firing within Tag Manager. So Tag Assistant is a great way to confirm if one, Tag Manager is on the site, and two, what other tags are firing on the site. Now, another way you could confirm if Tag Manager is firing on the site is you can go into preview mode. So even before you submit and publish your tag and trigger, you can click on the preview mode. So if I click preview in Tag Manager, so basically that's going to put me in preview mode. And so what does that mean? Well, that means that now I'm free to go to my website and see if those tags are firing. And so let's take a look at what that looks like. So if I go to the website and just click refresh, then what's going to happen is Tag Manager is going to load in preview mode, just as you see here. Okay, so that's going to take a couple seconds to load up. And now what can I see in preview mode? I could see that I have GTM firing, but I also have some other tags firing on this page. Remarketing, I have Google Analytics, I have Google Optimize. I have some other tags firing as well. And so the preview mode shows me what tags are firing on any given page. And I can also see what tags did not fire Okay, so here I have a number of tags already in GTM, but they didn't fire on this particular page. So let's just say I clicked on the Donate Now button. I'm still in preview mode, so I'm going to be able to see what tags fired. Now I could see I have a couple of tags that have fired on this particular page, and then I could see what tags did not fire on this page. Okay, so that's the preview mode. You can use the preview mode before you even submit a tag and trigger to see if it fires, and that's the great benefit of Tag Manager. So if you're not sure if something's going to fire or not, then you can always go into preview mode. And if you are sure it's going to fire, then you can go ahead and submit it. So you can leave preview mode and just go ahead and submit that particular tag and trigger. So here I'm going to leave preview mode, and now once I'm done and I'm sure the tag is going to fire, and go ahead and submit all my changes that I've worked on in terms of setting up tags and triggers. So that's really GTM in a nutshell. So I have my tags, okay? My tags are just snippets of code that I'm going to put in, whether that be Facebook or event tracking or any other Google product like Optimize or PageView. Then I have my triggers. My triggers are there to tell GTM when to fire that tag. And the variables are there to help those tags and triggers work together. So remember that particular variable we set up for Google Analytics. Okay, so here it is right here, because we want to tell GTM what property to specifically fire in Google Analytics. So that's why we set up that variable. But there are all sorts of variables. Google Tag Manager has built in, or variables already created for you, or you can specifically define a variable. So variables are there to help the tags and triggers work together. So when you set up a tag, you set up a trigger, you use a variable, you can always go into preview mode, preview it by going to the website, seeing if it fires. If it fires, then voila, you can go ahead and click submit, and that will publish the tag and trigger, and you're good to go. That's pretty much how Tag Manager works. And again, I can't stress that there's an unlimited number of tags you can add to Tag Manager. There's no limit. So you got anything from Google to non-Google to event tracking, okay? To Facebook, to anything that you want to track, you want to be able to put into Tag Manager. And again, there's versioning. That's one of the great benefits of Tag Manager. So if I want to go back to an older version, I can simply do that. So here you can see I'm on version 32. That's how Tag Manager works. And I can't stress that, Tag Manager is there to help you track interactivity on the site. Because if you have a site that's interactive, that has a video, that has a download button, let's just say, you have all sorts of newsletter signups, Facebook, YouTube buttons on your website, just like this website does, and you want to be able to track how many people click on that particular button, well, you're going to need Tag Manager. And when you have Tag Manager, you're going to be able to track all of these button clicks and interactivity on your website. Without Tag Manager, it's going to be hard to do that. So that's an introduction to Tag Manager. Today, we're going to talk about how to rank #1 on Google. So let's get started, and let's go with the scenario that you have a friend named Sam, and he has a website where he sells shoes. But Sam doesn't understand why his website's not ranking #1 on Google. And so typically, to rank #1 on Google, there are some factors involved. And those are factors that are going to help Sam get his website ranked #1 on Google so he can sell his shoes, get traffic, and convert that traffic to conversions. So there are factors involved. And so what are those factors? Well, it always starts with keyword research. So in order to rank for a website where you sell shoes, or you sell products, other products like clothing or food, or you're an automobile website, you're a mechanic, it doesn't matter whether you're selling to customers or selling to other businesses. You have to start with the keyword research. And so we're going to go into really explicit detail on how to conduct a proper keyword research. And then the second factor involved is high quality content. So in order to rank high on Google search, you need to have high quality content. So we're going to go over what's involved with creating high quality content. Then we're going to take that content, we're going to optimize it using on-page elements and website level factors. So we're going to take into account what's involved with your website and what's involved with specific pages on your website in order to rank number 1 on Google. Then we're going to get into the off-site engagement. So when it comes to ranking on Google, you need to optimize your website and you need to do some elements off your website. You need to be engaging off your website, meaning on other websites. And so we're going to talk about what's involved with off-site engagement. So SEO being a major channel for most companies and websites where the opportunity to drive a lot of traffic is there. But you have to earn that reward. The reward is a lot of traffic, but you have to earn the reward, and there's a lot of work involved. And so ideally, what we want to do is follow what we call the 80-20 rule when it comes to search engine optimization and ranking on Google. And what do we mean by the 80-20 rule? Well, 80-20 means we're investing 20% of our effort and 80% of the results are obtained. So we want to invest 20 and get back 80. That's basically what we mean by 80-20. So, for example, if 20% of our targeted keywords bring in 80% of the traffic, then that's following the 80-20 rule. Or 20% of our landing pages drive 80% of the overall traffic, that's following the 80-20 rule. Or 20% of our backlinks pass 80% of our link juice. That's the 80-20 rule. Meaning these targeted keywords, these targeted landing pages, these trying to target backlinks using off-site engagement. We want to put in 20% of our effort on those keywords, landing pages, and backlinks in return for 80% of the results. So without further ado, let's get started with the keyword research. Let's talk about that keyword research for a website with shoes. And it doesn't really matter what particular product you have. If you need to rank number 1 on Google, it all starts with the keywords as I mentioned before. And so in this example, if you have a website where you sell shoes for kids, you're going to want to be found for certain keywords. So the obvious keyword here would be shoes for kids. Well, every keyword that you target has search volume associated with it. So that means when we talk about search volume, we're talking about how many people on average type in that keyword or related keyword on Google.com or Google search. And there's always an average number of searches associated with every keyword, and we call that search volume. How much search volume? So obviously if we're going to target a keyword, we want to have as much volume as possible. However, there's always going to be competition for those keywords, meaning there's always going to be other websites who want to rank number 1 on Google for the same keywords. And we call that competition or difficulty. So for every keyword, you're going to have volume and you're going to have competition or difficulty. And the difficulty ranges as well, depending on the tool you use. And we'll get into that in a minute, but search volume is how much, on average, people are typing in that keyword or close variants of that keyword. And the difficulty is measured in terms of how many other websites are trying to rank for the same keyword. And so ideally, when it comes to keyword research, we want to find that nice balance. We want high volume and we want low competition. But at the same time, we want to focus on keywords that are highly relevant to our business. So if we're selling shoes for kids, and shoes for kids is highly relevant, has high volume and low competition, then that's a keyword we want to target. So we always want to focus in on those 3 areas. So there's always a trade-off with keywords. So shoes for kids might have high volume, but also might have high competition or difficulty. If we look for another keyword that's just as relevant, for example, shoes for children, it may still have high search volume, but the competition or the difficulty may be lower. And if that's the case, then that may be a better keyword for us to target. Instead of something highly competitive like shoes for kids, we can focus on another relevant keyword like shoes for children with just as much volume and lower competition. And the reason why we want lower competition is because we want to be able to rank for that keyword. So the higher the competition, the harder it is for us to rank number one on Google for that keyword. And so the whole idea behind keyword research is analyzing and choosing the best keywords. So we want to identify a list of keywords that are always relevant. We want to choose the keyword that your competitors are ranking for. And we want to use third-party tools to choose keywords to identify which keywords have low competition and what keywords have high search volume. So one thing to take into consideration when you're doing keyword research is that the longer the keyword phrase, or in other words, long tail keywords or keywords with 3 keywords in the phrase or more, you're going to always have less competition. But there's always a trade-off. With long tail keywords, meaning the longer the keyword phrase, there's going to be less volume, but the trade-off is less competition. And so what we want to do is we want to brainstorm some ideas and find those relevant keywords. So let's look at an example here. So if we go to Google Ads, so Google Ads has a tool called Keyword Planner. And let's just say I have a website where I'm selling dried figs. And if I'm selling dried figs, I want people to buy these dried figs. However, in order to attract them, I want to be able to show them that, hey, we have a bunch of recipes. And if I show you a bunch of recipes where you can use dried figs, maybe you'll buy these dried figs to use in these recipes. And so we're going to look for keywords related to bread recipes, because if we can optimize for our recipes page for bread, then that will attract an audience who wants to make bread and use dried figs with those bread recipes. So that's the example I'm going to give here. And so if I look at the keyword planner in Google Ads, if I just type in bread recipes, what Google is going to do is they're going to give me an average monthly search volume. So I can see the average monthly search volume here is 60,500. And so in order to do keyword research, what I would recommend is keep a spreadsheet. And so the idea behind the spreadsheet is to document the volume and the competition you're getting for certain keywords. So if I go into a spreadsheet, here, my theme of keywords is bread recipes. My keyword is bread recipes, and my volume, therefore, is going to be 60,500. However, if I go back into Google's keyword planner, Google's telling me the competition is low. So that's great. I want high volume, I want low competition. But how low is low? So we want to be careful. So if we're going to put in numbers into a spreadsheet, we want to figure out what that competition really is for the keyword bread recipes. So if I go to Google and just type in bread recipes, I'm going to be able to see 771 billion results for the keyword bread recipes. Now, is 771 billion our real competition? Maybe, maybe not. What we want to do is put in a syntax, and we want to put in the syntax all in title and then colon, space, and then our keyword. And the reason why we do that in search is because we want to be able to identify the true competitive number, or the true number of websites who are trying to rank for bread recipes. And if we put in the syntax all in title, colon, and then our keyword bread recipes, we'll be able to see that there are 998,000 results. That's a lot lower than 771 billion. So that means that 998,000 sites or listings have the keyword bread recipes in the title tag. And the title tag is what shows up in the search engine results. And so if I look down and scroll down here, I can see bread recipes are in every one of these title tags. So title tag is an important element to rank number one on Google, and we'll talk about that in a few minutes. But if we understand that there are 998,000 results with bread recipes in the title tag, then this tells us that those are the websites who are trying to rank number one on Google for that keyword, and therefore those are the websites we need to jump over in order for our website to rank number one on Google. And so therefore I'm going to put in 998,000 in my spreadsheet as the competitive number. And so now I could see for the keyword keyword bread recipes, I have 60,500. And if my competition is 998,000, then my KEI, or keyword effectiveness index, or in other words, the ratio of volume to competition, is 6%. So that's nothing more than volume divided by competition. So that tells me that my KEI, or my ratio between volume and competition, is 6%. So remember, we want more volume than we want competition. So anytime you do a keyword research, you're going to find a number of different relevant keywords. So if I go back into Google's keyword planner, if I typed in bread recipes, you could see that Google is going to give me a number of different keywords related to bread recipes. Let's just say I have another keyword that I want to think about optimizing for, being ranked on Google for, and that's banana bread recipe. Very similar keyword as bread recipes, except it's a little longer tail. Now, if I type in banana bread recipe in Google's keyword planner, now I can see the average monthly search volume has actually gone up. It's 368,000. I can also see the competition is low. So those are good signs. So now I can see 368,000. I'm going to go ahead and put that in my spreadsheet. Now I'm going to go into Google. I'm going to put in my syntax all in title. I'm going to put in banana bread recipe. I'm going to hit enter. And now I can see I have 233,000 results with the keyword banana bread recipe in the title tag. So if I look at the title tags, I can see banana bread recipe, banana bread recipe, banana bread recipe on all the listings in the Google search results. So that tells me I have 233,000 results that I have to jump over in order to rank number 1 on Google. So I'm going to put 233,000 in my spreadsheet. Now I can see my KEI, or my volume to competition ratio, is 157, 158%. And so to me, that's a lot better number to work with, or in other words, that's a lot better keyword because it's just as relevant and it has a higher ratio of volume to competition. So therefore, banana bread recipe is going to be a better keyword to optimize for in order to rank number 1 on Google. So that's the whole idea behind keyword research. You want to brainstorm ideas. There are plenty of tools out there. So the tool I recommend is Google Ads Keyword Planner. Google's going to give you how much search volume. They're going to tell you the competition, but then you're going to go into Google search. You're going to use the syntax all in title to get a more accurate read on the actual competitive number. And so to find out how keywords that your competitors are ranking for, you can use those keyword tools that I mentioned. Another tool that I use is Moz. So Moz, if you go to moz.com, they have a tool called Keyword Explorer. So if we just type in the keyword, for example, bread recipes, it's going to be able to tell us how much volume and the difficulty. So you can use other tools at your disposal, figure out the volume and the difficulty. There are plenty of tools out there. But the one thing I would just make sure is you use everything at your disposal. So you can use social media to find the most shared article for a particular topic or keyword, like bread recipes. You could check other platforms that have a lot of shared content, like Reddit and Quora, where you can ask people about certain topics using keywords to figure out how much competition or volume there might be. You could stay up to date on industry news to get an idea of what types of keywords are trending. But when it comes to keywords and keyword research, remember, for every web page, we want to be able to pick 2 keywords. We want a primary and secondary keyword. So when we do keyword research and we enter all our keywords into our spreadsheet, we want to be able to have a number of different keywords. In this case, we're focusing on the theme bread recipes. We want to have different keywords because we want to be able to choose a primary keyword and a secondary keyword, because we want to be able to focus on multiple keywords for each page, because we don't want to put necessarily all our eggs in one basket, meaning we won't want to put all our emphasis just on one keyword to rank for. We want multiple keywords to try and rank for. So the primary keyword can define the nature of our business. The The secondary keyword could be just highly relevant to our keyword. At the end of the day, we want to choose multiple keywords to try and rank on Google for that page. So for example, if we have a blog and we're using ice cream recipes and we're blogging about ice cream recipes, we can have a primary keyword that is about ice cream recipes or homemade ice cream recipes. We're going to always want to find out what the volume and the competition is. Our secondary keyword could be built around other similar keywords like low-fat ice cream recipes or fat-free ice cream recipes or low-fat homemade ice cream recipes. Those are complementary keywords, just like our bread recipes and banana bread recipe. So one thing we want to do when we do keyword research is we want to be able to target one keyword per content when you can target many. We want to be able to target multiple keywords, not necessarily target one keyword. And so we want to be able to cluster keywords. So we don't want to target just one, we want to target multiple keywords per page. And when we talk about clustering, if we go back to our keyword research, what we're doing is we're clustering a bunch of keywords under the theme bread recipes. And so by looking at the volume, looking at the competition, looking at the KEI, we can choose different keywords for our page. And that's what we mean by clustering. We want to cluster keywords into a content theme. So why target only one keyword per content when we can target many? Because we don't want to put all our eggs in one basket. We don't want to target just one keyword. We want to target many. And so that means clustering your keywords into a theme and choosing multiple keywords for that particular page. And when we do that, we have a better opportunity to rank high on Google search. And the whole idea behind ranking high on Google search is we can get the volume. So if we know we're ranked #1 on Google search for bread recipes or banana bread recipe, we know we stand a chance of getting a majority of the volume associated with that keyword. And if we can get the volume and get the traffic, then we can get the conversions. So let's move on to high quality content and talk about the impact content has on your ability to get your website ranked #1 on Google. So let's just say you have content on your website and the content is ranking on page 4 of Google. And it's that blog with ice cream recipes. And if it's just content for the sake of content, it's not really informative, then it's not necessarily going to get good engagement. In the eyes of Google, they want to rank content that's very informative, it's very fresh, it's exciting to read, it's interesting. It's going to have good engagement. So if it's a recipe or an article about any topic, if the content is just not informative, then you're not going to get good engagement. And when you don't get good engagement, if people don't stay on the site to engage in the content and they just leave the website after landing on the page, causing a bounce, then the content's just going to continue to fall down the rankings. And we want to prevent that. We want to move up the rankings. We want to be #1 on Google. We don't necessarily want to fall in the rankings for our content. So content is a key driver in being able to rank #1 on Google. So if the content is on page 9, what can we do? Well, we want to be able to, take that content and do something with it. We feel like we did write engaging content, so let's go ahead and share it on social media. And to me, social media is a good platform to share your content because on social media platforms like Facebook, for example, you're building a community on that platform. That community is already interested in your content. So if you're sharing an ice cream recipe, especially in the summertime, and you're engaging with your community on that platform, then the likelihood of that community on that platform is going to increase engagement. Increased engagement will send social signals to the search engine that says, hey, this content is good quality. Likewise for any other platform. Most social media platforms have engagement metrics, and those engagement metrics pass signals. Is it good? Is it not good? Do we like this content? Are we giving it a thumbs up? Are we going to want to follow it? Are we going to want to share it? And so if you share content that you feel is engaging on social platforms, then it's going to be engaging and it's likely going to cause an increase in engagement, for example, a decrease in bounces. And once you share that quality content, then the likelihood of it moving up the rankings, even as far as number one on Google, is going to be greater. So you always want to start out writing good quality content. So let's talk about good quality content, because Google does take content seriously. They do take into account what other people think of that content. So high quality content is an important factor. So how to create good content? That's always the question. So let's talk about some best practices here. Remember, in the last segment, we talked about keyword research. So we want to perform good keyword research. Why? Because we want to choose keywords. Remember, we're choosing multiple keywords per page. One keyword could be related to our brand. One keyword could be related to the content, but another keyword could be related to a user's intent, like recipes. If you recall the example we used with bread recipes, maybe somebody's looking to type in a keyword that says, how do I make, a bread? Or how do I make a specific type of bread? Or how do I make banana bread? Or what's the best recipe for banana bread? They're question related, and we want to be able to answer those questions. So that's where choosing those right keywords that's going to respond to a user's intent. So starts with choosing the right keywords. So remember, we talked about a number of different tools when we talked about keyword research. So there's a research tool that you can use called phrase.io, and that will help you do quick research on, keywords and trends and whatnot. So if you know a better research tool that you use for keyword research, then drop us a comment below. I'd be interested in getting your comments about keyword research and what research tools are out there. So if you know something better than phrase.io, drop a comment below and we'd be interested in getting your perspective. So keyword research is key, but creating content that fulfills users' requirements. So answering those questions. If it's a recipe, we want to answer that question. If it's directions, we want to answer that question. If they don't know how to do something, we want to answer that question. And that's the whole idea behind content. Content is not just to fill a page, it's to really fulfill users' requirements. That's when you get good engagement. So if somebody's typing in something on Google and they're looking for an answer, your content should answer that question. But we also want to make the content readable. So in other words, write for your audience. Don't impress anybody with very high vocabulary type words that somebody doesn't necessarily know the meaning of. Don't use jargon. Don't use a street language, for example. Use everyday common language that's just easily digestible when your audience is reading. And then we want to keep that content organized. And so when we mean organized, we want to use headers and subheaders. Break your content into paragraphs. Keep the flow organized. If we can keep the flow organized, then it's going to be easier for somebody to read. And then it's okay to add resources, especially resources from credible sites. So if you can incorporate those resources in there, then it's just going to add the credibility to your content and let the audience know that, hey, I've done my research on this topic, and this is what this person has to say about it. This person who seems to be credible. Okay, so it only adds value to your content. So these are all tips to remember when creating content. And then the one important tip here is we want to use white hat techniques. And when we say white hat techniques, that means, if we've chosen keywords that are going to answer somebody's question, we don't want to stuff those keywords into the content. We want the content to be naturally written. So when we say opt for white hat techniques, that's what we mean. Write the content naturally. Keep it organized, keep it readable, include third-party sources, and make sure it answers a question. So there are different types of content. So there's content where you just write words. It's all text-based. You could also use an infographic. An infographic is simply just a graphic that visualizes exactly what you're trying to explain. For example, if we want to write an article about how to write good, engaging content, we don't necessarily have to write all that out as a text. We can create an infographic. So for example, here's an infographic on 20 effective ways to basically not bore your readers, but write engaging content. So you could see this is an infographic. It's all graphically laid out. So infographics tend to be easier to understand because they're visual. They're easy for the end user to comprehend because there's generally no jargon. It's usually images that are portraying the point of what you're trying to get across. And so it tends to break it up, the monotony of just text. It's more visually appealing, and it's laid out and organized. So you can see this infographic has 20 different steps or rules, and they lay those out all here in this infographic. And the great thing I like about infographics is you could share them on social media, you can re-engage them as a post, you could save them on really any social platform. So infographics tend to tell a better story versus, say, just writing text. You can use video and images, so you don't necessarily have to lay it all out in an infographic. You can certainly insert a video or an image into your content, especially if it's a blog post. If it's a blog post, then sometimes video and images on its own tell the story. You don't necessarily need text to go ahead and tell your story. A video or an image, as they say, tells 1,000 words. And so images and videos are great to use in a blog post. So using different forms of content, you always want to review your content. When a user dwells on your web page for a longer time, Google will tend to think, okay, this person's engaged, so we're going to rank that favorably. So if you're using infographics, videos, and images, then the chances of somebody being more engaged are going to increase versus just text that's not well organized and written out in a way that somebody doesn't necessarily understand. So be creative in the types of content you use. So longer engaging content tends to bode well with search engines. So this is according to HubSpot. So the more word count you use, the more words you use, the chances of you ranking higher are going to be better. Just take into account best practices. You want to maybe break up the content with an image, organize it, make it engaging, use headers. So it's not necessarily just words, it's the words and how those words are written, how they're structured, the types of keywords you're using, how you're engaging with your audience. There's a lot of factors, again, those best practices we just went over. But the key is, if you have longer, more engaging content, then it's going to bode better for you on search engines. So a couple of steps to create high quality content. So you want to begin with a comprehensive introduction. So always introduce your content. Remember, the content should be relevant to the keywords. So if you're choosing keywords in your keyword research, think about answering that question. If somebody's typing in bread recipes, maybe they're looking for banana bread recipes. How to make the best banana bread, or how to make banana bread using dried figs. We want to be able to align our content with that keyword naturally. You want to create a title that's worthy, that's click-worthy. So remember, if you're in Google search and you're doing search for something simple like bread recipes, we want to make something that's going to be engaging for somebody to click on, like easy perfect yeast bread or easy crusty French bread, or something that's going to be engaging. The best bread recipes, or how to make the best homemade bread. Something that's going to draw somebody's attention to the title of that blog post. So we want to include LSI keywords. So what I mean by LSI keywords in your content, we mean, long tail keywords. Make it natural. Headings and subheadings should consist of keywords and variants. So if you're writing headers and subheaders, include the keyword in there. And that way, the content always stays relevant to the audience. Okay, shorten your sentences and paragraphs, so don't write long paragraphs. Remember, we want to break this up. We want to make it easier for the end user to read. And we want to always put internal links on our blog post. Why? Because if we have internal links, then if we have a link from one blog post to another blog post, or say our blog post to an internal page on our website, we want to make sure that it's relevant content. That way, if somebody's reading something and you have an internal link, let's just say from a bread recipes page to a banana bread recipes page, then they may find it interesting, click on that link, and go to the banana bread recipes page. So it's keeping somebody engaged on your website. So putting in internal linking will help keep the end user engaged because you're offering up links that's relevant to the content. You always want to break up that content with images. Okay, we want to use alt tags, meaning we want to pen the image with text, so that way if the image doesn't load, then at least the alt text will load. So we can incorporate call out boxes, and more importantly, we want to update our content regularly. So we always want to get the best recipe out there if it's banana bread, or different ways to create banana bread, or always just coming up with ways to update the content. So we want to keep our content, our blog post fresh. And then we want to include a CTA, call to action. If we include a call to action, then that's going to keep somebody engaged and have them act on your content. So these are steps to creating high quality content. And so let's look at an example here. And this is a 3-month-old post on BuzzFeed. And it's 21 pictures that restore your faith in humanity. So it has a lot of likes, a lot of tweaks, and that means it's engaged. People are engaged when reading that. And so if we go and look at it as an example, we could see it on BuzzFeed here, 21 pictures that will restore your faith in humanity. So this was written back in 2012. Again, a lot of engagement. But if we look at it, we can see immediately that it's taking into account third-party sources. It's got some content, it's got images, it's being broken up by images. We could see there's call to actions on there in the form of social, so people can go ahead and share it if they like it. Okay. It includes videos, it includes images, third-party sources. So it's a good post because, listen, it's engaging content. It's probably answering somebody's question about humanity. And we could see clearly that, look, there's a lot of different examples here from a lot of different sources, and we could take action on this content. So not just video, not just images, but text as well. And so it's very engaging, answers questions, takes into account the different types of content available. So this is a good post in that regard. So content's updated regularly, it's engaging, and it includes sources from high authority websites. Some do's and don'ts on the content. So take into account the best practices I mentioned about creating high quality content. Okay. Answer those questions that the end user wants to hear, because that likely is going to be their search. And so you want to be able to respond to the end user. That's part of creating high quality content. Different types of content, i.e. in the form of infographics or videos or text or images. You can add images from public domain sites. You can be relatable and use examples to clarify points, just like the BuzzFeed article. Simplify complex words. Don't use sophisticated language. Talk to your audience as if they were standing right in front of you. And use bullet points to exemplify your examples, your points. So some do's, the don'ts. Obviously, don't lift content. We don't want to lift content from another website. So that's plagiarism. So we want to have our own unique content. We also don't want to take images from other websites. And so if you do happen to find an image that works for your post and it's on somebody else's website, ideally that's not a good situation. But if you do happen to do that, then always give credit to the website. Okay, so if you took it from xyz.com, credit xyz.com for the image. And even put a link back. But ideally, you don't want to take images from other websites. Just as much as you don't want to take copy, you don't want to take images. Use your own imagery and content. But if you don't have imagery, then you can always go to stock photography. There are plenty of websites out there where you can sign up for a subscription, like Adobe Stock Images as an example. You could sign up for an account, and in some cases you can sign up for a free account and use stock imagery. Okay, don't give less information to your audience. Give your audience what they deserve, which is the information they're looking for. They're looking for the best banana bread recipes. Give them the best banana bread recipes. Incorporate your own images. Break it up with titles. Give them a good quality piece of content that they're going to be able to engage with. And so if you put long paragraphs, in your content, then it's going to be less engaging. So try to avoid those long paragraphs. Remember, shorten up the paragraphs, keep the language simple, add in images, answer those questions, use third-party credible sources, but write it in your own words, and you should be on your way to creating good quality content. Okay, so now that we've talked about high quality content in order to get your pages ranked high on Google search, let's turn our attention to optimizing on-page elements and discuss some website level factors that are both going to help you rank high on Google search. So let's just do an overview of what we're talking about when we talk about on-page elements and website level factors. So optimizing on-page elements include a number of different things. But primarily, we're going to focus in on meta tags, also known as meta description tags, header tags, also known as title tags, and URLs. So those are just some of the on-page elements we want to be able to optimize using relevant keywords in order to rank high in Google search. We also want to take a look at some website factors that will affect our ranking on Google search. They include website architecture, having a secure website, having a sitemap, and taking a look at page speed. So all of those are some of the website factors we need to take into account in order to rank high on Google search. So title tag and meta description together are considered meta tags. So both play an important role in ranking high on Google. So we want to be able to write unique title and descriptions for each page on our website. When I say unique, that means the title and the meta description need to be different for every page on the website. And so if you're not quite sure what a title tag and a meta description tag is, if you go to search and just type in any particular search query, the title tag is what's going to show up here in bold, and then the description is going to show up below it, below the URL, and that's going to describe the page. So both of these meta tags are important because it describes what your page is all about, and that's what Google uses in the search results pages. So we want to be able to pay attention to the length of our meta tags. So if we go back to our search results pages, title tags are generally 60-65 characters. Meta description tags are generally 160 characters. So anything really longer than that, then what's going to happen is the meta description tag or the title tag will get truncated. And so if we look here, for example, we can see all of the title tags here fit the 65 character limit. But if you run over the character count on meta description, then Google is going to truncate the copy. So you want to stay within your parameters in order to avoid getting your content truncated. And so the other thing when we're writing title meta description tags, we want to minimize keyword repetition. So if we're optimizing for keyword, we don't want to necessarily just plug that keyword into the title tag and meta description multiple times. We want to make sure our title tags and meta descriptions are naturally written. So if somebody's typing for banana bread recipe with dried figs, we want to have a nice title tag and a description that is going to get somebody to respond based on their need. And so we definitely want to avoid keyword repetition, but we want to be able to use that keyword in the title tag. Because if you remember from the earlier segment, when we did the all-in title syntax to find out exactly how many competitors were using that particular keyword, well, we obviously want to use that keyword in the title tag because, again, the title tag is an important factor when it comes to search engine results. So we want to use the keyword, but we want to avoid stuffing or using it repetitively in our title tag and our meta description. We want the title tag and the meta description to describe the page, sound natural, but also be engaging, because the point is we want people to click on our link and go to our website from search engines. So title tags with numbers tend to result in higher click-through rates. This is according to Moz. So for example, if you just put in a title tag that says learn digital marketing, well, that may work, but if you put a number in there like 5 easy ways to learn digital marketing, that might get somebody to click on your link and go to your website. So having questions in your meta tags can also increase your click-through rate. For example, if you just put learn the importance of first page rankings, not too bad, but again, generic. But if you put it into the form of a question, how to rank number 1 on Google, it's more action oriented. It's going to get somebody to resonate with the question that they have. And that may be their query, how to rank number 1 on Google. And so these techniques will help you get higher click-through rates. And so according to Backlinko, title tag with a keyword can improve site ranking. So remember, we want to include that keyword in the title tag. Even though we only have 65 characters, we want to include that keyword, but we want to avoid stuffing the keyword in there. We want to, again, make the title tag action-oriented, maybe with a number, maybe as a question, with the keyword in there once, naturally. Not easy to do, but that's the beauty of SEO. If you can follow these best practices and write a good title tag, then the chances of you improving in your search results are going to be greater. So having only one H1 tag in your post is going to be good. So remember, when somebody clicks on a link, so let's just say they do find a title tag engaging and they click on this link here and they go to that website, you want to start out with having that particular H1 tag, because the H1 tag, especially with the keyword in it, is going to signal to Google, hey, we're organizing our page, and because it's an H1 tag, it's important. We're structuring the page according to best practices. So having only one H1 tag in your post is definitely helpful. Having multiple tags, H tags in your post, help organize the page a lot better. So we want to add that targeted keyword in that tag, and your header tags should be relevant to the content. So if we go back to our example of the using dried figs with banana breads, well, the title says California fig banana bread. And remember the last segment when we're talking about high quality content? Well, look no further than including a video into our content. So not only will this video help keep the engagement high, but it breaks up the monotony of the page. And it's from a third-party source, so it adds credibility to the page. So adding a video based on the last segment of high-quality content definitely helps with ranking high on Google search. So following hierarchical structure, that means putting those H tags in there. H2 tags help break up the content. And we want to avoid repetition of H1 tags on your different web pages of your site, meaning don't just put the same H1 tag with the same keyword in it and keeping it blasé. We want to make those H1 tags exciting to read, but also used appropriately to break up the content. So remember, all white hat techniques. We want to avoid hidden tags. We want to avoid stuffing keywords. We want things to be natural. We don't want things to be forced. And your H1 tag should be 20 to 70 characters. Don't make long H1 tags. So if we go back to our page example, a short, sweet tag here, California fig banana bread. It's relevant to the content. It's short, sweet, and breaks up the monotony of the content. And more importantly, and again, any content you have on the page should always answer the user's intent. Remember, people are using search to answer questions, find information. Our content should be able to answer that for them. So, according to John Mueller, Senior Webmaster Trends Analyst at Google, header tags would definitely help Google for rankings in the search results. So we want to use header tags. So when it comes to URLs, we want to use hyphens and avoid underscores. So if we look at this URL here, this uses hyphens, fig and banana bread. So it's all broken up with hyphens. That's a best practice. Remember, canonical URLs. A canonical URL signals to Google this is the original content. So we want to use original content. And if you have multiple sources of content out there on, say, different websites, we want to use a canonical tag to signal to Google, this is the original content, please index this content. And that doesn't hurt to use a favicon in URL, meaning a small icon. It helps to break up the monotony and help your URL stand out. We can add targeted keywords in the URL. So again, looking at the URL here, I could see we're using targeted keyword as part of the URL structure. Fig and banana bread. And notice the H1 tag is fig banana bread. So it's all consistent and it flows naturally. URLs that are no longer existing, then we want to be able to set up a redirect for those URLs, meaning a 301 redirect is a server response for Google that says, hey, Google, this page is no longer available, but we permanently redirected it to this page, which is now available. So that's what a 301 redirect does. It helps signal to Google and all the other search engines that if the page is no longer there, that's fine. You're just going to go to this page. This is the page that's permanently there now. And another thing we want to do here is if you have mobile URLs, you want to include those in the sitemap. And we're going to hit on that in just a minute. But all URLs should be mobile friendly as well as desktop friendly, meaning take into account those best practices. Keep your URLs short, use hyphens, put the keyword in that URL, and make it easy to understand. Want to avoid capital letters in the URLs. The URLs are case sensitive, so go lowercase. You should always go lowercase on the URL. Readable URLs, again, the rule of thumb here is if you understand what the URL is, then Google's going to understand what the URL is. So the shorter the URL, the easier it is to read. The easier it is to read, the better chance you have to rank high on Google search. So according to backlink 2, URLs that are shorter definitely help you rank. So we want to be able to shorten those URLs. Keep them short and sweet. Don't make them long and unreadable. So those are some optimized ways or on-page elements that help you optimize. Now we want to look at some website level factors that will help you optimize and rank high on Google search. So good site structure provides better crawling for search engine bots. And what do we mean by that? Well, we mean having your site organized in a fashion that Google's going to be able to find all the pages. So what do we mean by that? Create a logical hierarchy structure. So if you're selling shoes, you're going to have a home page, break the structure up into men's shoes, women's shoes, children's shoes. Then under men's shoes, you could have it by brand. It could be Nike, Puma, Adidas. On the women's side, it could be Nike, Puma, Adidas. On the child side, it could be Nike, Puma, Adidas. And so you want to keep the structure, flow, in a hierarchy. So we want to balance the amount of subcategories within each category. So the men's, if it has Nike, Puma, Adidas, the women should have Nike, Puma, Adidas. And so you want to code your site navigation in CSS or HTML, meaning we want to be able to use something that Google is going to be able to index. So most sites are built in HTML, and that's what Google likes to index. They like to index something that they could take back to their servers. And then more importantly, build a comprehensive structure for internal linking. So internal links mean that if you're on a site, you should have natural links pointing to other pages on your website. So to keep the flow going, and we don't want to have unnatural inbound links. You always want to have natural internal links to keep the flow of the user going from one page to the other. So here I could see, as an example, all the ingredients in this recipe. Well, this has an internal link to another page on our site. And this happens to link to a page where somebody can buy the ingredient. So it's a natural internal link. So John Doherty of Credo has claimed that one of the biggest changes that he can make in fixing the Credo website is architecture. So for example, in Credo, John Doherty has increased the organic sessions by 74% and pages per session by 41%, just by changing the site architecture. So you'd be surprised by changing the site architecture what that will do to engagement. And so let's turn our attention to secure versus non-secure. So what we mean by that is securing your site. We want to make it sure that compliant with certain protocols. And so if we go back here, we can see that this particular site is compliant, it is secure. HTTPS means it has a secure license, meaning the site is secure. So Google likes secure versus non-secure. So non-secure would be HTTP. So we want HTTPS as our protocol. And what that means is just enabling SSL certificates. And that means when you enable an SSL certificate, that means your domain or your protocol is going to be turned to HTTPS. So Google prefers sites that are secure versus non-secure. So if you use HSTS as a protocol, that adds an extra layer of security over the HTTPS. And HSTS prevents cookie hijacking. So adding multiple layers of security always helps. In my opinion, if you have an HTTP website, a non-secure website, you should look into buying an SSL certificate, getting your sites flipped over to HTTPS, because what's going to happen is your URL structure is going to change. When your URL structure changes, Google's going to recognize that because they're going to index your site. And when they index your site, they're going to see those secure URLs. And that's going to work favorably in your favor and help you rank higher on Google search. So websites using secure or HTTPS have a higher chance of ranking higher. So HTTPS is a ranking signal because Google indexes those pages. So let's also talk about sitemaps. So sitemap is one of the most important ways to improve your website ranking. Why? Well, because sitemaps are a way to organize all your URLs into one file. So we're basically going to prioritize all our web pages in a sitemap. So if you go to any particular website and you type in sitemap XML, you're likely going to see all the pages on your website. So usually the sitemap is located in the root directory. So if I type in sitemap.xml, I'm going to be able to see all the pages in my root directory. And I can also prioritize them. I can also alert Google as to how often they change. And every page is going to have a date stamp associated with it. So Google can actually see how often it changes. So remember, we want our content to be updated frequently. So if content's not updated frequently or it's not fresh, then Google's going to see that date stamp, that last modification date. So we want to be able to make sure our content's updated frequently. We want to let Google know that we changed it frequently. And we want to be able to prioritize our pages, let Google know, hey, these pages are important to us. So all that can be set up in a sitemap. We want to be able to add canonical versions of URLs in the sitemap. So we want to be able to add all our original URLs in our sitemap. And so we always want to build dynamic URL sitemaps for larger websites. And what I mean by dynamic URLs, that means that if I look at this sitemap and we're always adding content, let's just say in the form of a blog, well, guess what? We want those pages to be added to the sitemap as they're published. So as we add pages to the blog or to the site, then they should automatically be added to the sitemap. And so in effect, what's going to happen is we're going to be able to see the sitemap grow with more URLs. When the sitemap grows with more URLs, then that means then Google's going to index more pages. They're going to index more fresh pages. So they're going to be able to get those pages that are just published quicker. So that's the whole idea behind dynamic sitemaps, is we want to be able to capture all the URLs just as they're published. And we want to be able to maintain our sitemaps. And so I would always recommend a dynamic sitemap, but you can always create your own sitemap just by going to a tool called XML sitemap. So if I just type in XML sitemaps into Google search, here I could see XML sitemaps generator, and I can be able, if I have a small website, just create a free and simple sitemap on my own. When XML sitemaps creates it, or your platform creates a dynamic sitemap, either way, the sitemap's going to sit in the root directory. And then what we want to do in turn is let Google know where that sitemap is. So in Search Console, we want to be able to submit the sitemap. So you're going to add the sitemap, you're going to let Google know where it is. It should be in the root directory, and it should be called sitemap.xml. And when you do that, Google's going to be able to take those URLs and index them. So we could see we submitted 528 URLs, Google indexed 521. So one thing about URLs here is when we create a sitemap, we're putting all our URLs in there. we do not add no index URLs in your sitemap. And what that means is that any URL we don't want Google to index, we're just going to exclude from the sitemap. Okay, so we want Google to take all the URLs we want indexed and put them in the sitemap. So according to Edgy, using sitemaps for SEO can increase your website's visibility and help you get indexed. Why? Because what you're in effect doing is taking all your URLs that you want indexed, you're telling Google how often they're modified, you're telling Google which ones are important, and you're submitting that to Google. And so Google's going to be able to take all these URLs quicker, index them quicker, and when they're indexed quicker, you can get ranked quicker. And when you get ranked quicker, you can get traffic quicker. So that's the whole idea behind sitemaps. So let's turn our attention to page speed now. So one of the last factors for our website, besides architecture, making it secure, and adding sitemaps, is we want to take a look at how quick our pages load. Here are some tips in order to optimize page speed, because ideally the quicker a page loads, the more engaged the user is going to be. If it takes a longer time for the page to load all the elements of that page, then what's going to happen is the user is going to get impatient, maybe leave the website altogether or go to another page. And so we want to be able to optimize images. So any image that's of large size in terms of megabytes, we want to be able to optimize that, compress the image. So that's one way to speed up page speed. We want to use a simple website design. HTML with CSS or cascading style sheets. Just a simple design with simple hierarchy and website navigation structure. So nothing fancy, nothing complex, just a simple website design with optimized images. We want to leverage browser caching, and we want to upgrade the server response time, meaning all your files are sitting on the server. So when somebody goes to a web page, the server is serving up all of those files, the images, the text, etc. And so we want the server to respond as quick as possible. So when it comes to page speed, we can look at the factors affecting page speed in Google Analytics. So if I go to Google Analytics and I go under behavior and I go under site speed and I go to overview, I'm going to be able to see what my average load time is for my site. And ideally, we want our pages to load as quick as possible. So that means anything under 4 seconds. Anything 4 seconds or higher, and it's likely the end user is going to leave the page. There's a correlation between page load time and bounce rate. And so what Google actually does is give you speed suggestions. So if we do have a page that loads slow, we can just go to speed suggestions in Google Analytics. And we go to speed suggestions, then Google's going to be able to tell us, hey, this particular page load fast, this particular page load slow, and if it loaded slow, why is it loading slow? So here we could see the home page, as an example, is loading on average of 7 seconds. Well, if we look here, they're going to give us some suggestions. So if I click on this page speed suggestions, it's going to load a report and a tool called Page Speed Insights. And basically what it's then going to do after it's done running is it's going to tell me all the ways in which I can optimize my pages. Not only for desktop, but also for mobile. So here I can see for desktop or for mobile, I can look at some ways in which I can optimize it to increase page speed. For example, sizing my images properly, server response time, reducing my server response time, avoiding multiple page redirects. So there's a lot of opportunities that we can do to speed up page load time. And all that's found in Page Speed Insights, and all that's found within Google Analytics. So remember, optimizing code, minimizing redirects, optimizing your images, upgrading your server response time, all of those are factors. And so again, you can go into Analytics, Page Speed Insights, and you can see exactly what Google is recognizing as what's lowering or slowing down your page load time. So Google takes site speed as one of the most important ranking factors. Why? Because they're going to rank pages not only with high quality content that are relevant to the keyword queries, but they want those pages to have a good user experience. So if somebody clicks on the page, then the user should be able to see that content fairly quickly. And so that's why it's such an important factor. So the quicker your pages load, the chances of you ranking higher are going to be better. So according to Web Performance Today, Walmart as an example, experienced a decline in conversions. So what they did was looked at their page speed. And when they looked at their page speed, you'd be surprised what that did. Just increasing it from 1 to 4 seconds or decreasing it basically increased conversion. So there's always going to be a correlation between how quick a page loads and how engaged the user is. Because if the user's engaged, they're going to stay on the site. And if they stay on the site, then their chances of converting are going to be higher. So just even 1 to 2 seconds increase in page load time will make a world of difference in terms of engagement and conversions. Let's turn our attention to off-site engagement. So previously we talked about on-page elements and website factors that affect our rankings for search results, but we also need to turn our attention away from our website, meaning what we do on our website, and turn our attention what we can do for our website off our website and onto other websites. So that's off-site engagement. And so let's look at an example. So that ice cream recipes blog. So we did everything we possibly could. We updated the meta tags, the title tag, the meta description. We added H1 tags. We made sure the site architecture was sound. We submitted a sitemap. We made sure the page load was good and fast. So we did all the things we're supposed to do on our web page, but we're still not ranking. Well, what do we need to do? Well, we need to turn our attention away from our website into other websites. We call this off-site or off-page SEO. And we need to basically generate links from high-quality sites back to our site. So if we've done everything we can on our own website and we're still not ranking where we want to be, well, then we need to turn our attention to other websites. And so if we turn our attention to other websites and other websites that are relevant, other websites that are of quality, other websites that have high domain authority, then we're going to see an increase in rankings. So it's just a matter of getting quality links from quality websites that are relevant. That's what's going to move the needle on search after we've taken care of all the on-page elements. So more backlinks from high domain authority results in higher rankings. SEO is a combination between what we do on our website, meaning optimizing the page and making sure our website has good site architecture and follows the best practices in terms of sitemaps and page load. Then we need to turn our attention to the backlinking to improve our domain authority. So according to Backlinko analysis, off-site engagement is one of the most important elements for ranking #1 in Google. So you can't just focus your attention on updating the title tag and making sure the pages load fast. You have to turn your attention as well to getting backlinks from high-quality sites. That's off-site engagement. And so gaining links, backlinks from multiple domains is vital. It's vital because they bring referring traffic to your site. They bring credibility to your site. But more importantly, Google's going to recognize the relationship between these sites and your website. And if these sites that have backlinks or links pointing to your site, and if they're of high quality, then we call that passing link juice. So it's going to bring quality to you in terms of organic search. So if we look at an example, if I do a search for banana bread recipe, there are 241 billion results for banana bread recipe. Why did this particular page from Simply Recipes rank #1? Well, we can turn our attention to Moz, and Moz has a report called Link Explorer. And so Moz's Link Explorer report helps us identify our own page authority, our own domain authority, and how many links we have from other quality websites. So if I put that particular URL into Link Explorer, and notice the URL here is short, even though it uses an underscore when it should use a hyphen, it's still ranked #1. And why? Because off-page elements help this page rank #1. Why? Their page authority out of 100 is 58. Their domain authority out of 100 is 82. And what does that mean? Well, that means that they have a lot of good links from other domains of high quality. They have 824 linking domains to this one domain. They have 3,600 inbound links. And they're ranking for a lot of different keywords. So if we scroll down, we're going to be able to see kind of a breakout, the quality of websites that are linking to them. So they have 19 domains with a domain authority of 91 to 100 linking to them. They have 15 domains between the range of 81 and 90. So what does that tell me? Between 15 and 19, that's 34 particular domains that are very high quality linking to them. And so we could see the breakout of the linking domains. We could see the top file links to the site, and we could see the page authority. So the Link Explorer report gives us an overview of what pages are linking to ours. And it also gives us an idea of what our own page authority and domain authority are. Because domain authority and page authority both need to be high in order for us to rank on Google search. And in order for it to get high, we need links from high quality sites. So that's the whole idea behind off-site engagement. So some of the off-site engagements are influencer marketing, meaning is there somebody out there on social who has a huge following? But not only do they have a huge following, but are they relevant to our product? For example, Usain Bolt, who's a famous sprinter. If we're selling shoes and we're selling Nike shoes, maybe Usain Bolt can reference us on Twitter or Facebook. That's influencer marketing, influencing people to buy our product. We can engage with audiences on multiple social media platforms like Facebook and Twitter. Meaning, if we're running a promotion on those running shoes, then we can promote that on Facebook. Okay, we can promote that on Twitter. We can also bookmark our webpage on popular bookmarking sites like StumbleUpon. We can also put our content on discussion forums like Reddit. We can join high PR quality Q&A sites, and post answers to questions related to our business like Quora.com. So we can engage in sharing our content and answering questions. So there's lots of ways to get links to your website. If you have a blog post as an example, you can make sure that maybe that content is shared on a similar blog post. So if you have an ice cream recipe blog post, well, maybe you can look at a dessert blog post and share your content on that particular blog post and have a backlink pointing from that blog post to yours as an example. And you can reciprocate. So the whole idea of content is sharing the content, but at the same time of sharing it, you're producing backlinks. And backlinks help domain authority. So not only do they help domain authority, but they improve the search rankings. So in Google's eyes, the higher your domain authority, higher the page authority. In Google's eyes, that means your page is important, it's credible, and we're going to improve it in the search engine rankings. It increases brand visibility. If we have our content on a highly engageable website, a highly popular website or a blog, it's going to lift our brand visibility. If we have Usain Bolt, who's a very famous sprinter, do some influence in marketing for us, then that's going to increase our brand visibility. So anytime we can associate with something that has some influence or some clout or high domain authority, then it's only going to increase our brand awareness and visibility. So again, it's going to increase our domain authority because of the association of passing link juice from one domain to another. It's going to then, as a result, increase referral traffic. Because if we're on a high quality website that gets a lot of traffic, then the chances of some of that traffic going to our site is going to be great. And again, it improves the credibility and trust of our website. And that's what we want. We want Google to trust us. And a way to build trust is by associating our website with other websites of equal or higher quality. So when we talk about offsite engagement, we want to do some guest posts on relevant websites. So if you have that ice cream blog, go to another blog like the dessert blog and do a guest post. So not only will that improve your brand awareness, but it'll generate a backlink and maybe drive some referral traffic. You can participate in forums and blog discussions like Quora.com or Reddit. Get your content out there. Start a discussion about a specific topic to engage users, build brand awareness, and generate that backlink. You can always put your site on a directory like Yelp, for example, or Yahoo directory. You could prefer testimonial link building, meaning if you serve products or offer up a service, well, somebody could provide a testimony on their website. Or you could just earn backlinks from relevant authoritative web pages like we mentioned Quora or Wikipedia, or there's plenty out there. So the idea is to associate yourself with high quality websites, but do it naturally. You don't want to force anything. So if you're selling a specific service or you're selling a specific product, look for like-minded services or products that complement what you do. And that'll create the natural environment, natural ecosystem that will eventually give you the benefits that you need to rank higher in the search results pages. So we don't want to purchase any links. We don't want to cloak content. We don't want to just inject links on sites that aren't relevant. We don't want to just have site-wide links all over the place pointing to the same page. And we certainly don't want to be on low-quality websites or directories. It's all about quality, not quantity, with off-site engagement. So having off-site engagement complements what you do on your website for on-site. Together, both of those efforts will get you higher search engine results.
And with that, we have reached the end of the session on data analytics with SQL, Tableau, and Google Analytics for course 2026. If you have any doubts or queries, let us know in the comment section below, and our team of experts will be happy to help you as soon as possible. Until next time, thank you and keep learning, and stay tuned for more from Simplilearn.